Welcome to SwiftUI Fundamentals. In this video, I'm going to talk about what we're going to learn in this course and how we're going to learn it and kind of the overall flow. First up, this was designed for people who at least have the basics of Swift down. You don't have to be a Swift pro, but at least know the basics. And if you don't know the basics, check out iOS Dev Launchpad. We go over all that. So this course is meant to build your foundation in SwiftUI and focus on what I believe is the core skill, and that is moving data around. SwiftUI is declarative, which is quite different from the imperative programming paradigm we all may be used to with UIKit, right? It kind of flips it on its head. You have to completely think about things differently, right? It's a mindset shift. And that mindset shift and properly passing data between views, that's what I want to focus on in this course. Yes, SwiftUI can do a lot of awesome animations, crazy cool UI stuff, but again, I want to focus on the foundation of building apps, and to me, that is passing the data and getting your app to act how you want it to, right? I say that all the time. When I first learned SwiftUI, getting my app to look like I wanted to, right, with just building the UI, to me, that was the easy part. Where I ran into frustrations and headaches was passing data and getting my app to act how I wanted. So that's what I want to be the focus of this app. Fun, cool UI and animations, that can and will come later. All right, so how is this course going to work? Let's talk about the flow. Overall, we're going to build 4 apps. It's going to start off pretty easy, but we're going to progressively get more difficult and build over time to where the final app is a bit complex, for a foundational course. And I'm going to introduce concepts slowly at first, and we'll get a lot of practice, building with them, using them, because as you know, I'm a big believer in practice, repetition. You don't just read one article or watch one video on a topic and then you know it. You got to practice, practice, practice. But we do start off pretty easy. So if you do have a little bit of SwiftUI experience and after the first 2 apps, you're like, oh man, this is super basic. Just wait. But okay, let's talk about those apps. So the first one is just the UI of a weather app. This is the introduction to the course. So we start off super basic. I want to get you familiar with the foundational tools in just building UI in SwiftUI. After that introductory app, I go into more of an explainer session, some talking head, graphical videos, where I explain, imperative versus declarative and the differences. I talk about how SwiftUI updates its views in the view tree hierarchy, talk about view modifiers, view builders, right? We kind of dive into the core concepts of explaining, but then we get back to code in the next app. It's about Apple frameworks, where, as you can see, there's a grid. You can tap on a framework, learn more about the framework. So not only will you learn how to build this kind of app, but hopefully you'll get inspired by reading about these frameworks and maybe get your next big app idea. But in that app, as you can see, we're adding a couple screens. We're starting to dip our toes into passing data from screen to screen. Like I said, we ease into it and get progressively more difficult. Now, the third app, all about the barcode scanner, this really focuses on UIKit integration with SwiftUI, right? Because, SwiftUI is pretty new. A lot of stuff still isn't built in, such as the camera, like we see in this app. And this app focuses on passing data from UIKit to SwiftUI when you have to integrate UIKit. That's using UIViewRepresentable in coordinators to pass all the data. So the whole point of this app is to get you used to using that, because if you're building apps in SwiftUI, it's very likely that you're going to have to go to UIKit for some things. And finally, we finish off with a more complex app, well complex for a foundational course, where you can order appetizers, see a detail view of it, add it to your cart or your order, and then place your order. To be clear, I don't want to have any misconceptions. We're not implementing Stripe and actual payment processing. That's a bit outside the scope of this course, but I don't want there to be any wrong expectations. Now this app, besides what you see, we're going to deal with network calls in this app. So we're going to do proper error handling, alerts, some advanced animations. So again, this is where it gets a little more complex, above what we did in the previous apps. And during each of these apps, we're going to be refactoring along the way. We're going to be talking about project organization, and I'll be providing various levels of challenges after each app. If you do want to push yourself further and further to build upon the base, of what these apps give you. After we build the 4 apps, we're going to have a review section. And I think this is going to be a very valuable section because it's part of the learning process, right? You're going to hear me talk about it. We're going to get a chance to build and play with it a couple times, right? But once you've seen it in action, you've actually touched it. And then now if you go back and review it, I feel like that's going to really solidify your knowledge and just really drive it into your head. And then lastly, my final disclaimer. The only thing I can promise you is that SwiftUI is going to change, right? So don't treat this course as the final end all be all of your Swift foundation, right? I want to give you those foundational skills so that you can easily grow and evolve and adapt as this world of SwiftUI changes and evolves itself. So just keep that in mind. things are probably going to change, but hopefully you leave this course with a solid foundation so you can change with it. This course has been updated for iOS 15 and iOS 16. This course is structured into 4 apps, and I did the updates at the end of each app. For example, the first app you'll do is the weather app. So at the end of the weather app, there's a what's new in iOS 15, and then there's a what's new in iOS 16, and then the same thing for each app after that. I put the updates at the end of the app so you can still see the old way, because a lot of apps have to support older versions of iOS, iOS 14, iOS 15. So if I just redid everything for only iOS 16 and above, well, you're missing out on how to do things the old way, which you may need. I also think it's good for you to see the evolution of how things change and how we go about updating projects, as new iOS versions come out. So if you're going through this course for the very first time, and before you get to those iOS 15 and iOS 16 sections, you see some deprecations or Xcode warnings, don't worry, wait till you get through the updated for iOS 16 version, we will address those. You'll also see some what's new in Xcode videos, I believe Xcode 13 and Xcode 14, and that's because Xcode itself is changing and evolving over time. So again, if you're going through the first time, you see something weird or different in Xcode, make sure you check out those what's new in Xcode videos to help you out. Over the next few videos, I'm going to introduce you to SwiftUI by building this weather app. Well, at least the UI for the weather app. Now, as I said in the course overview, if you remember, the purpose of this app is to not give you the full deep explanations all right away. The purpose of building this app is to show you SwiftUI in action, give you a light introduction to it. So as I'm going through this app, if you're not quite following everything or I'm moving too quickly, that is by design. Because again, I want you to see it, because when I give deeper explanations in future videos, I think that will make it easier for you to understand what I'm talking about, right? If I just dove right into those deep explanations right away and you hadn't seen it in action, it's going to be like confusing. But if you've seen it in action, then I give the deep explanation, I think you'll be able to connect those two and actually understand what's going on. Not to mention, this is going to be the first of a couple apps we build in the course, and we're going to be doing all this a lot. You're going to get plenty of practice and repetition. So again, like I said in the intro, the flow of this course over those apps is the first app may be confusing. The second app, you're going to start to get it. By the third and fourth app, hopefully you're typing this stuff out before I even say it. That's the goal. That's what I want out of this course. So that's my disclaimer. And again, try to refrain from asking like specific questions on these videos in the comments, because I'm very likely going to answer those in the videos after we build this weather app. Again, the whole point of this is just for you to see it in action. All right, let's start building. So open up Xcode, create a new Xcode project, and I'll make this full screen here. No, Siri, not you. Okay, so right away you see you have a couple options when building a SwiftUI app, like just an app. Well, you can also click multi-platform, but here's the thing. In the early Xcode 12 betas, when you clicked on multi-platform, which would give you macOS, iOS, iPadOS, that stuff, you used to be able to create an app here. Well, in the release of Xcode 12, it's gone, and allegedly it's back in the Xcode 12.2 beta. So if you're doing this later, you might see it in Xcode 12.2 and beyond, but you should be able to create a multi-platform app. That's one of the features of SwiftUI. So for now, because I am on Xcode 12.1, just click App for iOS and hit Next. And I'm going to name this SwiftUI-Weather. You can name it whatever you want. That's what I'm going to name it. And make sure you have SwiftUI as the interface checked and the Lifecycle SwiftUI app. Don't worry about core data or tests. We're not there yet. Go ahead and hit Next and save it wherever you like. I'm going to put it on my desktop for now. And here we are. This is what a SwiftUI Xcode interface looks like. Now your preview may not be up and running like mine isn't, so hit resume. And this is kind of what is nice about SwiftUI is you get this hot reloading. Now, in theory, that's what you're supposed to get. Oftentimes the preview acts kind of finicky. Sometimes it's slow, as you're seeing. This is on an iMac Pro, still going a little slow. So to be quite honest, when I'm actually building my apps in SwiftUI, I'm like rarely using the preview and only for very specific like screens. But again, SwiftUI is so new, I expect previews to improve a lot over the coming years. First of all, we don't want an iPad Touch 7th generation. Let's go to the iPhone 12 Pro, the new hotness. Okay, here we are, and you can adjust the size here. Now, what I'm gonna show you here is how you can visually edit code, but I'm only showing this to you out of what I feel is kind of an obligation to at least let you know it exists, because I never use it. I recommend you don't use it, because once you learn how to just like write the code, it's 10 times faster. You can be so much more productive. But I want to show you this exists, and maybe it'll help you when you're first learning, but I don't recommend getting used to doing this and making this like the way you do things. But before I dive into that, let's actually break down what's going on over here in our content view. So SwiftUI is all about views. I'll dive more into that later. But every view you create is going to return a body and it's going to return a view. So right now, our content view has a property called body and it's returning text, hello world. And that's what you see here. So that's what's going on right now. And of course, we're going to build a lot more code in there to expand on that. But let me get back to this preview real quick, just to show you this so I can get it out of the way. So if you do Command-Shift-L, you can kind of pull up your modifiers. Now, more on modifiers later, but it's kind of how you customize a view. Again, we're going to do a deep dive into modifiers with its own dedicated video. So right now, just know this is how you kind of customize a view or drag a view on there. So let's say we want a button below our hello world text over here. Well, if you're using the preview, you can just literally drag that button and you can see where you put it. You can put it below it, above it, to the left of it, to the right of it. Now, this is where stacks come in, and stacks are very fundamental to SwiftUI. We're going to be using them so much, they're going to be second nature by the time we may even be done with this first video, but definitely by the time we're done with the course, stacks are going to be second nature to you. So if you're a little confused now, don't worry. But you can see the little message at the bottom. Adding a button to the new horizontal stack along with existing text. And if I move it to the bottom, it says adding a button to a vertical stack along with existing text. So let's add it to the bottom and create a vertical stack or a VStack. So now what you see happen is the button is in this vertical stack, which is that red outline, that's the frame of it. So you got the hello world text and a button. Now the cool thing, kind of cool, right? You dropped it on your preview and look what happened in the code. The code automatically popped in. It popped up a VStack with, here's our text that we had, and then it put a button below in the VStack. So that is pretty cool. I'm not going to lie. When you see just drag and dropping and it makes the code for you, you're going to think, wow, that's an awesome way to do it. That's great. It's great for like little small stuff. It's cool. Yeah, trust me, you're going to be just wanting to write code more often than not. All right, let's do this one more time. Command-Shift-L to pull up your library. And let's drop another text into this, except now we're not going to drop it. So I could drop it here to just add it into the VStack that we have, the vertical stack. But let's try something different. Let's put it to the left to create a new horizontal stack, an HStack, right? So I drop it there. Boom, see placeholder for the text. And then, so here's the horizontal stack, right? You got the placeholder on the left and then our VStack. So you can like nest your stacks as you're seeing. So the VStack of hello world and button is now on the right of the HStack. And you can see this here, right? The whole thing is wrapped in this HStack. And then to the left of the HStack is the text. And then we have our VStack here to the right. So again, you can see you can nest HStacks and VStacks. Now that's all I'm going to show you for the drag and drop again, because I don't recommend using that, but I felt like I needed to show that off. Now let's take a look at the design, and I'm going to break down the HStacks, the VStacks, and the ZStacks, haven't talked about that yet, of this design to hopefully, make you start understanding how these stacks work. Because again, this is like fundamental to SwiftUI. You're going to be writing a million stacks throughout your career. So looking at the design, the elements on the screen that are on top of the background color is one big VStack, right? So as you can see in this outline, the city name, Cupertino, the icons, everything is within a VStack. But like I mentioned, you can nest other stacks in that. For example, the weather icon that we have, the cloud and the sun, and the 76 degrees, like that in and of itself is its own VStack nested within the overall VStack. And down here, you can see we have individual VStacks, right, of the day of the week, like Tuesday, the weather icon, and the temperature. That in and of itself is a VStack, but it's nested within the overall HStack that is the days of the week going across. And again, that itself is nested within the overall VStack. And then of course we have the button at the bottom of the VStack there. So hopefully that gives you an example of, how these stacks works, the HStacks and the VStacks. And again, we're going to build this, so you're going to get more in-depth knowledge, but that's it on the surface. And then the ZStack that I haven't talked about is kind of like vertical layers, right? So for example, the VStack that holds all the elements is on top of our background view, which is the color gradient, right? So that is the ZStack, and that's kind of like vertical view hierarchy, if you will. So that covers the three main types of stacks. Again, we're going to build this, so you're going to get more knowledge, and we're going to build a bunch more apps with them. So let's get to it. All right, so back what we were messing with before, one thing you can do when you're not using the drag and drop preview is get rid of this pane on the right. That'll give you more room. I like to make my canvas a little smaller. If you want the mini map, cool. I tend to not. I think the mini map's super cool. I just never use it. So I click it off because again, I like screen real estate. But let me show you something real quick. And this is why I prefer the code way. Like I can go from an HStack to a VStack like in a second just by deleting H to V, and now you can see it changed. So again, I find code so much quicker. And then again, this VStack, let's change it to an HStack. Literally by changing one letter in your code, it changes the layout of your screen. So that is the power of like doing it via code. So one little tip there. That's why I like that. So on that note, we're gonna have remember I said the whole thing is a Z stack. So I'm gonna make that a Z stack, and you can see it put everything on top of each other, not what we want. So let's delete all of this here, because the first thing we're gonna build in our Z stack is our background. And if you look at the design again, look at the background, it's a nice gradient color for the background. So the first thing we want to do is actually make a color. Now a color is a view, like everything in SwiftUI is a view. Again, I'll be saying that all throughout the course. So let's do color.blue, right? Bam. Okay, so you can see in the color, it fills the entire space available, which is everything but the safe area. But you notice on our designs, like we don't want to respect the safe area for a background. We want to fill the whole view. How we can fix that is by adding a modifier onto our color to say .edges, ignoring safe area, all. As you can see in our preview, that fills up the whole phone. And we put that on our color view because that's the view we want to ignore the safe area. When we actually put our content in there, we want to respect the safe area for that. But our background, ignore the safe area. Now that demonstrates color, how it fills everything up. However, our designs call for a gradient, not just a solid color. For that, we can create a linear gradient. So as you type linear gradient, there you go. Let's get our initializer here. You can see it takes in a gradient, a start point, and an endpoint. So it gives us default values there, so you can start to see how quickly that comes in. So for our gradient here, we want an array of colors. So let's do, we want .blue, and then .white, right? Because this is kind of like the blue sky thing that we're looking for. Not blue, white. All right, so you see blue, white. Now starting point is leading and trailing. So you can see the gradient starts in the leading, which is on the left here, and it goes to the right. However, we want dot, and you can just hit dot to see all your options here. We want top leading, because we kind of want it to come down from the right? And then bottom trailing is what we want. We kind of want that angle there. Right, so there you go. So it starts in the top left, goes down to the bottom right, and we get kind of that like blue sky look. Now, gradients are nice and flexible, right? If you wanted to get kind of crazy with it, right, we have an array of colors here. You can add as many colors to this array that you want. And again, I don't want to get too wrapped up in like every detail about the UI, but I thought this was pretty cool to share. So I can do .blue, .red, .white. I guess that's pretty patriotic. Didn't even mean to do that, but you know, let's add a green in there, right? Just to really drive the point home here. Green, comma. Not semicolon, comma. Damn, Mike's in the way. So you can see, you can get kind of crazy with the gradients just by adding colors to the array, setting a start point, setting an end point, and SwiftUI does the rest. So that's just one little taste of like kind of the powerful stuff SwiftUI can do. And there's so much of that, and I did dabble in it here. But remember, the point of this course is to really focus on like the passing of the data and understanding how SwiftUI works. You could do like 7 courses on all the cool UI stuff you can do, but that's not the focus of this one. So that's as far as we're gonna go on like playing around with cool stuff, at least right away. So we just want the blue and the white for our gradient. And we're actually going to create a custom color for light blue because the white is like too much, but that's going to come later. And quick note, you'll notice in SwiftUI, a lot of times has very long like initializers. So a style that I've adopted, and many people already did this, but a style that I've adopted on the long ones is to start basically, you know, lining up my parameters vertically like that for my views. And you'll see me do that throughout the course, and it really depends on how long, you know, the initializer is. So as you can see, our background gradient is set up in our Z stack. So the next thing we need to do is start building that overall V stack on top of our background linear gradient. And we're gonna do that in the next video. We left off last video getting our background gradient all set up. Well, now we're going to start the process of building the rest of the UI elements to eventually get to the final product that you see there. And we're just going to go top to bottom. So first, let's start with the city name that we want to put in there. Okay, so back to our code. As a recap, we have our Z stack with a linear gradient. Now remember, Z stack is kind of like vertical, view hierarchy, layers, if you will. Remember we said all the UI elements are held within one V stack back when I went over that last video. So here, this is where now we're going to start typing the code, not dragging and dropping. Go ahead and start typing V stack, get autocomplete here, open and close bracers. There we go. There's our V stack. You don't see it yet because nothing's in there. Now we want the city name, right? So that is a text. Text is a view that takes in a string. So we want to do Cupertino, California. So Apple's headquarters. Now you'll notice it is dead center of the screen, no styling. That's not where we want it. That's not what we want it to look like. So first up, let's get it looking how we want, right? And that comes with modifiers. Again, more on modifiers later. But one thing to note about modifiers as you're adding multiples, now you may be used to UIKit where you would say, UIView.background color equals red. You're telling that view to make its background color red. SwiftUI is a little different in that every modifier wraps the previous view in another view. I know that sounds confusing. Again, we're gonna dive into that later. So just remember that modifiers are a whole nother view wrapping the existing view. So when I do font and I do .system, here we go, we're gonna get size, we'll do 32, font weight, medium, and design is default. So that just wrapped the text view in another view, with the font and the system stuff. Same thing when I do foreground color, right? We're gonna make it white. .foreground color .white, right? There you go. Now you're seeing it update. So again, it's getting wrapped in another view. And the reason that is important, and you'll understand that the more you get practice as we go through the course, is the order of the modifier matters. Now, if I do .background color and do color .red, you can see the background is red. Now watch, okay? So that is a view. Now I'm gonna wrap that view in a frame. All right, so let's do .frame, because you can define the frame, and we'll just do a 200 by 200 frame. So now you see on my preview here, you can see the red outline that represents my frame. That's just because I have this line highlighted, by the way. That red outline's not going to be there. Let me highlight the text view, or let me highlight the linear gradient, right? So you can see that's what that red outline means on the preview. Whatever you have selected, it's going to show you kind of the details of it. So by clicking on the text, you can see I have a 200 by 200 frame. However, my background color didn't fill the frame because I put the frame on after I did the background color, right? We wrapped it in a frame, but it already had its background color. So that was a very simple example, but the main thing to take away here, and again, we're going to get plenty of practice with this, is that the order of your modifiers matter because your modifiers are basically wrapping the existing view in another view. And the reason SwiftUI can do that is because views are so cheap in SwiftUI. They get destroyed and recreated all the time. More on that in more detail, right? I don't want to get too into the weeds right now, but I wanted to point out the order of modifiers matter and what modifiers are really doing. Okay, so let's delete that example here. And now we have our text looking like we want it to, right? That Cupertino, California. It's not in the location we want. And let's talk about why. Because a VStack, right, is only going to take up as much space as it needs. If I click on the VStack to highlight it in red on my preview, look how big my VStack is. Only as large as the text is, right? So if you want that VStack to stretch, there's a view called a spacer, right? So if I put a spacer below the text, it's going to push it all the way to the top. So what that means is basically the VStack now is the whole length of the screen, essentially. However, the text is only taking up that top part, and the rest of the space below the text is the spacer. So strategically using spacers to move your UI around is often how you lay out your UI. And you can get real custom with it. You can set a custom height or width on the spacer. More on that later. Just know that spacers will kind of fill the entire space. So that's kind of what we want. However, Cupertino, California is hugging the notch a little bit too much. So another modifier we can put on text is padding. So I can do .padding. This is kind of like a default thing all the way around. And now you can see my red outline on the text has some padding in it, right? It's not hugging the Cupertino, California text so tightly because it has padding around it. So now with that padding, our city name is spaced how we want it, right? It's not hugging the notch too much. And again, you can do padding 100. Okay, now look at the padding I added. That's not what we want, of course, but I want to point out that the padding is flexible. You can do padding only on the bottom, space 200, right? And you'll see now there's only padding on the bottom. So padding is pretty flexible. Now, one thing I want to show you before we end this video is one thing you'll notice when working with SwiftUI is that the list of parameters is often very flexible. Like you just saw that I was able to do dot bottom, dot top with a comma. It almost looked like I was making up my own parameters. Well, let me show you why that is. If you command click on padding, go to jump to definition. Sure, I'm trying to get to the documentation here. Okay, so here we are. Here's the padding implementation, right? Well, what SwiftUI does a lot, not all the time, but you'll see this a lot, is it sets default values for its parameters. So you can see the edges set is equal to all, and the length is equal to nil. So when they give default values, what that means is if you don't include that parameter, it's going to default to the default value, of course. So you'll see that a lot in SwiftUI, where the parameters are often very, very flexible. And I know that confused me at first. I was like, wait a minute, like I can pretty much write whatever I want in the parameter. How do I know what I can and what I can't? And then when you dig into the documentation here, basically it reveals why, because they said default values for a lot of things. So it's very flexible, which I like. All right, back to our code here. So like I said, the spacer is filling up. Sometimes you have to hit resume. As you see, previews can be finicky sometimes. So if you see that resume button, make sure you hit it so your previews are up to date. So now, like I said, the spacer is filling up the whole space. Obviously, we're going to add more elements in here with a VStack. If you go back to the design, now we're going to add our cloud sun icon or whatever weather you want to pick. Put that icon there and the temperature. And that's going to be its own VStack. But in order for me to get that nice looking icon, like that is an SF symbol. So I want to introduce you to SF symbols, show you how to download that and get you started using that, because we're going to use that in a lot of the apps the rest of the course. All right, SF symbols. Well, this is SF symbols 2 at the moment. Maybe it's 3 by the time you're taking this, who knows? Anyway, SF symbols were introduced in 2019, kind of when SwiftUI came out. And as you can see here, it's just a bunch of built-in iconography that Apple provides, and they are awesome. If you haven't used them yet, I think you're going to learn to love them. We're going to use them throughout the course. But the flexibility here, so this is like the official developer site. This is the human interface guidelines site. I'll link to both of these in the description, but to be honest, if you just Google SF symbols, these are the top 2 results, or click the link, whatever you want to do. So here's the human interface guidelines on SF symbols. So you can see they're nice, multicolored. There's 2,400 of them. They're great. They're built into Xcode, free to use. If you've ever struggled to find icons for your app, you know the struggle. That's why these are awesome. Another cool thing is like they have like font weights attached to them. They adapt to dynamic type. They're just great. And by font weights, you can see here, right? An ultralight version of the icon all the way to like a heavy, bold version and everything in between. So they're very flexible, support dynamic type. They're awesome. I'm so happy Apple, started doing this. And again, it's only year 2 in existence and they're already at 2,400. I just imagine that they're going to get better and better and better over time. For example, new in 2020, they announced colored icons. Before it was just monochrome, just one color. You could change like the tint color. It didn't have to be black or white. You can make it any color, but it was all monochrome. Well, now there's like multicolored icons. So that's great. So let me show you how to download it. Again, back to this one, the Apple developer website, not the human interface guidelines. If you scroll down a little bit, make sure you download SF Symbols 2. Not SF Symbols 1.1, because SF Symbols 2 has, 750 new symbols, and it got the multicolored symbols, which we're going to use for our cloud, right? Remember, the cloud was white, the sun was yellow. That's an example of a multicolored SF symbol that we're going to use. So once you got that downloaded and you open it up, and I made it full screen, again, here's all 2,400 icons, right? And you see the categories on the left, but we'll tap on gaming, just an example. So you got all these controller icons, D-pads, buttons, transportation, all kind of cars, planes, cool. So any topic you want over here, click on multicolor. You can click there, or you can click this little color wheel to get the multicolor. Now, you're gonna see most of mine are red. This is because that is my Mac accessory color. If you haven't, I get asked this all the time about my Xcode, how I made it red. If you go into general, quick little tip here, general settings, highlight color, red, accent color, red. You can pick any color you want. Watch when I change this to green. Look, now all my icons are green. So that means whatever system color that the user has, that's what's gonna show on these multicolored icons, at least the ones that have that. So anyway, now you can start to see our weather ones that we're going to use. Here's the cloud and the sun. But again, play around in SF symbols, scroll. You can see there's a ton of cool ones, literally 2,400 of them. So how to use SF symbols, we'll get into in the next video. I'm going to show you actually how. Basically, you just copy and paste this name right here, like docfill badge.plus. And there's a way to copy paste. We'll talk about that. But I wanted to use this video to introduce you to SF symbols, show you how to download it, and definitely download it. Don't just watch this video because we're going to be using this all throughout the course. So get this downloaded and let's move on to the next video. Now that we got SF symbols downloaded, we're back in our project. Pulling up the design again, what we're going to create right now is our VStack with our main weather icon and the temperature. We're going to focus on that for this video. So looking back at our code, right, we have our overall Z stack, and then we have our overall V stack, which again holds all our elements. Right now, all we have is our text that you see at the top there, and our spacer, which fills that up. So we are going to keep the spacer at the bottom and add another V stack, because the V stack is going to hold, again, our SF symbol and our temperature text. So an SF symbol is an image. So if we type image And then here's the thing, like image has a couple different initializers. If you do image name, this would be like just an image in your bundle, like you would have in your UIKit, right? Where you do UI image named string, right? That's the same thing here. However, if we type system name, this gives us our SF symbols, right? So now I need a string. Well, what string do I need? That's where we need to open up SF symbols to find out. So I'm going to tab over to SF symbols, and here we are. I'm in my multicolored section. Again, now we're down to the weather. Again, this cloud.sun.fill is what we want. So you can either type in that string, or if you tap on it and do Command-Shift-C, so just like Command-C to copy, but add a shift in there, Command-Shift-C to copy, that will copy the string. And if we Command-Tab back to Xcode and do a Command-V to paste that in, there you go, cloud sun fill. There it is on the right, exactly how we want it. No, it's not. So, all right. So we didn't get multicolor. We just got this very small, black icon. That's not what we want. Okay, so first let's handle getting the multicolored. So what you need to do there, you need to do rendering mode and then pass in .original. That'll give us the multicolor. There you go. It's still super small, as you can barely see probably, but at least we got the color combo we're looking for. Now, images, when you bring them into SwiftUI, you'll notice like if you bring in like an actual image like from your phone or something like that, it'll blow up to like its actual size. So pretty much all the time, you're gonna wanna make your images resizable, put that modifier. So now when you do that, bam, now it's huge because it's filling up all that space. We don't want that either. So we wanna put a frame around our image to give it like a fixed size. So again, down here, let's add another modifier to our image, .frame width and height. So let's do 180 by 180. And I get asked this all the time when I kind of do tutorials, like, oh, where'd you come up with those numbers? And I'm not doing it on the video, but the honest answer is like, I guess the number, okay, that's too big. And I just slowly tweak it over time to dial it in. So you're gonna see that a lot throughout the course where I just throw out these numbers. Just know that it took a lot of trial and error to like dial it into that number, which is nice in SwiftUI, because look, I can say, hey, 180 or 80 by 80. And real quick, instantly, I can like get a feel for it. So again, just trial by error. So if you don't know these numbers off the top of your head, neither did I just figured it out. Okay, so there's our frame. It doesn't quite look right. Our cloud and sun is more of a landscape type image, right? It's not a perfectly square aspect ratio. And it kind of looks like it's stretching a little bit to fix our square. But we don't want to like adjust our frame. We want our 180 by 180 because if we go back to SF symbols, a lot of these other symbols are a square. So we want to keep our frame a square. We just want to keep the aspect ratio of the image. So there's a modifier. We'll put it below resizable, .aspect ratio, content mode, and we can do .fit. There you go. So that keeps the aspect ratio, but fits it within our 180 by 180 frame. And now you can see that doesn't look like a stretched out image anymore. That's the image we want. So now that we have that, we need to add our text. Again, let's stay in the VStack, right? And our little nested VStack here. So now we want text of, again, a string to say 76. And if you do Option Shift 8, that'll give you the degree symbol. I had to look that up. I didn't know that either. So as you can see in the text, same thing that happened with our image. It's the black color. It's small. It's not exactly how we want it. So again, let's start adding our modifiers. So add our font here. Now, one thing about the way I'm adding font, and we're not going to get into this at the moment. So I do .system. So when I do system size and weight, that is giving me the San Francisco font, which is like the default Apple font. And the other thing is this won't support dynamic type. We're basically hard coding the font size. And one, dynamic type is way too much to get into for this initial app. But two, our city label and our degrees here, we want to be really big. Like they're already big. So they don't really need to support dynamic type because they're already huge. So we want to make this size 70, right? Told you it was huge. And then .medium font weight. And you can play around with this if you want it super bold, if you want it ultra thin, make your own, play around. We can delete that because again, that's one of those default value parameters that I talked about with padding. So again, we have our 76 degrees looking how we want it. We just don't have the color. So again, .foreground color, .white. There we go. Okay, so we're starting to see this come together a little bit. Now, one final touch I want to put on this VStack that has our icon and our temperature in it is you notice there's a lot of space in between there. So there's a couple ways we can do this, right? We could add a spacer here with a very small frame in between. Maybe we could add some padding with a negative number. That's a little hacky. However, VStacks also have parameters. So do HStacks and all that stuff. So if I do the initializer here, you can see I have alignment, spacing, and content. So you can align everything to the left, align everything to the right, or you know, as an example, and then we can set a spacing. So we're gonna use a spacing parameter here. And again, because we can pick and choose parameters because they're all default values on the other ones. So spacing, let's make an 8. Again, I just kind of dialed this in. And you saw the 76 get pushed up a little bit closer to the cloud. And that looks about right. And the reason it's not even a little closer is because remember, the cloud and the sun is kind of like a landscape, right? We had to make it aspect fit. So our frame of our image, if you look, is actually more, right? So when we put a square image in there, it's actually gonna fill it up. So something to keep in mind is some images may not all have the right aspect ratio. So for an example, and I just have this memorized, to be honest with you, I can do sun.max.fill, and that'll give me the big sun. And it's always good to like test your UI with multiple images if they're dynamic like these. So now we can see when it's like full bright sun, maybe it's a little cramped. Maybe I want to add spacing to 10 on my VStack there to bump it out a little bit. You can dial this in. Let's go back to cloud.sun.fill. And there you go. So again, something to think about with SF symbols is they may not all have the same aspect ratio when you use them. Okay, now before I move on to the next video, I want to point something out, right? Here's our overall Z stack. You can see that we're adding all these elements, right? The text, the image here. It's starting to grow a little bit. And you can imagine as we add our HStack with all the other VStack views, right, that you see on the design here, we add our button, this could get a bit unruly. Now, in later videos of this weather app, I'm going to go back and refactor and show you another cool thing about SwiftUI is how you can really structure your code and make your view very readable, right? Because you can imagine if this was much longer, it'd be kind of hard to read. There's a lot going on. We're going to fix that in a future video, but I'm going to lay out all the UI first so you can see what it's like when it's all laid out, and then we're going to refactor it. All right, on to the next one. In this video, we're going to build this HStack of day views, whatever you want to call it, that has each individual day with the different weather icons. But we're going to start this video with your very first challenge. I know it's a little early, we're just getting started, but it's very similar to what we just did. So the challenge here, and just pause the video real quick, is to create this VStack that has the day of the week at the top, you know, the icon in the middle, and then the temperature at the bottom. And like I said, just pause the video real quick because I'm going to get right into actually building it together. You can check your answer then, or if you don't want to do the challenge, we'll go ahead. But I'm going to be issuing challenges like this all throughout the course. And at the end of each app, I'm going to give you a kind of a list of things that you could do to potentially, you know, take this app further if you want to continue your learning and continue challenging yourself. This is your last chance to pause. I'm moving on. 3, 2, 1. All right, let's go. So like I said, we're building this HStack of all these individual days. So again, back to our structure of our screen, right? We have the Z stack with the background of the color. On top of that color background, we have our overall VStack that holds, you know, all of our items. Within that, we have our city text, and then we have our VStack that is our icon and temperature. So now we want to add an HStack down here for these days. So again, HStack. Okay, cool. But now remember, within that HStack, we're going to have 5 individual VStacks. So let's create our first one, and you'll see we'll just end up copying and pasting a lot before we refactor. We're going to refactor this, but we'll just do our VStack here. And again, remember, it's a text at the top because it's our days of the week. So let's just kind of build out the rudimentary version here first. So we'll say Tuesday. And then below that is our image, right? Because this is our SF symbol. Same thing that we have up here. Except, you know, let's just copy and paste this. You'll see this happen a lot in SwiftUI actually. So we'll copy and paste that. And now our frame isn't going to be 180 by 180, right? That's huge. In fact, our frame is going to be 40 by 40 here. Now, you may already be seeing how we could potentially reuse these views, right? Because it was the same thing as this image up here. However, the frame is just different. So you can imagine we could refactor this into its own view and just pass in our frame size, and then we could reuse it and resize it however we like. You know, we may do that later, but that's something you may see as this code gets repetitive. Same thing here with our text of the temperature. Again, we're just going to copy and paste that down here. The difference here is our font. Font is not going to be 70. Here it's going to be 28. So there you go. So you can see it kind of starting to come together. However, you know, we copied and pasted the image in the text because we'd already built that. We hadn't built our day of the week yet, so we're going to have to format this ourselves. So let's do that here. We have our font. Again, we'll do .system. size 16. And like I said, I'm kind of hard coding .medium our fonts right now. If you want to support dynamic type, you're not going to be hard coding this. And we'll give it the .foreground color of .white. And again, back to kind of this idea of refactoring, you can see a lot of the text we use, it has the same font weight, the same foreground color, the same font. The only difference is a size of 16. So you can see how you can make a custom text view that takes in a parameter of just the size. And now you have this white medium, font size text that you can use all throughout your app where you just pass in a font size. All right, so we have our VStack here built, which is the start of our HStack. That's just one. Now what I could do is literally do that, copy and paste this 5 times. But because our file's already getting long, and to be quite honest, my font's got to be big, so it's really hard to navigate around, we're actually going to refactor this part right now. We'll refactor the rest of the file in a later video. But in order to not copy and paste this chunk 5 times, let's do that now. So one cool thing you can do here is if you command click on the VStack, you get a bunch of different options, right? Embed and all this stuff here. Let's focus on the extract subview. So it kind of helps you refactor. So we're going to hit extract subview. And now you see I get a struct down here below the content view. So this is its own standalone thing. If we wanted to, we could put this in its own file separate. We're not going to do that right now, but we could if we wanted to. And it gives it the name extracted view because it doesn't know what we want to name it. So let's call this weather day view. Now let's look here. Remember, pretty much everything in Swift is a view. So weather day view has a variable called body and it returns a view. Like kind of drill that into your brain. We're going to be talking about that a lot. Now to make this reusable, we have to pass in a couple variables. So let's just look at this weather day view by itself and see what we need. Okay, well, the day of the week needs to be passed in, right? It's not always going to be Tuesday. So let's create that variable here. Var day of week, and that's going to be a string. So now that we have that, we can replace Tuesday with day of week. And then we're going to need the system name because not every day is going to be cloudy, sunny, right? Maybe it's rainy, maybe it's windy. So we're going to have to pass in the image name. So var image name, call that a string, or it is a string, not call it a string. And instead of that, we'll pass in image name. And you're going to see how we use this, how we're going to have to pass in this information. And then we're also going to need the temperature. And that is also a string. But actually, you know what? We're going to, even though we're not going to use it like this in this app fully, let's actually make this an int. And then that way, because like if we were getting this back from an API, I don't know, maybe it comes back as a string, but most, it's probably going to be an int if you have like temperature, somewhere in your database. So here we can do instead of 76 degrees, we can do string interpolation based on temperature that we pass in, right? We're going to pass in an integer, but we're going to convert it to a string here. So now we have our reusable weather day view. So now when I create a weather day view, I have to pass in day of the week, I have to pass in image name, and I have to pass in temperature. So let's go ahead and make 5 weather day views up here on extracted view. So we'll do weather day view. It's going to take in, as you can see, I'm going to get that autocomplete back, day of week, image name, and temperature. So again, day of week, we'll start off with Tuesday for this one, image string. For now, let's just do the same that we have up here, the cloud sun fill. We'll go back and make this some variety with temperatures, but we're just kind of testing this and getting our, the structure of our view in place. And like I said, sometimes the parameters can get long. I'd like to put return there. Now, if your parameters are getting like 4, 5, 6, 7 things, you can refactor that parameter it takes or all the properties it takes into its own, object that you can create elsewhere and just pass in the one object. So there's a little bit of a balancing act here. Usually 3 or 4 parameters I start to feel weird about. Anything over 4, I definitely want to refactor that so I'm not passing in like 10 different things. That's just personal code style preference. You don't necessarily have to do that. So again, let's say the temperature is 74 that we pass in. So let's hit resume up here. Again, sometimes your preview will stop. And you can see on our VStack here, we have Tuesday and 74 degrees with the same cloud sun fill that we did. So now let's copy and paste this 5 times. And again, if we had like a data model that had our days in an array, we could actually do this HStack, by passing in an array that would parse out all that data. We don't have that currently, so we're going to kind of do it the long way here. So again, here's our HStack with our 5 weather day views. Now, like I said, we just got the initial structure, but it's not quite right. It feels cramped up against the 76 degrees. So in between our VStack here, which is our main kind of image that you see here, we can put a spacer to push that down. And remember, spacer is going to push it all the way to the bottom. So we're going to do something here, right? So Well, it pushed it down. It didn't push it all the way down to the bottom because I forgot we have another spacer down here, right? So you can see the spacer is filling up the bottom and the spacer here is above that horizontal HStack, right? So you can see it kind of puts it in the middle. So that's the power of spacers, kind of like evening things out. The other thing here is you kind of notice they're kind of cramped together, maybe. So just like VStack had the spacer or spacing parameter here, so does an HStack. I don't know, let's just play around. Again, this is how I come up with these numbers. Let's try 10. There you go, spread it out to 10. Man, that's a little, let's try 20. Oh, not 200. Let's see, 200 is a bit much. Okay, 20 looks about right. All right, so we're getting there. It's not quite perfect, but you can start to see it take shape. Before we mess with it too much, let's kind of get our individual data in there. So let's keep Tuesday the same, because right, Monday and Tuesday are probably gonna be similar. Let's start changing our days of the week. So Wednesday, we'll do this kind of like one property at a time here. Thursday, Friday, and then Saturday, right? So there's our days of the week going across the top. Now let's change our icons, right? We don't want it always to have the same weather. Like let's look at some different weather. And for that, let's go back to SF symbols. So here we are in SF symbols, and you can start to see, and feel free to pick any weather you want. You don't have to pick exactly what I pick. I'm gonna go with sun.maxfill, Command-Shift-C to copy that. And we'll go back to Xcode here, and I'm gonna paste that here, and you'll see it update like right away. So Command-V, bam, there you go. You see Wednesday, now sunny. I'm gonna make Thursday windy. I don't know what that means, so let's go back to symbols. Here's wind and snow. Yeah, let's go wind and snow. It's quite drastic changes here in this climate. So Command-Shift-C to copy that. Back to Xcode, paste it here. There you go, a little snow and wind. Let's see what else we got here in SF symbols. I'm gonna go with this sunset here. Command-Shift-C for sunset fill. And again, pick whatever you want. You don't have to do what I do. But you can kind of see this coming together, right? There's sunset fill, and then it's going to snow on Saturday. That's what we want, just flat out snow, right? It's getting to be that time of year. Actually, you know what? Let's go. Rain's not going to. This is the tricky thing about picking your background color, is that rain blue probably won't show up. So, maybe an issue we have to deal with later. Anyway, pick the snow. Come back here to the snowflake, Command-V. There you go. Now it's snowing on Saturday. And now let's change our temperatures just to kind of reflect that. It's going to be really hot on Wednesday. Let's say 88 degrees. Fahrenheit for those in the US here. Thursday it's windy, it's going to cool down to 55. Friday it's going to sunset, we'll say it's 60, right? And if it's snowing on Saturday, man, it's down to like 25 degrees. Quite a drastic change. But you can see our weather app is now starting to take shape. One thing you may notice is that we picked all the way back in the beginning, right? We picked white for our array. Well, now you can see that white is starting to clash with the white of our text. It makes it kind of hard to read. We can create a custom color because I think a lighter blue would look better, right? So at the top, we go from just the normal blue, and then at the bottom, we go to just a lighter blue. So that makes the gradient more subtle. So let's talk about how you can create your own custom colors. So over here in your XC assets, just like you were dropping in an image, down at the bottom, you can hit the plus button, hit color set, and then here you color, you do any appearance, dark appearance. This is for, light mode, dark mode. Let's do any appearance because we're not going to mess with dark mode in this current app. And bring out your toolbar on the right if it's gone. And here you can pick, your color gamut. You can pick whatever color you want here. So we're going to try to get a light blue. And I'm not going to have like an exact, value here. You can just see it changing colors up there and pick what you want. So we're going to go like very subtle light blue, and maybe a little more. We can test this out and see it. So, but the key here is when you click on color, you want to name it, right? So we'll say light blue, right? You can name it whatever you want. And usually in an app, you're going to have a lot of custom colors typically. So what I like to do is down here, hit plus, folder, create a folder called colors. Let's change that, colors, and drag light blue into colors. That's all we're going to make for this one, but it's a good habit to get into. So back in our content view, now we have a color called light blue. Let's get rid of this side panel. We need the screen real estate. So instead of color here passing in .white, we can do color and then initialize that. And you see we can initialize that with a name. And here we're going to name it light blue, whatever you named your color, right? And let's do a Command B to get this to run, because right now it looked like I put a gray down there. Oh, I got to hit resume on my preview. That's going to get you a lot. There you go. Now it's like a more subtle light blue. You can see it going from dark blue to light blue. Almost has like a teal feel to it. But our white colors stand out a little more. Maybe not much, but a little more. Now, if you look at our design, our HStack is not way down there, right? We got to have room for a button because we're going to be changing to day to night mode later. So instead of a spacer in between our HStack and our big weather temperature, let's delete that spacer and see what happens. So we're going to delete that. Bam, okay, it pushed it up. So it's a little cramped, obviously, right? It's cramped right up on there. But what we can do is we can put a padding bottom on our VStack here that has our huge icon and huge temperature, right? That would be this VStack right here. So we can do .padding and pass in specifically on the bottom, .bottom, and comma, we can give it a value. Again, this is where you just kind of dial it in. Say 40. Yeah, that looks about right. I mean, I literally just pulled that out of my butt, but yeah, that looks about right. And then you got the bottom down there. Now, of course, you know, if we were going really deep into this and we had to, you know, account for all the screen sizes super small, you got to be a little more thorough. But again, this is the intro video, baby steps, right? But now you can see it's starting to be spaced out nicely and we have room for our button, which we're going to add in the next video. All right, so our UI is coming together. We're going to add the final piece, which is the button, just the UI of it. Then we're going to refactor. And then in the next video, I'm going to introduce state and how we can switch from night mode to dark mode and change things based on state and pass that state in a binding down to another view. We're going to start dipping our toes in passing data, keeping it very, very simple. But again, it's just the beginning. So let's get to it. All right, so down at the bottom here, again, remember this whole thing is a VStack, right, on our design. So the last piece of the VStack, I'm sorry, vertical stack V, is our button. So after the spacer that goes after our HStack, which is right here, I'm gonna make some room here. We're gonna create our button. And to do that, it's just button. And button takes in two pieces, right? You have this first kind of closure here, but then there's a second one. You do label, right? So the label, there's a couple different ways to initialize a button. This is what I found is the most common because this first section here is the action. It's what the button does, right? So we'll do right now, just print tapped. This is where we're going to change from day to night in our UI, but for now, button tapped. Label is what the button looks like, right? And it's kind of different from UIKit, where in UIKit, you're actually customizing the button itself. Well, here you just kind of get the functionality of a button and you can make it look however you like. So for example, our button label is actually going to be a text that says change daytime. You can name it whatever you want. And you can see we got our button down at the bottom. Now, what do you think we're going to put below that button to get it off the bottom of the screen? We don't want it down there, right? We're going to put a spacer down there. So one more spacer. Now, something you need to keep in mind when building spacers on and I'm curious if I'll run into it. No, on all these views is a spacer counts as a view. And one restriction on purpose of SwiftUI is that in this whole Z stack, right? In the overall view, you can only have 10 views. As soon as you put in your 11th view, Xcode is going to yell at you and say, you know, you can't do this, right? So if we count ours, we have our gradient background view, cool. We have our VStack, right? Now, nested stuff doesn't count, right? So linear gradient view is 1. Our VStack with our big icon is 2. Our HStack with our days is 3. The spacer's 4. The button is 5. And this last spacer is 6. Okay, so we're well below the 10, no big deal. But something when I was learning SwiftUI that I kept running into is, you know, I'll admit my mistakes, right? I was overusing spacer, right? And you could argue I'm even overusing it here too. And I was hitting that like 10 view limit a lot. So something to keep in mind, spacers are great, but you can easily kind of overuse them and kind of run into trouble there. And real quick, the solution to that 10 view limit is to refactor your views, right? Refactor it out into another HStack here, refactor it out into its own separate VStack, you know? So there's easy ways around it through composition. So I don't want you to think that like it's super limiting. It's to prevent you from creating like SwiftUI's version of massive view controller. You know, you don't create massive view, right? It forces you to kind of refactor that. So anyway, now that we put our spacer down here at the bottom, you can see our button is up higher. But we just have the default button layout, right? We don't want that. We got to make this look pretty good, right? So first thing I'm going to do is give it a frame. And the width is 280. And this is just 280 by 50 is kind of like my go-to button frame. And you can see the red outline down there of what it is. And to be honest with you, that's kind of like the typical default Apple button nowadays, right? It stretches out the screen. It's pretty thick, easy to tap. So now you can see our frame. Let's give our frame a background color. Dot background. And that's going to be color dot white. Right, there we go. So there's our button. And let's actually, I like a big bold font on my buttons. Personal preference. You don't have to do this one if you don't want to. So we'll do font. And again, we'll do dot system, hard code it. And we'll say 20 of dot bold and design.default. There you go. So nice big chunky bold font. And then the The final piece of the puzzle here is rounded corners, which you can't see because of this red outline, but if I click somewhere else, right, you see it's a very blocky button. Again, I go for the default Apple look, get a little bit of a corner radius. So the modifier for corner radius is corner radius, dot corner radius. And real quick, it may seem like there's tons of modifiers and it's going to be impossible to memorize those. However, there's a group of them that are very, very, very common that you're going to, like frame, font, background color, corner radius. You'll get very familiar with those. But, you know, I could go through modifier by modifier, making a video for each one. I feel like that's kind of a waste of time. You'll learn and you'll pick those up over time as you use them. So let's make this corner radius 10. And if I get rid of that red square, now you can see our nice Apple default looking button. So our UI, without the whole night mode stuff, is done. Great. What'd you think? How'd that go? Right? Not so bad. Again, I went very quick, but we're going to dive into a bunch of different apps. We're going to do this over and over again. I'm very confident you'll have the hang of the UI part at the end. Because if I'm being honest, like the UI part, the HStacks, the VStacks, like that's kind of the easy and fun part of SwiftUI. It's the passing the data that really trips people up. So that's what I want to focus on. But anyway, UI is done. Let's start refactoring this thing. So let's start from the top. And my big disclaimer here is SwiftUI is so early. How you structure, how you refactor, how you compartmentalize your code. Like a lot of us iOS developers are still trying to figure out best practices. So I'm kind of figuring out the way I like to organize. I will, give the disclaimer that if you ask me in 2 years, I'll probably be a little different. Best practices will be established. However, I do think this initial way is a good way to start. And then hopefully you and your learnings can evolve as the SwiftUI best practices evolve. You're just super early that hasn't really been established yet. So starting with the linear gradient, we're just going to create a view called background view, right? So command click, and you can see the extract subview down here. So now we just have extracted view. Let's go down to our struct here at the bottom. You see we got our extracted view that we just kind of did that. Well, I'll do the next one manually so you can see how both work. Because to be honest with you, sometimes that extract subview is a little wonky and it doesn't work all the time. So I usually end up doing it manually anyway, but I wanted to show you that. So we'll probably do the rest of them manually. But let's call this background view here. And okay, let's talk about what we want to pass in here. Because if you look at the design here, night mode has a different gradient. So we want to be able to pass in the different colors, right? So we wanted to pass in, blue and light blue or whatever the colors we need. So we probably need variables here, right? So var, call it top color, and that is a color that we pass in. And let's call var bottom color, and that's a color that we pass in. And then let's replace this with bottom color, top color. Top color goes first, top color, bottom color. There you go. So now that view is refactored, and we will now replace, all that up here with, instead of extracted view, let's call it background view. And I'm going to tell you why here as soon as I'm done with this, why this is helpful and makes things more readable here. Okay, looks like I lost my autocomplete here. Let's see what's going on with background view. Okay, silly mistake here. This is the problem when you're kind of like talking while coding. So I put variables inside the variable called body. You cannot do that. So what needs to happen, as you saw that we did up here with weather day view, those variables and properties need to be on the struct itself, not in the view. So I put them in the wrong spot because I was talking and explaining, kind of half paying attention. So now if we do Command B, that should be all good down here. We still got build failed because our code is messed up at the top, but background view here is now good to go now that the properties are on the outside. Small little misstep there. So background view, that explains why I wasn't getting my initializers here. So let's try to type that again. My habit, like if I don't get the autocomplete, I don't feel good about it, right? So I like to make sure I get that autocomplete. So background view down here, and there you go, top color, bottom color. So let's pass in .blue. And pass in color with the initializer of a name called light blue. And even though this may seem like it didn't save a lot of lines of code and is very similar to what we just did, well, one, you're going to see the flexibility we introduce when we go to like night mode, but two, it just makes your screen read a lot nicer, right? Background view, top color, blue, bottom color, light blue. Cool, pretty simple. You get that. And then as you rename your other views that you refactor, your screen is going to read quite nicely. All right, let's keep it moving. Here, this text, we have our city name. So we'll copy, and then now we're gonna start doing this manually here. For now, I'm gonna put all these in the same file. I'll talk about project organization after we get it refactored and how we move stuff around. That'll come in a little bit. So let's do struct. We'll call this city text view, and it conforms to view. And then if you just type var body, you'll get the autocomplete. So body some view, there you go, that's the same structure. And now if you look here, if we want to make our city text a little bit reusable, we just need to pass in the text, right? The city name. So here, the variable on city text view can just be var city name, that is a string. And because I've already copied that text view, I can come down here, do paste, right? So instead of Cupertino, we can just do city name, and now this is reusable. So back up, and then now you're gonna start to see the readability here. So instead of just this glob of text, city text view, and pass in the city name, and now we can do Cupertino, California. Hope I spelled that right. We'll see. Hit resume on our preview just to make sure. I always like to do it a lot, do a Command B to make sure everything is all good, and looks like we're good. Nothing changed. But now you can see how our screen is reading a bit better. So now let's refactor out this VStack that is our main kind of weather. So again, I'm going to copy this, and down here at the bottom, we'll create another struct. Again, this is kind of probably starting to get repetitive, but you'll see that all this repetition is really going to help you learn how all this stuff works. And this is the first step of this, right? Because right now we're just refactoring out the views, but eventually when we're passing data around, we got to make sure these views have all the correct data. So I want to make sure you understand how to refactor these views before we add the more complex step to it, right? So we'll call this main weather status view. Naming's hard. If you don't like that name, name it whatever you like. That's fine. So here's what I like to do here. First, we'll do var body. Before I do my variables, I like to paste what I copied in there, right? I copied and pasted this, and by looking at this, I can see what variables I need, right? Like I'm going to need an image name, right? Because it's not always going to be cloud sun fill. So var image name, and that's a string. Cool. Now I can plug in image name here, and it looks like my temperature is going to be dynamic. So same thing we did up here with the weather day view. Temperature is an int, so I'm going to copy that. I mean, you could type it out if you like, but I'm going to paste that. Looks like I forgot to copy the v. All good. So var temperature is an int, and again, just like we did before, very similar. String interpolation, temperature. Cool. So again, now up here in our view, clean this up a bit. We can get rid of this VStack and just call this main weather status view. Completion here, string. We want the image name to be cloud, and I'm just looking down here to remember what it was. Cloud.sun.fill, and the temperature 76, right? And again, if it gets too long, feel free to bring your variables down like that. I like to do that. Okay, cool. So now let's make sure, do Command B. I always, again, Command B after I refactor, make sure everything's good, make sure my preview's right. Cool, again, now you're starting to see the readability. I have a ZStack with a background view. Now I have a VStack with the city text view, the main weather status view. A new developer coming into this screen is gonna really know what's going on based on how you structured your refactor here. Now this is where a debate could come in, and I do think you can take what I've been doing, I do think you can take that too far. So there's like a balancing act. For example, I kind of think leaving this HStack, even though it takes up a lot of code, right? Remember the goal is not to be like, let me get my content view to 3 lines of code, right? Because oftentimes getting it that short makes it a little hard to like understand. I kind of think that leaving this HStack, if we didn't have an array with our data and passing an array, that's a totally different thing. If you're familiar with SwiftUI, you know what I'm talking about. But in this circumstance, I think this makes it very clear what this is on the UI, right? Because you have 5 weather day views. It's pretty straightforward what's going on here. Yes, it is an extra 10, 15 lines of code that you could refactor out. But again, getting down to 3 lines of code is not the goal. Making it easy to read and understand is the goal. So I'm going to leave that there. I'm going to leave this spacer here. And one thing I like to do with my buttons here, well, first get rid of the space. I don't like that. So I'm going to refactor this text out into a button. And I do this with my buttons because, again, this is like a default looking button, right? You're probably going to use this type of button all throughout your app. So again, let's create another struct down here at the bottom. And like I mentioned, we're going to do some project organization next. These can be in separate files, but I'm putting them all here for now. So not var, struct. Let's call this weather button. And I just like to kind of put like what type of app it is. Usually it's just like SA button you may have seen in my previous videos for Sean Allen button, or GF button for GitHub followers button in my previous course. So I like to put something about the app in the beginning of it. That is a view. And again, var body some view, you're going to type that 1,000 times. You'll be very used to that. And again, I paste in here to see what variables I need. Okay, so let's look. So I'm going to need a title, that's for sure. So var title, it's my button title, that's a string. So let's change this here to title and zoom up here. Now, I'm probably going to want to change the background color and most likely the foreground color as well. But you see, I don't have foreground color here. So let's do type foreground color, just put in .blue for now. That's what it is as the default. But let's actually make these variables here. So var, let's say text color, just to make it very clear. That is going to be a color. And then background color, also a color, right? So instead of background being color.white, it's going to be background color. Nope. Kind of the perils of naming your stuff close to the default stuff here. And then text color, right? So on our weather button, we're going to pass in a title, text color, background color. That makes it so I can reuse this button in a lot of different contexts here. So again, up here, instead of this button, we're going to do weather button. And then we're going to pass in the 3 parameters, right? Title is change day time. Text color is .blue. And background color is .white. And again, you can leave it one line if you want. My text is so big here that I'll put that on 3. So again, now you can see our button, what it does. It's just going to print something for now. We're going to fix that. It's a weather button with the text, title, color, background color. So that's reusable. So that is like our very first pass at refactoring. So you can see how to extract the views into their own struct, which again, I have the whole list of them down here, right? The weather day view, the background view, city text view, weather status view. Now, when it comes to organization, I want to talk about this. I'm not actually going to create new files and move them around. But again, like this is a standalone struct as an example, weather button. Like actually, you know what? I am going to do that. I lied to you. Little ad lib on the fly. So I'm going to do Command N in the Swift weather, do a new Swift file, hit next, call this weather button. And the reason I'm doing this for weather button is because, like I said, weather button is the type of thing that you are going to use all throughout your app, right? That's very reusable. Your buttons should all look the same or similar. So that is something I want out of this file and outside of it, right? Now, if I do a Command B, well, it's going to say, oh, I didn't import SwiftUI. Import SwiftUI. I copied and pasted over some important stuff. And you see invalid redeclaration. That's fine. That's expected. That is because I still have it here. But once I delete that there, done. So again, on the topic of project organization, as that example, if a view that I've refactored out is going to be used all throughout the app and elsewhere, definitely I put that in its own file. However, if a view is very unique and specific to the current screen that I'm on, but I just refactored it out to make my screen more readable and easy to understand, like you see here, then I keep that in the same file, right? So you get that distinction. If it's unique to this screen, I recommend keeping it in the same file because it's easy to find, less confusing. If it's going to be used all over your app or in other screens of your app, put that off into another file. All right, so that's the refactor. In the next video, we're going to dip our toes into actually passing data. It'll be pretty simple, but you'll get to start seeing how SwiftUI handles view updates based on a source of truth with data. I'm getting ahead of myself. Let's go to the next video. We left off last video with a bit of refactoring and dipping our toes into project organization, which we'll get more in depth later. In this video, we're going to introduce the passing of the data and changing from day to night, like you see in this video, based on a Boolean, and start talking about state in SwiftUI. All right, back to our code, our weather day view that we refactored. Let's go back up to the top. Let's add what's called a state variable, and I'll give you the quick explanation. But like I said, the bulk of this course is going to focus on, at state, at binding, at state object, at observable object, passing the data. So this is like just the very first steps of it. So don't get me wrong, this took me a long time to wrap my head around all the data flow in SwiftUI. So in this app, if you leave this being like, I have no idea what's going on, don't worry, we're going to hammer this home over the next couple apps and throughout the rest of the course. So state private var is night, and that's going to equal false by default, right? So do Command B to get rid of any errors here. Okay, so big picture, again, we'll drill down later. The way SwiftUI works is you don't directly update UI. You tell some source of truth, some piece of data. In this example, that source of truth data is this Boolean is night. So you set up your UI to handle if is night is true and if is night is false. And you can imagine we're going to change our background color based on is night true or false. So your UI is waiting for that change. And when that change happens, your UI is like watching that source of truth And when that change happens, your UI will change. Like it's reacting to it, right? It's declarative programming versus imperative programming. I have a whole video in the next section all about that, but that's big picture, keeping it simple. So what we need to do is set up our UI to handle both cases. Like what happens if isNight is true and isNight is false, okay? So what we're going to do is just change the top color and bottom color on our gradient view. If you're familiar with ternary operators, we can do isNight, and then if it's true, we'll do .black, and if it's false, we'll do .blue, right? That's just for our top color. And then for the bottom color, because this is going to get too long, again, let's put our parameters on a separate line here. So same thing, isNight, and it's going to be .gray if it's true, and if night is false, it's going to be light blue. So if isNight is false, it's going to look just like we have it here. However, if isNight is true, we're going to change it to black and gray. So let's try this out here. Down in our button, remember we just did button tapped. Now we're actually going to flip that Boolean. So we can do isNight.toggle. So no, not custom mirror. What are you doing, Xcode? Toggle. All right. So now when I tap the button, it's going to just toggle from true to false. And based on that, our UI is going to be watching it, and it's going to adjust our background gradient accordingly, right? So you can either run this on your device if you want, run it on the simulator, or the nice thing about previews, if you hit this play button and you'll see the background will change to this like grayish blue kind of thing, that means your app is like actually running and you can interact with it. So watch what happens when I tap the change daytime button. Bam, now it's into night, just like that. So what's happening is right now isNight equals true. When I tap this, isNight equals false. And now my UI knows that that source of truth of data changed, and then it updates accordingly. Now let's make some small tweaks here. So if I go back to night, well, it's still sunny and cloudy at night. Well, that's a little weird. So let's go to our main weather status view, and the same thing we can do here, right? We can do isNight. If isNight is true, we don't want cloud sun fill. We want moon stars fill, right? You see it here? Or you can do just moon or whatever you want. Who cares, right? Sparkles, whatever you want to put in there. I'm going to do moon stars fill. Back to Xcode. Do Command V to paste that in there. So now if isNight is true, we're going to show the moon. If it's false, we're going to show the cloud sun. Hit change daytime, and you'll notice I didn't have to stop my preview and restart it, right? It's hot reloading the code. So this is the nice thing about previews when they work. But you see now when we're going from day to night, we're also changing the icon back and forth, right? So that's pretty cool. So that is the very, very basics of how Swift's data flow works. Again, you have a source of truth, your data model, and when that changes, your UI updates. Now the trick is making sure you set up your UI properly and making sure the UI is, listening to the right stuff to update. You got to make sure your model objects is publishing its information. You got to make sure like things are listening. So that's kind of the tricky part of it. Again, we'll get to that. One last thing, right? So we covered state. Now let me give you, I'm going to dive into this later, but real quick, the reason you put state variable in front of it is if you're familiar with your structs versus classes like Swift 101, structs are value types. So they don't hold state, right? They get destroyed and recreated. So how can you make a struct hold state? Well, that's what this state property wrapper is for, right? So if you can imagine this view called content view is just a struct, and it gets created and destroyed all the time, created and destroyed. That's what SwiftUI is all about. Very cheap views that get created and destroyed, redrawn all the time. However, this little piece of this view called isNight, this little piece of data, this Boolean, has state in front of it. So that means that gets put off somewhere else to keep that state, while the rest of the view is constantly created and destroyed. This keeps state. So super basic explanation, but hopefully your mind is starting to see how like SwiftUI works a little bit. Okay, so now onto that final piece I'm going to talk about. We're going to refactor background view even more so we don't have to this is kind of like messy, and it's going to introduce binding. Okay, so let's go down to our background view. Okay, so we don't want to use this. We don't want to pass in a top color and a bottom color. We want to pass in var is night, and that is a bool. Now, this isNight needs to keep state, like we just talked about, right? It needs to always know, am I day, am I night, what am I showing? Because again, this view could get recreated and destroyed. Now this isNight variable always needs to match this isNight variable, right? Because it's the same thing, right? This view is a child of that view, right? We're passing this isNight variable down the view hierarchy to the children. So they need to be the same at all times, right? So that's what binding is for. So if I put binding in front of at here, so binding var is night, and then we're going to have to do that logic here where is night, this is what we just did before, dot black if is night is true. If is night is false, we do dot blue, and then let's delete top color because we're done there. And same thing with bottom color. Again, is night. If that's true, we're going to use for the bottom color dot gray. If it's false, color initializer name. Remember, this is exactly what we did up top. You could even copy and paste it if you like. So that way, every time we use our background view, like right here, every time we use background view, if we're using this, all throughout the app, we would have to pass in these kind of colors. Well, now background view just takes in a binding, right? Is night, but you can see it's not just a bool, right? It's a binding bool. So I can't just put is night, right? Because it's not binding. Because down here in the background view, I specifically said this needs to be binding. And again, what binding does is makes it so my is night variable on my background view is always the same as this is night variable, right? So to do that, you put a $ in front of it. So that makes it binding. So now I'm passing into my background view a binding to is night, right? And then now here, so that means on my background view, this is night is always going to be the same as this is night. That's what binding does. So back down in the background view, we should be good to go here. And then again, it's just a little cleaner up here. Just background view is night, you pass in is night. So let's stop this just to be sure, rerun the preview. And now if we do this, it should work the same. Yep, it works the same. And that's a very basic example. I just wanted to introduce the concept of binding and how when passing it down, that's the key, passing it down the view hierarchy to the children, right? Because the background view here in this circumstance is a child of the content view, right? It's part of the content view. So we can pass the binding down the view hierarchy. Now, in more complex apps, you could imagine like you could be passing a binding down 6 views down the view hierarchy to use it. There's other ways, things like the environment, we'll get into that later. But again, this is the basic introduction of state and binding. Those are the 2 most basic ways to pass data. We're going to be doing that a lot throughout the rest of the apps, but this is your introduction. So that finishes off this weather app. I want to leave you with some challenges that you can take this app and go even further with it. Another challenge, and this is more towards those who have experience building Swift apps, create a data model that you don't have to individually pass in this stuff, right? You can have an array of like a day, right? And a day would have, a day of the week, a temperature, an image name, or maybe a weather enum that you pass in that has the specific image attached to it. You can make this neat and represent a data model that's a bit more, it's not advanced. It's kind of basic iOS knowledge. But if you are like a super beginner just learning SwiftUI, that may be above it. But if you have app experience, you should be able to do that. So that'd be a good challenge. And then if you really want to take this far, create a network call from a basic weather API that will take whatever city you want and it'll actually give you the next 5 days of weather. That's taking it pretty far, but my goal here is to give you the basis of an app that you can tweak yourself, build upon all that good stuff. Or maybe you put a tab view that shows 5 different cities based on that API. I don't know, have a ball with it. Here's the basis. Those are some challenges you can do to push yourself. And if you have questions about those challenges, feel free to ask in the Slack channel. I'm sure plenty of people will help you out. So that wraps up the weather app. And again, if I went super fast, you felt like I was throwing a lot at you, this was just so you could see it in action. In the next section, I'm going to do a lot of talking head explainer videos that do a deep dive into a lot of the theory and the concepts. But again, because you've seen it in action, now when I explain that stuff, hopefully that connection can be made. Whereas if I just started off explaining things and you never seen it in action, it's kind of confusing. So again, that was the purpose of this, just to give you a taste of it. In the future apps, we're going to go a little bit slower. We're going to dive into a lot of the details, and you're going to get a lot of practice and repetition because, to be honest with you, a lot of it's the same when it comes to like the UI and stuff. In this video, we're going to update the weather app for iOS 15 and fix some issues we had before. Now, this is a pretty basic app, so the only new iOS 15 thing we're going to explore is the new SF symbol stuff, but I want to clear up an issue with binding that I originally did on this app that will maybe clear things up, and then we'll talk about some deprecated syntax that usually happens when a new iOS version comes out. Okay, so here I am right where the project left off. So hopefully you're in a similar version that I am. But the first thing I always do anytime a new iOS comes out is you click on the project here, right? And then now you want to target, if you click on project, iOS deployment target iOS 15. Now again, this makes your minimum target iOS 15. Like I said in the iOS 15 update overview, very, very few apps can actually do this. Usually they have to support iOS 14, maybe even 13. But again, for checking things, I go to iOS 15 because then I'll get all the errors if I'm using stuff that like doesn't work. And again, this is a super beginner teaching app, so we're not worried about supporting like older iOS versions. The whole point of this is to show you the new stuff in iOS 15. So now that I am supporting iOS 15, I do a Command B to do a build. And doing that will show me any errors or warnings that I have. You can see I have 2 errors up here. Let me go to iOS 13 Pro here. Maybe that's the issue here. I'm not sure what errors I have. Yeah, those errors were because I was not on an iPhone and it didn't quite get it. So make sure you have the iPhone 13 in your simulator to clear that up. Okay, so into the content view. The first thing I want to talk about is deprecated syntax. Because like I said, this happens every iOS update. Usually you'll get a warning for them if they're like being close to actually like not working anymore. But what's deprecated, and actually we'll go down here. This was actually deprecated in iOS 14 and I missed it. And that's another lesson is like, you're not going to catch all the deprecations right away. Well, let me back up because this is a beginner course. What does deprecating even mean? Well, Apple will change the language of Swift or SwiftUI and, they'll try to constantly improve it. So sometimes they'll change the syntax of old language and, just change the way you do things. The good thing here is when they're deprecating something, they'll usually give you like a couple years warning. So for example, like this edge is ignoring safe area still works great. You don't even see any warnings. That's what I'm saying. So that just happened last year. So probably in like a year or two, you'll start to see warnings. And then maybe another year after that, then they'll finally break your code. So don't worry about deprecations too much. It's great to stay on top of them and not like wait for it to break your code. But like I said, Apple does give you plenty of warning. And we can see that if we option click on ignore safe area and go into open developer documentation, you can see on the right, deprecated. Now you may be wondering like, well, how do I know if it's deprecated? A lot of times you got to look in like the Xcode release notes. In the iOS developer world, after WWDC in like June, so from June to September, Xcode betas are coming out. Everybody's looking at the documentation. You're seeing all the new deprecations. A lot of people are talking about them on Twitter. So unfortunately, at least not that I know of, there's no like centrally located list you can go look at. I guess keeping up with the Xcode beta release notes will show you. But like I said, try to keep up with them that way. But if you miss one or two, it's not a huge deal. And then again, in probably like a year or so, you will get the warning that tells you this has been deprecated, check out the new thing. So the new thing is ignore safe area. And like I said, this was deprecated in iOS 14. So I missed this one. But again, no big deal if you miss it, come back and fix it. So that's just the big picture lessons on deprecations. And with SwiftUI, because it's so new, it's so young, you're going to see a lot of like changes early on. Over time, as it matures, that will slowly happen less and less. But again, we are in the beginning, so you kind of got to expect that to happen. Now, the next thing I want to point out, since we are in our background view, let me refresh your memory. We refactored out this background view, which again is this black and gray here gradient. For example, I'm going to go to isNight equals false to go back to the blue. And there we go. I like that look better. So we have isNight is false. Now you see this background view, which is what I was talking about. We passed in isNight. Now, if you're doing this course from the first time, this should be very fresh in your mind. If you're coming back, maybe it's not so fresh. But what we did here in the background view is I passed a binding down to isNight. We don't have to do that in this case. To be honest with you, I'm not sure why I did that here, but this is a good learning opportunity. Good chance for me to actually show you more of what binding does, because anytime you do something wrong and then you come back and fix it, usually you learn it more that way rather than doing it right the first time, as weird as that is. So we messed this up before because the whole purpose of binding is if in our background view, we're going to change this isNight variable. Like maybe if we tapped our background view, we changed it from isNight to true or false. Maybe that was how we changed the background. Then yeah, binding would be good. And we would have to change isNight down here in our background view. But because we're only like reading, I guess, if you think about read, write, right? We're only just looking at what the value is and then adjusting our background color accordingly. We don't need binding, right? The whole purpose of binding is if we were going to change this variable, because again, it's bound to our initial variable up here on line 12. So if we changed it in our background view and it was marked binding, this would also change. But we're not doing that in our background view. So making it binding, there's no reason to do that. So we'll delete that $sign there as well. So apologies for the confusion. We'll discuss binding more, I believe, in the Appetizers app we get into it. But apologies for any confusion. Hopefully that cleared it up. Again, only use binding is if whatever view you're passing that value to, for example, it was our background view, you're actually going to change the isNight variable. Because we're not changing the isNight variable, there's no reason to make it binding. All right, the last thing we're going to do on this weather app is actually the first new in iOS 15 thing, right? The previous two things were fixing some mistakes, but now this is new in iOS 15, and that has to do with our SF symbols. So before we get into that, let's look at Safari here, and I'll link to this in the description. SF symbols 3 is the new thing. So you see it added over 600 new symbols, enhanced color customizations, which is the main thing we're going to discuss here. But check out this link. Here's what we're going to deal with here, right? This enhanced color customizations. So it got a new hierarchical and palette rendering. So what hierarchical is, I'll keep zooming in here to make this image bigger. I guess the image isn't getting bigger. Funny, I zoomed out and made it bigger. Anyway, hierarchical is this second row. You see how it's kind of like the same color, but there's like layers to it? Like there's like a brighter blue and a dimmer blue. So hierarchical gives it layers, and if you have the same color with hierarchical, it'll look like this, kind of like the monochrome look. Whereas palette gives you full control over these layers. So you can make them all kinds of different crazy color combinations or whatever fits with your app. And that's what we're gonna play around with. So back to Xcode, let's deal with that here. And we'll do that in our main weather status view, right? Where we have our image, which we're passing an image name, which again is the SF symbol that we pass in, which we did up here, right? How we did, wind.snow, sunset.fill, snow, right? So that was just a quick little recap. But we're basically just gonna mess with the modifiers on this image, right? And you can see the little red squares on my preview. Those are the images that we're dealing with here. So we did rendering mode original to get the multicolor. So you don't wanna mess with that anymore. You wanna do symbol rendering mode. And then you're gonna see, or if you do a dot, you can see the options. So as we just talked about, hierarchical, multicolor, palette. So if we want what we have now, we would do multicolor. Do a Command B, nothing should change because that's what we have. Okay, now let's go hierarchical. And then we have to give it a foreground color. Where you can see it's black by default, and you can already kind of see the layers. I'm gonna zoom in really close to our SF symbols here, right? You can already see the layers even though they're black. If you wanna change the color, gotta do it after resizable. Do foreground color, let's say .red, and those will change to red, and you can see the depth, right? We got really bright red and then like a 50% opacity red. And real quick, the reason you have to do this after resizable is because the resizable modifier is only on an image. So as soon as we put a foreground color modifier before that, it won't be an image anymore, it'll just be a view, and a view doesn't have resizable. I believe we get into that in a little bit when I talk about modifiers and how you're just building like layers and layers and layers. So that was a little preview. You'll see that in a little bit. Okay, now let's mess with palette, because palette is the pretty cool one, right? So palette here, nothing, well, I guess it did change. Everything's all red. So a palette has 3 colors you can give it. So instead of foreground color, we'll give it foreground style. And then you can see, actually, that's not the initializer I wanted. So I want to do foreground style. And then like, look, so that was just one color, but you see we got primary, secondary, tertiary. So this will give you 3 colors. And here's how this works, because some of these shapes, I think ours are only gonna have 2, but some of our SF symbols have like 3 layers of palette. So you gotta give it 3 colors. So we're gonna do .mint, .orange, and then green for our third one. So the first 2 colors, right? If your SF symbol only has 1 layer, okay, mint's a bad color. You can barely see that. I guess we'll do pink here. So like I was saying, if your SF symbol only has 1 layer, like our Wednesday sun, that only has 1 layer, so that's gonna give you the first color, which is pink. If your SF symbol has 2 layers, which you can see Tuesday, Thursday, Friday has 2 layers, well, the second layer is going to be orange. So you can see how that works. And then I don't think any of ours have 3 layers. No, but some of the SF symbols do have 3 layers. So that's what this third color will be. So you can see if you have a certain like brand color scheme going on, you can change your SF symbols to have different layers to match that color scheme. So big picture, we're just getting a lot more control over the SF symbols. And again, if you just want more of the same color look, hierarchical, and then you don't do a foreground style, you just do a foreground color, and then we can do .pink, and then that'll give us, again, that kind of pink layered look right there. Hit resume on the preview, just make sure we're good. But that is new in iOS 15, new in SF symbols. Again, SF symbols are constantly growing year over year. They're getting better and better and better. I love them, and just the addition to completely customize the color is a super good one. So that's what's new in iOS 15 in the weather app. let's move on.
Here I am in the weather app where we left off at the end of the iOS 15 section. You can tell because the colors of our icons are all messed up. So first thing we want to do, go to our project here. Minimum deployment target is iOS 16. And same thing here in your target, iOS 16. There we go. Do a Command B, make sure everything is okay. Cool, build succeeded. Go back to our content view, get preview back up and running. Cool, everything looks good. Let's fix these colors real quick. They're bothering me here. So rendering mode, back to multi-color, and we'll just comment out this foreground style just so you can still see the code, but we're not gonna mess with that, obviously. Okay, let's talk about this gradient here. So we have our gradient view, or background view, I'm sorry, that is our linear gradient. iOS 16 introduced a simple modifier, .gradient, that will give you a default, very subtle gradient. Now, I want to stress it's the default one, so you can't really customize it, right? So when you make this linear gradient view like we did, as you can see, you can customize the exact color, you can do the starting point, the end point. So to be very clear, if you need a super custom gradient that you want to mess with, you're still going to need to stick with this. However, on things like buttons or certain views, a default simple subtle gradient works perfectly. That's what I'm going to show you. We're going to do it for our background and we're going to do it for our button. So I'll comment this out so you can still see that and you still have the code here. And we want to do a container relative shape and we want to give this a dot fill. You'll see, so there it is. There's a shape, it's just black, but we want to give it a fill. And we want to do color dot blue dot gradient. And I just want to show you this first. So let's actually do dot ignores safe area, so it fills the whole thing up. So you can see it's a very subtle gradient. You might not even have noticed it. Let me go back to line 105. Let me delete gradient. So there's just blue. Okay, so look at the top part of the screen, and then dot gradient. So you can see very subtle, but this is Apple's default gradient that they use all throughout their system. Now, of course, we don't always want blue, right? We want the ternary operator of is night. If night is true, we want color dot, we're gonna do black dot gradient or color dot blue dot gradient. So now let's tap change daytime. That goes to night. And again, you can see the subtle gradient. It's actually more prominent on the black. You can definitely see the gradient, but maybe you don't want black. Maybe you want gray. I don't know, I'm kind of trying this in real time. Oh, change time of day. Nope, gray's too light. Yeah, we'll do black. But anyway, again, this gradient may not work. Maybe you do want the more custom gradient where you can customize the angle and the specific colors. For that, you would still need to use this linear gradient. However, if you want just a simple, subtle gradient and just a simple modifier of dot gradient, this is a great way to go. Let's do this on our button too. Let's go to weather button here. So instead of background color, we're gonna do background color dot gradient. And that's what I like about it. Super simple. You just type dot gradient and you can see the subtle gradient that we get there. Now, if we go to our content view for our button here, we'll scroll up to our button. There you go, where we have the title, text color of blue. Let's do background color of, because you can't really see the gradient on white. Let's try dot mint and text color of dot white. Right? You can play around with different color combinations, but that's how you can see the very subtle gradient on the button. So that's the new way in iOS 16 to do gradients. Again, it may not suit your needs. That's fine. Use the old gradient and customize it. However, if you're just looking for a super simple gradient, this is beautiful. I know I'm going to use this on a lot of buttons in my apps.
Now that we've coded a bit and seen the basics of SwiftUI in action, the next few videos are going to be a couple of explainer videos, just kind of talking about how SwiftUI works, kind of in the big picture sense, to help your mindset maybe shift to thinking in the SwiftUI way. And after you have the basic understanding from the next few videos, we'll get back into coding to put those principles into practice. Okay, so this first video is going to be talking about declarative versus imperative, because if you're coming from the UIKit world, that's likely the methodology you've been using in your previous iOS developer career. Now, like I said, SwiftUI is declarative. It's a whole different way of thinking. And to be honest, this is probably the hardest part of coming from UIKit and learning SwiftUI is getting your brain to switch. Because as I'll explain in a second, like the way you think about things is kind of like flipped on its head a little bit. I know this was like one of my biggest struggles because, I've been doing UIKit for about 5 years now. So my brain is just, in the habit, that muscle memory of just thinking that way. And like I said, you have to change the way you think. I know I've said that before, but it's kind of tough to break the habit. And it was only after a lot of practice, a lot of frustration, a lot of headaches that my brain, finally flipped. And to be honest, I don't think it's fully flipped. I still revert back to that UIKit way of thinking sometimes, but I'm getting there. Okay, so I've been throwing out this imperative, declarative words. You may not know what that means, so let's break that down. So imperative, like I said, is the old UIKit way of thinking. And in that methodology, you are specifically telling your UI what to look like all throughout the execution of your program. So that means there's like two code paths, right? There's the code path where all your logic is changing, you're changing all your data. And then as you're going along that path, changing everything, at every moment in time, you have to be telling your UI, okay, UI, something changed, now update. Okay, something else changed, update, right? You're managing these two code paths, your logic and your UI, and they always had to be in sync. And that's a lot easier said than done, and this was the cause of a lot of bugs. Well, declarative gets rid of one of those code paths entirely, right? You've heard me mention in the previous videos, all we do in SwiftUI is update our data and our UI responds accordingly. Now that sounds like magic the way I just said it, but here's how it actually happens, right? We declare, or we give all the rules for our UI up front, right? We give all the possible states our UI can be in. That way, when we change the data, our UI just follows the rules we put in place and shows the proper UI. Now, if that was a little bit confusing, let's go back to our weather app and I'll really break this down. So here we are in the app, and again, super basic example, right? Our only piece of data really is this isNight variable that we flip from true or false. And what I meant by how we set up our UI for all the possibilities up front, well, luckily for this simple example, there's only two possibilities. Isnight is true, isnight is false. And this is what we just did, right? In our background view, let's go to that down here where we built that here, right? So here we are in our background view. We've already set up our UI ahead of time, right? With our gradient, changing our colors based on isNight, it'll be black or blue for the top color, or it'll be gray or light blue for the bottom color, depending on isNight. So again, our UI knows ahead of time, like every possible state it can be in. We've already set up the rules, right? Same thing for our main weather status view, right? Where we either show the moon or the cloud and the sun. We've set up the rules for both states. It knows it. That's why that code path where you're updating the UI completely goes away. And you don't have to worry about your UI always being in sync, because if you set everything up correctly, all you do is change the data source, the isNight to true or false, and our UI just follows the rules and it knows what to show. So that's just a super basic example with one piece of data, a Boolean true or false, but hopefully that starts to get your mind seeing how declarative UI works versus imperative, right? Where imperative, you are specifically telling the UI when and how to update when the time comes. Declarative, you set all the rules up front, you set all your states up front, and then you just change the data and the UI acts according to those rules. In the next video, we're going to talk about SwiftUI's view trees and how views get updated when we flip the isNight Boolean, to true or false, because it doesn't redraw the entire screen, it only redraws some of it. So that's what we're going to dive into in the next video. Now let's do a bit of a deeper dive into the concept of modifiers. But the key takeaway, like I mentioned in previous videos, like as long as you understand that every time you add a new modifier under your view, you're wrapping that in another view. And because of that, the order in which you put your modifiers on matter. So we'll take a deeper look at that, but that's really the concept at a high level. So back in our weather app, as an example, let's go to our weather button. And one thing that you may not have is I created a preview for our weather button. So just copy that text, put it in there to get a preview so we can actually see this while I'm talking about the modifiers. So like I said, the order matters, and I illustrated this before, but I'm going to show it to you again. So on text, we have our frame modifier, right? If I put the frame modifier last, so if I do Command X and down here, well, what happens is now that background and foreground color happens on the text itself, and then the frame gets added after the colors have already been put on, right? So I'm going to put that back and kind of walk you through how this actually goes, right? And then I'll show it to you in code, and then I'll show you some visuals. Hopefully at the end of this, you'll get it. So what's happening is we have our text, then we add a frame to it, right? Then when we add our background color, the background color is actually getting added to this combined view of text and frame. Then you add the background color. Now foreground color gets added to the overall combined view of title or text, frame, background. And then you can see how we keep going, right? Font gets added to text, frame, background, foreground, right? I pictured this circle that you see on the screen here, right? Like you're just putting new views, wrapping around the existing views. And again, that's why the order really matters. So now for those of you that like to see it in code, like to see what's going on, let's go to the content view here. There's a modifier that we can put on our ZStacks and our VStacks called onAppear. This is kind of a preview. We're going to get more into that later. It's not about onAppear right now, but think of onAppear and there's an onDisappear, similar to like, view will appear, view did appear, view will disappear, similar to that, right? So on our ZStack here, that's what we're going to use here. We're going to use that onAppear, and we're going to go ahead and give it that closure. Now here in these, you can actually write all your Swift code, right? This is not a view builder, right? You can just write any code you want here to do onAppear. So we're going to say let button equal weather button. And this is just to get a debug printout, by the way. You don't have to necessarily follow this. This is just so I can print out what the views are doing in the button in the debugger. Again, you don't have to do this if you don't want to. But you're going to do print type of, and then button dot body, right? So we're printing out the body of our button, which again, if we go back to weather button, body is this right here. So we're going to print out what happens in this part of the code here. And we're going to do that when our ZStack appears. That's what onAppear does. Okay. And we're going to get a printout in our console here. So I'm going to run it on the simulator to get the printout. There we go. Let me move this out of the way, move this up so you can see. So this is what all this modified content, that's what's going on with the wrappers. So let's copy and paste this, and I'm going to put it in my code here. It's going to give me all kinds of errors, but I think it'll be better if I lay it out this way. Again, you don't have to be following me doing this. This is just for explanation purposes. So I'm going to kind of unnest this. So at every modified content there, I'm going to make a new line, again, for illustrative purposes. Return there, return. And then hopefully this nesting makes it easier to kind of like see and understand what's going on. But basically the principle applies of what I talked about. It's how every time you add a modifier, you're wrapping it in a new thing. Here it is called modified content, right? If we count our modified contents, 1, 2, 3, 4, 5, well, how many modifiers do we have? 1, 2, 3, 4, 5. So like I said, every time you're adding a frame, a background, a new modifier to your object, it's getting wrapped in this modified content that you see here. So this was for those that like to see it in code. Again, I visualize this, circles wrapping circles kind of image that you see on the screen here. That's how I think of it, like as I'm adding my modifiers, that, whatever new modifier I add wraps all the existing views that I've already built, and so forth as I go out in the circle. Now back to our content view, I want to talk about two more things here. So back to the content view, you can see, right, environment key writing modifier. So there are these environment modifiers that are a little bit different than the normal ones, and let me show you them in action. So let me delete all this so Xcode can stop going nuts here. So we'll delete all that onAppear, do a Command B so Xcode can stop freaking out with all that bad code. Let's go to our weather button. So let's pretend hypothetically, again, we're just kind of messing with our code. We're not like really building stuff. Let's put a VStack here. And let's say we wanted 2 buttons in our button for some reason, right? This is, you wouldn't really do this, but what I'm showing you is the environment. So there's many different ways to use the word environment in SwiftUI, but for this environment, we're talking about everything within the VStack. And when you have multiple things like multiple text or multiple buttons, there are certain modifiers that you can put on the VStack overall that it'll apply to all the children like of that VStack. For example, foreground color, right? Let's Command X that, and we'll put it onto the VStack overall. I can delete foreground color out of both of my individual buttons. And you see our preview. Okay, I forgot to add spacing onto our VStack. Spacing of 20, just to space those out so you can see. But you can see I basically refactored out foreground color and put it on the environment of the VStack so that all the children of the VStack will get that modifier. And to really drive the point home, let's do one more. Font is another one that we can put on the overall VStack and not each individual element, if they're the same font, of course, right? If you have different fonts, you probably need them to be different. But again, that shows you environment modifiers that you can put on the environment of the VStack, HStack, whatever, to apply to all the children. And then lastly, there are like item-specific modifiers, like text has a .bold. All right, so let's get rid of our font modifier real quick to show you how each individual one can have it, because it has to do with text weight. So that put us at our default font weight. Well, modifiers that are specific to like a text, like for example, bold is one of them, .bold, right? You can see now that made our title bold. That was actually kind of hard to see, but I'll comment it out and recomment it so you can see the title changing, right? Okay, so watch what happens, right? Because bold is specific to text, and because we're wrapping each view in a new view, right? Well, once I wrap it in, .frame, right, as my first modifier, I can't put .bold down here, right? I'll get an error, Command B. It's because value of type SumView has no member bold, right? Like text has .bold, but the combined, modified content of text and frame does not have a bold. So when you're using specific modifiers like that, you need to put them first. And again, those are, specific to, this example, like bold and text. So that's an example of using, the environment type modifiers and then specific modifiers. Now, there's a ton of modifiers out there. Some are environment, some aren't. Some are specific, some aren't. I don't recommend going through the entire list and trying to memorize like what's what. Again, I think as long as you remember what's going on every time we add a modifier, we're wrapping that in a new view and, as many times as needed, and that the order of the modifiers matter. If you remember those two key things, you're well on your way. In this video, we're going to talk about view builders, right? And the main takeaway here is basically what they are, so they exist, and then the limitations of them, so you can set your expectations and not get frustrated like I did before I knew what they were. Okay, so in our code here on the weather app, let's use our ZStack, for example. And I'm gonna do the code folding again on the VStack just to make this clean and nice and easy to see here. I'll blow it up so you can read it a little better. So what the view builder is this closure. It's not a typical Swift closure, right? But the ZStack takes an open and close curly brace. Our VStack takes an open and close curly brace, right? All the elements that return a view, that is the view builder, right? The open and close curly brace, the scope of that is the view builder. And like I said, they're limited. You can't write any code you want in a view builder. You can only write, certain things. More on that in a second. But if let's command click on VStack, do jump to definition, get into some documentation here so we can show you, right? So on the initializer of the VStack, remember how we showed it has an alignment parameter, which, has a default value of .center for the horizontal alignment, has a spacing parameter, default value of nil. That's why we didn't always have to use them, but we could if we wanted because they had default values. That's just a little extra repetition review there. But the last parameter of content you can see is marked view builder, right? And it returns content. And if we scroll up to see what content is, it needs to conform to view. So content being marked view builder makes that closure, that scope, it's different, special. Again, like I said, you can't write whatever code you want in there, for loops, whatever. Well, at least for now, because the functionality of these view builders is expanding, right? It started off very basic in iOS 13 with just basically if-else statements, and I'll show you that in action in a second. But in iOS 14, it got functionality for if-let as well as switch statements, which is nice. So the functionality is slowly expanding. Who knows how far it will expand, but I do expect more functionality to be in these view builders down the road. Okay, so let's get out of the documentation, into our code, and again to review, the view builder is the scope of the open and close curly brace, of the ZStack or of the VStack. Now I'm going to show you some of that logic in action in my consulting project app. All right, so here we are at my category list screen. Let me put it up on the screen so you can see what you're looking at. It's basically just a list of items that if we tap on it, we can show a sheet of the detail, and then we can add to cart, whatever. So if we go back to the code, let me break that down for you. And I'll keep a little picture of the screen up there so you can kind of, correlate what's going on. So that list is basically a ZStack, as you see here. At the bottom of the ZStack is our grocery item list, and I've code folded all the implementation because it's quite long. That will be confusing. I'll tell you what I'm doing just so you know. So I'm showing the grocery list. On up here is where I fire off to the view model to make the network call to actually download, what's in that category. This sheet is how I present, when they tap on it, it presents all the detail view. That's what's going on there. And then this alert is for, any errors in the network call or any errors, whatever, we pop up the alert. So that's what's going on the list. Super high level, don't want to confuse you. But the main point I want to show here is, okay, so it's in a ZStack. So remember, ZStack is vertical layers of views. So at the bottom of the VStack is my list. Well, on top of it, I'm conditionally showing either a loading view or an empty state, right? Like I said, I make a network call to get all the items. Well, while it's loading, I put up just a blank white screen with a spinner, right? It's nothing crazy, nothing special. But that goes on top of the ZStack, so that's all you see. So what happens in the view model when it's done loading, that'll publish out to say, hey, loading equals false. So now it'll redraw this view. And now I'm kind of going into review on the whole, view tree reloading and updating. And now it'll go through this, is loading will be false. And then if my category list is not empty, none of this will show, right? Because it's in an if statement. And the only thing that will show is my grocery item list, right? But if, it is loading, now my loading view will show. And if it's done loading, but I have no items in my list, it will show the empty state that you see here. So again, this is using the if statement in the view builders. This is how you can conditionally show views in the view builder, depending on what's going on. Like I said, if everything's fine, cool, show the list. If it's loading, show the loading view. If it's empty, show the empty state, right? That's how I'm conditionally doing that. And like I said, new in iOS 14, you can now have switch statements in here. If you have like 5 different view types you need to show based on some piece of data, you can now have switch statements in here, which is really nice. And then you can now have if let, to handle any optionals. So that's view builders. And again, the key takeaways here are knowing that they exist and knowing what they are. Hopefully you know that now. And then knowing the limitations of them, that you can't just write whatever code you want in here. You're pretty limited to basic control flow, like if else, switch statements, that kind of stuff. So if you find yourself trying to write all the code you want in your view builder and it's not working, this is why. I know when I was first learning, I had so many headaches because I didn't learn that and I was just trying to write whatever I wanted in here. I learned it pretty quickly when nothing worked, but hopefully I can save you that headache. So that's view builders. Now let's talk about how SwiftUI actually updates those views when the data change. And before we dive into that too much, we have to talk about how SwiftUI uses structs for its views versus classes for its views, like in UIKit. So looking at UIKit, for example, like a UI button, right? You see that inherits from UIView. Inherits being the key word there, because that means UI button has all the features and functionalities of a UI view that they probably don't need all of that. So there's a lot of bloat that gets inherited, right? It kind of makes the classes a little more heavier. Well, in SwiftUI, a struct just conforms the view, like there's no inheritance going on. So in SwiftUI, the view structs are super lightweight and performant. Like I said, they get created and destroyed and re-rendered all the time in SwiftUI. And the reason that's possible is because they are super lightweight structs. So that's the key piece of information you need to know before we dive into the view trees and the diffing and all that stuff. So I'm going to illustrate the view trees in 2 ways, one in code and then one visually after we do it in code, just to hopefully that helps you make the connection. So in our code here, our weather app, just our content view, I don't know if you have these code folding ribbons on the side, but if you go to Xcode, preferences, text editing, and then code folding ribbon, make sure you check that box if you want to do what I'm doing. If you just want to watch, that's fine. Anyway, so what these code folding ribbons do is I can like fold up the code. So I'm going to fold up my VStack, right? Remember, the VStack is what holds all of our elements. So let's fold up that VStack to illustrate this tree here. So if you click that arrow, that folds it up. And the reason I want to do that is to show you, like, the base of our view tree is our Z stack, right? And our Z stack has 2 elements. It has our background view, which is on the bottom of the Z stack, and then it has our V stack, which is on the top, right? That holds all of our elements. So that is kind of the root of our tree, right? This Z stack. Off to the left, we can put our background. Off to the right, we can put our V stack, and that V stack would, break down into more branches on that tree. And those branches of the VStack tree, as you can see, if I unfold it, would be the city text view, the main weather status view, another HStack, which again would have its own branches. So you can see this view tree can get a little complex as you have a lot of branches. I'm going to try to keep this as simple and high level as possible to not confuse you. So if we were to fold up the HStack there, that shows all the elements of the view stack. And for the purpose of this explanation, this is as deep into the tree as I'm going to go, again, as to not overwhelm and confuse. So that is it kind of in code, and hopefully you can kind of see, how the branches of the tree branch out. If you can't, I'm going to do it visually, and hopefully that'll help. So here in the high level visual, I just cut out sections of the screen to help you visualize it, right? I figured that might help to see how this the view tree is structured. And again, to be clear, in reality, it's a bit more complicated than this because there's a lot more sub branches, but keeping it at a high level to explain the point. Right? Because the point of this video and where we're at in SwiftUI fundamentals, the point is not for you to understand all the complex stuff, SwiftUI's, tree diffing algorithm, all that stuff. Like, if you want to dive into that, that comes later, right? That's not what you teach in the fundamentals course. If you leave this video just understanding how the view tree works, how SwiftUI compares the view trees, and then only updates the views that are necessary, like, that's great. That's what you need to know at this stage of the game. All right, so let's use this visual to explain what I just said about how SwiftUI only changes what's different. So you see the view tree here. Well, when an update happens, there's an identical view tree that gets created. This is why we have to declare all the rules of our UI up front, is so the trees are exactly the same. And that is for performance reasons, To get a little technical, and look, I'm not gonna bullshit you. I'm not gonna act like I understand SwiftUI's tree diffing algorithm. I know the basics of what's going on, so I'm gonna explain that to you. So the reason the trees are exactly the same is for performance reasons, right? If the trees were different, now that algorithm would have a much, much higher runtime, right? However, if the trees are exactly the same, the diffing algorithm between the two view trees can be very, very fast. So again, that is why we declare all the possibilities of our UI up front. That way the view trees are the same for diffing algorithm purposes. Okay, so what happens when we flip our isNight from true to false or false to true, vice versa? When that Boolean changes, SwiftUI goes through the view tree to see what changed, and then when it gets to a view where that data affects it, it triggers the body property of the view, right? Remember how every view has that body, and it will re-render and re-update that based on the new data. So let's walk through our tree real quick to see how that would play out, right? So we start at the top of the VStack. Our isNight changed to true. Well, we'll go down to the left here, look at our background color. Okay, that view is affected by isNight being true. So we'll trigger the body to re-render. It's going to re-render. It's going to show the right colors based on the isNight Boolean. Good to go. That view got redrawn. Then if we go down the other branch of the tree into our VStack, we see we have the city name. Well, that didn't change, so that's not going to get redrawn. Then we go down to our VStack that holds our main weather status. Well, that did get affected by the Boolean, right? We're going to show the moon and the stars, not the cloud and the sun. So that view's body will get triggered, re-rendered, and show up differently on the screen. And then down the rest of the VStack, right, our HStack of days, that doesn't change, our button doesn't change, so none of that gets re-triggered. So that is how SwiftUI only updates like what changed. So even if all the structs and the views are getting destroyed and recreated, the body's not firing off unless there's a difference. So like I said, this gets much more complex under the hood, but at a high level, what you should know now, the key takeaways are that there is a view tree structure. The view trees have to be the same. That's why we have to declare all the possibilities up front in our UI. And then when the data change, SwiftUI will go down that view tree, look to see what views are affected by that change, and then re-render just those views. So that's the big picture takeaway from this section. If you understand that, you're good to go for a Swift beginner. I wanted to include this fun video just to share my story with SwiftUI, how I was, pretty taken aback when it was announced. I was a little skeptical at first, and my journey on learning it. If you don't care about this stuff, skip this video, feel free. But I wanted to share kind of my journey and how I got to where I am right now with SwiftUI. So when SwiftUI was first announced at WWDC 2019, it messed me up. I was shook, as the kids say, because it was a pretty big deal, and I knew it was a whole new way of thinking, so I knew I was going to be a beginner again. I knew this was obviously Apple's direction for the future. It was a pretty big deal, and my career making content around this stuff, everything was going to change. I had all these great WWDC plans for 2019. I took the week off of work, cleared my calendar. This happened, and I literally did nothing. It was so much to take in. I was okay, I just sat back and watched videos. I didn't put out any content, even as all the other, content creators were putting out all kinds of SwiftUI stuff. I didn't do anything. And actually, even as of today, November of 2020, there's almost no SwiftUI content on my channel. Now that's about to change because I wanted to wait until I got some experience with it, learned it, etc. But yeah, when it was first announced, I was pretty shook, and it messed me up. It messed up my whole content plan. Had to change everything because, like I said, this was obvious. This was the future. But when it was first announced, I was a little skeptical. I tweeted this out. Partially because the developer reaction was almost unanimously glowing. Everybody loved it. And every time a large group of people are just all in on something, I kind of take a little skeptical approach. I'm wait a minute. And even during the presentation, it seemed too good to be true. They were building table views in 2 seconds and 4 lines of code, and it just felt too good to be true. And one of my biggest skepticisms was every app is going to kind of look the same. And a year and a half later, I think that's kind of playing out. And the reason I thought that, even from the instant I saw it, was, to make a list, you just type list and there it is, or a form, and then you get all the default form. Now I know in SwiftUI you can customize and make it, but you get all this stuff out of the box for free that I was man, a lot of the apps are going to look the same. And I think you can really tell a SwiftUI app, they do. They look a lot alike. And now you could argue that's a good thing or a bad thing, right? It could be a good thing because now apps are going to be so easy to use because everybody's familiar with it, right? That's good. Usability, UX. However, you're going to lose a lot of the character of a lot of apps, a lot of the whimsy, if you will. So I can see the pros and cons of it. I don't know where I fall. Like I said, there's good and there's bad. Guess we just got to live with that. But when I first started learning, like I really struggled with SwiftUI because like I've said, in this course previously, it's a complete mindset shift, and like all my old habits and ways of thinking like wouldn't work. And I did the 100 days of SwiftUI. I did Meng 2's course, I did a lot of other YouTube tutorials, and it wasn't clicking. Like let me rephrase. The building the UI, like HStacks, VStacks, like that clicked almost right away. I hate saying things are easy because everybody's different, but to me, the UI aspect of SwiftUI, like getting it to look how you want, is the easy part. Like that's relatively straightforward to me. Again, sorry if it's hard for you, I apologize. To me, what was like hard to get click was like moving data around. Like I said this, I don't know if I've said this in this course before, maybe recording the videos kind of out of order. But anyway, it's very easy to get your app to look how you want it. To me, it was very hard to get my app to act how I wanted it, right? And that's the whole like passing data around. And that's why I wanted to focus this course a lot on, state, binding, state object, observed object, like making your app act like you want is what I want you to leave this course like having a good feel for. But for me, when I was learning, like that kicked my ass. And to be fair to myself, like I was only like half learning, right? Like I was still doing my other projects, making my videos, still living in the UIKit world. And every once in a while I would dabble in SwiftUI. So I never gave it like the full focus until a few months ago when I got a consulting project. It was, again, brand new project. As you can see on the screen here, I'm showing some screenshots. Like the app is like dead simple UI wise, right? Nothing complex is going on. It's just table views, nothing crazy, right? So it was a perfect candidate for SwiftUI. Not to mention the client was like very forward looking. He wanted a latest and greatest technology app because he's trying to build a team around this up and coming product. And, he wanted to attract, talent, right? Because who wouldn't be interested in working on a SwiftUI app that's iOS 14, server-side Swift, right? It's like a Swift developer's dream, if you're willing to put up with the headaches of being on that cutting edge. So like I said, I was like half learning before, kind of doing it here and there, but when kind of your full-time job gets shifted to working in SwiftUI day in, day out, you start to pick it up pretty quickly, right? You're putting a lot of time into it. And this project is where I got comfortable with SwiftUI. Now, don't get me wrong. I had many nights of banging my head where I couldn't figure stuff out, just Googling every little thing. I'm not going to act like I picked it up right away, but we got there eventually. And this is where I got the hang of MVVM as well. Because again, before this app, I had dabbled in it, done a tutorial, but I never built an app in it. However, this app was built in MVVM, not originally. I refactored it into MVVM, but again, that's how I got the hang of it. If you've heard my content before, I'm big on like repetition and practice. Well, when you refactor 8 screens back to back to back to back into MVVM, like that's a lot of repetition and practice. So I feel like I got the hang of it through building this app. And now that I'm through that project, I'm still dabbling, working on it with the client, but for the most part, I'm done there. Now I'm moving on to Creator View. Here's a sneak peek at a prototype, but I am building my own product in SwiftUI for the iPad, the Mac, all that stuff. So I'm expanding my own knowledge and my horizons in SwiftUI. Now, by no means do I declare myself a SwiftUI pro, right? It's very hard to be that because it is so new, right? Very few people have a lot of like production app experience there. So again, don't get it twisted. I'm not here saying I know everything about SwiftUI. You listen to what I say. I feel like I've been very honest about that up front. And that is why this is a fundamentals, like straight down the middle course. We're not doing anything crazy. We're keeping it to the essentials. And that is why, because that's what I have actual experience in and I feel like I can teach. Now, don't get me wrong. I have plans over the coming years to continue building, my own projects and stuff and continue sharing that knowledge in future courses. But again, this is the fundamentals. We're going to expand to the fun, crazy stuff as we go. So that's where I'm at with SwiftUI. And again, there's pros and cons to fully adopting SwiftUI early when it's not fully baked yet, right? It's still being built. Of course, when you do that, you're going to deal with all kinds of headaches and frustrations. Like that just comes with the territory of doing that. However, I like dealing with like the latest and greatest. Like I've always been an early adopter for everything in my life. So like I'm fine dealing with those kind of like headaches, if you will. But I just enjoy dealing with like the latest and greatest stuff. So hopefully that just continues and, SwiftUI will mature eventually and more developers will adopt it and shift to that. This is obviously where Apple's going for the future, but I'm glad you're here now. You're here early as well. It'll be fun to grow together with SwiftUI. In this app, I hope to build something fun and useful for you. As you can see on the screen, it's kind of a reference for Apple frameworks. You tap on a framework, modal, or they're called sheets in SwiftUI, pops up with more information, and you can tap Learn More to pull up a Safari View controller to really do a deep dive on all these different Apple frameworks. And as we build out this project, we're going to slowly start to expand on our SwiftUI skills. As you can see from the design here, obviously there's a grid. We're going to learn about that. We're going to put that grid in a scroll view, so we're going to get some exposure to that. There's a navigation view. We're going to pass data to a whole new view, the modal slide up. In SwiftUI, they're actually called sheets, but modal, sheet, kind of the same thing. Of course, we're going to refactor. We're going to dip our toes into MVVM a little bit, model view, view model, super basic on that, just to introduce you to the concept. And in the last video is kind of a little bonus. I'm going to show you how you can quickly convert this grid and modal slide up into a typical list and detail view with like a navigation controller. Well, they're called navigation views, but trying to relate this to UIKit terms, right? Like a navigation controller with a detail view, we can slide back. We're going to convert it to that pretty quickly to kind of show you the power of SwiftUI. So let's get into it. We're going to create a new Xcode project. Hopefully this isn't anything new to you by now. Let's go ahead and make this full screen here. Cool, and then we're gonna do iOS app, nice. And call this whatever you like. I'm gonna call this Apple Frameworks, Interface SwiftUI, Lifecycle SwiftUI app, language, Objective-C, right? Swift, next. And then save it, I'm gonna save mine on my desktop, save it wherever you like. Cool, here we are, brand new SwiftUI project. I'm gonna minimize my right pane here, hit resume. This is kind of my typical starting thing. Get my canvas to not look ridiculous. Get it off the iPod 7. We're gonna go to the iPhone 12 Pro. And let's make it not ridiculously huge. There we go. Okay, great. So the first thing we're going to do is start a little bit of our data model, right? This is all about Apple frameworks. So we wanna have a framework object, right? That has the icon, the name, the description, the URL to go to with Safari, all that stuff. So click on your Apple Frameworks folder here, do Command N for a new folder or a new file. We'll just do a Swift file because this is just part of our model. Hit next. I'm just gonna call this framework. That's our object name. Create, cool. And then we're going to, it's a struct called framework, and pretty simple for right now. Let name, it's going to be a string, and these are going to be constants because they're not changing. We don't want these to be dynamic or anything like that. So let image name, right? This is how we, know what icon to show. That's also a string. URL string, that is also going to be a string. And then let description, also a string, right? So those are the 4 properties we need right now to, populate our app. Now I'm going to save you some time so you don't have to type out all this mock data. On this video, you'll see a file attached in the Teachable platform. It's going to be called mockdata.swift. Go ahead and download that file, open it up, and don't like drag the file into the project. Just open it up separately and copy and paste it into this file like I'm going to do here. So I went and copied that from that file. I'm going to do a Command V here, and there you see mock data. And what we have here on this mock data is just an array of frameworks. And you can see I've created all these frameworks, right? I gave it the name of app clips, the image name, we'll import those images here in a second, and URL string for how we open up our Safari view controller, and then the paragraph, description for each one. Now that we have like our data set up, let's bring in these images, right? You see image name app clip. Well, again, attached to the video as a file in Teachable, you'll see a folder called framework icons or something similar to that. You'll be able to figure it out. But download that folder and then drag your images in like this. So if I go to my Finder, open up the folder, you'll see all these. So actually back in Xcode, we need to do our assets folder. Let's go back to Finder. And I'm going to hold Shift, drag all of these in here to my assets folder. There you go. You should see our framework icons. And then the names again match up with what we have in our model. So now that we have our images in here, let's go to our content view. Well, actually, I'm just now seeing this. When we built our framework, it put it down here. I hate when they're always down there. I like to move them up there. And then eventually, put them in their own folders for like views, model, all that stuff. We'll get to that later. So anyway, we have our framework. The data is ready to go. We have our images. The last thing I want to do for this setup is this content view. Now, I do this a lot in my tutorials and previous courses. Everybody always tells me there's an easier way. Cool. I'm going to do it my way still. Here's what I always do, right? Because I don't want this to be called content view. I want this to be called framework grid view, right? For a proper name. So I know you can, rename it, but I've just had a lot of issues in the past trying to just rename a file. And then like my file paths get messed up because the name is wrong. And like I spent hours like trying to mess with those bugs. So I know you can do proper renaming, but I do it this way just for peace of mind and like start a stopwatch. Watch how long this takes, right? Here's what I do. I delete the content view. Move to trash. Cool. Apple Frameworks, Command N, new file, SwiftUI view, next. And then I do framework grid view, create. And then again, it puts it at the bottom, so I drag it up. Cool, done. Now that took 10 seconds and I have the peace of mind that like all that pathing issue is not going to be an issue. It's a fresh, clean slate. So again, if you choose to, and of course, I forgot something. So maybe not 10 seconds, maybe 12 seconds, because you have to go to your app file here, and instead of content view, now it's got to be framework grid view, like I said, right? Because content view doesn't exist anymore. So do a Command B. Okay, so 12 seconds instead of 10 seconds, whatever. But the point is, now I have peace of mind that I'm working on a fresh slate. I'm not going to deal with any of those like pathing issues. So anyway, that's just I'm scarred, I guess, from that. So if you choose to do the renaming, cool, fine. I do it that way. So that's our initial project setup, but I want to leave you with another challenge. And I'll admit, it's a little bit repetitive, but that's kind of the point. So as you can see in the design, right, look what our grid is made up of, right? The icon and the name. What kind of stack do you think that is, right? It's a VStack, right? You got the image at the top, name at the bottom. So in this quick challenge, before we move on to the next video, try to create that VStack real quick, right? That has the image of the icon and the name. Now, remember, we're going to be in a small grid and some of the framework names are long. So when you format the text of the VStack, think about that, right? Maybe our font needs to be dynamic. It needs to adjust to our grid view so it doesn't get truncated or go down to 2 lines. So how do you format that text view so that it shrinks if needed? So that's something to keep in mind. And that's the first building block of our grid, which we're going to build together in the next video. So if you want to take a stab at that, now's your time. We're going to jump right into it in the next one. We left off last video getting our project set up with our data and our images, and I left you with the challenge of building the VStack. So hopefully that went smooth. Again, a lot of repetition. It's from what we did before. However, we're going to build that right now because that is the first building block of our grid. So let's get right to it and see how my code compares to yours if you did that. So of course, we're going to want a VStack, right? Because we have the image at the top and the title underneath it. So like I just said, image. And what is that image? That's going to be name, right? Remember when we were doing the weather app, we did system name because that was SF symbol. Well, now we actually have images in our bundle. So now we do image name, and then the string we pass in, let's do app clip. There we go. So there's our image. Obviously that's huge. That's way bigger than we want. And if you remember what I said you're going to do with your images almost always is .resizable, probably like 99.9% of the time. And that makes it look even more ridiculous, but we need to do that. So now we do a frame and we're going to give it a width and height of 90 by 90. And again, that is just me dialing in those numbers, figuring it out. So if your numbers weren't the same as mine, like you didn't get it wrong, like you just dialed it in differently than I did. So now let's put our text in, right? So text in our framework name, and we're kind of hard coding this. We have the object of framework, but we don't quite have that framework object on our grid view yet. So we'll kind of inject this specific framework later. We're hard coding values now just to get our UI set up. And to be honest, that's usually how I build the apps. Before I have all my data from like a network call or something like that, I fill it in with like mock data or dummy data just to make sure the structure is correct. And then I can kind of like inject the data as needed. So just a little tidbit there. So we'll call this app clips, right? So there you go. Now that text is kind of small, kind of skinny. Again, we want this kind of big, bold, chunky. So let's do font. Now here's where we're going to mix it up a little bit from what we did last time. Last time we weren't kind of supporting dynamic type. We were hard coding our font values. So if I do font, now I'm just going to do dot title, and you can see, well, I'm just going to do dot first to show you the options. So dot, and now you see, body, call out, caption, caption 2, footnote, headline, large title, subheading, right? These are different categories of like font sizes, but this will support dynamic type, right? So if I just do title 2, now whatever the user has a setting for a dynamic type, this will respect that. But it's still not bold like we want, but we can put a font weight on top of that, right? So font weight, and let's do semi-bold, right? But again, I'll just do dot to show you, right? Black, bold, heavy, light, medium, regular. So we're going to do semi-bold there, as you can see. So that's the basic text. But if you remember when I gave you the challenge, I said some of these framework names are long and our grid squares are only so big. So we're going to need the text to be able to shrink to fit the name if need be. So there's a couple more modifiers we got to put on our text for that. Scaled to fit, there you go. And then now what we want to do is we want to give it a minimum scale factor, and we'll say 0.5. So what this does here is this says, hey, you now have the ability to shrink if needed for the text, but we only want you to shrink so much, right? We don't want you to shrink to like 10% and be unreadable. Now, this number, you could dial it in, you could change it if need be, but we'll say only go down to 50%. And to be honest with you, that might even be like too small. We'll say 60, but you can see how you can dial that in, right? So the smallest this text is gonna go, if it's like a really long name, is 60% of the original size. So that handles our font scaling when our name is super long. Now, something different we're going to do in this app is we're going to refactor as we go rather than wait till everything's done to refactor. And especially something like this VStack here, we know if you look at the detail view on the screen here, like we're going to reuse that VStack in another view. So this is going to be reusable for sure. So again, I'm going to copy and I put the struct in here to start. We'll put it up here. So struct, and then I'll move it into its own view or file later. We'll call this framework title view. And this is going to be adjusted later on, but for now we'll do let name equal or be a string that we pass in, and then let image name also be a string that we're going to pass in. Remember how I was talking about how we're kind of hard coding this for now? Well, once we get our framework array working that we have in our data, we're actually just going to pass in a framework to this framework title view, and it's going to do everything from there. So, but for now, we're going to kind of hard code this. So now I'm going to do a command V to paste that VStack, and instead of app clip, we're going to have image name there, and then for the text here, we're just going to have name. Right, so eventually that's going to be framework.name, framework.imageName, etc. Okay, what did I mess up? I know what I messed up. Var body, right? Every view has this body that is of type some view, and then open and closed. Cool. Yeah, you can't just put the VStack in a struct. You got to put the VStack in the body. There we go. So yeah, that var body some view should be the first thing you always type when you're creating a new view there. And I didn't conform this to two. Man, typos everywhere. We're leaving it in though, just to show you that I'm not perfect. Developers aren't perfect. Everybody makes these kind of silly little mistakes. I'm probably making them more than usual right now, just because, anytime you're talking and explaining and presenting on a video, you're not kind of like in just your code mode, if you will. But anyway, here's our framework title view refactored. So let's use it up here now. Framework title view. And now this is going to take in a name, and then we'll do app clips and then an image name, which is app-clip. So if I do a resume, we should be good to go here. Cool, everything is the same, that's refactored out. All right, now for the main event of this video, let's start building our grid. Now grids were introduced in iOS 14, so they're relatively new to SwiftUI, lazy V grids and lazy H grids. So let me break that down a little bit. Lazy just means that the views get initialized as they're needed. For example, VStacks and HStacks also got a lazy version in iOS 14. So before, your whole VStack would populate. Like if you had 10 views in your VStack and maybe your each VStack was actually pretty tall on the screen, like for example, Instagram, right? If you see Instagram, the photo, the caption, that could all be one VStack, but that one VStack takes up the entire screen. So if you had 10 of those in your VStack, and it wasn't lazy, all 10 of those would load, even though only one of them is showing up on the screen. So that's why lazy got introduced in iOS 14 to make it so it only kind of generates the views when they're needed. So grids are lazy by default. At the moment, that's the only way you can make them. And then as you can imagine, a lazy V grid is what we're gonna build. As you can see on the screen here, that is a grid that's gonna scroll vertically. Okay, so a key component of building a grid, whether it's vertical or horizontal, is you're going to need columns or rows. Right? So columns for a vertical grid, rows for a horizontal grid. We're going to need columns because we're vertical. So for that, in our framework grid view here, let's create a variable. Let columns equal, and it's cool. No, we got to give it a type here because we're not going to fill it just yet. So that's going to be an array of grid items. I'll explain that in a second. And that's going to equal an empty array for now. We're going to fill that array with grid items. Let's talk about a grid item. So if I type grid item, you can set your columns to be, 90 points wide. That might make sense because our frame's 90 by 90. We're going to do it a different way. But the big picture, the point, to put it super simple, you can basically give it a fixed width, height, set your fixed parameters, or you can do what we're going to do and initialize a grid item with .flexible. And we're not going to do a minimum maximum width. You could do that if you want. Like, it's flexible. Here's the minimum size it can be. Here's the maximum size it can be. We're just going to do flexible with no parameters, so there is no min max. And what flexible does is, based on how many columns you have, it's going to fill that screen. let's create the beginnings of our lazy V grid, and then we're going to come back to these columns to show you that in action. So here in the body of our framework grid view, right, we have our framework title view that we just built. We want that to be part of our grid. So down here, we can type lazy V grid here. And you can see you can have, just like VStacks, right? You can have columns, alignment, spacing, more stuff, or you can just have columns and content. Now here's a little tricky thing with SwiftUI, and this is a little bit of an experience thing that you're going to learn over time, is sometimes the autocompletes can be more confusing than just typing it out the more simple way. So watch when I do autocomplete on contents and column, right? Like, what is this? So columns, it is giving me the grid items of fixed 20, or like that's what we kind of demonstrated up there. So for columns, I definitely want just our columns array that we created up here on line 12. That's what I want to pass in. But now this is what I'm talking about, like start menu token, end menu token. Like I have no idea what that even means. It gives me these text placeholders. Like it's just much easier to type the lazy V grid like this. And again, you'll learn this over time. Just lazy V grid, kind of type it out yourself. Columns, right? I know I'm going to want my columns array, and then literally just an open and closed closure there. And we're getting two previews because it looks like we have two different views in our body. We have our lazy V grid and our framework title is separate, but we want to move the framework title into the lazy V grid, right? So it looks no different. And you want to know why? It's because we only have one column. There's only one column in our array. And if I'm highlighting the lazy V grid here, you can see the red frame. You can see that one column is taking up the entire width of the screen. Okay, cool. So let's add a comma here, hit return, and we're going to add another grid item with flexible. So that'll give us 2 rows. So return, enter. Okay, so now we have 2 rows, hit resume, and you can see, well, we only have one framework title view here. Let's put in another. Let's go crazy, right? Put in a bunch. So here you go. There's 2 columns because we did 2 grid items of flexible. And again, eventually our grid is going to take our array from our dummy data of our frameworks, but we're hard coding now just to play with the layout and for me to show you this. So you can probably imagine what happens if we add a third grid item here in our columns, right? We're just adding more columns every time we do this. Hit resume. There you go. 3 columns, just like that. Guess what happens when you do 4? Resume 4, right? You see where I'm going with this. But now you can see our UI might be starting to break down a little bit because we made our vertical stack for our framework 90 by 90, right? So you can imagine if you wanted a lot of columns, you would probably have to adjust that. Let's do 5 just to show, this kind of gets silly here. Again, I'm just kind of illustrating this. Okay, so that's super cramped, but you can see our text shrinking. That's why we put that minimum scale factor on our text. Okay, so let's get back to what we're actually gonna do here. Delete 2 of those grid items. We definitely want 3 of them here. So 3 in our array, hit resume. There you go. That looks more like what we're trying to build. Again, when we have our real data in there. And that's what we're going to do in the next video. This video is just setting up the basic structure of our grid. In the next video, we're going to work on getting it showing the frameworks in our array and getting our grid looking like you see here on that design. So exciting stuff. Let's go. We left off last time getting the general structure of our grid in place. We discussed, how grids work with the lazy V grid, how you have to define columns. We got that in place. Now let's put in like our real data that's called mock data. You get it. So rather than like hard coding all of these. So let's actually, we'll keep 1 because we're going to need that. So anytime you want to kind of iterate through an array to populate a list, a grid, sometimes even a VStack or an HStack, what you're going to use in SwiftUI is something called for each. And like I said, this will iterate through your array and create each view accordingly. So when we initialize the for each here, you can see it takes in data and content. And here we use this initializer because this means our data doesn't have to have that data parameter name, right? So for our data, again, if we go to our framework here, right, we can see we're going to have mock data.frameworks, and that's going to be this array of all this mock data that I gave you. So back to this. So we'll do framework. No, my bad. Mock data.frameworks. There we go. So now ID, when SwiftUI is iterating through all this data, each one has to be uniquely identifiable for SwiftUI to know what to change, like if you're adding or deleting objects. So for right now, \self, right, because this will basically take the object out of framework and hash it and give it its own kind of identifier. Let's dive into that real quick because that may have been very confusing. But again, back to these kind of autocomplete things, I like to do this and then just open and close braces afterwards, and Command C, Command V, get our framework in the for each, right? Not separately. So there you go. Now, let's do a Command B. We should get an error. And as you can see, cannot convert value of type void to framework title view. So what I forgot to put here is as it's iterating through this, and this is very similar to like a for loop that you may be used to, you need to like have a name for each item. Well, you could do underscore to not have a name, but we want a name. We want to do framework is what we're going to name each of our elements and then in. Right? Just again, kind of like you're iterating through this. So now what that does for me is that as I'm iterating through, instead of hard coding app clips, right, I can do framework.name. Again, this is kind of similar, to a for loop that you may be used to in UIKit. So framework.image name, right? So that's what I'm doing. I'm using this framework to get the values I need from each framework as we iterate through that. Now, it's not working because I'm missing a very key point here. It says generic struct for each requires that framework conform to hashable. Okay, so let's go to our framework object. And the reason it needs to hash the object is because, like I said, it needs to give it like a unique identifier. And we're saying just, hey, the ID should just be self. Now doing something like self is fine when you have like maybe an array of integers, but when you have a custom object like we do in our framework, it's best to, well, you have to conform to hashable like this. And then you're going to get automatic hashable conformance because when you use, the foundation types here of like string, int, double, because those all automatically conform to hashable. If you have more custom types in here, you might have to write your own hashable conformance. But what I want to do to make this like super clear here, and this is what you should do when you have custom objects like our framework, is also conform to identifiable. Now you're going to see here, Command B, type framework does not conform to protocol identifiable. All it needs to conform to identifiable is an ID. So I can click this, hit protocol stubs. We're not going to do the object identifier. I guess this is kind of the same thing. This is what I always do. Var ID equals just to initialize a new UUID. And we'll actually make this a let because we're not changing it here. Make it a constant. So here we gave framework an ID and it's going to initialize a new UUID every time. And that's going to be the unique identifier for this object when it's in like, for loops and such. So now back to our grid view. Now, instead of ID being keypath.self, it's going to be keypath.id. And what that ID is, again, back to framework, the property ID. So that's how the for each is going to identify the object. Now, the nice thing about SwiftUI, if we want to clean this up a little more, is when you conform to identifiable, like we just did, yeah, you can keep this here, this ID, but SwiftUI is already going to know because this object conforms to identifiable, I'm going to identify that object by its ID. So this code is kind of redundant. So if you want to clean up your code a little bit, conform your objects to identifiable, and then now you can delete that and SwiftUI is going to know to look for the ID. That way your for each is a little bit cleaner, right? For each, our array of frameworks, and then the variable name for each framework as it iterates through. So now by running this, I should see like 16 app clips. No, what am I missing? Let's try it again. Sometimes previews, there we go. Again, previews can be a little finicky, like I just said, but I said 16 app clips, but that's a lie because I forgot we actually passed in the framework.name, framework.image name. So you can see our grid is, let's click off here so all those red squares aren't cluttering everything up. Our grid is kind of taking shape. It's not exactly how we want it, of course, but you're starting to see this come together. But now that we have this framework here, like I mentioned before, let's take the time to clean up our framework title view. So if we go down to framework title view here, right? We don't want to pass in an image name and a name separately, right? It's all part of the same framework. So what we can pass in here is say, let framework of type framework, right? So that's all we're going to pass in. And then now we got to change our names here, right? So we got to do framework.image name and framework.name. Do Command B to make sure everything is copacetic. Build failed. What do we do? Oh yeah, we haven't fixed this yet. So yeah, now our framework title view just takes in a framework. Like we've kind of done this before here. So now we can do framework, and then we're going to pass in this framework again as it's iterating through the for each. It's iterating through our array. We're going to pass in each framework into the framework title view to populate that. So again, now our grid is actually very clean, right? We pass in our columns. Cool. Our for each, again, like I said, the array, each framework, build a framework title view with the framework. Pretty straightforward. So if I pull up the design real quick, you're going to see it doesn't quite look like what we have. Well, one, it's It's not in dark mode. Like, what are we, psychopaths? Let's go back to our preview here. If you click this icon here, we can change the, what our preview looks like, right? If you want to change the device, the layout, we're going to change the color scheme, right? And also below this, you can check dynamic type, right? If you want to test what your app looks like. So this little environment overrides is a great place to test your app on the fly in the preview. We're going to keep it simple just now, change it to dark mode because we're not psychopaths. And you see what it did to our preview here, right? Here's our preview struct. Well, we used to have just framework grid view, but now we added a preferred color scheme .dark. So if you wanted to convert to dark mode just by typing that line of code, you can, or you can go to the environment overrides and change stuff here, right? So now we're testing this in dark mode now. Let's add our navigation view to get our nice looking Apple Frameworks navigation title. Okay, so here in our body, which again is only a couple lines of code. Again, the goal isn't to get to the minimum lines of code. It's for maximum understanding. Like, I'm going to kind of pound that into your head. But I feel like even though this is only a couple lines of code, very understandable, at least in my opinion. Of course, that is very subjective. I get that. Okay, so let's wrap this whole thing in a navigation view, right? So the navigation view, if you're coming from UIKit, which I think a lot of you are, is basically a navigation controller. Right? So that's all we did to add a navigation controller, right? And if you remember how navigation controllers work, they hold an array of view controllers. I'm speaking UIKit terms right now, right? The navigation controller itself doesn't have a specific title like the Apple frameworks that you see in the design, right? As you're swiping through a navigation controller, that navigation title is going to change based on what screen is showing. So this threw me off at first, right? So when I want to add this navigation title in SwiftUI back to our code, I thought, hey, here's my navigation view. Cool. Let me add navigation title, and we'll do, I like to add the emojis here. Apple frameworks. So when I wanted to add the navigation title, I tried to add it to my navigation view, thinking, hey, that makes sense, right? That's logical. But again, if you think about that UIKit example I gave you, it's the content in the navigation view that has to know what title to show. So that's why you put the navigation title on we're going to put it on our grid here. Eventually we'll put it on something else, but right now our grid is the top level view in our navigation view, as you can see. So that's not the desired outcome, obviously, or is it? I don't know. What's your style? Who knows? So we need to put our lazy V grid in a scroll view. Now, if you've ever built a scroll view in Storyboard or Programmatic was a little easier than Storyboard, but building a scroll view in Storyboard is a nightmare. Watch how easy it is in SwiftUI. I'm going to type scroll view, open and close braces, and then we're going to copy or cut the grid, put it into the scroll view. And by doing that, we're leaving our navigation title on the scroll view. Real quick tip, if you want to see what is on something, this was introduced a couple of Xcode versions ago, but using your arrow keys, just arrow left and right over a brace, and it'll show like what you can see this flashing yellow light. That means that brace is the scroll view. And if I go up to this curly brace, oh, that's my V grid. If I go up to this one, okay, cool, that's my for each. Because sometimes SwiftUI curly braces can get out of control, so that's a nice way to see like what's what. So that way you can tell our navigation title is on frameworks. We put our lazy V grid in a scroll view, which all of that is inside our navigation view. Hope that made sense. But now when I run this here on the preview, now we get the scrolling action that we expect. And you can see the navigation title. You see it went up smaller at the top. We get that nice blurry effect up there with all of our frameworks. So just like that, and only a few lines of code. One last little tweak, and this is just personal preference, but I feel like our frameworks are pretty cramped, right? It's cramped up at the top here. It's cramped all the way, look at SF symbols. It's cramped all the way here to the left of the screen. So what we can do here is in our framework title view, right? So each individual framework is going to get this padding, right? So on the VStack of our framework title view, let's add .padding. And then if you see what that did, that just spaced things out, gave it more room to breathe. In my opinion, that's a nice cleaner look. This is totally subjective though. Here, real quick, watch the preview. I'm just going to comment out the code real quick. This is with padding. That's without padding. With padding. Without padding. But it's cool how you can play around with like looks like that in SwiftUI, literally in like seconds. So let's put the padding back in there because I like that. So our grid is built nicely. And then again, the cool thing is like, here's the code for our grid, And again, I try not to brag about, look how little lines of code it is, but this is a case where it's nice and readable, easy to understand what's going on. Now, the challenge I'm going to leave you with at the end of this video is to try to build our detail view, a whole separate screen, as you can see in the designs, right? We tap on a a framework, and the detail view slides up. Now, I'm not asking you to pass the data, connect everything. No, we're going to do all that in a future video. All I want to see if you can do is to just build the UI structure of the screen. And I'll give you a hint, it's just a VStack. So nothing, all these challenges, I'm not trying to be like too crazy if you haven't noticed that yet. Again, I want to get you practicing, building these skills. But in the next video, we're going to build that screen together. But if you want to take a shot at it on your own, go for it. All right, see you in a bit. We left off last video getting our grid in place as you see here. I left you with the challenge to build the UI of the detail view, and that's what we're going to do in this video. So if you struggle with that challenge, don't worry. We're still early. We're still getting started. We got plenty of practice to go. If you did complete the challenge, now's where we can kind of compare code and compare methods and, see how it went. Okay, so the first thing we're going to do, this is going to be a separate file. So click on our Apple Frameworks folder, Command N, new file, new SwiftUI file, hit next. We're going to call this framework detail view. Create. Cool, it's blank. Let's get our preview up and running nicely. There we go. Hello world. Cool. So again, pulling up the design, let's talk about the overall structure, right? So we have our framework title view, like the VStack we've already created, right? Remember we said we were going to reuse that. So that's one part of the VStack. And then we have our body of the description, right? The 2 paragraphs or 1 paragraph, whatever. That's another part of the VStack. And then we have the button at the bottom. That's the final piece of the puzzle. If you see in the upper right, we have the X dismiss button. More on that later, but that is also going to be part of the VStack. So I like to take this step by step. I mean, I just kind of broke it down for you. So we'll leave the X towards the end because there's more explanation there for why we're doing that. But let's start with our framework title view, right? The reusable VStack we created. So here in our body, let's get rid of the text here, give us our kind of overall VStack, and let's create our framework title view. And here's where it gets tricky, right? So it takes in a framework. Well, okay, we haven't passed in the framework yet. We're going to pass data in the next video. But I can set that up, right? So I can do var framework that we're going to get, and it is a framework. Now, when you create a variable on your view overall, but you don't give it a value, and you want your preview to work, you're going to have to give your preview a value. Like it's got to know what to show, right? So you can see missing argument for parameter, framework, and call. Hit that, fix it. Cool, so now it's expecting a framework. Well, if I initialize a framework, you see it takes a name, image, cool. So I can initialize one right here. We'll go to our framework real quick. I'm just gonna give you an example here. So I could copy, paste this, go to our framework detail view. Let's move that up. If I wanted to just kind of paste that framework initialization right here, like this will work. If I hit my preview, well, editor and source, got to pass in framework up there so it knows what to do. Now try again on my preview. There we go, app clip. So this works, but man, this is sloppy. Even if I made my canvas small, I don't want all that in here. And oftentimes when building a preview, you'll find out that you have to pass in a lot of your objects. And then if you're passing in objects, you have to initialize a new one. And some of those initializers can be long, as you can see here. So that's super sloppy. So this is why I like building nice mock data. So if we go to our framework model here, just like we had our array of frameworks, we can do something very similar. Static let sample framework, right? So just one, and that is going to equal, and we'll just, you can pick whatever one you want. We'll use ARKit, right? Who doesn't like some good old AR? So copy ARKit, and now our sample framework equals ARKit. So, our messiness, right, if you will, or kind of the necessary evil of having all this stuff is in our mock data file, right? Kind of separate away from our nice, neat code that we want people to use and read. So now instead of initializing this here, right, I can just do, what framework do I want to pass in? I want to pass in mock data.sample framework. Is that what I called it? Yeah. How quickly you forget. So if I do Command B now, try again on my simulator or preview. Come on, preview, work with me here. There we go. So now ARKit is showing up, and our preview is nice and clean, right? Mock data.sample framework. So that was a little aside, but as you build more and more complex apps and you want the preview, and I'm going to be honest, sometimes my views will get kind of complex that I just give up on the preview. I'm like, you know what? This view's just not going to have a preview because I don't want to take the time to build it. Maybe that's bad practice, but I'm just being honest. That's how I kind of worked in my last app. Sometimes I didn't take the time to build the preview because it can get complex. So anyway, that is the initial step of our detail view. Now, what's the next step of the VStack? Like I said, well, it's our body, our description. Well, that's just the text here. So if I do text, and what's the text we want to pass in? We want to pass in framework.description, right? So bam, there you go. It shows up right away. Now we want to adjust this text a little bit, right? Because as you can see, it's hugged up right up against the edge, right? You want to make this, because these are going to be paragraphs in, I tried not to make them walls of text, right? You don't want to have walls of text in your app. So I tried to break them up a little bit, but I want to make this easy to read. So let's get it away from the edges here. How do you think we're going to do that? We're going to put padding on it. So I do dot padding, there we go. Now it's spaced out nicely, as you can see. That's much more easier on the eye. One thing we want to change as well is the font. Now, remember, like I said, this is not a title. As you can see, title's huge. You don't want it to be like that. We want body. So body is more just for like actual reading, like paragraphs, like we're doing here. So there you go. There's the body. All right, so we got that in place. Now the next piece of the puzzle is the button at the bottom. So we've done this before in our weather app. Button. Again, the first part is the action. The second part is the label, what it actually looks like. And we're going to do the same thing we did in the weather app. So text, and the text is going to be learn more. And again, as you can see, we just get the learn more blue button. That's pretty basic. We want to make it actually look like a button. So let's do font. Again, this is a little bit different. Last time we hard coded a font of 20. This time we're going to support the dynamic type .title2, right? So that's getting a little bigger. Again, I want to make it semi-bold, .font weight, .semi-bold, right? Not too bold, but bold enough. So again, that's one button you could do, but we want to again put the background around it. So background color, we're going to do color.red, but red and blue doesn't look good, right? So we want our foreground color, which is going to be our text color, .foreground color to be .white. There we go. Well, that looks pretty cramped, of course, right? Because we didn't give it a frame. And now here's an example of where the order of the modifiers matter, right? So you may just be like, okay, cool, let me give it a frame. Frame, and then like I mentioned, my typical go-to button is 280 by 50. That's just my personal preference. Change it if you like. Cool. But you may be like, wait a minute, it doesn't look any different. Well, again, that's because we're putting the frame on after we've already established our background color. So the frame's got to come before background color, so the background color actually fills up the frame, right? So there you go. Now you see the change here down in the lower right. And then the final touch that we're missing is .corner radius of 10, right? Just to round off those corners a little bit to get the button looking nice. So that is our button here in the VStack. Now the button is kind of cramped up against the text, right? I want the button to be pushed down to the bottom. So if I want the button to always be pushed down to the bottom, what do I need? I need a spacer. So we'll put a spacer above the button. Spacer, there you go. And as you can see, that pushes the button to the bottom. But again, as you see, we put the spacer in this area here. So it's going to push everything above it as far as it can go up to the top. Well, we don't want that. So let's put a spacer above our ARKit VStack, right? Our framework title view. So we'll put a spacer here to push that down. And now it'll like even things out, right? The spacers, these two spacers will do their job to have an even space at the top and an even space at the bottom and push our content in the middle. And that's kind of the look we're going for. Okay, and as I said before, we're going to refactor on the fly as we go, right? So this button here, again, you're going to most likely use buttons all throughout your app. So let's do Command-C to copy, and over in your Apple frameworks, Command-N, create a new file, SwiftUI view. We'll call this AF for Apple frameworks button. So AF button, create. Here we go. Now in our body, because I copied that text earlier, just paste that text. Let's get our preview going. So you can see we have our preview of our button. If you want to like tweak it, maybe adjust the design a little bit, you have this nice isolated preview. We don't want it to be learn more all the time. We want to be able to pass in our title string. We want to be able to pass that in and then put title into the text. All right, so now our button can say whatever I want. It is, in this case, remember last time, well, hold on, let's update our preview. Remember, like I said, if you have properties on your view, you have to pass them in the preview. So we'll say test title, just to show that it is going to update the preview here. So it went from learn more to test title. Now, last time we actually kind of made colors and foreground color a property to make it like super flexible. Well, let's say we have a certain style in our app. It's always going to be red. Our font is always going to be white. So that way, all we got to pass in is the title. So let's go back to framework detail view. And instead of having all this code, we can just do AF button and then pass in a title of learn more. And again, our code in our view is nice and clean. I personally like to have spaces in between each like element. To me, that helps me visually like realize what's separate and what's not. That's a personal preference. Another personal preference, dark mode. I just don't like the way this app looks in like light mode. Anyway, I think it looks so much better like that. Now, the last piece of the puzzle here is when we present the screen modally, as you see in the design, it's going to pull up the card, right? You see how it takes up like 98% of the screen. You may have seen this in like your day-to-day apps. Well, when it does this, you can just swipe it down and you don't have to write any code for that. You get that functionality like automatically. Something you should know about when you display something modally, which is quite common in apps, is the human interface guidelines by Apple. Let's go to that real quick here. So, and I'll link to this in the description of the video. So the human interface guidelines on modality, right? Presenting a modal. Here's the example they showed, like the mail app, right? You slide that up. Well, if we go here, right? So yes, you get that swipe to delete for free. You may think that's enough. But here in the human interface guidelines, here's why you should always include a button, right? Well, because they say, always include a button that dismisses the modal view. I'll make this bigger so I can be sure you can read it on the screen, right? For example, you might use a done or a cancel. We're going to use a little X. Including a button ensures that the modal view is accessible to assistive technologies and provides an alternative to dismissal gestures. So human interface guidelines basically says, always add a button to your modals. Don't rely on just the swipe. So we're going to be good citizens, iOS citizens here, and we're going to adhere to that. So we want to put our X in the upper right-hand corner. Okay, so let's start doing that. So we'll put it at the very top. We'll do a button, very, very similar to what we did with the AF button down below. Label. And what do we want our label to be? What do we want it to look like? Well, SF Symbols has a generic X, right? We're going to use that. So that's going to be an image of system name, right? Not just name, because we're using SF Symbols, called X mark. Right? So there you see, there's our blue X, pretty small. It's in the middle, doesn't look like how we want it. So let's start changing that. Let's give it a foreground color. .foreground color. Now, you could do .white. You may think that, but .white is going to be .white on the black background and .white on the white background. So you got to support light and dark mode, so you can't just do white, right? So you can get access to UIKit's system colors, right? That adopt to light mode, dark mode. So you do color and you initialize the color with .label, right? And this whole dot thing, right? This is where you get all the, again, system colors from UIKit, right? Right, where you can get like, system fill, secondary system, placeholder text, right? So label is one of those that will be essentially black in light mode and white in dark mode is what that label does. So that X is quite small. Let's make it a little bigger. You can do image, scale, and you can see .medium, small, medium, large. We're going to do .large. And this is something you can do with your SF symbols. I tend to do that a lot. And then we'll give it a frame of 44 by 44 because that's a typical touch target, right? You don't want your touch targets to be so small that they're hard to press, right? And you'll see when I run this, you'll see the touch target I get. Like you can see it clicking. You can see it like fading out. Well, you can see I can click over here and still get it. And if I'm clicking here, I'm not getting it, right? So we made our touch target pretty big, right? So you can miss the X and still hit it. Now, the final piece here is, okay, it's dead center. Maybe we're doing a new design style, I don't know, but we probably want it over off to the right. That's pretty typical where dismiss buttons are. So how do I move my X button over to the right? Well, VStack has an alignment. I can do the alignment parameter on the VStack here, and I can do .trailing. Okay, well, that moves everything to the right. So I'm kind of showing you what the VStack alignment can do. That's not what we want. And just so you know, you could do .leading. Cool. Okay, that's not it. So, okay, we're going to leave the alignment as is on that VStack. However, what I could do is I can put our X button, which is right here, we're going to refactor this out in a second, into an HStack. So HStack. And let's put our button here into that HStack. So Command X, Command V. So now our button is in the HStack, but you'll notice nothing changed. Well, what can we do to push it to the right in an HStack? A spacer, right? So if we put a spacer in front of that button, now it's going to push that X all the way over to the right, too much to the right. In fact, let's add some padding onto our overall HStack to give it more space, more room to breathe, not so much right up to the edge. So here we have this HStack, which again goes across the top, pushes the X to the right, and we keep all of our content pushed towards the bottom where we want it, right? We want it to be at the bottom of the card above the button. That wraps up the UI for our detail view. We're going to come back and refactor that X dismiss button later because we still got more to do with that. And in the next video, we're going to pass data and connect these screens. We left off last video building the UI for our detail screen that you see here in my preview. Well, in this video, we're going to work on connecting everything so that when you tap on a framework, this detail view will slide up and you can dismiss it. So let's talk about how we're going to do that first. If we go back to our grid view, right, that has our grid here, and you can see our for each, right? Remember, this for each is what's building each individual framework title view. Well, in UIKit, in like a collection view, you would have like did select item at index path, right? That may sound familiar to you. We don't really have that in SwiftUI, so we actually put a tap gesture on the individual title view, right? So we're going to do that now, and then we're going to explain like how we manage the data and like how we actually do this. So I just want to add this real quick. So on tap gesture, right? And then you see the closure with the code. Again, I just like to have the on tap gesture with just the code. Pretty simple. And here's what we want. Right now, I'm just going to put print, whatever, just to get Xcode to not yell at me. So I'm going to kind of relate this to UIKit in order to explain SwiftUI. And I want to explain it that way so I can, reiterate the imperative way of thinking versus the declarative way of thinking, right? Part of that mindset shift. Well, in UIKit, you can imagine on this tap gesture, or again, it was did select item at index, whatever, you would say, okay, present the modal screen with that framework. Like you would specifically say that in your did select delegate method, again, in UIKit, right? But that's the imperative way. You're telling the UI exactly when and how to update. Whereas remember, in declarative, we just update the data, right? We update that source of truth, and then our UI reacts to that change and updates accordingly. So again, that's the major shift. So what we want to do on tap gesture here is we want to update our source of truth or our data. And what we need to update is what framework we actually selected. Now here's where we're going to introduce MVVM or model view model. And real quick, this is going to be a dead simple implementation, super basic. As we've been doing throughout the course, we're going to build on that in future apps, but this is kind of like your introduction. Now, before I give the overview of what MVVM is, let me give the typical architecture debate disclaimer, right? No matter what you're doing, what architecture to use is always going to be some sort of debate in the developer community, right? If we're coming from UIKit, there's MVC, MVVM, Viper, MVP. It seemed like there was a hot new architecture like every couple months, right? And that was one of the most common questions I always got asked is like, what architecture should I use? So when it comes to SwiftUI, it seems like the early consensus is MVVM, but I've seen plenty of dissenting opinions on Twitter saying that MVVM isn't the right architecture. So I guess what I'm trying to say is I don't think that architecture debate's going to go away. You're going to constantly hear other people recommending different architectures. And that's just me giving the disclaimer, like, yes, we're going to learn MVVM, but there are going to be plenty of other architectures. That debate is going to rage on. But again, the early consensus seems to be MVVM. But like I said in the beginning, SwiftUI is so early, it's constantly evolving. Like there's a chance we could look back in 3 years and be like, hey, remember when we built SwiftUI apps in MVVM? That was funny. Or it could become the standard. The point is, the only thing I can promise you is that things are going to change. So hopefully through this course, I can help you build those fundamental skills so that you can evolve and grow with those changes. Okay, so disclaimer out of the way. What is MVVM model view model? Well, let's start with the endpoints, right? We have our model on one side, which in our case in our app is our framework, right? Our framework object. And then we have our view on the other side, which, in this early case is like our grid. So to put it really simply, and again, this is the intro, we're going to build on this more as we practice it and learn it. But to put it really simply, you have your model, which is all the data. You have your view, which just displays everything. And then the view model is a layer in between that kind of handles all the display logic. Again, keeping it big picture. You kind of want your view that displays whatever it displays to be as dumb as possible, right? It shouldn't know about anything other than tell me what to display and I'll display it, right? There should be no logic in your view. That all should go in the view model in this philosophy. Now, do you need a view model for every single view you have? No. The view model should really only come into play when the view is dynamic, like things can change. Like in our example, the selected framework is kind of dynamic, right? You can't hard code that. However, if all we were doing was displaying this list of frameworks in a grid, like you couldn't tap anything, it was just display. You don't need a view model for that, right? You just read directly from the data or the model. So you only need a view model when there's some logic and changes going on, which to be honest with you is probably going to be most screens. But I want to be sure to say that a view model is not required for every screen. If you're just reading and displaying data, that's it. So that's the high level overview. Again, we're going to get plenty of practice with this in the coming apps. This is your introduction. So let's build our view model. Again, it'll be very simple. So click our Apple Frameworks folder, do Command N for a new file, just a Swift file because it's not a SwiftUI view. And we'll call this framework grid view model. I basically use the name of the view and then like add model to the end of it, right? So hit create and import foundation. It's fine. We're actually going to have to import SwiftUI. And you'll notice everything in SwiftUI has been a struct so far, right? Well, now we actually want to hold state. So this is going to be a class. So you do class, and again, we'll call this framework grid view model. And then the key to make this the view model for your SwiftUI is to make this an observable object. So what this allows is for our object to publish information, right? Kind of like broadcast, like, hey, I changed, and we need to make sure we set up the proper views listening to this so they can update their views when their properties change. You're going to see this in action. If that was confusing, apologies, but you're going to see this in action. One quick thing, this should be a final class. That's just a general Swift note. If you're not going to subclass your class, make it final. So what do we need in our framework grid view model? We need a selected framework, right? That's really what we're trying to keep track of here. So we'll do var selected framework. And that is of type framework. And it's going to be an optional because at the start, like we don't have a selected framework. Maybe if you wanted to give it a default value, sure, we're going to keep it optional. So we've created the beginnings of our view model. Again, it's an observable object. So now we need to tie this to our framework grid view. So let's go back to our framework grid view. Well, first I'm going to drag this up above. I'm going to do project organization at the end, so this will become less cluttered, but framework grid view. So now we need to use our view model here. So I want to do at state object. We're going to explain this state object. So state object and observed object are similar. I'm going to explain the differences here in a bit. Var view model. So this is us creating our view model, and it equals framework grid view model, right? And we're going to initialize a new one. And we'll come back to this in a second, but that's the difference between state object and observed object. Like when you're initializing a brand new view model, like we are here, you want to use state object. If you're injecting it from like a previous view, like when you initialize your framework grid view, you initialize it with a view model, then you're going to use observed object. I don't want to get too in the weeds on that right now because we're just introducing the topic, but we'll dive into that later. So let me stay on state object for a second here. What this allows, let me hit resume because that's bothering me. What this allows is previews, am I right? This is very similar to state. Remember how I said state is kind of like a little piece of data that persists while the view gets destroyed and recreated all the time, right? So you can imagine if this wasn't a state object, right? If our framework grid view gets destroyed, re-rendered, which happens all the time, like anytime you make a change, then this is going to get reinitialized. And every time it gets re-rendered, because we are creating a new view model, it's going to create a new view model. And it's not going to hold state, right? Because it'll initialize with whatever default values we gave it. For example, the default values right now is our selected framework is nil, right? So if we had a selected framework and then it got destroyed and re-rendered, that would revert back to nil. So that's why we want to hold state object, because it's very similar to at state on our other variables, where framework grid view can get destroyed and recreated all the time, but this is going to be held off elsewhere and persist and maintain its data. It's going to stay alive while framework's grid view gets destroyed and recreated all the time. I know I repeated myself a lot there, but state object, observed object, this whole passing data, this is one of the trickier parts of SwiftUI and getting things to work correctly. And this is just your first exposure to it. Like I said, we're going to keep building on this and use it a lot. So for now, we're going to use state object with our view model to create that. Now what we can do here is on tap gesture, we can do view model dot selected framework equals framework. And what we did here is this framework, remember that we're passing into each framework title view. When we tap it, we're making our selected framework in our view model equal to that framework. So we know what to pass to the detail view. So, okay, we're changing our source of truth, right? That's the whole idea behind declarative. Change the source of truth and the UI updates. Well, now we have to set up our UI so that it updates. So let's go back to our view model here. And we want to create a variable called is showing detail view. And it's going to equal false by default. It's a Boolean. Now this property needs to be published, right? Because we want our grid view to be listening for when is showing detail view changes. Because when is showing detail view changes to true, that's when we're going to show our detail view, right? So our grid view back here needs to be like listening for that and waiting. But in order to be able to hear it, it's got to publish itself. So in order to do that, you just add @published in front of the variable. So now our view model, whenever is showing detail view changes, it's going to publish that change. And our grid view, we haven't set it up yet, is going to listen for that and change when it updates. So now while we're in our view model, let's make some space here. How do we get this to trigger? Well, we can put a did set here, did set, and we can do is showing detail view equals true. Let's do a Command B to make sure everything's good. Now what we're doing here is anytime the selected framework changes, we're going to make is showing detail view true, right? So when does selected framework change? When we tap on the grid, this will change. This will flip this is detail to true, and then we'll show our detail view. So back in our grid view, now we need to set up the detail view to show when that changes. And our detail view is called a sheet. So on our scroll view, we can do it below our navigation title. We want to do .sheet, and we're going to do, there's a couple different ways to implement these, but we want to do is presented. So is presented takes in a Boolean, like is it presented, true or false? So we want this Boolean to be whatever in our view model is showing detail view is, right? Whatever is showing detail view is, that's what we want, right? Because that's what we're listening to. So back in our grid view, is presented, and we need to make it binding. So $ view model dot is showing detail view. And I'm going to get rid of this content parameter label because I don't need it. Put that there. Okay, so what we're saying here is show this sheet whenever is showing detail view changes. Now, what view do we want to show? Well, we want to show our framework detail view. Now, if we initialize our framework detail view, you see it takes a framework. What framework do we want to pass in? We want to pass in view model.selected framework. There we go. Now we have our detail view. Let's do a Command B. Looks like I'm getting some errors here. Probably forgot something silly. Yeah, it looks like I left this parentheses here from the autocomplete. And I believe I'm going to get yelled at because this is an optional and I'm not unwrapping it. Yes, that's what it is. So what we can do here is a couple things. We can force unwrap. That's the easy route, but that's a little dangerous. What you could do is you could do nil coalescing, and we're going to give it we're going to do mock data.sample framework just to give it a default value if that is nil. Now that's going to show app clips, right? Because that's our ARKit. That's our sample thing. What you would do in like a real app, a real product is maybe you would have a detail view like this that is meant for like the empty state. And, you know, instead of saying ARKit, you could say, oops, could not find. Instead of the icon, you could have like a sad face, and then your body could say something different. You could pop up an error message. There's so many different ways to handle the errors. For now, we're just going to give it a default sample framework, but that should be set up now to work. If I hit resume on my preview's been acting up. Hopefully it's good. Okay, we'll hit play. Okay, so now we're actually running it. So now when I tap on a framework, we should see the slide up card. Tap, slides up. I thought I was in dark mode. Well, I can't dismiss it. That's by design. I knew that was going to happen. We're going to implement that here in a second. But let me stop this. Weren't we in dark mode? Yeah. Okay, so this could just be a preview thing. I'm confused right now. Sometimes previews act weird. I'm going to run this in the simulator to make sure we didn't mess something up. I think that's just a preview issue. So here we are in the simulator. If you do Command-Shift-A, that'll shift to dark mode real quick. Okay, so we're in dark mode. Let's tap on CloudKit. Okay, so yeah, that was just a preview issue. Again, just showing you previews can be finicky. They can be a little weird. Always test in a simulator or on a device if you see something weird going on in your preview. Don't bang your head thinking you have a bug if your previews are messed up. Double check it on a simulator or a device. So okay, so this is the expected behavior. I can't dismiss it. I mean, I can swipe down. Remember I said you got that for free. You got the swipe down for free, but we need to be able to dismiss from this button. So we have to use that is showing detail view. We have to pass that down to our detail view in a binding so it has access to it. So when I tap the X button, I can flip is showing detail to false, and then it will dismiss. So let's do that. Okay, we'll stop running this. Back to Xcode, resume the preview. So like I said, we need to pass to our detail view a binding of is showing detail. So in framework detail view, let's go ahead and give it another @binding var is showing detail view, and that is a bool. And what we're going to do here, you notice in our button right here, we're in our HStack with our X button, right? Remember that. We didn't give it an action before, so it does nothing as you saw. now we want to do is showing detail view equals true. And remember binding, right? I know I'm repeating myself, but I want to drill this passing data home. Binding makes is showing detail view equal to whatever it is in the parent view, which is our grid view. And if you look at our grid view, we're using the view models is showing detail view, right? This is what we need to flip to show and hide the sheet. So you'll notice if I do a command B, what I need to do is update my initializer here for our framework detail view. Because before it was just taking a framework, but now I need to have an is showing detail view binding, right? So let's make our parameters like that. Okay, just for sake of making this readable, I don't know, this annoys the crap out of me when they wrap on 2 lines. I've already explained to you how not to force unwrap it. I'm gonna go back to the force unwrap just so it's easy to read and looks nice for you in the video. Again, don't force unwrap it, but just for ease of understanding and ease of seeing it, I'm gonna force unwrap it. And now in the binding, we need to pass in $view model, it's gonna happen here too, is showing detail view. Part of it is my font is ridiculously huge. I guess I'll have to live with that. Now you know why my code is nice and clean and readable, because stuff like that drives me nuts. Okay, so what we're doing here is passing the binding, like I said, from the view model into our detail view. So now when we flip that back in our detail view, everything's gonna trigger and we're going to hide the sheet. So let's run this on the simulator again, just to be safe. Build failed, I forgot something. All right, what's the error here? What did I forget? Missing parameter. Okay, the previews. I remember I told you previews can be a headache. Like we just didn't update our preview here with our new is showing detail on our detail screen, right? So, right, we added our is showing detail view to the initializer. Well, you got to update your previews as well. Now, when you do bindings, right, because you're not really passing anything into the preview, you can do .constant, we'll say false. This is just a way to kind of like hard code bindings for your previews if you want to do that. So now if I run it on the simulator, we should be good. I'm gonna go back to the grid view here. Okay, back to the simulator. Okay, so now when I tap on health kit, I can swipe down, that was good. Tap on health kit again. Now when I hit the X, all right, what did we mess up? So stop running this and take a look. Okay, I found my issue. Embarrassing, but we leave this in because this type of little stuff happens, right? So I literally spent like 3 minutes debugging, making sure everything I had connected was working. And I was like, the binding's fine. Like this should be working. What's going on? Again, these are these silly mistakes that all programmers make. Well, when I'm tapping my X button, right, is showing detail view, I'm setting it to true. So of course the detail view is going to still show when I'm tapping X. I'm setting it to true. I need to be setting this to false. So again, super silly mistakes can kind of lead to, you debugging for a few minutes the wrong thing. So hey, happens to the best of us, but we switched that to false. Now let's run it on the simulator. And now, let's go to Catalyst. So now when I hit X, again, now we're flipping it to false. So now it goes away. 4 little characters messed me up for a few minutes there. But our data is all being passed around, working correctly. You got the intro to MVVM. Let's go to our view model just to kind of rehash it a little bit. So like I said, it is a class and you want to conform to observable objects. This way it can broadcast its changes. The stuff you want to broadcast, you put a published in front of it. So now anytime is showing detail view changes, it broadcasts, it publishes. And then here in our grid view, here in our sheet, right, our sheet is listening to that view model is showing detail view. So whenever that changes, our sheet shows and dismisses accordingly, as long as you set the right Boolean. But that's kind of the very simple example of how all this works. If you kind of understand it, great. If you're still a little confused, don't worry. Like I said, this was just me showing it to you, just our introduction. We're gonna work with this in future apps and get more in depth, more complex. Like if you look at our view model, pretty simple, right? We just have one variable that changes and then, we broadcast a Boolean when it changes. But you can imagine like a real app, there's gonna be network calls in here. Maybe there's other functions with other logic. So these can and will get more complex in this course. But again, I just wanted to show you what it was all about. Let's move on to the next video. Just like last video was your first little taste of MVVM, this one's gonna be your first little taste of interacting with UIKit. And we do that through UIViewRepresentable or UIViewRepresentable. And the reason we have to use these is, like I said 100 times now, SwiftUI is so new, so it's not fully built out yet. So for example, in iOS 14, SwiftUI just got support for MapKit and SpriteKit. So now you no longer have to use UIViewRepresentable for like your MapKit stuff. But there's still a lot left, such as the camera, which we're going to do in the next app, that doesn't have SwiftUI functionality yet. And there's many more, the photo picker. So for that, we need to integrate with UIKit, and that's what I'm going to show you here. However, I do suspect over the coming years, right, just like MapKit and SpriteKit got introduced this year, over time, I do believe the need for this UIViewController or UIViewRepresentable is going to, I don't know if it'll ever go fully away, but it'll become very, very niche, whereas most of the common, UIKit stuff will get SwiftUI counterparts. But for now, and until that actually happens, this is going to be a key skill you're going to need to know. Okay, so big picture, what's going on with these UIViewController representables and UIViewRepresentables? By the way, that's a mouthful. I'm just going to say UIViewController representable. Just know that I'm talking about both. You would use them accordingly. If you need a whole view controller, use the view controller one. If you just need a view, use the view one. All right, so basically what we're going to create is a SwiftUI view that conforms to UIViewController representable. And that view, like, every view has what we're looking at here, this var body some view, right? In SwiftUI, every view has a body. Well, what the body of the UIViewController representable is whatever view controller in UIKit we create, right? Okay, so that's what's happening. This body is getting replaced with the UIKit view controller. So let's create this kind of container view, if you will. So we'll do Command N in Apple Frameworks. So File, hit Next. We'll call this Safari view because that's what we're showing. The UIKit component we're using here is the Safari view controller, right? At the moment, there is no SwiftUI Safari view. Again, I'm assuming there will be in the coming years, but right now there's not. Whoa. Quick interruption, because after I filmed, edited, upload, recorded, all that stuff, this entire section, I randomly discovered that, oh yeah, iOS 14 did introduce a link that kind of does what the Safari view controller functionality does. No idea how that slipped by me. When I saw it, I was like, how the hell did I not know about this? So anyway, I'm leaving this in and just putting in this little insert because the lesson remains the same, right? The lesson isn't about Safari view controller. The lesson is the introduction into UIViewController representable. So call this Safari view, hit create, and here we are. So we need a struct, just like we're creating a view. So Safari view, except we're not going to do view here, right? We're going to do UIViewController, and I'm not getting it because we didn't import SwiftUI. That's a key thing here. So UIViewController, there we go. UIViewController representable. Now, when I hit return, it's going to say I'm missing a few things because in order to conform to this UIViewController representable, we need two functions, right? One of them is going to be called make UIViewController, and the other, as you may have seen, would be update viewController. Now, these boilerplate functions that auto-filled for me doesn't have all the information correct, right? It kind of gave me the generic information, right? Like, for example, we don't want to return some UIViewController. We want to return Safari view, and we're not getting that because with Safari, you need to import Safari services, right? There's a framework. So do Command B. Now I should get a Safari view controller here. Yeah, there we go. SF Safari view controller. Forgot that as well. Now our context is just the generic context. We want this to be a UI, this is going to be a mouthful, view, controller, representable context, right? And then it takes in what we have here. We have our Safari view. And again, we're going to do the deep dive later. I'm just showing you this. Really what I want to get across is the two main functions we need and what's actually happening in this Safari view controller. We'll get into the nitty gritty in the next app. So can you guess what make UIViewController does? It makes the UIViewController that is going to take the place of our body in our view. So here's where we create that view controller. And the reason why this is a really straightforward, simple example is because, if we had our own custom view controller, of course, we would have to build that and make that. That's what we're doing in the next app. This one, a SF Safari view controller is kind of built into UIKit. So it's just one line of code. It takes in a URL. You know what? We want to make this generic, right? I can't hard code a URL because every framework is going to have a different URL. So our Safari view needs to take we can make it a let URL, and it's going to take in a URL object. So now we can just pass that URL into the make UIViewController. So whenever we initialize a Safari view, we'll pass in a URL that gets passed in down here to the Safari view controller. Now we need to update the update UIViewController here. Again, we're not doing just a generic UIViewController type. The UIViewController type is a Safari or SF Safari view controller, right? That's the type of view controller we're using. And then the context, again, is going to be this same context that we put up here, this mouthful, UIViewController representable context, and then we pass in our Safari view here. And then the update view controller is actually just an empty implementation. You have to put that there For what we're doing, because we're not actually updating anything on the Safari View Controller, it's empty, but this should, what am I missing? But I thought this should work. What am I missing? There we go. Build succeeded. That's why I always do Command B all the time, just to like refresh my errors. So quick overview, again, just the introduction. You create a kind of container SwiftUI view, and it conforms the UIViewRepresentable. Let's dig in here just so you understand what this is a little bit. Again, we're going to do the deep dive. But so SwiftUI conforms to view, right? Where self.body equals never. So this is a view that we can use, in our SwiftUI code here. So that explains why we're not conforming to view here. And again, the body of this view, we're going to make a UIViewController for the body of the view, and that's what we're going to show. So this is the basics of how you dive into UIKit. Again, creating our view controller is just a built-in Safari view controller. That's why that's so simple, one line. You can imagine if you had a more complex view controller, you'd have to do more code here. We're going to do that later. Okay, so now that we have our Safari view, move that up here. Let's go to our detail view. And if I pull up the design, you can see that the Safari view controller slides up in a modal sheet, just like our detail view. So back to the code, we need to add a sheet onto our detail view. So here we can do .sheet, and again, is presented. So like I said, we need a binding bool. We don't have that bool yet, so we're going to create that bool on our detail view called at state var. We'll make it private var. So your at state variables that are just unique to one screen should always be private. So private var is showing Safari view, and again, that's going to equal false by default. We're going to flip that to true when we hit the Learn More button. So let's do that first here. So here's our Learn More button, right? Our AF button that we created. So our action for the button we want to do is showing Safari view equals true. So now when we tap that button, flip that to true. Again, the declarative, right? We're just changing a source of truth of data. The UI reacts. So is presented now, we want that to be based on is showing binding is showing Safari view. So again, whether the sheet is presented or not depends on what value is showing Safari view is. And the content we want to pass in is our Safari view, right? And then remember, we made Safari view take in a URL. So here's where we create our URL, and the URL we want to create from string, right? Let's find that here, right? String. And the string we want to pass in is framework.url string, right? We already have that in our data. Now, you can go like this if you like to live dangerously. That is force unwrapping it, and just assuming our URLs are always going to be correct. Or you can do some nil coalescing, give it a URL, again, pass in a string, and you could give it. This could be some website you have on your server, like seanallen.co/notfound, and you could have a nice little empty state, or you could send them to some default website if that makes sense. Like we'll send it to apple.com. We know that's going to be good, so we'll force unwrap that. Or if the URL string on the framework doesn't work, you could pop up an error. Again, there's tons of different ways you can handle the errors. We're going to get into error handling in the final app of this course. So again, to recap what's going on here, our sheet is going to be presented based on our is showing Safari view bool. What we're going to show is our Safari view, which again is our UI view controller representable here. When this initializes, instead of having a body like the view has, it's going to make a view controller. The view controller that it's going to make is Safari view controller with the URL that we pass in. So if we go back, that's what's going on down here. We're passing in our framework URL string. And if that is nil for some reason, we'll pass in apple.com or handle the error. And again, this all gets triggered when we tap our Learn More button, we flip that to true. So let's hit stop, run it. Okay, let's tap on Class Kit, Learn More. There's our Safari View Controller that pops up. And the nice thing about Safari View Controller is that it has all this done button. Remember how we had to create our own X button to dismiss it? Well, now it has its own done button. So, you can learn about Class Kit real quick. Okay, I'm done. And then it'll slide back down. And then you can either slide this down or hit X. One quick thing I want to show you before we wrap up this video is just a little slight variation we can do on sheets, right? Because like when we hit metal, right, it's pulling up this card that has this auto dismiss swipe down. You may want that. You may like that. You got to add your button. That could be your style. Well, maybe on our Safari View Controller, we don't want this card here. We want it to be like full screen, right? Just, I don't know, maybe we like the way that looks. So new in iOS 14 here, let's stop this. Instead of sheet, literally the only thing that's different is you do instead of sheet dot full screen cover, as you can see, and you're going to get the same. If I hit return, it's going to mess me up. So I'll just type full screen cover like it is. And literally none of the parameters change. They're all the same. You just go from sheet to full screen cover. So now when we run it, and I guess I'm just running it on simulator from here on out. Now watch what happens when we pull up our Safari View Controller, because that's the one we made full screen. So we go to Health Kit, learn more. Now our Safari View Controller is full screen, right? It's not that little card that takes up 98% of the screen. So, depending on what look you're going for in your app on the navigation, use a sheet or use a full screen cover, whatever's best for you. As I showed, it is literally just change that from full screen cover to sheet and vice versa, and you get that behavior. That is new in iOS 14. Kind of sucked because if you wanted full screen cover before iOS 14, like in iOS 13, you had to do a lot of like hacky workarounds. It was rough. Now it's just a simple change. But again, that illustrates how SwiftUI is still being built and it's so early. A lot of very like basic stuff like that like wasn't in iOS 13, just came in iOS 14, and who knows what's going to be in iOS 15, 16, and beyond. So again, super early, but that is how you go from a sheet to a full screen cover. And that wraps up our introduction to UIViewRepresentable and diving into UIKit. And again, we're going to build a barcode camera app that passes data with coordinators, gets really into that topic in the next app, but just wanted to show it to you here. That wraps up this video. Next video, we're going to do some quick refactoring and then convert this grid into a list. And the cool thing about that is it's pretty quick to do. So let's do it. We left off last video basically wrapping up the app with our UI View Controller representable, showing our Safari View Controller. In this video, we're going to do a last minute refactor pass and quick little project organization. And then we're going to convert this into a list and navigation, detail view. So let's get on with the quick refactor because we got all our files here. So let's go file by file, then we'll reorganize it like in the folders here. So our view model here, pretty simple, not much to do here. One quick styling thing I like is if I have a simple did set or will set, whatever, and it's on one line like this, I like to just clean it up if it's like super simple, right? You don't want to make it the one line terribly hard to read and super long, but this is a real quick short line, super simple thing. So I like to put that there in that circumstance. Personal preference, just me. All right, next file. Let's get rid of our preview here because we're not going to need that. We need to focus on the code. Okay, so what we can do here is this grid items, even though it is directly related to how the view should look, again, I kind of like to put this into the view model. So I cut that. Let's go back to our view model here, and below these variables, we can just say let columns equal that. So now in our view, again, I like the view to be as clean and like dumb as possible. So it's very easy to read for one thing. So now instead of columns, we just do view model.columns. There we go. We're getting the same thing there. And then let's actually bring our preview back up because anytime you're refactoring, you definitely want to make sure you don't break stuff, right? So hit resume on our preview, try again. Preview, work with me preview, try again. No, play. Okay, I guess we're giving up on previews here. Let's get rid of that. We'll just do it the old fashioned way. And this is what I was talking about, how previews are great, like when they work. Okay, so running it on the simulator the old fashioned way, refactoring our columns, didn't break it, we're good, cool. Okay, so like I mentioned earlier when we built this, I feel like this is nice and clean, very simple, no need to refactor there. Same thing, sheet is presented, no need to refactor here. Scrolling down, okay, here we have our framework title view. And remember what I said about project organization. This is used in multiple screens, right? It's used on our grid and it's used on our detail. So I want to put this into its own file. So we'll do Command X there, Apple Frameworks, Command N, new SwiftUI view. Next, call this framework title view, create. Cool, there it is. And then in my body, or actually I think I copied the whole thing. Yeah, so we'll just overwrite the whole struct there. Framework title view, good to go. Missing an argument for the parameter and call. That's right, it takes in a framework, right? And then we have our mock data.sample framework. And then back to our grid view to make sure it's gone. Yep. So our framework grid view just shows our grid view. And we have our separate file here for framework title view. Cool. And again, I'm just going file by file. So we did our grid view. That's good. Our framework model, pretty straightforward, right? Just a basic model and then all of our mock data. Cool. Our detail view. See if there's anything that really stands out here. You could, let me do a Command B. Let me do a Command B to see if I can get my syntax highlighting back. Xcode, there we go. Yeah, let's do this, right? Because this X, right? If I pull up the canvas on the preview here on our detail view, resume, right? You can imagine in your app, you're going to have a lot of modal displays. Well, you could have a lot of modal displays. So this X could be a common thing you need to put, on multiple screens. So let's refactor out this button HStack here. We'll actually keep the padding as well. I mean, That's debatable. You could add the padding as you need it on each screen, or you could include it because you know you're pretty much going to need it, because if you don't put it, it's going to push it all the way to the edge. We don't want that. So I'm going to do Command X there, new file, Command N, SwiftUI view. We'll call this X dismiss button, create. There we go. And then paste it into our body. HStack, let's get a preview of that nice little X. It'd be pretty basic. Okay, forgot something. Oh, that's right. We have to pass in our binding, right? So I need a at binding var of is showing detail view. And most likely in your app, you're always going to want to dismiss your modal. Like it's kind of the whole point of this X button. So maybe you name it something different. Maybe it's just like is showing modal, right? To be more generic, because it might not always be a detail view. But that's, just a little tip there. So you don't actually give your binding things a value. You get passed in a value. So you just tell it is a bool. So now that is good. Whoops, I gotta, again, the previews. Remember, the previews are always gonna get you. And because it's a binding, we actually have to pass in .constant, and then we'll say false for now. So hit try again. Let's get our preview of our nice little just X. Cool, there it is. Kind of a useless preview, but there you go. So X dismiss button is now refactored. So let's go back to our detail view and use in this space here, X dismiss button. And then we need to pass in a binding, right? Is showing detail view, or if you renamed it to is showing modal, probably a better name. Now we want to pass in our binding of $ is showing detail view. And I want to point this out because what's happening here, and this is where it can get kind of crazy by passing bindings down many, many layers of views. And if you find yourself doing this a lot, there's the environment object, which again, we'll talk about in a later video. Passing it down to one child view is basically a must, right? That's the whole point of it. Once you start passing it down to 2 and more, that's when you want to consider environment. So in this case, we're now passing this is showing detail view binding down 2 layers here, right? Because our grid view, right, back to the grid view passes the is showing detail view to the detail view, and then the detail view passes that binding down to the X dismiss button, right? So we're going down two layers here. But the point of binding, and I hope this really illustrates it, is as long as you keep passing the binding down, no matter how deep you go, they're all going to be tied together, right? Because they're bound. So if I could be 5 levels of views deep, and if I switch is showing detail view on that view, it's going to go all the way up the binding, all the way up to like the top level, this framework grid view to change it. Again, that just illustrates how it works. If you're passing it down 5 views, you should probably use environment, which is different. But again, hopefully that helps you understand binding a little bit more. So we just refactored out our X dismiss button here. Cool. So now our detail view looks pretty good. You could argue to refactor out call this like a body text to always have font body and padding. You could do that if you find yourself reusing that a lot. We're going to leave that for now. That's probably overkill for this little app. And our Safari view, again, pretty straightforward there. So we just went our AF button. Yeah, nothing to do there. It's just our button. So we just went file by file and kind of did an extra little refactor. Now let's start organizing these, right? So organization, hugely subjective. And there's not really a best practice out for SwiftUI yet. What I'm about to show you is just how I organize my projects and what I have found easy to understand, but that is very subjective. You may find your own style of organization. That's perfectly fine. Just use mine as an example. Take what you like, leave what you don't, but here's how I do it. So I create a new group. I'm going to call this screens, even though that's kind of a weird word in SwiftUI. Everything's a view, but this helps me bundle all the views in a certain screen in one area. So I do screens. And now in this folder, I'll create a new group. I'm going to call this framework grid view, right? So this is our grid view. And I'm going to put in the grid view. I'm going to move this out here so you can see it, right? So we have our grid view and our grid view model. Well, those both go in the grid view folder, right? Because they're both related. So that way, when I open up my grid view folder, I got my view model and my view. They're all right there. I don't separate a separate view model folder because now you're going back and forth. It's confusing. I put everything right where I use it the most. So the other screen we have, and the reason I like doing this is because I can go screen by screen and see what I need, right? Is the framework detail view. Cool. So that is just the framework detail view goes in there. We don't have a framework detail view model. That's fine. And then I kind of like to put these in the order that they show, right? So like the grid view is first, then you go down to the detail view. So now we're, now in the Apple frameworks, let's build our model folder. So right click, new group, and call this model. Cool. What goes in the model? Frameworks. There we go. So like I said, I have my screens folder, but that's for like the overall screens, right? But we have these reusable views, right? AF button, X dismiss button, framework title view. So I usually create a new group called, well, not in model. Let's delete that. So make sure you click on Apple frameworks, new group. Now I call this views, and this is just overarching. So within views, new group, I'll create something like buttons. So, right, so we have our X dismiss button and our AF button. So that can be dragged into buttons. And then in here, you can imagine I would have like, text, labels, images, like any custom views, I kind of give their own folder. So one of the custom views here is just views. So I understand this is redundant, but like our framework title view is just a view. So that type of stuff for me goes into the sub view of views. I get it. And then usually what I create to keep things separately is a new group, and I call this UIKit components. And that's where I put all like my UI view controller, representables, that sort of stuff. So we'll drag the Safari view up here. And the reason I do this, and I want to keep these separate and compartmentalized, is because like I said, I expect this UI view controller representable to not fully go away over the years, but become less and less, right? Like Safari view controller, perfect example. I very much expect a SwiftUI native Safari view very soon. So I want to keep this separate. So when I come back to my project, like I know like what I can replace as this new stuff comes out, right? It's all in my UIKit components folder. So that is the reason I separate all of that. So that's my basic folder structure. Again, views will have views, buttons, text, images, whatever custom views I've made will go in that views folder. Model, and then screens, where I bundle the screens and their view models. And if there's any other view that's like only specific to that screen, I'll put it in there as well. So that's a little bit of project organization, little bonus. Now to wrap up this video, let's convert this thing to a list. It doesn't take long at all. One thing I always got to do though, and this is just Xcode, because we moved all of these screens around, like we messed up the file pathing. So we lost our syntax highlighting, autocomplete. So usually I just quit Xcode and reopen it. So that's what I'm going to do right now. All right, so I've quit Xcode, reopened it. We got our syntax highlighting back. That usually happens anytime I move files between folder structures. All right, so let's convert this to a list. Actually, wait, big stop. I forgot. Before we do that, because I want this grid app to persist for you, because we're going to come back to this later, go into your Finder here, wherever you have your Apple Frameworks project saved. So in this folder, I'm going to do right click, duplicate, right? You can call this Apple Frameworks, list. And that's why you have these separately, right? So now make sure you open up the duplicate that's called list. So that way you have that all done, saved, not touched, and you have this list one separately. You can reference them both. It'll be much better that way. So now open up your list one. Okay, pulling up the design, the first major change you're going to notice is in our framework title view. It's no longer a VStack, it's an HStack, right? It's got to go horizontally because of the list. So let's go to our view here, framework title view, and instead of VStack, let's actually open up our preview so we can see this here. Okay, we'll make this smaller here. Okay, so instead of a V, change it to an H. Pretty straightforward. Cool. We may come back and mess with the text size, but just like that, we went from an VStack to an HStack. That should be good. Now let's go to our grid view here, right? Screens, framework grid view, grid view. Okay, so what we can get rid of first is the scroll view, right? Because a table view, or a list, if you will, has scrolling by default. So what I do is I kind of come to the bottom first. Okay, that's my scroll view. Cool, let's delete that one and then delete scroll view. And then the neat little trick here is if you highlight your whole struct here, Control I, that'll line up any, bracer issues that you have. Okay, so the next thing we want to do is let's get rid of our lazy V grid, right? We're not doing a grid. So let's get rid of the lazy V grid and just call it a list. Pretty simple. We're still using our for each because the same principle applies, right? We want to iterate through our array and create our cells accordingly. However, list has a built-in tap gesture. Like we don't need to add the tap gesture there. So let's get rid of that tap gesture. However, what a navigation view has is what's called a navigation link. So again, on the list, when you tap it, we're going to use the navigation controller to slide on the detail view. So the key here is that each framework title view, and side note, if you're doing a list, you should probably name this framework cell or something like that. So anyway, we'll hold off on the naming, because it could be different for a list. Just want to get the functionality in there. So you need a navigation link. That's what kind of triggers the segue here. Well, it's not a segue, that's storyboard. Sorry to confuse you with my lingo. To trigger the transition to the detail screen. So let's call it a navigation link here. Link, cool. That takes in a destination. And you can see there's a whole bunch of stuff you can do. I just do destination. And again, this is another one of those cases where autocomplete is confusing. So I just do destination because all that takes in is a view we want to go to. And for that, we want to go to our framework detail view, right? And we want to initialize that with a framework. And again, this is this framework that we're iterating through. So we want to pass that framework to the destination view. And then is showing detail view. Again, same thing. View model dot is showing detail view. And then that destination needs open and close curly braces and X. There we go. So that should be working. I'm going to get rid of the preview real quick, just so you can see the code, kind of how it should look. Put our parameters down there. So trying to make this look as neat as possible here, right? So we have our navigation link. It takes in a destination. What that destination is whatever view you want to be your detail view. For us, it's our framework detail view. Our framework detail view takes in two parameters, right? It needs to know the framework, and then it needs to know if it is showing detail view, and that's what we're passing in the binding. Really, this is like the exact same thing that we're passing into the sheet here, right? It's just a little different. And on that note, we don't need the sheet anymore, so we can delete that because we're not presenting a sheet, we're presenting a detail view. So we essentially moved all the stuff from our sheet up into here into our destination on our navigation link. So the navigation link has the open and closed curly braces, and inside that we have our framework title view. We're basically saying whatever is tapped on the list, which is our framework title view, that's when you trigger the navigation link. And I'm gonna actually make my code smaller for a second, just to show that like, when you're actually coding on your screen, and you may see it, it's actually not that big. It's just I gotta blow up my font so huge. Trust me, it drives me nuts how my code looks when I'm teaching. Okay, so now if we run this on the simulator here, and here we are, not looking 100% like I want it to look, but the general functionality is there. Let's tap on CarPlay, right? See, we're sliding the navigation controller over to our detail view. You can see we get the back button. We still have our X here, so this doesn't look quite right. So we do need to make some adjustments here. So let's go back. The first thing I want to do is these are quite big, at least for my taste. We're still using that 90 by 90 frame for the image that we hard coded. So if you like this big look, cool, leave it like that. I actually want to go to our framework title view here. And instead of 90 by 90, let's do 70 by 70 just to make it a little smaller. We'll run that on the simulator. Take a look at how that feels here. Okay, we're getting there. The icons are smaller that I like. Now, you may notice there's a lot of padding on the top and bottom. And this is all subjective. You can play around with this, but I want to show you how you can tweak this a little bit. So instead of having the padding on the entire HStack of our framework title view, let me pull up the simulator again. Right, I also want a little more space in between the icon and the label here. So I'm going to put the padding, actually, Command X, I'm going to put that on the text. Right, so that'll give the text a little padding, space it out a little bit. Let's run this. I know I'm doing the old-fashioned way, the running, but I've been having issues with the previews. So now I kind of like the way this looks a little better. Now let's fix our detail view, because again, if you click class kit, like everything's pushed down to the bottom. So let's go to our detail view here, framework detail view. Now we don't need that X button, so let's get rid of that, and we'll keep the spacer. So let's just get rid of the X dismiss button that we're doing. Give it a run, see what it's like. We could probably actually go to Canvas for this, but I'm in the habit of this. Class kit, there we go. No more X, things are looking good. See AR kit, there we go. So the last thing, we may not want this blue frameworks, right? That back button, right? See, if I click on something, it's blue. Well, let's make that white, or actually label, right? Because we want it, black in light mode and white in dark mode. So the way you can do that is on your list, if we go back to the grid view, or I'm sorry, not on the list, but on the actual navigation view itself, right? Because that's where the back button actually is. We could do .accent color, and we can pass in color with initializer of .label. And you can see now we'll run it. Now our back button will be white in dark mode and black in light mode. So let's hit Catalyst. There you go. You see our frameworks is white. It's not that blue. So that's how you adjust that. Make sure our Safari View Controller still works as expected. Now we can hit back. There you go. So as you can see, that took just a couple minutes, small little tweaks here and there, and we converted a grid view to a list view. Now, if you're coming from UIKit, you can imagine trying to like rip out a collection view and replace that with the list view would have taken a lot longer. So that is a nice little benefit of SwiftUI, is like switching between all these things with relatively little effort. So the last thing I want to leave you with in this video is the challenge. And this challenge is going to be a little bit different. So let's click on SwiftUI here, right? Let's go to SwiftUI, keep the theme going. So this is our detail view. Not my best work, not going to lie. As far as like design, right? It's very, very plain. Not much is going on here, but this is where I want to challenge you. This is a little bit of a design challenge, but it will also give you a chance to play around with the layout of SwiftUI. So my idea here is redesign this detail view, right? You can completely change the layout, keep the data the same, right? We just need the name of our framework, the icon, the body, and the Learn More button, but play with the layout, like completely reinvent it and see what you can come up with. And what I think would be cool is if you came up with a good design, you shared it in the Slack channel. That way other people taking the course can see it. And then one, they can get inspiration from your design, or two, they can get practice building a bunch of different cool designs on this detail screen. Now I know it's pretty limited. It's not like you can go crazy with it, but I'm curious to see your creativity, what you come up with for the screen, and then hopefully other people can build it as well. So I think that'll be a fun little challenge. And that finishes off our Apple Frameworks app. Hope you learned a lot. As you can see, we're slowly expanding our knowledge. In the next app we build, the Barcode Scanner, it's going to be all about that UIViewRepresentable and actually passing data from UIKit to SwiftUI. In this video, we're going to discuss the iOS 15 updates for the Frameworks app. And there's really only one, right? Again, these pretty simple apps in the beginning, there's not much there, but I want to take time to showcase the new button system in iOS 15. As you can see here in the lower right, we have our Learn More button that we customized. To refresh your memory here, I'm going to go to the Views, Buttons, this AF button, right? We have a text and we're customizing with all these modifiers, and there you go. Well, Apple introduced a new system that gives you a lot of the default looking Apple buttons kind of built in out of the box. As you can see here, there's some pretty basic styles where you have the plain, gray, tinted, filled. There's a nice WWDC video that I'm going to link to, really specializes in UIKit for that video, but there is a SwiftUI equivalent, and that's what we're going to talk about in this video. So again, the whole point here, big picture, if you want Apple looking default buttons like they belong in an iOS app, this is probably the way to go, the new way that I'm about to show you. However, if you want your own super crazy custom buttons that you want full control over, you should probably stick with the old way that we've already done with AF button. I shouldn't even call it the old way. I should just call it the more customizable way, because again, the new way just basically gives you Apple looking buttons. All right, so let's talk about that. So this AF button, where do we use that, right? We use that on the framework detail view, right? This Learn More button down in the lower right. And then here on line 30 is where our button is. And you can see for our button, we're using the label of AF button where we pass in the title, right? That's what this AF button is, right? Pass in the title, and that's what we give it. Okay, refresher over. So now there's some modifiers on button itself, but we still have to give like some content to the button here. So I'm going to comment this out. And that's another thing I should point out. Like, I'm not going to go back and delete AF button, even though we're not using it, strictly for learning purposes. So you can go back and see the difference. You know, in a real app, if you were converting to these buttons, you should probably delete and get rid of your old code, right? It's called zombie code that's around that you're not using. And over the lifetime of a project, that really adds up over time. So you want to make sure you're keeping that under control so your code base isn't so cluttered with like, are we even using this anymore? And it's confusing and you're not sure. So once you delete stuff, get rid of it. For the most part, there's always exceptions, of course. But anyway, I'm going to keep it in there for now. Framework detail view. Now, what I want to put in here is, let's resume this so I can see this in real time. You could just put a text if we wanted to keep the same exact look, but I'm going to add a little spice to it, right? We're going to put a little image in there. So this is going to be a label as well. And make sure you do system image name, not just image name, because remember, system image name is what gives us the SF symbols. If you had your own custom image, then you would have to load it into your project and use that. System image name is what we want to do. So again, this is still going to be Learn More. The label is what the text is. Again, same as what we had on our AF button. System image, the SF symbol, is going to be book.fill. And I just know that that's SF symbols. You can look it up. I did that to save time, but I'll zoom in on our simulator here. You can see that's our basic learn more button. We haven't added any styling to it, right? So that's why it looks like that. And I put that little book there for the learn more. If you want a different image, explore, have at it. Now, the new modifiers for the button is where the new system comes into play. So the first modifier we want to add to the button is .button style here, right? And then we get bordered, bordered prominent, borderless, plain. So this plain is what you see there. Bordered, we'll do there. You see the default we get. Okay, come on, preview. Oh, see, bordered is only available in iOS 15 or newer. This is what I was talking about in the overview video about how a lot of the new SwiftUI stuff requires iOS 15. So let me go to the project. Forgot to do this in the beginning. Project here, iOS deployment target, make that iOS 15. And if you're wondering, how do I, add this new stuff, but still, support less than iOS 15? Well, that leads to a little bit of messy code, because I'm not going to go into it now, but there's these conditionals where you can say, like, if this device is on iOS 15, run this code. If it's on iOS 14 and below, run this code. So you're kind of like duplicating your code to do things twice. That's why most apps, they won't adopt the iOS 15 stuff until iOS 15 is the minimum deployment target. So a lot of iOS developers, they see all the new iOS 15 stuff, but they know they can't even use it for another year or two. But luckily for us, we're in an educational environment. We're going to support minimum iOS 15. So Apple Frameworks, iOS 15. And then now that we're supporting iOS 15, do a Command B to make sure everything's all good. Okay, good to go. Back to our framework detail view. This error is no longer there. And then now our bordered button, if you can see, has a slightly gray background on the border. That is the default. Now we can style that, but that is one style of button. That's that gray style. You may have seen buttons like this, again, all over Apple's default apps. But let's customize this a little bit. So we can do .control size. So you see it's kind of small. Again, large, mini, regular, small. We'll go to large. You can pick that. Now you can see our button got bigger. I'm going to click off of it to get rid of that red square, but now you can see what our button looks like. So you can customize this a little bit, but you're getting that Apple look and feel out of the box. We didn't have to mess with corner radius. We didn't have to do anything like that. And now we can customize the colors a little bit. So I can do .tint and then .red. That'll give us the red tint, and I'll get off it to get rid of that red box. But you've seen these buttons in iOS too, right? Where you have like the 50% opacity of the same color background with the same color as the foreground of the letters. Now, the reason these buttons work well is due to contrast ratio. Usually when you're using the same color, you're going to get a good contrast ratio for people that are colorblind. You can imagine like a yellow button with white letters. Those white letters are really hard to see, so some colors in white don't really go well. This is a nice way to ensure great contrast ratio. And that's the bordered style, right? So we saw the gray background and then the tinted background, but how do we get the button that we had, right? Well, that would be bordered prominent, right? And now we get that. You see, and the tint is red, that's the background. Our foreground color is white by default, but now you can see we get a button that looks like how we had it. And if you do want to change the foreground color, say you have some weird color scheme, right? You can do .foreground color, we'll say .yellow. And the foreground color will be your text. As you can see, now our button looks like McDonald's, right? But you can see how you can customize that. Now, if you do want to customize the shape a little bit, you can do button border shape, hit dot, so you get automatic capsule. So capsule would be, as you can see here, that typical capsule look. You've seen that a lot of the places. Or you may have noticed, instead of dot capsule, you can do dot rounded rectangle, and you can determine the corner radius. I don't know, we'll just put 20 in there, right? If you do have a specific corner radius, so you do have the possibility to customize it a little bit. But you can see just with these few modifiers, we can, do everything we need to do. And again, that is to get these Apple looking buttons. And I'm just going to comment it out so you see this in the code here, but I'm commenting out the border shape. I'm going to go back to dot bordered because this is the look I like. This is how I'm going to make like all my buttons from here on out in my apps. Like I really like that tinted look. Now, anytime you have a bunch of modifiers on a button like this, I like to abstract that away into like a custom modifier. This was just your introduction into this button system. We're going to deal with that custom modifier in the Appetizers app when we do that for our buttons there. But this was the introduction. Highly recommend checking out the WWDC video. I will link below. And that's all we're going to do in the Frameworks app because, again, there's not much here, but this was a good opportunity to learn about buttons.
iOS 16 introduces a fundamental improvement to SwiftUI, and that is the good old navigation view, right? Used in so many apps, used so many places, is now deprecated in favor of navigation stack and navigation split view. So a navigation stack is the typical navigation you're used to. They call it master detail navigation, where if you tap on something, a view slides in from the right and goes on top of the stack. Pretty typical. Navigation split view, you've seen this before too. That's the 2 and 3 column layouts. Now, of course, you could do that navigation in SwiftUI now, but the reason for this improvement is it's a new data-driven navigation API. So that means how you navigate is based on your data type. I know that may sound confusing. Let's actually convert our frameworks app to that master detail navigation type rather than showing a sheet from the bottom in order to showcase this new data-driven navigation API. Now, to be clear, there's nothing wrong with showing a sheet like we're currently doing. I'm just converting it to the master detail to showcase this new way of doing things. Okay, so our navigation view, because we're showing a sheet, the only reason we have this in the navigation view is so we can get this pretty navigation header that says, the frameworks. So let's convert this to a navigation stack. And you'll notice, nothing happening. Oh, navigation stack is only available in iOS 16 or newer. I forgot the most pivotal first step. Click on your project, go to Apple Frameworks, make this iOS 16. Now, before I go on my rant here, let me update our target as well to iOS 16. Okay, so we're minimum supporting is iOS 16. Now you may be thinking, well, a normal app has to support iOS 15 and previous stuff. That's fine, this is educational. But my rant is that, let me do a Command B to get, I can't think when Xcode's yelling at me with red stuff. You can conditionally support the iOS 16 stuff like this navigation stack and still support iOS 15. That's how most apps will, support the new stuff while still supporting old stuff. However, that means you basically have to write the code twice, right? You have to do all the new iOS 16 stuff. In our case, it would be all this new navigation stack code. And then we'd have to have this giant if else, essentially, right? If iOS 16, do all the new navigation stack stuff. Else, keep all the old iOS 15 stuff. So the point I'm trying to make here is you don't always have to automatically support the new iOS 16 code, right? The old navigation view will work fine for a couple years. That's the beauty when Apple deprecates stuff. It just doesn't stop working automatically. They let you know. They say, hey, this navigation view is going to be deprecated. They don't tell you exactly when most of the time, but you usually have 2, 3, 4 years before it stops working. So just so you know, you have time to slowly update your code base. You don't have to do everything right away. And why you probably wouldn't want to update all your navigation views to navigation stacks is because this is such a fundamental part of the view that your code would be like a nightmare. You'd have giant if-else statements everywhere. So my recommendation would be not to convert all your old navigation views to navigation stacks until iOS 16 is your minimum target. Most of the time, it's just not going to be worth it. Okay, so now that we have our navigation stack, let's get rid of our sheet here because we're no longer doing that. And then we no longer need this selected framework, right? Because we're not doing anything on tap gesture. So get rid of that tap gesture. And let's go into our view model and get rid of all of that stuff, right? We don't need is showing detail view. We don't need selected framework. So we just need our columns there. So back to grid view, make sure we get our preview back, good to go. So now like nothing happens, right? We tap, nothing happens. This is when the sheet would show up, but nothing happens now. Okay, so now we want to implement that master detail view with the new navigation driven API. So to do that in our for each, right? Normally we had the tap gesture on each thing. Now we need to have a navigation link with a value in the label. So the value is going to be our framework. Remember, so the value is the data. I'm going to explain all that at the end. Let me get through the code and then I'll do my little summary. So the label is basically our framework title view. This is whatever the UI is for our navigation link. So now you'll notice everything turned to blue. That's the default for the navigation link. Well, we don't want that. If we go up in our view folder here, our framework title view, for the text, let's give it a .foreground color. And then here's a little trick here, right? We want to do .label because we want it to be white in dark mode and black in light mode. But SwiftUI color doesn't have just a .label. So you can do color and initialize it with a .label. This is how you get to the UIKit semantic colors. If you're familiar with UIKit, UIKit has a bunch of semantic colors that look good in both light and dark mode, and they have like secondary system color, secondary background, they have all those. So that is how you get to those. So that's what we want there with the label. So if we go back to framework grid view, we should lose that blue tint. There we go. That's how it's looking. So now when we click it, still nothing happens, but this is where we want the master detail navigation to slide on the detail view. Down here after our navigation title, we do navigation destination, and then this is the type. Again, it's data-driven navigation, which means it's based on the data type. Our data type is our framework. right? This would be whatever type we had, whether it was a string or our custom type of a framework, whatever data type you're doing. So this is going to be framework.self, and then our destination, well, hashable, it has to conform to hashable, which our framework already does. So this is going to be the framework that we tap. And then now it is going to be framework detail view, which takes in, whoops, okay, so we still have this is showing detail view. Let's go to our framework detail view. We no longer need that. That is showing detail view. Actually, we can clean this up a little bit. Let's go to the preview. SwiftUI preview is not working. We'll just do this. So I don't need is showing detail view because remember, that is how we dismiss it. I no longer need this X dismiss button. Let's see if we get our preview back. Nope. Okay, I no longer need that X dismiss button because we are in the master detail navigation. I don't need the spacer at the top because that had to do with the dismiss button. Okay, so still not showing the preview. Let's go back to the grid view here. Now let's initialize this framework detail view. It just takes in a framework, and that is going to be the framework that we pass in when we tap it. So essentially, wherever framework we tap, we're going to navigate to a framework detail view with that framework. Okay. Lost the SwiftUI preview. Let's see if my project builds. Build failed. What did I mess up? Is showing detail view in cell. Okay, yeah, previews. So my framework detail view doesn't have the is showing detail view parameter anymore. So see if that works. There we go. Okay, so now you can see the UI of our detail view that will get pushed on to the navigation stack. So back to the framework grid view. Refresh the preview. Oh man, these previews. Let me try running the app here. I see what I did. Line 26, I missed the period. Wow, that little thing, yeah, just completely destroyed Xcode. Anyway, now when I tap on this, you get the master detail navigation, right? It's slid in from the right. That is the navigation stack. And again, let's talk about the why this data-driven API is helpful. Because yeah, with just our framework simple app where we just have one data type of a framework, seems, you might not see the value in it. However, a more complex view, like maybe like the App Store that has a bunch of different horizontal scroll views, a bunch of different collection views, or maybe our app had a bunch of different types, right? Maybe we were making a developer app where we had a horizontal scroll view of frameworks, and then we had a horizontal scroll view of like developer software with like Xcode, SF symbols. Maybe we had another one of, recommended blog websites. So you can see we have all these different data types on one screen, and you're navigating to different screens based on that data type. So that's why this data-driven navigation API is so helpful for situations like that. So that's the new navigation stack in iOS 16 SwiftUI. And again, the main thing is that it is data-driven. It is based on your data type, like our framework, and it really shines. You really see all the benefits of it when you have a screen that has multiple different data types and you're navigating to different screens based on that data type.
The app we're going to build in this section focuses on passing data from UIKit up to SwiftUI via a coordinator and delegates. If those words didn't mean anything to you, we're going to dive into it. But as you can see on the screen here, what the app does, it's a barcode scanner. So we utilize the camera. This is what's not in SwiftUI yet. This is why we have to integrate UIKit to use the camera. So, we'll just scan a barcode and we'll display the barcode that we saw. So as you can imagine, the barcode and any potential errors, that is the data that we're passing from UIKit up to SwiftUI so we can display it on the screen. And again, we'll pass that data from UIKit to SwiftUI using UIViewRepresentable and coordinators. In this first video, we're just going to set up the UI, but a lot of this is stuff we've done before. So here's what the UI is going to look like, this dummy UI, right? It's not going to be connected. But if you want to pause the video, take a shot at building that yourself, now's your chance. We're going to go through this real quick here in a second. Two things of note, if you are going to try this on your own, I am going to rename the content view to barcode scanner view, so just a heads up. And then there's one UI element that we haven't talked about, just a little hint there. So there's one new thing, but you may be able to figure it out. If not, we're going to build it together right now. So that's your last chance to pause the video if you want to try it yourself. Right now we're doing file in Xcode, obviously, new project, and it's an iOS app. In the app, hit next, barcode scanner. And again, interface SwiftUI, Lifecycle SwiftUI app, language Swift, hit next. Save it wherever you like, saving it to my desktop. And I'm going to hold Option, hit the green dot right there to make it full screen. Let's resume our preview. Let's get rid of our right pane. Again, this is the typical setup we've been doing. And here we are. Well, preview's not ready yet, but that will get ready. There it is. And okay, I don't know why it defaults to iPod 7th generation. Like who even has that? We'll go to the iPhone 12 Pro to get that set up. We'll minimize it so it doesn't look super huge. Drag this over. Okay, so the first thing I'm going to do is, get rid of this content view. Now, This is why I like putting out these videos as I go, because I got a comment talking about the rename thing, and I know about this feature, right? You remember me going on my rant, how I just delete the file and create a new one. I'm gonna try to adopt and change. We'll see if this burns me, but we're gonna try the rename here. So I'll also show you what's going on. So if you click into the content view and right click, you can see Refactor, rename, and then you get the code folding. This was new in Xcode 9. Like I remember doing the what's new in Xcode and like talking about this. But I guess what I didn't realize, like I knew it changed the name throughout it, but if you look up here, it changes the actual file name, right? You see right there, file name. So that is what the commenter pointed out that I wasn't aware of, because that's what caused the file pathing issues. Okay, I know I'm going on a bit of a side rant, but let's just do this, call this Barcode Scanner view. And right, you see it's renaming it in my previews, in my window group. This is the app, right, where we have to tell it what view shows first, and it's updating the file. This is the key new thing that I wasn't aware of, that it updates the file name. So in the upper right, you can hit rename, and there you go. And look, yeah, our file got renamed, our struct got renamed, our preview got renamed, and then again, in the app file here, that got renamed, that got renamed. So nice feature. We'll see if I get burned on file pathing. I'm assuming I'm not going to, so maybe I'll have changed my ways and learned something new as well by doing this course. So anyway, little tip there. Now this is the dummy UI I'm gonna build, because we're gonna put a placeholder in for the camera view. We're gonna hook all that up later, but just to get the structure, we're gonna build this. Again, this is what I put up earlier. I am gonna go a little bit quicker through this UI, because hopefully this is a lot of review by now. So I like to start, here's the text, right? I know I'm gonna have a navigation view, so I kind of like to work my way, right? Like the top view, and I like to work my way down, right? So there's the navigation view. If I spell it right, put the A in there. Navigation view, cool. Try again on the preview. The preview always tells on you, like when you mess stuff up. Try again. Okay, preview, whatever. Okay, so in the navigation view, I know I'm going to have a VStack, right? If we pull up the screen again, you can see just how the elements are. It's going to be a VStack. So now my VStack, cool. And then on this VStack, I can put my .navigation title, and this is Barcode Scanner. There we go. Again, I'm working top down just to let you know my thought process and like what's going on in my head right now. So the next thing down is the kind of the dummy camera view. SwiftUI has what's called shapes. So I can just do rectangle, right? And it'll draw me just a square, basically, as you can see. But we don't want the whole camera view filling up, because we want to be able to display the barcode once we get it. Now, of course, you could redesign this however you like. Maybe you do want the camera view filling up the entire phone screen and you want to overlay the label on it. You know, after we build this, come back and play with the design. If you like, you can play around with this, but we're going to keep this just kind of like a window on part of the phone. So we want to give this a frame. Now, here's where it's a little bit different, right? So frame has width height. We're used to doing that. Well, if we click into frame, command click, jump to definition, you can see this is the initializer we've been using, right? Frame, height, alignment. Well, if we go down, you can see an extension here that has this frame: min width, ideal width, max height, right? There's a much more robust initializer on frame, and that's the one we're going to use here. So let's go back. So we can do max width. I'm not going to do the whole initializer because I'm going to have to like delete it. Again, this is part of the what you'll realize with SwiftUI. You'll kind of start to learn these initializers, and you'll only just type out what you need. Because if you do autocomplete, like I would have got like 7 parameters there, and I would have had to delete them. It would have just taken longer. So we're gonna do 300 there. Now here's the difference, right? Okay, let me explain this as I go. So I put max height 300 because that's as tall as I want it to be, right? Width is gonna be dynamic. I want it to fill the whole screen. But height, like I only want it to be a certain height no matter what screen we're on, right? A barcode is only so big. So max width though, you can do .infinity. And what this means is it will just fill the screen, as you can see. However wide the screen is, it'll fill. So if max width infinity, max height 300, you can see it's centered on the screen because that's kind of the default behavior of the VStack. It does look a little lower than centered, and the reason why is because our navigation bar in the title is taking up a chunk. So if you imagined like an imaginary line under the barcode scanner, now that space would be centered in. So again, it is centered, but if it looks lower than centered, it's because of our nav title. Okay, so the next thing we want is the words underneath the camera view that say scan label, kind of like our label. Spoiler alert, we're going to use a label to do that. I couldn't think of a different word other than label. So now this is the new element that I talked about, and this is also new in iOS 14. So you now have a label element, and once I put this in, I'll tell you what it is, right? So it takes in a string And an image name, you can see on the right. So that would be if we had an image in our bundle, or it takes a system image name, which is a SF symbol, this is probably the more common one because it's very common now to have like a little icon and a label, which is what we're doing here. So the string we want is scanned barcode, right? Because we're going to put the barcode under this. And the system image, remember this is an SF symbol. So open up your SF symbols here. I already got it open. And just search for barcode. And you see we get just a normal barcode and then like a barcode in a viewfinder. We're going to use the barcode in a viewfinder. So again, Command-Shift-C to copy that. Let's go back to Xcode. We will paste this string into there. So see, barcode.viewfinder. And then you can see it's real small down there. But you can see that's what a label is. So a label is like a little icon and then words. And as you know, that is a very common like pattern in like a lot of apps. So that's why SwiftUI just built it into one like UI element called label because it was so common. Now, label we can treat just like a text. So we can do font title because we want that to be a little bigger. So let's do .font and we're going to make this .title, right? So there you go. That's how big it is. Now, the last element we need is where we're actually going to display our barcode. Well, if you see in the example, it'll say not yet scanned. And then when we scan, it'll flip to the barcode. We'll set that up later. We're kind of just setting up the structure of our UI. So we'll put some dummy data in there. So this is just the text. And for now, not yet scanned because we are going to use that. And as you saw in the design, I do want this to be big, bold, bright, like you can't miss it. So we're going to do .bold and then .font large title. Like we want this to be big. You can see it down there. It's already big and bold. And then we can do .foreground color, .green for now. Again, as you saw in the design, it's going to be red at first. When we get a successful scan, we're going to flip it to green. And then lastly, it's a little tight right there. So let's add some padding. There you go. We're letting it breathe a little bit. Now, one thing you may notice, and this is getting kind of like nitpicky on the design, it's pushed down a little lower. Now, in the previous design, we were using spacers, right? To push stuff all the way to the top or push stuff all the way to the bottom. We're not using any spacers yet. So everything's kind of like huddled around the center of the screen, right? Like it's like the center of gravity. Everything's pinned to the center. It's not going to pin to the top or bottom unless we push it there with a spacer. We're not going to do that, but I wanted to point out the differences in the structure of the UI. We are going to use a spacer, however, to add some space in between our camera view and our titles down here. So let's do that. So after the rectangle, let's go spacer, right? Now this is not going to be what we want, but I want to illustrate what the spacer does. It just pushes everything up or down. You know, it just takes up all the remaining space essentially. But you can customize your spacers a little bit, right? So that's just a regular spacer. We can give our spacer a frame. So I can do .frame and width. I don't care about the width. We're only worried about the height. So get rid of that. And then the height, let's make it 30. And again, I dialed these numbers in. Get rid of this here. You know what? That still looks a little bit too low. Let's do 50 and maybe even 60. You can see how it's like moving up. Let's do 80. It's like slowly like moving up as we do that. So you can tweak that and dial it in. Let's go back to 60. That's fine. The camera's kind of centered a little above. That's what we want. So that's our UI in place. Again, we just have this random rectangle, this black thing as like a placeholder for our camera view. We'll replace that in time. But speaking of the camera view, one thing I want to make sure we do before we forget is to update our privacy settings to give us permission to use the camera. Because if you don't do this, your app's going to crash. Or if you somehow manage it not to crash, it'll get rejected from the App Store. So anyway, in your info.plist, type in or hit this plus button here. Just type in privacy. It's kind of searching, and you can see like this is where you ask for all your permissions, right? If you want to get location permission, photos permission, contacts permission. In this case, we're going to do camera permission. So you can see it's right here, camera usage. So there you go. Now you have to give it a string, and this is what pops up in the alert. So we'll say we need to use the camera to scan barcodes. Pretty straightforward. But you have to have this in your plist, or else when you try to access the camera, bad things are going to happen. So back to our barcode scanner view, our UI is in place. In the next video, we're going to start setting up our camera view controller, which is again down in UIKit. So if you're not familiar with UIKit, this may be new to you. If you are familiar with UIKit, this will be a nice little going back home a little bit. But that's what we're going to do in the next video. We left off last video getting the structure of our UI in place. In this video, we're going to build this view controller, which is our camera preview layer and capture session and all that stuff. Now, as you can see, there's a lot of AV Foundation stuff going on here. I'm going to go relatively quickly through this, but still give a high-level overview of what's going on. And the reason being is I don't want to go too far down the rabbit hole of AV Foundation, how the camera and capture session works. Like that could be a completely different course, right? There's a lot going on in AV Foundation. So again, I'll give the high level, but I'm not going to dissect every line. And we'll go pretty quickly through the view controller because again, the point of this lesson is communicating from the view controller to SwiftUI, not cameras and AV Foundation. Okay, so first things first, on your barcode scanner folder, Command N for a new file, Swift file, hit next. We're going to call this scanner VC for view controller. Hit create. Here we go, import foundation. We're also going to need to import AV Foundation. Again, this is anytime you're dealing with the camera, video, like you're going to need AV Foundation. And I suppose we should probably import UIKit, right? I guess we should do that. So anyway, this is going to be a, we'll do final class because we're not going to subclass this. Final class scanner VC, and that is a subclass of UIViewController. There we go. Now, actually, before we dive into actually writing the code for this, let me explain big picture how this communication works with the coordinator, right? We'll keep it super high level and then we'll dive in. So the way UIKit communicates to SwiftUI is basically through delegates and protocols. If you're familiar with that in UIKit, you'll kind of understand what's going on. If that's brand new to you, I'll kind of explain it as we go, but I'm not going to go too deep into it. I have a video here that you can check out. It's one of my most popular videos. It's how a lot of people discover me through that video. Quick disclaimer though, it is one of the first videos like I ever did when I started YouTube. So I think I speak fast even here, but I speak like 3 times as fast in that video. So just a heads up. But if you want to get familiar with delegates and protocols, check out that video. Again, I'll give the overview during this video. But back to how coordinators work. It's still kind of the same pattern, except the coordinator is like this relayer or translator in the middle, right? If you have UIKit will talk to the coordinator will talk to SwiftUI, right? So it's the same concept. We're just putting something in the middle to relay the message. Like big picture, that's all that's going on. So let's actually set that up in this view controller. So the first thing I want to do before even like writing the view controller is set up our protocol here. So protocol scanner VC delegate. That'll be a class protocol. I guess I should put the R in there for protocol. Can't spell. So when you're doing creating a protocol, this is basically just like a list of commands. Like you don't write any implementation here. You just kind of say what functions are going to be a part of this delegate, right? So we want to have one called did find. Whoops, I guess it's a function. Function did find, and then what we're going to do is pass in a barcode. And that is going to be a string value. That's what we get from the camera. When it successfully scans a barcode, it returns it as a string. So that's what we're setting up here is, hey, when you find the barcode, send it to your delegate, right? And our delegate is going to be our coordinator. So our coordinator is going to get that barcode. And then our coordinator is going to be like, thanks, view controller. And the coordinator is going to take that barcode and send it up to our SwiftUI view. Okay, that's the big picture. Okay, so on our scanner VC, we're going to need a couple properties here. So let's do let capture session equal AV capture session. And this is us capturing, what's on the camera, right? So again, keeping this super high level. We're also going to need a preview layer. And this is going to be of type AV preview, video preview layer, right? It's going to be optional for now because we set this up when we set up our capture session. So we don't have this value right away. But what the preview layer is kind of exactly what it sounds like. It's what actually is displayed on the screen as you're moving your camera around like you see here on the screen. And then next we'll need a weak var for our delegate. We'll call this the scanner delegate. And that is of type scanner VC delegate. And commonly you'll see this force unwrap like that because we are going to pass this in when we create it. But if we really want to be safe here, we can not force unwrap it and we can make it part of our initializer. So when we create our scanner VC, it's going to be required to take in a delegate. So let's actually create that initializer now. So init. We'll say scanner delegate of type scanner VC delegate, and we'll do self.scanner delegate equals scanner delegate. So basically what we're saying here is when we initialize this, we're going to take in a scanner VC delegate. You'll see we'll do that later. And then once we initialize it, we set our self.scanner delegate, which is this, to scanner delegate. So now we don't need to make that optional because we know we're going to have it when we init. Okay, now you see we're getting Xcode yelling at us as required initializer init with coder. This is, you can do this and just leave fatal error in there. And I actually just like to put this on one line. So real quick, this is basically if you ever initialized a scanner VC via storyboard. We're not going to do that, obviously. This is what will get fired off, so you do need to have this in there. And then, oh yeah, I forgot to call the super here in our init. So super.init, and then because we're initializing a view controller, it does take in a nib, nabe, and a bundle. These are just both nil in our case, but you have to have that when initializing a view controller. It's the designated initializer on a view controller. Okay, so what we have set up is our properties here, our initializer. Now the main function we're gonna have on here is gonna be private func setup capture session. So this is where we're going to basically do all the setup to get our camera actually, looking for barcodes and, our preview layer up and running. This is again, this is the heart of the screen here. And in this function, there's a lot of like checks to make sure, we even have access to the camera, make sure things are okay. So you're going to see a lot of that, in the beginning. So first of all, let's guard let video capture device equal AV capture device here dot default for in the media type here, right? You can built in dual, whatever. We just want for all the video here. VIDEO, cool. Else, so this is basically saying like, hey, do we have a device that can capture video? And then else we're just going to return for now, but this is where we would present an error because just like it's important to pass the barcode information, well, if things go wrong, we want to pass the error as well. So we'll have a whole separate video for that later in this section. Okay, next, let's say let video, scroll up here a bit, input, AV capture device input. There you go. And by the way, like what you're not seeing is I have all this code off to the side. Like I don't have all this AV foundation stuff memorized in the camera. Yeah, I've used the camera in a few different apps. I'm familiar with it, but like, I just want to set expectations, right? I don't have this memorized. I'm editing out me like looking and reading, right? Because people don't memorize like all their code. So in case you're wondering like, man, how does he know all this stuff? I don't. So again, don't think that you're lesser if you don't have all this like memorized. Just a little caveat there. So with video input, we need a do try catch block. So we can just say do, and then we're going to try video input equals, and we'll initialize an AV capture device input, and it takes in a device, and this is the device we just created up here if we had it, right? The video capture device. And then if that doesn't work, we go ahead and catch that here, and this is again where we'll surface an error. But for now, we're just going to return. Again, more error handling later. So now, again, more checks. So if capture session.can add input, we want to make sure we actually can get input from the device here. And the input is, again, video input that we just created right up here. And then, okay, so if we can add input, let's add the input. So capture, again, just a lot of checks. Not can add input, and the input we want to add is video input. Else, not self. So easy to type in self. Else, and again, return, but we're gonna put an error in here later. Okay, we're almost done with all of our checks here to make sure we even can use the camera. All right, last check here. So say let metadata output. Now this is what actually gets scanned here, equal AV capture metadata output. And then here, one last check. Oops, I got to initialize that. My bad. And then, okay, back to our last check. And this check is similar to if we can add input, we want to check to see if we can add output. So if capture session.can add output, and then the output again is the metadata output we just put up there. If that is true, we're going to add it. So capture session.add output metadata output. Again, AV Foundation is very, very confusing. I'm not going to act like I know it very, very well. I can use it. I've used it before, but if you're not understanding what I'm doing right now, don't worry. In fact, I even debated on just not even doing this video and just giving you the view controller. Like, hey, just copy and paste this view controller. But I thought some people might want to actually go through this. So again, another caveat, if you're lost right now, don't worry. This is a SwiftUI tutorial. This is not an AV Foundation tutorial. So now we want to start adjusting this metadata output. So metadata output dot set meta. We're basically setting the delegate here, right? Set metadata objects delegate, and it's going to be self, and then the queue is going to be the main queue, and that's dispatch queue.main. And we're getting an error because I did not capitalize data in metadata. It took me like a minute to find that, what's going on here. And that's not actually the reason I was getting an error. We're not conforming to the delegate yet here. So let's, just so Xcode stops yelling at me, we'll get a little bit ahead of ourselves here. So extension on scanner VC, and this is us conforming to the delegate here. So we want to conform to AV capture metadata output objects delegate. It's a mouthful, right? but this is what we're just doing here, right? Set metadata objects delegate. Well, we need to conform to that. And then do Command B, it'll yell at us, we're not conforming to the delegate, or not. Build succeeded. I guess they're not required functions here. So we'll come back and fill that in later. So next we want to do metadata output dot metadata object types, right? So now this is an array of basically types of barcodes that we want to scan. So if I do dot, you can see these are all the different types of code, barcodes, and all the different stuff you can scan, right? QR, human body, that's interesting, I guess. But we want EAN8 and .EAN13. And this is just the standard 8-digit barcode or 13-digit barcode you see up on the screen. So that's what we're doing there. We're basically telling the camera, hey, look for these types of barcodes. Okay, and back up a couple lines here, right? We're saying if we can add the output, cool. But if we can't, this again, surface the error. For now, we're just going to return. Okay, so that's our last check to make sure everything's good. So the last thing we need to do here, well, two more things. We need to set up our preview layer based on all the checks we just did so we can actually show the camera. And then we need to input the delegate method here to implement what we want to do when we find the barcode. So here we can finally set our preview layer. So preview layer equals AV capture video preview layer, there it is, right? And you initialize that. You can see it takes in a session, which is an AV capture session, which is what we created here with our capture session. So we want to pass in the capture session that we just set up and did all our checks on, right? So basically, we set up our capture session, make sure everything was good to go. Once it's good to go, now we can set that to our preview layer. Now we can do preview layer. Now, a preview layer isn't optional. I'm going to force unwrap it here, and I'll tell you why here. And we'll do video gravity equals resize aspect fill. Basically what this is saying is whatever view we create, if on the design, right, we have this black square, that's kind of the structure of our view, basically saying fill that view, but keep your aspect ratio is what this is doing. And back to the force unwrapping. Now, again, hotly debated topic. I'll touch on why I'm doing it here. We're literally setting preview layer right here. And on the very next line, we're using it, right? So, you know, there's two camps. I think it's okay to sometimes force unwrap, and this is an example of that situation. There's other people in the camp that are like, never force unwrap. You never know. There's always this, 0.0001% edge case that could happen. They're not wrong. It's fine. I just told you the camp I'm in. If you're in the other camp, cool. Unwrap the optional. No big deal. And then here we add the preview layer to our view. So we do view.layer.add sublayer, kind of like view.add subview, similar concept here. And then the layer we want to add is our preview layer. And again, force unwrap that because we have the value literally right there. Okay, so now we have our preview layer set up with our capture session. The final thing we need to do is actually do capture session dot start running. So this will actually start running the capture session so you can see the preview on the camera. Okay, so that's our AV foundation code. We just set up our capture session with a bunch of checks like, do we even have access to video? Can it do all this stuff? And if all that is good, then we set up our preview layer to show our capture session and basically start running the capture session. Super high level, that's what that code is doing. Again, don't worry if you were lost. AV foundation is trips up a lot of people. Okay, so the last piece of the puzzle is what to do when we actually scan a barcode. And again, remember, our barcode has to be EAN8 or EAN13, right? So when that happens, what do we do? Well, here's where we tell our delegate, which in this case is going to be our coordinator, the barcode that we found. And remember, the coordinator is going to take that information and then pass it to SwiftUI. That's the whole flow here. So the delegate method for that, we'll do func metadata, and you can see it's this big long one here, right? Did output metadata objects. So what we get back here that's key is our metadata objects. This will be the barcodes that we scan here, right? We get an array of it. And then from the connection is our AV capture connection that we set up. Okay, so cool. So what we want is the first object in this array, right? We just want the very first one that it found. So let's set that up first. So let's check to make sure we have it. Guard let object equal metadata objects. Again, this is our array dot first, right? Again, we just want to take the first one, else. And again, we're going to return here. We'll do the error messages later. I know I'm a broken record. But okay, we want to make sure we have our objects. That is the first one in the array. Now we have to do another check on the object. Now we do guard let machine readable object equal object. And then here's where we have to cast it. And again, I had to look this up. I don't know this off the top of my head, but it needs to be of type AV machine metadata, machine readable, codable. Like it's a mouthful, right? It's basically a machine readable object here. Else, and again, we'll do the error stuff, but for now, just return. Okay, so now we have the machine readable object, but this has a string value attached to it, and that's what we want, right? We're digging through the data to get what we want, and we want this barcode string value that we're going to get here. Do guard let barcode equal machine readable object dot string value. Okay, so make sure we have a string value, else again, return with the error. Okay, and if we have that, we just want to do delegate, right? This is the delegate that we set up, or I'm sorry, scanner delegate dot did find, and then the barcode we found was barcode. Okay, again, that was a lot of checks everywhere. Real quick, hey, do we have a metadata object in our array? Cool, grab that. Is it this machine readable code object? Cool, moving on. Let's take that machine readable object and get the string value of it. Cool, got it. Okay, that string value, let's send it to our delegate, right? So now whoever our delegate is, right now at this moment, nobody's our delegate. We haven't set that up yet. So right now, if we ran this, our scanner VC is just like screaming into the void. Here's my barcode. Here's my barcode. Nobody's listening. That's what we're going to set up in the next video, but that's what we just set up right now. It's just one side of the communication. And here is us, after we did all that setup, finally telling our delegate what we found. So now that we've told our delegate, hey, when we found a barcode, in the next video, we're going to set up the structure for our errors so that we can also tell our delegate, like, hey, we messed up somewhere along the line. Here's what happened. In the last video, we built our scanner VC, setting up the capture session as you see here. Again, if you're a little bit lost, it's fine. Don't worry about it. But just know that what we set up is when we find a barcode, we're now telling our delegate, hey, we found a barcode, right? So that's the successful case. Deleting my spacing here. So now we're going to set up the structure for our errors so that we can also pass up the errors when things don't go right, because that's just as important, right? Especially when you're building a production app, strong error handling is a huge piece of it. So up top, we're going to create this here for now, just to keep things here. We'll kind of project organization later, but let's create an enum called camera error, and for now it'll have a raw value of string, because we're going to kind of attach our error messages here for now. We're going to do more error stuff later that gets rid of this. So the first case is, we'll call it invalid device input equals, and this will be the string raw value. I'm only going to create 2 errors. In reality, you may need to create an error type for each one of the different checks because, proper error handling, you want to tell the user like exactly what went wrong. But just for the sake of time, and instead of having 7 different error types, I'm just going to keep it to 2 to keep them generalized. But I do want to let you know that, you can get you can and should get very specific with your error messages. So case invalid scanned value, right? I like to tab these over. Okay, so for now, we're going to put these strings here. Something is wrong with the camera. We are unable to capture the input, right? And then here we'll just say like the value scanned is not valid. This app scans EAN-8 and EAN-13. Again, those are the barcode types. Okay, so I'm going to move this over here. I'm so anal. That bothered me. Okay, so those are our error types for right now. So what we need to do is also now have a delegate method here. Just like we had did find that fires off when we successfully found a barcode, now we need a protocol method here to fire off when we got an error. So I'm going to call this func did surface and then call the parameter error, and that takes in a camera error that we just created right up here. So now at all these places, right, where we had just return, right? Because what happens when you don't surface an error here, if video capture device, this fails, then nothing happens. Like it just fails silently and the user is left like clueless. Like, why isn't my camera showing up? What's going on? They have no idea. So that's why you want to surface the errors, just to let them know when your app doesn't work properly, here's why. So we're going to add this one line of code throughout here. But again, it's just scanner delegate dot did surface error. And then the error we want to pass in is dot invalid device input, right? Again, these are just the 2 generic types. So our capture device is messed up. I'm actually going to copy this so I don't have to type it out a bunch because here, the same thing. If the video input is wrong, we're going to invalid device input. If the capture session cannot add the input, right, instead of just returning, we're going to surface the invalid device input. And again, I know I'm a broken record, but in reality, these could probably be like different errors with different messages. But again, for the sake of time and simplicity, we're just going to do this. Okay, and then we are going to change it up to invalid scan value down in the bottom here. But that handles all of our like, hey, can we even capture the camera type checks that we were doing? Handles that with invalid device input. So now in our delegate here, right, where we actually scanned it successfully, but now we have to make sure it's the right type of data. Now we will do here scanner delegate dot did surface error, except we're going to pass in invalid scanned value. And you can see the power of putting your errors in an enum if you're not like familiar with that, right? Instead of like typing out the error message string or whatever, I can just pass in invalid scanned value and I get the autocomplete and all that good stuff. So again, we'll copy and paste this 3 times here. 1, 2, and 3. So you notice we surfaced the error like 7 or 8 times. And we only did find once. And that's pretty typical when you're doing proper error handling, right? Because usually a lot of different things can go wrong, but there's only like one right way to do things. So it's a little skewed there, but that's typically how it goes. Okay, so now we have our scanner VC basically done. Again, we have it set up so on a good case, we yell into the void, here's our barcode. When things go wrong, now we're yelling into the void, hey, things went wrong, here's the type of error it was. So again, what we need to set up now is someone to listen to our view controller that's yelling out all this information. And now that is going to be our coordinator, our UIViewRepresentable that has a coordinator that's that middle person in between our UIKit view controller and our SwiftUI view. So let's go set up our coordinator to listen to this thing. Now we get back to SwiftUI and start building our coordinator in our UI view controller representable, right? We're almost done with all the AV foundation stuff. I know that may have been rough, but I did forget 2 things in the last video because I got distracted. So, right, we created our setup capture session function, but we never called it. So after our inits, we want some view lifecycle methods here. So view did load, super.view did load here, and then we want to call setup capture session, right? Because if you don't call your functions, they don't run. And then the second thing we want to do is set up our preview layer after the view did layout subviews. So again, more view lifecycle here. View did layout subviews, super.view did layout subviews. And then here's where we want to set our preview layer. Preview layer dot frame, right? We want to set the size of it equals view dot layer dot bounds. Right? So, but this is optional and we want to surface an error if this doesn't work correctly, right? So we're just going to unwrap that optional. Guard let preview layer equals preview layer else. And again, scanner delegate dot did surface error, and then this will be invalid device input and then return. Right? And then now this no longer needs to be optional. So again, what's going to happen here is if we don't have a preview layer yet, we'll return this error. And this will actually fire off when you try to run your camera on the simulator, because again, there's no camera on the simulator. And then we'll go ahead and make the preview layer equal to the layer's bounds, the size that we declared. Okay, so that was the 2 things I forgot in the last video. Now we are done with this view controller. And now we can go to create our scanner view, which is going to be our UI view controller representable. So to do that, click on Barcode Scanner, Command N, new SwiftUI view, hit next, call this scanner view, and we'll make this small. Now, if you remember me describing this, right, a normal view, which is what we have right now, has a body that returns some view. In this case, it's text. But remember, if we conform to UI view controller representable here, now the body that normally would be returned, like this is still a view that we can use in SwiftUI, but the body that we would return is replaced with the view controller that we can make. So if you do Command B, what it's going to say is we're not conforming to that protocol, right? Remember the 2 stubs, make view controller and update view controller. However, Xcode has you do something first, right? You're going to say, oh, add protocol stubs. We're just going to give you this type alias. But this can be a stepping stone, right? Because the view controller type we're going to use is scanner VC. So now if you do Command B, now it's going to give you the same thing, does not conform, but now it's going to give us the proper protocol stubs, and it figured it out because we told the view controller type it was a scanner VC. So here we go. And then we're not going to use this anymore, so we can delete that type alias. But we did get our make view controller and our update view controller with the scanner VC, right? Now, if you have a keen eye and you remember what we did last time on the Safari view controller that we're going to go back and fix with Link, right? We had a much longer thing here for context, right? We had actually UI view controller representable context, right? And then that took in a scanner view, right? That's what we had last time. Now, what we got when we did the autocomplete there was just context. So that's nice and neat. That's nice and clean. But let's see what context is. So if you click in it, jump to definition. Context is just a type alias for that UIViewRepresentable context with self in it, right? So that we put in scanner view there last time. Context is just a type alias for that. So it makes it nice and neat. Quick rant on type aliases. I have a love-hate relationship with them. Oftentimes I feel they just add an extra layer of complexity to try to figure stuff out. A lot of people use them for like closures. Me, I would rather see like the definition of the closure right there rather than like having a type alias that just says like closure and then I got to go look up what it is. Like it has an extra step. However, in this case, I like it, right? Because it just removes all that boilerplate because this is always going to be that UIViewRepresentable context with, scanner view in it. So anyway, sorry for that type alias rant, but we're going to keep this context now because it's the same thing there. Okay, so just like before, our update view controller is just an empty implementation. Again, if you were doing updates to the view controller, you could, that's where you would do it. So right now we need to return a scanner VC. But remember, we set up an initializer, right? On our scanner VC, we initialize it with a scanner delegate. And remember, we want the delegate of our scanner VC to be our coordinator, which we're going to set up here in a second. So that's going to be context, which remember, context is again the scanner view essentially, dot, and you see it as a coordinator on it. Now it's not going to work because we don't have the coordinator set up yet, but that's what it's going to be. So let's set up that coordinator. So down here below our update, we're going to do final class and just call it coordinator. Now you may have never done this before, right? Where you're putting a class inside a struct, right? That seems weird. You could define this outside of it, but if you had multiple coordinators in your app, which if you're building a larger app, you're probably gonna have to drop down to UIKit a couple times. So you may have to like name these specifically, like Safari coordinator, camera coordinator, and that just adds the confusion. If you just put it here on the scanner view, you just have it built in on there. You can always call it coordinator. You don't have to have like, proper naming. So our coordinator is an NS object, and then it needs to conform to, remember I said our coordinator is basically the delegate of our scanner VC, right? So that needs to conform to scanner VC delegate. And remember in this path that we saw here, right? Our UIKit talks to the coordinator, coordinator talks to SwiftUI. So we're setting up that first part of the communication there where our coordinator is listening to our scanner VC. That's what the scanner VC delegate is. Now, if you look here, scanner view.coordinator does not conform to the protocol. So hit your fixits and you're going to get your protocol stubs, which they should look familiar, right? We got did find and did surface error, right? So this is the UIKit telling our coordinator, hey, I found the barcode. Here it is. Do with it what you want. Well, what the coordinator is going to do is tell our SwiftUI view, right? Again, it's like a two-step process. So for right now, we're just going to print barcode. And then for did surface error, we're going to print error.raw. This is why we put the raw value on our camera error. If I go back to our scanner VC, the raw value here is this string, right? We're going to replace that in the last video when we properly do our errors. But to test this communication, I just want to make sure we have the value before we work on the next step on passing it to the SwiftUI view. Okay, to review that real quick, we created our coordinator here. We made it conform to scanner VC delegate, and we implemented our delegate methods, and then we're doing something temporarily with the info we get. That is the basic setup. We're not 100% done yet, but Xcode is still yelling at us saying scanner view does not conform to protocol UIViewRepresentable. Wait a minute, I thought we just did that, right? It was only these two functions that needed to conform, right? Make UI and update UIViewController. Well, when you have a coordinator, you have to do another similar function called make coordinator, right? So hit that and you'll see it'll add it in there, make coordinator. I'm very particular about the order. So, right, I think make coordinator is kind of come down here last. But anyway, this gets called automatically, just like make UIViewController gets called automatically, right? When a scanner view gets built, it's automatically going to call make viewController, make coordinator. So we need to basically return a coordinator here. And what coordinator are we going to return? Well, that's this one down here. So let's initialize a new coordinator. Okay, so now our coordinator is officially listening to our scanner VC, right? That's step one in the process. UIKit, tell the coordinator. Okay, I think we have that set up. Let's test it. First, I'm going to test on the simulator because we should get an error because the simulator doesn't have a camera. So we should see a printout of the error.raw value. And then I'll test it on a device, and we should be able to print a barcode when I scan something. So let me actually run this. See on the iPhone 12 Pro, we'll run it, and then we should get an error printout in our console. No. And we didn't. You want to know why? See if you can guess why. I'll give you 2 seconds. 1, 2. All right, because Sean's dumb. That's why. Again, these silly mistakes happen all the time. So here's why I didn't get the printout, right? Because if I go back to my barcode scanner view, I still have just a regular rectangle, right? Don't even have my scanner view. So that would help, right? So instead of a rectangle here, we're going to have our scanner view. Again, the frame is the same. That's what's nice about setting up like the dummy structure, is all I had to do was replace rectangle with scanner view, good to go. So now when we run it, it's going to initialize the scanner view here, which again, in our scanner view, when it initializes, it's going to call make UIViewController. It's going to call make coordinator. It's going to set up all the delegates. And then I should get an error because it's going to try to set up the camera, but because I'm on the simulator, it shouldn't work in theory. There we go. Okay. So I got the error down here in the console, and you can see it printed out a bunch, like 7 times. Here's why. And I'm interested to get your feedback on this. I would like to hear it because I don't have a great solution. So if I go to my scanner VC here, this error that's printing out is in this is in my view did layout subviews, right? This is the one that's getting fired off, and that's because view did layout subviews gets ran a bunch of times. Now here's why I kept this in here is because later in the error alerts, it doesn't affect anything. So I think it's fine, because it's really the only way to surface an error if we wanted to actually surface an error. I mean, the other option would be to have it fail silently, which I don't really want to do. So anyway, I'd be interested in your feedback. Like, what do you think of this? Is having this error message fire off 7 times because view did layout subviews, like just that's how many times it gets called. I'm sure you could run some crazy check logic to make sure it only runs once, but I don't know. I feel like this is not hurting anything. It's not doing anything. So I don't know, but I would love your thoughts on that if you do. That's not what this course is about, but a little side note. Anyway, so back to our barcode scanner view. Like I said, did the error show up? Oh no, it didn't show up because we haven't set up the alerts yet. Getting ahead of myself. But what you saw happen was in our scanner view, yes, it is working. Did surface fired off, and our scanner view is printing this. So step 1 of that communication chain working. Our coordinator has the information it needs. Actually, I just tested the error. Let me actually run this on device and see if it can actually get a barcode. All right, so now I'm going to run this on my iPhone 12 Pro here. Weird flex, just got it. And then the barcode I'm going to scan is the iPhone 12 Pro box here. And I'll put up like a little picture-in-picture because I can't just like throw it up like I can in the simulator. Okay, so you see the first thing that pops up is the camera permissions, right? Remember setting that up a couple videos ago? So I hit OK. Now you see my preview layer, a little sneak peek at my camera setup and lights, and here's the code. So, okay, if I scan the barcode of, you see here, my Apple box, see if this works here. All right, cool. Now you can see it printed out a bunch, right? And then we did get an error. The scan value is not valid because it must have picked something else up. But I want to point something out, right? It picked up a number like a ton of times. Like it's constantly scanning. There's two trains of thought here, right? So if I go back, let me stop running this here, and we'll go back to some code. So if I go back to my scanner VC here, you'll notice we can start capture session. Well, we can also stop the capture session, right? So I guess it depends on the functionality of your barcode scanner. This is a bit beyond the course, but I'm just letting you know like how you should think about it. So you can imagine there are some use cases where you would want to continuously scan, right? Like just scan and display the barcode, right? That way you could scan a bunch of different barcodes at once. Or there could be a case where like as soon as you detect one barcode, you want to stop scanning because maybe you want to check that barcode against the database to see if it exists in your database. So there's two kind of use cases, right? I can see arguments for both. The reason why I kept it running is because if you do stop, and I'll show you here, we can go ahead and do that. Just like you can call start running, you can call stop running. Down here I can call capture session.stop running, and this will stop it as soon as I detect a barcode here. If you're having issues scanning a barcode, here's what you can do real quick. Go to Safari, see I have barcode example already in Google, and then you can just see it stopped right away. So it picked up the barcode. Now let's see what happened here, right? So it printed out the barcode here in the console, and then stop running got captured. Now the reason I didn't do this is because to restart it, we would have to implement a restart button and do more UI, and I felt that was going too far down the rabbit hole of nothing to do with SwiftUI and UIViewRepresentable. So that's why I just kept it running. But I did want to show you that you can stop the capture session if you do want to like take this barcode scanner and like maybe build something upon it or implement it into an app or something. But for right now, you can see back in our scanner view, that first step of the communication is working. We're able to get the error raw value. We're able to get the barcode. Now we need to set up the coordinator so it sends that message to our barcode scanner view so that we can display the barcode properly on the screen or any errors if necessary. We're going to do that in the next video. All right, we left off last video with UIKit properly communicating with our coordinator. Now we're going to take that information from our coordinator and pass it to our scanner view. So to do that, we're going to use state variables and bindings. This is where it may get a little familiar. This is now kind of the stuff we've done already, but it's always good to review and for you to see the whole process. Now, at first, we're going to do this all in the barcode scanner view, but really this type of stuff, should be in the view model. We're going to implement that later, but I want to walk you through this way and then refactor. I think you'll get a better understanding that way. So we need a variable here, right? Or state private var called scanned code, right? This is what it is, and it is a string. And actually, let's just initialize it with an empty string. So what you'll notice, if I just left it like that, and this is kind of a quirk, which not a quirk, I guess this is how it's designed, but if I just leave it there, now when I create a barcode scanner view, I have to pass in a value for scan code, like when I initialize it, like here in our app. Right? I would have to pass in some value for scan code. So if you give it a default value, you don't have to initialize it with one. And in our case, the empty string is fine. You'll see how we check against that. So let's work on the barcode part first, because the error is a little more complex because we're setting up like our error alert structure. So let's just keep this simple with the scan code first. So again, to review state variables real quick, basically state, whenever scan code changes, the view will get updated, right? So instead of our text saying not yet scanned, we want that to be based on the scan code. So we can say scanned code dot is empty. So all strings have this is empty Boolean to check to see if it's an empty string, which ours is right now. So if is empty is true, we're going to say not yet scanned, right? And if is empty is false, we're going to say scanned code. And similarly, in the foreground color, we can do scanned code dot is empty. If it is empty, we want it to be .red. If it's not empty, we want it to be .green, right? We want not yet scanned to be in red. And when we scan a code successfully, we want that number to be in green. And again, I'm kind of spelling things out the long way. We're going to refactor this better in the view model later, but I think spelling it out like this, again, is easier to understand. Okay, so now that our UI is going to update, whenever scan code changes and it's going to update properly, we need to basically change our scan code. And we want to change our scan code whenever we scan it, right? But right now, our barcode scanner view doesn't have a way to get that information, right? Because our coordinator has that information, but our UI here, our bar scanner view, doesn't. So in our scanner view, we want to create a binding to scan code, right? Remember what a binding is whenever we change that binding in the scanner view, it will update the one here in our barcode scanner view. I know those are similarly named. Maybe we should have been better about that. So anyway, in the scanner view, right, we want to create a binding at binding var, and this is scanned code, and that is a string. So I do Command B to make sure we get it here. Okay, build failed. Oh yeah, we don't have a parameter, right? So here, right in our barcode scanner view, now that we put that binding there, we need to initialize our scanner view with a scan code, and that is going to be a binding to this scanned code up here. Remember, that's what that $sign is. A $sign is how you make those bindings. So again, whenever we change this scan code variable in our scanner view, it's bound to this scan code, and that's going to update. And then when this updates, our view is going to get redrawn and update accordingly based on our ternary operators here, when we have a scan code and when we don't. Okay, so if I do Command B, that error should go away. We're still not done. Why? Because these previews on our scanner view, remember I told you previews are always going to get you. And again, for bindings, just for your previews, you can do .constant, and then you give it a value 1, 2, 3, 4, 5, 6. That's kind of like our random barcode view. But that's again, just to get the preview initializer done. So now we have a binding to scan code. So here in our scanner view, we just need to update the scan code, and that'll trigger all of our changes. So you may think, cool, well, in my delegate method where I get the barcode, right, did find I have a barcode, why don't I just do scanned code equals barcode? Cool, good to go. Wrong. Now remember, like I said, our coordinator needs to pass information to our scanner view. But right now, if you look at our final class, it doesn't know about our scanner view. It doesn't know, there's no connection there. So what we can do here is private let scanner view, and that is of type scanner view, right? So we're giving it a property of a scanner view so we can make that connection. Okay, getting a bunch of errors, that's fine. Let's comment this out to avoid confusion. We'll come back to you later. What this is saying is like now we can't initialize a coordinator with nothing, right? Because we have to give scanner view a value. So what we do here is coordinator scanner view, right? And that takes the type of scanner view, but we can pass in self, right? Because on here, self is the scanner view, right? So this scanner view, when we create our coordinator, we're saying that, hey, I am your scanner view, essentially. And I forgot the initializer. Sorry for the confusion there. So we can do init, and then it initializes with the scanner view, and that scanner view is of type scanner view. And this is just like a normal UIKit type initializer. So you would do self.scanner view equals scanner view. And again, to explain this real quick, when we initialize it, whatever scanner view we pass in here, we're going to set that equal to our self.scanner view, which again is this scanner view up here. I know I said scanner view 1,000 times there. Do Command B, we should be good to go. So again, when we create our coordinator in make coordinator, we're passing in self as the scanner view, which again is the scanner view. And then here we're setting that scanner view equal to that. So that is how we made the connection between our coordinator and our scanner view. So now instead of just doing scancode.barcode, we need to do scanner view.scancode.barcode, right? Because our coordinator doesn't have a property called scanned code, right? Our scanner view has a property called scan code. And again, we pass in that scanner view here so we can use it there. And then to finish off this thread, right? So now we're setting the scanner views.scancode equal to barcode when we found it, right? Remember the UIKit component talks to our coordinator, says, hey, I did find a barcode. So this is our coordinator saying, great, I got your barcode. Now let me tell the scanner view what that barcode is. So this is us telling the scanner view what the barcode is. And then here our scanner view, because it has a binding, right? So our scanner code, scan code changes. But this is a binding to our barcode scanner views scan code, right? So when that changes, this is going to change, right? We're just pulling on the thread here. And when this changes, now our UI is going to redraw and update accordingly, right? Because scan code will no longer be empty, ideally, right? We send it a barcode. So now it's going to change to the scan code and the color is going to change to green. In theory, let's test this out. All right, so I'm going to run it on my device, throw up the picture in picture so you can see my device. So let's open up Safari here for our example barcodes, and there you go. You can see as it's scanning, let's try and scan like a different one to see the barcode change. Okay, so cool. You can see our numbers changing as I'm scanning different barcodes, right? So nice. Our UI is all connected. As you can see, our numbers are changing. The color is green when we scanned it. And that wraps up the connection between, UIKit to the coordinator to the scanner view. That is coordinators in a nutshell. We're going to go through that process real quick one more time with our error alerts, just to kind of give you practice and drive the point home. And then we're going to refactor and project organization into MVVM and organize our project to finish off this app. We left off last video getting the whole communication pattern with coordinators done for our scanned barcode. Well, now we want to do that again with alerts, but first we want to kind of set up the structure of our alerts. You'll see why in a second, because there's kind of two ways to do alerts. One's pretty basic and one is more involved. And the more involved one is actually what you're probably going to use in like real apps, and you'll see why. So let's start with the basic alert here. And we'll just do this on a quick button tap. So after our text, add a button. This is just temporary. We're not going to keep this button here. So label, this will be a text. I know there's a quicker way, but I don't care. I'm just doing this temporarily real quick. Tap me, right? And on this, we want to show an alert. And again, whenever you want to update your UI, you need a state variable here. So you can do @state private var is showing alert, and that can equal false at first. So in our button tap, we just want to make this true, is showing alert equals true. So that is the trigger to show our alert. Again, this is the super basic way. This is kind of a side note I'm showing you. We're going to build the more involved way. But I want you to know this because sometimes you may just need this simple way. So now we want to put the alert on our VStack here. We can do .alert, and then you see it's item in content or is presented. So the more involved one involves an item. We'll do that later. Right now, we just want is presented. And the is presented we want is the binding to is showing alert. And then the content we want to show, capital A, to initialize an alert. And you can do, right, title, test, message. This is a test. Dismiss button. We'll do .default, and you see it takes in a text. So we'll do text of just Okay. Okay, so just a super dead simple alert, and maybe you can start to see what's going to happen here. As soon as I tap me, is showing alert is going to flip to true. And because this alert is kind of watching is showing alert, it's going to show when that gets flipped. And I forgot, this is not just a string. I need to do text. Used to kind of the UIKit way. This is the SwiftUI. I got to wrap it in a text. So there we go. Okay, so that should be the default alert. I'm going to run this on the simulator because it's a pain to show you my phone with the camera. So let's run it on the iPhone 12 Pro, and then you'll see the alert pop up. Well, I think we'll get an alert for the camera not working, which I think we tested before. Nope, that's a lie. We haven't connected that yet. That's what we're doing this video. Getting a little mixed up. Okay, so you see our tap me button down here. I'm going to move this over here. So I'm going to do tap me. Bam, there's the test alert, test, this is a test. And then when you hit OK, it automatically dismisses. You don't have to like set up the dismissal. So again, tap me, alert, bam. That is the super basic way. Just on an event, you do is presented based on that state variable, cool. When you do it based on an item, it triggers when that item changes. And we'll do that here. So let's get rid of this alert for now because we're gonna set some stuff up. Let's get rid of this button. Told you that was just temporary. And then let's get rid of our is showing alert variable. However, we are going to need an alert item. So we can do @state private var alert item, and that is going to be of type alert item that we don't have yet. Let's create that. I'm going to create that right here for now, just so it's all very visual for you. You can see what's going on. We're going to come back and like obviously organize this. So we can make a struct called alert item and give that the properties, right? The properties we need on alert item well, I deleted it, but it was like a title, a message, and a dismiss button. So we can do let title, that is a string, let message, also a string, and then let dismiss button, and that is going to be an alert.button. And basically I'm just recreating that autocomplete that you saw before on the alert. So that is our alert item. So now this is of type alert item. There we go. And it's going to be optional because we don't have an alert item yet. We're not sure which one it is. And we're going to build our alert item based on whatever error type we pass in. Back to the scanner VC. You remember we had our camera error. Well, that's what we're going to use to determine what information goes in our alert item. And here we're going to create another small struct. Again, this will go in its own file later. Struct called alert context. And this is another kind of helper shortcut. You'll see how we use it here very quickly. But this is where we basically create our alert items. Static let invalid device input equal is going to be an alert item that we just created. So alert item, parentheses, and you see I get a title message string. So the title, we can say invalid device input, and then bring our parameters down here on the same level. Message. Again, we're just going to copy and paste the message that we already typed from our scanner VC here, right? Remember I said we're going to come back and get rid of these raw value strings. It's because we're using it here in our alert context. And if you're a little confused, not following along, I think this will all come together in the end, and I'll come back and explain it. So if you're not quite following along, it's all good. So there's our message. And then again, our button, we want to have .default with a label of text okay. That's what we want. And whatever you want your button to say, you can say that. So let's copy and paste this because we have two types of alerts, right? We have our invalid scan type. So let's do that. Say invalid.scanned, and be careful of copy paste errors. They'll get you every time. So here in the title, we can change this to invalid scan type. And then again, back in our scanner VC, we'll copy and paste that message. Whoops. In our barcode scanner view. Here's the message, and then we want our button to be okay. So what this is an example of is usually in a bigger project, you're gonna have tons of alerts, right? Network calls, different types of errors, so many different errors in a project. So I usually have an alert context file that has like a ton of these, right? We're only using 2 for this example, but you'll see how this makes it very, very easy to call certain alerts. Again, I'll put it all together and we'll do the review. But again, what's happening is we're creating individual alert items based on our error here. So now we can go back to scanner VC. Let's get rid of this just for cleanliness here. We no longer need a raw value of a string. And we're probably going to get an error because it's expecting to read that raw value. Do Command B, build failed. Yep, that was expected. Click on the error. Yep, camera has no raw value. So we'll just, for now, print the empty string just so we don't get an error. We're going to come back and obviously implement that here in a second. So now back to our barcode scanner view, which is holding our alerts. That's the setup. So now what I want to do in my barcode scanner view, again, create that alert again, just like we did last time, but instead of the is presented, we're going to use the item. And the item is going to be a binding to our alert item property here on our barcode scanner view. Now what you'll notice here is it says binding identifiable. So that means it has to be identifiable. So if we go back to our alert item, let's conform the alert item to identifiable. And if you remember, when you conform to identifiable, what do you need to do? You need to do let ID equals UUID to give it an ID, something to identify it by. So now that alert item conforms to identifiable, we can create the binding here, binding alert item, and then again, the autocomplete will get you sometimes. So the alert item, we want to do open bracket, alert item in. Okay, so now here's we want to build that alert that we built previously. So we do capital A for alert and then initialize it. And again, we want a title, message, dismiss button, right? Now you can kind of see why I structured my alert item, title, message, dismiss button, right? So title is going to be the alert item that we get back here, alert item dot title. Same thing, alert item dot message. And we can, for cleanliness here, let's do this. And then alert item dot dismiss button. Okay, do Command B. Hopefully we don't have any more errors. We do have errors. Again, I keep forgetting to wrap this in the text. There we go. Now we're good. Okay, so again, what's going on here is our alert is waiting to see what alert item it gets. And when it gets an alert item, right, we have it here. Now we're setting the alert's title, message, and button to whatever alert item we passed in. And if you look up here, the two alert items we created in our alert context are the invalid device input alert and then the invalid scan type alert. And a quick note about alerts, the reason why you have to do this is because you can't have more than one alert on an item, right? I can't like do dot alert and create another one, for my different cases. That's not going to work. You have to have one. So that's why you create one alert and then pass in variable context into like what the alert is. So now let's actually use our alert context, right? How are we going to pass our barcode scanner view? Like we have to update this alert item, right? So remember our communication path, right? UIKit to coordinator to scanner view. Well, let's go to our coordinator because our coordinator has our alert information right here, right? We have the error type. That's all we need. We just need to know what error type it is. But again, we have to communicate from the coordinator to the scanner view, what's going on. So here in our scanner view, let's create a binding. And again, I'm going to run through this again, and hopefully it'll make sense if you're a little lost. So this coordinator thing is tricky the first couple times you do it, but after that, you get the hang of it. So we want an alert item. And again, that is a type alert item. That is optional. Command B, we're going to get an error because we need to now initialize our scanner view with an alert item. Where is our scanner view initialized? On our main barcode scanner view. Here it is, scanner view. Remember, we passed in the binding to the scan code. Now we need to pass in the binding to the alert item. So when we update the alert item in the coordinator, this alert item gets updated. You're following this trend here? When this alert item gets updated, this alert triggers and shows the proper alert. That's kind of the path here. Again, we'll go over that once everything's all built. So missing parameter, go ahead and hit the fix it. It'll fill that in for you. So I need a binding to an alert item. So again, $ to binding, alert item. Okay, so now I'm passing that binding down to my scanner view, right? So now I need to update this alert item so the whole chain triggers off here. Well, I'm going to update that in my coordinator, right? Remember my coordinator was listening to the UIKit. My UIKit camera view is saying, here's the error. So now my coordinator needs to pass that error to the scanner view. So here, we're just going to switch off the error type. Switch error, right? That's what we get. And on case dot invalid device input, we want to do, well, let's put in the two cases first, right? Case dot invalid scan value, right? So when it's invalid device input, we want to update the alert item properly, right? Because that's what's going to trigger the whole chain of events. Now here's where our alert context comes in. We can do alert item. I'm sorry, not just alert item. Remember, scanner view dot alert item. I forget that a lot too. So if you're forgetting that, and remember that scanner view is the scanner view we had to pass in and put to our coordinator so it knew which scanner view to update. Now here's where the nice alert context comes in. We can do alert context dot invalid device input. right? So the alternative to that, well, let me finish off here. Scanner view dot alert item equals alert context dot invalid scan type. So the alternative here is to define our alert here. Well, you saw, if I go back to my scanner view, like you saw how messy this alert code is, right? We want to get that abstracted away in its own file, which it will be next video. But back to our scanner view, like it's nice and neat here, right? So did surface error is going to come up. All we're passing up is the enum case, right? I'm either passing up invalid device input or invalid scan value. Here in my coordinator, I know that, okay, cool. When it's invalid device input, I'm going to tell my scanner views alert item, hey, use this alert item, which is the invalid device input alert item, again, that we created right here. So it has all that value. It has the title, the message, the dismiss button. So back to the scanner view. Again, this updates our scanner view's binding to alert item, which again is bound to this alert item in our barcode scanner view. So this is going to update when that whole communication pattern fires off. When this updates, this is going to trigger, and this is going to update with the proper alert. So now when I run this, and I think I've tried to test this 3 times now. Now when I run this on the simulator, well, okay, what's the error? Okay, previews. Told you, previews are going to get you every time and when you update stuff. And they're kind of like meaningless. Like our scanner view doesn't even have a preview. In fact, get out of here. So you can see my frustration with previews sometimes. So now let's run this on the simulator. Because our simulator doesn't have a camera, we should get an error message pops up. There you go. Invalid device input. Something is wrong with the camera. We're unable to, right? Because we're on a simulator. So now you can see our errors propagating from UIKit to the coordinator, from the coordinator all the way up, through our bindings to the scanner view to the barcode scanner view to properly update our UI. So I know that's like a long chain of communication, but how do you feel about coordinators? Again, think of a coordinator as the middle relayer, the translator between UIKit and your SwiftUI views, right? The UIKit view controller communicates with the coordinator via delegates, and the coordinator communicates with SwiftUI, just like a little middle person, if you will. Now, this can be a tricky topic. I get it. So if you have questions, definitely leave comments. If you have questions about AV Foundation and the camera, look it up. I'm not going to act like I'm a pro. So kind of save those questions. Keep it to the coordinators and the passing of the data. But in the next video, we're going to implement our view models for this and clean up our project organization and do any last little bit of review. We left off last video with our project working. Hopefully you have a little bit of a feel for coordinators. Now we're going to refactor into MVVM and organize our project. So first things first on our barcode scanner view, again, this alert stuff, let's get it out of here. In barcode scanner, do Command N for a new file, Swift file, next. I always just call this alert. And I usually keep these together. Again, organization, highly subjective, but I don't separate out my alert item and my alert context into, gotta import SwiftUI here, because I don't know, I find it more confusing to keep these separate, because really this is all this is. What gets long in this file is you may have 30 different alert contexts potentially, right, in a big app. So that gets kind of long, but I just like to keep these all in the same file. Okay, so that is our alert. That cleaned up our barcode scanner a bit. Let's clean up some spacing. All right, so now let's create our view model, because again, I like to have my views here be as dumb as possible. Hey, just tell me what to show and I'll show it, right? I don't need to know this kind of stuff. So I like to put this in the view model. So again, barcode scanner, do Command N, new Swift file, hit next, and then barcode scanner view, and then just model at the end. Create. Cool, here we go. Again, import SwiftUI. It is a final class barcode scanner view model. And here's the key here. I know this is only the second time I believe we're doing this, but we're going to get a lot of practice with this in the final app. But again, this is an observable object. All your view models should be observable object there. So what we want to do, and our Xcode is going to break for a little bit here, is we basically want to get these two pieces of data out of our view and into our view model. All right, so I cut there. I'm going to paste here, except in the view model, you don't use state or private, you do published, right? Because remember the view model is broadcasting its changes, and you have to set something up to listen to those changes, right? So publish means we're going to broadcast our changes here. So we definitely want to broadcast our changes to scanned code, right? Because that's updating, and then also our changes to alert item. So back in our barcode scanner view, right? Xcode's yelling at us because we moved our alert item in our scan code. But let's create our view model variable here, or property. Now, we're going to do @stateObject for this one, and it's going to be var view model, and we're going to initialize a new one. That's the key here. I know I said this before, and I'll say it again. Barcode Scanner view model, and we are initializing a new one. So super high level, what to know. We're gonna do a deep dive into state object, observed object in the review section, and we're gonna get more practice with it. But again, the key thing to remember, if you're initializing a new view model, right here, that's what these two parentheses are. We're creating a new one. You want to use state object. If you are passing in a view model from like a previous screen, right? Because maybe your view model relies on data from a previous screen, and when you create your barcode scanner, you need to inject in a view model with that previous data, right? So in that circumstance, you want to use observed object. We'll have some examples of that down the road, but that's the key thing to remember. Creating a new view model, state object. Passing one in, observed object. And again, state object is brand new in iOS 14. Okay, so now that I have my view model, let's do a Command B here. Now my scanned code right here is on my view model. So I just do view model.scan code. Same thing here, view model.scan code. Same thing here, view model.scan code. Again, I lost my syntax highlighting. We'll do a Command B here. And again, my alert item, just put view model in front of it because we moved it over there. So do a Command B. Failed. Okay, we have alert items and scan codes over here as well. We're going to clean this up too, but I want to do it one step at a time. And again, let's move our parameters kind of, down to the next line. View model.scan code. Command B. Cool, everything good to go. And if that was a little fast for you, all we did was anywhere there was a scan code, we just put a view model in front of it, right? Because now that's on the view model. Same thing, anywhere there was an alert item, we just put view model in front of it. Okay, let's run this to make sure our errors are propagating properly. I'm just doing it on the simulator. Cool, errors are still working. Barcodes are still gonna be working. And I'm testing on the simulator because it's a pain to like actually show it on device. But hopefully you're testing this on the device as well. So if we go into our view model, it's set up, it's pretty basic. We can improve this even more. And again, I like to have my stuff clean and easily readable. I find this kind of stuff like not super readable, right? I have viewModel.scanCode.isEmpty. If it is, cool, our text is going to be not yet scanned. If it's not, it's viewModel.scanCode. Now that's not terribly difficult to read, but if all this kind of stuff is just super littered throughout your code, I don't know, it does make things complicated. I don't know why I highlighted this. That's got to be there. But I was talking about like this kind of stuff, right? So we can create properties on our view model to extract this logic and put it onto our view model. In fact, I'm going to copy that because we're going to need that here. So barcode scanner view model, we can start creating some computed properties here, right? I can do var status text, and that is going to be a string. And then here we want to compute that, and that's how we're going to figure it out. Except we no longer have to have view model in front of it because we're on our view model, right? Just use the scan code. So now, anytime I do like viewModel.status text, it's going to check, is my scan code empty? If it is, cool, give me not yet scanned. If it's not, give me scan code. It's going to give me the proper data. All we're doing here is moving that logic out of our view and into our view model to clean things up, and you'll see how it does. One thing you see normally you're probably used to doing like return that. Well, in Swift 5.1, if you only have one line that returns, you can omit the return. I'm not sure how I feel about that yet. I'm slowly getting used to it. At first, it really threw me off. Like I didn't see the return. I didn't think it returned something. So if it's throwing you off and you're not used to it, don't worry. I did too. You can put it in there if you want, but you don't have to have it. So we're going to do something similar. So var status text color is going to be of type color. And same thing, right? Let's go back to our barcode scanner view. Literally just copy this logic and paste it here. But again, we can delete the view model because we don't need that. Do a Command B. Cool, so now we have variables, viewModel.status text, viewModel.status text color, and it's going to do that logic here for us. So again, you can see how this is going to clean up our view here, right? Instead of having all this logic in my text, I can just do viewModel.status text, right? Nice and clean, neat, I like it. Same thing here. Even though this is not crazy logic, I get it. It's pretty simple. But I just think this is much neater, much easier to read like what's going on. So to recap that, like the only property on our barcode scanner view is our view model, right? And then any logic we have here, if I click on our view model, right, our scan code, our alert item, some helper method or helper properties, right? To get, the logic in there for our text and our text color, like move that to the view model, get that out of your view. At least that's my opinion. I like my view to be as simple, as clean, and as dumb as possible. I find that just easier to understand when it's like that. And I'm not going to refactor this text. You can make this you can make a thing called status text. A view, right? And refactor this out. That way that just says status text. Maybe that's a nice little challenge you can do real quick. I'm not going to do that. And the reason being is I'm not like reusing it. Maybe I'm a little lazy. I don't know. Maybe you can just try it if you want. But we're going to move on to project organization, right? Start moving some of these files around. And again, this will be a little bit repetitive, but I want to show you how I do it. So again, new group for folders. Call this screens. And again, this is what I put in the folder, I'm sorry, new group, call this barcode scanner. And then this is where I'll put in my barcode scanner view and then my scanner view model. And I usually put the view model on top. I'll make this bigger so you can see it. I usually put the view model on top. I don't know, that's personal preference. Okay, but now I have my barcode scanner. That's the only screen. So again, on barcode scanner, new group, create kind of this parent folder called views. Inside views, a new group called UIKit components. And again, in here, we're going to put in our scanner VC and our scanner view. And again, I like to keep the UIKit components segregated. So, eventually SwiftUI is going to get a camera view. And then that way I know exactly what I need to go in and replace, right? It's all in one folder. So the only thing left is like our app stuff. I usually leave that out. And then alert, I usually do a folder, new group, called utilities. You got to be careful with these utilities folders because these can end up being just like a dumping ground for like a lot of different stuff. So if you do find yourself having like a lot of different utilities, for example, like extensions, other helper things, like maybe create individual folders for those. Just be organized. Don't have your utilities be a catch-all for everything. Just add folders to be organized. So again, that's my project organization, how I do that. We've refactored into MVVM. We've talked about coordinators. Again, if you have any questions or comments, concerns, leave it in the comments or, hop in Slack, have a conversation there. Happy to help out. But that wraps up this app. The next app we're going to do is the big one. It's the final app that brings all this together. We're going to add a lot more stuff, networking into the mix. So these other apps have been, 5, 6, 7 videos, kind of short. Next one's going to be a lot longer, so strap in. Over the next 20 or so videos, we're going to build this simple appetizer ordering app, right? Where you can download a list of appetizers that you see here. That's going to be our network call. We're going to get practice with that and implementing MVVM with our network calls, passing all that stuff. But then you can tap on an item, see the detail screen. You can see with our match geometry effect animation, see the details about the item, add it to our order, and then go back to shopping for more if we want. And then we have a very basic account screen that you see here. I wanted to get practice using forms because a form like this, whether it's an account screen, a setting screen, is quite common. So I definitely wanted to get practice with forms. And then the order screen that you see here helps us manage an object like our order, right? Because our order can be accessed from our list screen and our order screen if we want to add or delete. So managing that object, in the environment of our entire app. So even though that looks relatively simple on the surface, like I said, it's going to be at least 20 videos. I'm not sure exactly how many quite yet, but it can get pretty in depth. And on that note, while we're building this, I know you're going to want to be like, oh man, I wish we would keep going and build this out further and build out this functionality, build out that functionality. And I hear you. But you have to keep in mind, if we went down all those rabbit holes, built this out to be fully functional with like a fully functional backend database, all that stuff, like that's an entire separate course, right? It's already going to be 20 plus videos. Like if I did all that, we'd be talking 50, 60 more videos and I'd have to charge a hell of a lot more for this course. It'd be super long. So again, this is SwiftUI fundamentals. We're keeping it simple. So I want to put out that disclaimer before we start building this. Because again, I know the engineers in us, the developers, we're going to want to build it out more. So just a quick disclaimer on that. But like I said, we are going to spend about 20 plus videos building out a nice foundation and the core concepts that you need to understand to build this app out further, should you choose to challenge yourself and take this to the next level. But remember, this is a foundational course. So I'm trying to keep things as simple and as digestible as possible. I will have plenty of future courses where we do go very in depth on this, more advanced courses. Okay, with the app overview and disclaimers out of the way, let's actually start building this thing. In this video, we're going to set up the basic tab bar structure of the app that you see pictured here. So Xcode, create new Xcode project. Again, it's an app, hit next. I'm going to call this Appetizers, right? Team, whatever, interface SwiftUI, Lifecycle SwiftUI app. We're going to explain that in the next video. We've kind of glossed over that until now. Well, now's when we explain it. And then language Swift, of course. Next, save it wherever you want, saving it to my desktop. And as usual, hold option, click the green plus there, get rid of my right pane. It's on Sean's iPhone 12 Pro. Get it to the simulator iPhone 12 Pro, hit resume, drag this over. Again, that's just my usual routine there. So first up, we're going to rename this with the handy dandy renaming technique, right? Click on it, right factor, rename. Let's call this the Appetizer tab view. Hit return. There we go. So again, this is we're going to return a tab view. So you can imagine we're going to want a tab view. I shouldn't have said you can imagine. We haven't done this before. Why would you know that? So it's as simple as that though. Tab view, we're going to put our text in here for now. That's not what we want though. I just put it in there so Xcode stops yelling at us. What we want in our tab view is to actually show 3 different screens, right? If I pull up the design again, you see we have our home tab, our account tab, and our orders tab. So we're going to need those 3 screens. So I'm going to create those files right now. So again, in the Appetizers, Command N, we're going to build them out later, but let's at least get the file created because we're going to need it. So SwiftUI view, hit next. We'll call this the Appetizer list view, right? That's kind of the home screen, if you will. Again, we're going to do this 3 times, Command N, new SwiftUI view. Let's call this the account view, create. And then the other one is the order view, right? SwiftUI view, order view. So I just created 3 SwiftUI views, which is going to be our screens. Now for the text, just so we know like what's what, here in the order view, I'm going to actually put the text to say order view. That way, when we like actually tap our tabs, we can see like, okay, yeah, we are on the proper screen. So call order view, account view, and then appetizer list view, appetizer list view. Okay, so back to our appetizer tab view here. Now I can start putting these screens in my tab view and then giving them the proper icon, the proper name, all that good stuff for the tab bar. So let's do that. Instead of text here, I want an appetizer list view, right? We'll initialize that with empty. Now here we want to put on a modifier, right? A tab item modifier, and it has a label. So let's get our builder here, and it's going to take an image, and we want to do system name because we're going to use an SF symbol. That's pretty common for the tab bar. Of course, you could use your own images if you like, but it's pretty common to use the SF symbols. So what do we want to use? Let's go to our SF symbols here. We want a picture of the house, right? That's what is on the design. So just type in house. See different variations of it. If you want circles, cool, use that. I'm just going to use the house outline here. So Command-Shift-C to copy, and we'll tab back to our Xcode. And for the string here, paste in house. I guess you could have just typed house. That's pretty simple, but there we go. And then now we need a text for the title. So text, and it's going to be home. That's what we want to call our tab. So now let's hit resume on our preview here and see what we got. Hit resume. We want to minimize that again. There you go. You can see we have our home tab. That's the only one, and it does show the appetizer list view. So let's copy and paste this because we want this 2 more times, right? So copy, and again, be careful. Copy paste errors, they'll get you. Instead of the appetizer list view, we want the account view. And the tab item for the account view, we don't want to be the home in the house. You can see we have 3 tabs at the bottom. They're all the home in the house. That's not what we want. So let's see what we want for account. Again, back to our trusty SF symbols. Type in person, and then you can see all the different types of person type icons you can have for your account. Again, I just kept it simple and went with this outline person. So again, Command-Shift-C to copy, tab back to Xcode, and instead of house here in our account view, it's Command-V for that to be a person. And then now you see our tab bar updates there to a person. And instead of it saying home, let's call it account. Cool. Now you can see our tab bar updating in real time down there. And again, instead of appetizer list view, we want an order view. In the image for the order, pulling up the design again, you can see it's like a nice little bag inspired by the Apple app to actually shop. Someone might have shopped for an iPhone 12 recently, don't know. So let's just do our SF symbols again. Type in bag. Okay, again, various types of bags. Again, I kept it simple, just did bag. I'm not even going to copy and paste that. I'm just going to type in bag. Pretty simple there. And again, we don't want it to be called home. We want it to be called order. Right, so now you can see our tab bar taking shape. We have home, account, order, looking nice. And now if we run this in our preview here, click the play button. Again, you get this bluish gray background. Now when we tap account view, we can see it says account view, tap order, see it says order view, we're good to go there. Now we'll stop this, but you can see this is like the default blue color. Again, pulling up the designs, we have this nice dark green as like our primary brand color. So we want to make our tab bar, have that color as the accent color. But first, we need to create that color. So we did this before in the weather app, but you go to assets, hit the plus button down here, and we want to create a color set. And here you go. We're going to name the color brand primary. I like to, if possible, right? Sometimes the design doesn't call for it, but if possible, I like to have my colors be a generic name, like a brand primary, right? Whatever app you're in, Twitter, YouTube, like it's gonna have a primary brand color. That way, if that color ever changes, whether it's a completely different color or maybe a completely different shade, like I don't have to go renaming everything. Like I know it's the primary brand color. So tap on any appearance here and then pull out the right pane if it's not pulled out there. We want to go to input method here. We want 8-bit hexadecimal because I have the hex code. I'm going to paste this in here. It's a hashtag 00633D for our dark green color. Hit return. There you go. And then we want this to be for any appearance. Like it's going to be the same, dark or light mode. If we wanted a different shade of it for dark mode, we can change that, but we're going to keep it the same here. So we're going to keep any appearance there. So now we have a color called brand primary, as you can see there. So back in our appetizer tab view, it's pretty simple, right? On our tab view, we can do .accent color, and it just takes in a color. So we do color, and then brand primary. And we're going to refactor our colors so we don't have to type, I don't want to have to type out brand primary every time I use it. We're going to refactor that later. But now if I hit resume, oftentimes in the preview, you won't see this color type accent stuff. So let's go ahead and run this on the simulator so we can see. And then yep, on the simulator, you can see the dark green home, dark green account, dark green order view. So now our tab bar is set up. Let's spruce up our views here real quick, just so it's more obvious, and we're gonna need to do this anyway. So stop the simulator. We're gonna add the navigation view with the navigation title to each of these views, right? So if I go to appetizer list view, let's wrap our text in a navigation view. Put this Command X, Command V, put that in there. And then on our text, for now, we're gonna obviously change this, but I wanna get the visual there so we can see it better. Say .navigation title, and we're gonna call this Appetizers. Now, I like to kind of put emojis in mine. You don't have to, I'm gonna do fries. You can put any food you want in there. That's kind of like an appetizer, but I like my navigation view here. I don't know, I just like how it looks, right? You got the emoji, then the name. If you don't like that, don't use the emoji. If you want a different emoji, use a different emoji. Cool. But I'm going to copy this whole navigation view. That way it's quicker to type for the rest of our views here, right? So if I go to account view, again, over this whole text, copy paste. Obviously, this is not the appetizer list view. Let's just call this orders for now. And then not appetizers for our title. And you can see it updating in real time, right? On the right, orders. And then the emoji I want is kind of like a receipt looking thing, right? Oh, see, this is the danger. I just realized I'm on the wrong screen. So no, this is the account, right? So this is where copy pasting and going too fast can kind of bite you. So you always kind of want to check that. We're on the account screen, not the order screen. Got a little ahead of myself. And for account, I just want to use a laughing emoji, right? You can use whatever you want. We'll just put that there because accounts are funny, like aren't they, right? So again, order view, paste here. Now we'll do what I was talking about before. We'll call this orders. And then orders. So hopefully this is repetition, right? We've built a couple navigation titles before. That's why I'm going a little quicker. Type in receipt. And again, I just like this look of my navigation titles with the little emoji. So if we run this again, oops, so we don't have our tab bar because we ran it from our order view, right? So our previews, when we start them, like it treats this as like the entry point. So let's make sure we go back to our appetizer tab view. Now we run it. So now we have appetizers, account with our nav title bar, and order. So that's it for the setup and just the overall structure of our tab view. Just a quick review. It's pretty straightforward, right? You create a tab view. In the view builder of your tab view, you give it whatever views you want, and then you got to make sure you create a tab item modifier on that view so you get the image and the text. And then again, to change the accent color, right? Whatever color the highlight, there you go. .accent color, and then pass in whatever color you like. In the next video, we're going to dive into the new app lifecycle of SwiftUI, right? You see appetizers.app. Like, what is this app thing? What is this scene? What is this window group? What main? Like, what is that? We're going to talk about all that in the next video. We left off last video getting the general navigation structure in our tab bar in place for our app. In this video, we're going to kind of take a little detour and talk about the app lifecycle that is new in iOS 14 and with SwiftUI. Now, if you're coming from UIKit, you're probably used to the app delegate and the scene delegate that was introduced in iOS 13. But, in the app delegate did finish launching with options, that kind of stuff. You had to run some code there. Well, that's not here, as you can see on the screen. Like, we have a much simpler implementation. Now, in UIKit, app delegate, scene delegate, that was the entry point for your app. That's where your program started. Well, how do we know how to do that in SwiftUI? Well, that's where this main keyword comes in, right? The main keyword acts as your entry point into your program. Now, there's a function that has to be ran when you use the main keyword. It's a main function, and you don't see that anywhere in here. Well, it's kind of hidden away by conforming to app, right? You've been used to seeing us conform to view, right? Our structs are conforming to view. Well, let's dig into app and see what that is. So I'm going to click on app to jump to definition. Well, you can see it's a scene representing the content of the app, right? And scenes were introduced in iOS 13. Real quickly, a scene is what shows up and allows you to have multiple windows, right? And a big part of SwiftUI is being good on iPad, macOS, where there's multiple windows. Whereas if you're only on iOS, you just have one window to worry about. That's your app. But that's why scene delegate was introduced in iOS 13. And this is kind of, replacing the scene delegate, right? So like I said, the body of an app conforms or returns a scene, right? Again, we're used to the body of our view returning some view. Well, now we need to return a scene, which is again, the window of our app. And if I keep scrolling down, you can see our body is a scene builder, right? We discussed view builders, how the view builder, constructed a view is pretty limited. It wasn't a typical, you can't just write any Swift code in there. Very similar concept, except now this returns a scene, and it builds a scene. But we talked about that main keyword and how it required the main function. Well, you see the extension on app here. This is where this public static func main is, right? And let's actually copy and paste this URL and take a look here in the Swift guide. And I hope you're getting a little taste of like how I kind of like explore and develop. Don't get me wrong. I do a ton of tutorials, YouTube videos, articles, definitely. But when I want to dive deeper while I'm coding, I just, command click into something, look at the definition, read about it. I'll make this bigger so we can see it here. So again, here's main, right? Apply this attribute to a structure, class, or enum declaration to indicate that it contains the top level entry point for a program flow. The type must provide a main type function that doesn't take any arguments and returns void. So if we go back to Xcode, that's what's going on here. The extension on the app protocol has the static function main. So that's how our program gets started, right? We conform to app. The app returns a scene, right? Again, you're used to body some view. Well, now we're doing body some scene. The scene is just like the window of your app, and it's different from like the old app delegate because you can have multiple instances of the same app. Whether on Mac OS or iPad OS, right? You can have that multi-window. Not really on the iPhone yet. Maybe that'll come someday. But if you're doing iPad or Mac, you got to be familiar with scenes. And then the final piece of the puzzle in this basic kind of implementation is the window group. So again, we'll command click. Now you can command click to jump to definition to see what we just did. Or if you want a more like nice kind of documentation, option click, and you get this little pop-up, which is nice. I typically like to open in developer documentation because it's bigger. So you can see a window group is a scene that presents a group of identically structured windows. Okay, that may be confusing, but the overview, let's read it here. Use a window group as a container for a view hierarchy presented by your app. The hierarchy that you declare here as the group's content serves as the template for each window that the app creates from that group, right? So back in our example, anytime you open up a new Appetizer app, like again, if you were opening this on the iPad and you opened up multiple instances of it, or again, Mac OS, you opened up multiple windows, every one of those windows is going to be initialized with our Appetizer tab view, right? So what you're setting up in the window group is what opens up when a window of your app opens. Hopefully that wasn't confusing. But in our case, we want to show the Appetizer tab view. And again, that is kind of like how our whole app is structured, that holds all our views, etc. So again, that's just the simple basic implementation. Again, the main foundational knowledge that you should know. Of course, this topic can expand, right? If you remember the whole did enter background, will enter foreground, did become active, deep linking. This can get pretty complex. There's a lot that can go on here. But again, for foundational knowledge, knowing how the app is structured, how it builds a scene, has a window group, how it, main is your entry point. Again, that's the foundational knowledge you should know. If you want to build on that, I'll link to some resources below. All right, in the next video, we're going to start building our data model for our appetizer object so we can start building out this appetizer list view that you see here, and then eventually connect it all up with a network call. So let's keep this thing moving. We left off last video discussing the new app lifecycle in iOS 14. In this video, we're going to start getting ready to build the list screen that you see here, and that is going to be a network call. We're going to get all this appetizer information via a server so we can populate that. The first thing we need to do, though, is start building our model and building our appetizer object. And looking at this screen, you can start to see, right? It's going to have an image or an image URL. It's going to have a name, a price. If we pull up the detail screen, you can see there's more information, like a little description, some nutrition information, right? So our appetizer object has a lot of properties on it. And to know what properties we need to include on that, we need to look at the JSON that we're going to get back from the server. So to do that, you'll notice a link in the description to this video. There's going to be a link to our JSON. So click that link and open it up in Safari. So I'm going to pull up Safari. I'm going to Command V because I already had it copy and pasted. Here's our JSON. Real quick, if yours doesn't look like that, right? If it looks more, I'm going to click this little monkey in the upper right. If it looks more like this, a jumbled mess, you should probably install some Safari extensions or a Chrome extension, right? If I go to Safari extensions, this will pull up the App Store. Just type in JSON viewer or something like that. There's a bunch of them out there. I got this JSON Peep. That's the one I'm using. There's other paid ones, that do more. Totally up to you what you want to get, but I highly recommend doing that because, as an iOS developer, you're going to be looking at a lot of JSON. It's nice if it is formatted nicely. All right, so back to Safari. You can see, right, we have a request, which is an array, and then here are our appetizer objects, right? We have a name, Asian flank steak, description, protein, an ID, calories, price, carbs, and then the image URL. So this is how we're going to structure our model based on looking at this JSON. And here's the downside about this one that I got from Safari. Like, I can't manipulate the structure of this. So I'm going to go to Chrome here. And I'm showing you both ways, like intentionally. If you're a Safari user or Chrome user, you can do this. So again, I'm going to paste the URL in there. And the Chrome extension I use is called Pretty JSON. Again, they're all free. But the one in Chrome I like because I can see these little down arrows, right? Like, I can manipulate the structure so I can get a better visualization of it. Because oftentimes JSON can be like heavily nested and hard to figure out what's going on. So here I can see we get a request that has an array of items. That array of items is our array, like I'm minimizing each one here, right? Is our array of appetizer items. So that gives you a sense of how the JSON is structured. We'll come back to that in a little bit. Right now I want to focus on just the appetizer itself. But a quick note about showing you the JSON like this, there's a wide variety of how well documented an API can be. Sometimes the API is beautifully documented. You don't have to dig into the JSON. The documentation will show you, hey, description is a string, price is a double, very well documented. However, that's not always the case. It's very often that, sometimes the API is not well documented and you have to dig into the JSON to figure out for yourself. So that's why I wanted to show you this. Well, that's one reason. Another reason, as you can see by this URL up here, is one thing I'm starting to do for my courses is build out my own backend. So I can start building my own APIs and endpoints, which gives me more flexibility to be more creative in the types of sample apps I can make. You're seeing the very, very first version of it right now. But my idea is that in future courses, building out my own backend gives me a lot more flexibility in what I can build. Because to be honest with you, my previous courses, I had to find an API that was like open and free, didn't deal with like OAuth or API keys, because oftentimes that was outside the scope of the course. So I was really limited in like what types of apps I can build because I was limited to, what API was free that also offered up, the stuff that I needed in the format that I needed, right? So building my own backend, hopefully I can do better stuff. I just wanted to talk about that real quick to give you the context on like why this is kind of a little hacky, a little janky. But I didn't think it was bad to include in the course because oftentimes when dealing with JSON and APIs, it may not be well documented. So knowing how to do this is a good skill. Okay, again, using this structure, let's build our appetizer object. So in Xcode, in appetizers, do Command N for new Swift file, not SwiftUI view, hit next. And this is going to be called appetizer. So for now, we can keep a foundation. I'll do struct appetizer. And the first, let's see, these are going to be lets, not vars, because we're not changing these, right? We're just reading the data. We're not like, changing the name of something and sending it back up to the server. So these can be lets. So let's just kind of start logically here. I'm going to go back to Chrome. This order doesn't necessarily have to be the order you do it in. Again, I like to be logical. So I look at this, I think ID should probably go at the top. I'm thinking like ID, name, description, price, image URL, and then like, nutritional data. You can put them in whatever order you want, but I like to put them in that kind of logical order. So let's do let ID, and that is going to be an int. Let name, that is going to be a string. what did I say? What was the next one? Yeah, description, price, image URL. Let description, that's going to be a string. Price is going to be a double. Whoops, I gotta say let price. And then let image URL is going to be a string. One thing to keep in mind here, this is a very, very common mistake. You see how I made URL all caps here? A lot of people will do URL. And when using Codable, which we're going to use, more on that in a second, it needs to match like exactly with what we have coming from the API, right? So if this image URL, if this URL wasn't all caps, but you made it all caps, things are gonna break. So be very careful to name your properties exactly what's in the JSON if you're going to use Codable, which is what we are going to use to parse the JSON. Now there is a thing called like coding keys that you can customize all that. Beyond the scope of this course, we're not going to go down that rabbit hole. Just name your properties the same as you see here. So you might even want to copy and paste. That could be a safe way to do it. We've already gone too far. We haven't done that yet. So image URL, the URL is all caps. Trust me, that gets a lot of people. Okay, so now we just need the nutritional information. So let calories, and that is going to be a int. You know what? I'm just going to be safe. Let's do this. Let's practice what we preach here. Calories, because again, if you misspell it, it's going to be off. Okay, so let calories equals int. That's good. Protein, copy, paste, int. Let, what is this? Carbs, and paste, and int. Okay, so now we have, let's not make sure we didn't forget one, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. Just to double check, make sure we have everything. We have the basis of our model object for the appetizer ready to go. Now I talked about Codable, how that's how we're going to parse our JSON. That was new in like Swift 4, so it's been out for a couple years now. I'm not going to give a Codable lesson. If you don't know that, I'll link to some helpful resources. Hopefully you've been doing that by now. But I will keep it at a high level and describe what's going on. It just won't be super in depth. So you may be used to conforming to Codable like this, right? Just Codable. Well, if we click into Codable, little lesson here, all Codable is a type alias for conforming to both decodable and encodable. First of all, we just need to use decodable, right? There's no need for us to encode data. So real quick, what this does is decodable. When we get JSON from the server, it will decode that into our appetizer object, right? So when we just retrieve data and receiving, we just need to decode it. We don't need to encode it. When you would need to encode your data is like, say we were downloading the appetizers, we were manipulating them. Like I said, maybe we were changing the name, changing the price, and then sending them back up to the server. So before you send it back up to the server, that's when you need encodable, right? We're not doing any of that, so there's no reason to conform to encodable. It's just unnecessary. So we're only going to conform to decodable because again, we're just decoding the data from the server. And like I said, in order for decodable to work, your structure has to be exactly what's expected from the server. And if we go back to our JSON here, remember the structure, right? And just at a high level, we have request and then an array, right? The JSON is just a dictionary, key value pairs. So it's like one layer of nesting going on here. So we can't just decode our response from the server into an appetizer. We have to decode it into that request that has an array of appetizers. So below this, let's create a response object to handle that. That way codable or decodable works smoothly. So I'm going to create another struct right below here. It's kind of like a helper struct, if you will. We'll call it appetizer response. And oftentimes you have to do this if your JSON's like really, really nested here. But just like what we do, we have let request, and then that is an array of appetizer, right? That is all what we built here is this, right? So this object right here is our appetizer response. It has a property of a request, and that request is an array of appetizers. So we're just mirroring the structure of the JSON. So that's why we have this appetizer response with the variable array of appetizers. Okay, so now that we have that response and that is getting ready to accept our network call and we have our appetizer, the last thing I want to do is create just a little bit of mock data for when we build our list view in the next video. It's nice to have like a mock appetizer to work with since we're not going to have our network call implemented yet. So we can structure our UI using the mock data. So we're going to build that. And we've done this before in an app, but I usually have this. Usually once the app is done being developed, I delete this stuff, it goes away. But usually during development, it's nice to have this mock data type stuff here. So mock data, first thing we're going to have is a static let sample appetizer, and that's going to equal an appetizer. We're going to initialize a new one here. Again, it's initialized based off of, you know, the properties we just had here. So ID, and I'm just going to make stuff up here because this doesn't matter, right? This is just to populate our UI to make sure things are looking good. So the name, we can say test appetizer. Description. This is the description for my appetizer. It's yummy. And again, we'll start lining up our parameters like this. We'll go ahead and do this right now because it's annoying. Okay, so the price, we can say this is $9.99. Image URL, I'm just going to leave blank right now because we're not downloading images yet. That's fine. We're going to use like a placeholder image as well. Calories, cool, 99. Protein, 99. You can put whatever numbers in here you want. Again, this is just to get the structure of our UI looking good. So oftentimes in your sample data, it's nice to test you know, extremes, right? Like if you wanted to test a really long appetizer name, you can test this here. So that's our sample appetizer that we're going to use. And then in the next video, we're going to need an array of appetizers to populate our list, right? Remember, if you have a list, you need an array of something to populate it. So we're going to do static let appetizers equal, and then I'm just going to do sample. Again, this is just dummy data. Just like give me 4 sample appetizers. And the last thing we're going to set up in our mock data is we need a test image. So if you open up your XC assets, right now we just have our colors here, but we're going to add an image to that. And I've attached the image to the video in the description. You'll see an image down there, the Asian flank steak image. So I'm going to grab the Asian flank steak JPEG, drop it into my images, and we're good to go. Remember, we're going to be downloading the images from the server. This is just a test one to structure our UI. So back to our appetizer object. Like I said, we created our object based on the JSON that we are getting back from the server. We created our response object to handle the structure of the JSON, and this is necessary when we're using Codable. If you're manually parsing the JSON, you don't have to do this. You can dig through the JSON manually, but we are using Codable, so we're going to do that. And then we set up our mock data with the sample appetizer and just a basic little array just to, you know, help us build the list in the next video. We left off last video getting our appetizer object ready. In this video, we're going to build this list view that you see here. So back into our code, we already have our appetizer list view created. Remember, kind of our dummy mockup for the tab bar, but all we have in here is a text that says that. Well, we're going to replace this with a list. So let's get rid of all this. We'll retype that navigation title later. List, and then open it up. So you got a lot of possible, you know, initializers here. We just want the simple one, blank, which is our array, ID, and row content. So here you can see the data we have is a random access collection, which is an array. So the array we're going to use is our mock data dot appetizers, right? That's that array we created. In the key path here, we wanted to do dot ID. And if you remember, we can conform to identifiable to not have to do that. We'll come back to that in a second, but right now we want to just use the ID. I wanted to spell that out for you. And then the content here, I can delete that because we can just put the view builder here. Then we need to do appetizer in, right? So this in our list here, we're going to have, it's going to iterate through the mock data.appetizers, and we're going to get an appetizer for each one. And then in here, we're going to create our cell for each appetizer. But for now, just to get Xcode to stop yelling at us, I think I'm missing a closing curly brace here. Yep. For now, to get Xcode to stop yelling at us, let's just do text, and then we'll use appetizer.name, right? We'll just print out that, just the name of the appetizer in our list view, just to get this structure, you know, running. So let's open up our canvas so we can see that here. Get this going. I forgot to start that. Hit resume. We are on the iPhone 12 Pro. It is 75%. Cool, there we are. Test appetizer. Remember, if we go back to our appetizer, that's what we named our sample. So that is working. Back to our appetizer list view. Let's add that navigation title to our list, remember, not the navigation view. The navigation titles goes on the element inside the navigation view. So dot navigation title, and then, you know, command control space to pull up the emojis. We wanted French fries. You can put whatever you want in there. Appetizers, there we go. Let's get our navigation title back. Okay, so again, that is just basically how you create a simple list, right? List, initialize it with an array of an object. We're gonna go ahead and conform to identifiable right now. so we don't need to have this ID, but I'm gonna run through the rest of this real quick. So as it's iterating through our array of appetizers, we get, just like in a for loop, we get an appetizer variable that we can use here. So for every appetizer, we're gonna create a text cell that just has the appetizer.name. That's what's going on here. So that's the very, very bare bones minimum of a list. But again, first, back in appetizer, let's also make this conform to identifiable. And then now in our list view, we can get rid of this ID just to clean stuff up a little bit. Now, one thing, our sample data, I mean, it's going to work to show stuff, but if we were doing this more advanced, it wouldn't work. And I want to point out why. That it uses that ID as a unique identifier, a way to identify each object. Well, if you look at our appetizers, right, we have our sample appetizer with an ID of 001 or whatever. Well, we have 4 of the same sample appetizers in there, right? So they're all gonna have the same ID. It's gonna be fine for the basics of what we're using, but I wanna point this out that, if we were moving items within the table or deleting stuff and inserting stuff, that would be an issue. It's not gonna be an issue for us, but I wanted to point that out. Okay, so appetizer list view, here we go. Let's start creating our cell because just this text, not exactly what we're looking for. We wanna build this cell that you see on the screen, and it's going to be a challenge for you. You can pause right now, pause the video. If you want to try to build out this cell here, basically just replace this text with, spoiler alert, it's going to be an HStack. If you want to build your HStack here, give it a shot, go for it. But now's your last chance to pause if you want to try to build that yourself, because here we go. Okay, so looking at the structure of the cell, like I said, it's an HStack. On the left side of the HStack, we have our image. But then on the right side of the HStack, we have a VStack that holds our title and price, right? Pretty simple structure. We've done something similar before, but let's walk through this, right? So overall, let's get rid of our text. Let's make it an HStack with our view builder here. The first part of our HStack is going to be our image. Like I said, we're going to initialize this image with a name, right? Because remember, in our XC assets, we brought over the Asian flank steak. So again, to prevent typos, Command-C, appetizer list view, it's just paste that name in here, the Asian flank steak, bam. Not exactly what we're looking for, and that's because the images come in kind of raw, right? So if you remember, on all the images, we want to do resizable. Again, I'm not going to say you always want to do that, but 99.9% of the time, you're probably going to want to have resizable on your images. So that resized it to fit the screen. However, the aspect ratio is off, right? It's not what our image looks like. So we need to add the aspect ratio, right? So aspect ratio content mode, we want to fit to the entire area, but we don't know the area yet. So that's going to look like no difference. We need to give it a frame, right? So give it a frame with the width and height. You see that default to do 100 by 100, but you'll notice our image is more of a landscape. It's actually 600 by 450, so it's not a perfect square, but our frame is a perfect square. So you can see because we did fit, it's not filling the entire square. Let me go back to fill, and you'll see now it will fill the entire square, but that's not the look we want. We want to do fit, and we want to match the aspect ratio of our images. This is where, knowing your design and building to a design spec comes into play. So we know our images are 600 by 450. So we want to keep that aspect ratio just at a smaller size. So we're gonna do 120 by 90. Okay, that gives us the size we're looking for, based on our design. And we don't need this alignment parameter. Okay, so the last thing we need to do for our image is our corner radius of 8. Remember, it's got that subtle corner radius, not overbearing, but it just, doesn't have so many sharp edges. I like that look. So that's our image in our HStack. Remember what's on the right side of our HStack is the VStack, which contains the 2 texts holding our price and stuff. So let's do VStack. Scroll up a bit. And there's going to be a text, as you saw here. And the text we want to put in here is going to be the appetizer name. So appetizer.name. And remember, this is the appetizer that we're iterating through our array and creating each cell, right? So again, we have all the same sample data in there, so it's all going to say test appetizer. But like I said, this is just to get the structure of the UI. And then we want this to be a font.title2 is what we're going to go for. And then we want this to be .font weight of medium. And again, this is just me matching a design spec, right? If you want to change the look and feel of this, make it super big and bold or tiny and small, have at it, play around with this. This is just the design that I came up with. So that is the name. However, below it, smaller, less emphasized, we want to have the price. So here we can do text. And here we can't just do appetizer.price because that's a double, right? Text needs a string. So we need to use some string interpolation here. Appetizer.price, but we're going to want a $sign in front of it. Now you'll notice we don't want all those decimal places, right? 999.000, like we don't want that. So within my string interpolation, if I do comma specifier, I can add a string, and this is a little weird, I get it, %.2f. That's 2 decimal places. If I wanted no decimal places, I would just get rid of that 2, and you can see it's gonna round up to $10 instead of $9.99. 1f, 1 decimal place, there you go, you can see on the right, we got 1 decimal place. We want 2 decimal places because this is a price. And then now, as you see in the design, this is it's like a lighter gray. It's not the black text color. So we want to do foreground color dot secondary, right? So this is kind of like that secondary color you can see here that'll gray it out. And then we want to do dot font weight dot semi bold, right? We do want the price to be, kind of bold. Now you'll notice here in our text, it's centering the items here, right? See, test appetizer and $9.99 are centered. Well, we want them to align on the left. So in order to do that, we can update our VStack here to have the alignment parameter. I don't think we've used this yet. We've used spacing, but we haven't used alignment, right? So there you go. You can do alignment, spacing, then content. We're just going to do the alignment, and we're going to do dot leading, right? So now if you look here, now they all got pushed to the left to be leading. And I feel like the test appetizer and the numbers are too cramped. So we are going to use the spacing parameter as well. And we're going to give that a 5 to start here. Right, you see that just spaced it out a little bit? I'll do that again. Watch the test appetizer and the price. You see, super cramped. And if we go back to 5, just a little bit of extra spacing. So you can tweak your design a bit. And then another thing I want to tweak about my VStack here, again, we're working with this VStack, just the stack of the name and the price. I feel like it's too cramped up close to the pictures. So I want to add a little extra padding just to space that out a bit. So here at the bottom of my VStack, I can do padding. I can do padding all around. That's fine. You're not going to notice the difference here. If I wanted to be very specific though, remember I can do padding dot leading, and there you go. That only gives the padding on the leading edge. Now you can't see it because nothing is on the right, but now there'll be no padding on the top, no padding off to the right, just padding on the leading edge. Okay, so we have the basic structure of our cell here. Let's run it in the simulator just to see what we're getting, make sure nothing is weird is going on because we're going to refactor this next, but I want to, again, run it to test it. Because I always like to make sure my stuff is working before I refactor, right? If you refactor something that's not working yet, that's tricky. But anyway, here we are in the simulator, scrolling up and down. Things seem to be fine. I can't tap it. We haven't added that yet. But again, our cell's looking good. All right, so let's refactor it and wrap up this video. So this is common what you want to do for your cells here. And our cell, if you remember, is basically this HStack. That's the cell that we just built. So we want to take this HStack and move it into its own file called, appetizer list cell. Now I just said move it into its own file. That's fine. Remember, organization is subjective. I wouldn't argue with you if you wanted to keep it in this file, but just move it like down here to the bottom. Wouldn't argue with that at all. I don't know. I like having a folder of cells because oftentimes cells get reused. So just a habit of mine. I like to create a folder called cells and put it there. We're going to do project reorganization in a few more videos. So don't worry about creating that folder just yet, but let's create that file. So in appetizers, Command N, it's going to be a SwiftUI view, hit next. And SwiftUI view is going to be appetizer list cell, hit create. And then we can literally just go to our appetizer list view, copy the HStack, and then go to our appetizer list cell, get rid of the hello world text, paste it in there, but you're going to notice something, right? We don't have access to appetizer. So we have to have appetizer be a variable on our list cell so we can pass the appetizer into the cell and then it will create itself. So we'll do let appetizer, that is of type appetizer. Hit return here, do Command B. And now the only thing missing is our preview. Remember I said you got to initialize your previews with all the information you need. The information our cell needs is an appetizer, right? So fix that, appetizer. And then this is why we created our mock data. So mock data dot sample appetizer, right? If we didn't have that mock data, we would have to do this, right? We'd have to do appetizer and then initialize that. And then look at this long initializer. It gets ridiculous. This is why we create mock data.sample appetizer. Nice and clean. We got it right there. Now, if I hit resume on my preview, we should be able to preview this cell, and there it is. Now, what looks different than what we saw on our cell, like look at all this padding here, is because right now it's just an HStack by itself, right? In this preview, it's not in the context of a list, right? A list has very specific formatting that if we go back to our list view, like it handles all the formatting of a list. So that's why the previews look a little different. But back here in our appetizer list view, we can get rid of this HStack, right? Be gone. And then now we can just replace that with appetizer list cell. And then you'll see that takes in an appetizer. And then we're just going to pass in the appetizer that we have here as we iterate through our array. So, right, that cleans up this screen nicely, right? You just got a navigation view with the list in it. You can see the list has appetizer list cell with an appetizer and then our navigation title. Of course, this is just the very basics of our screen, but you can see how it reads nicely, pretty easy to understand what's going on here. Now, this is just our mock data, right? The real app we want, we're going to hit a server, we're going to get the appetizer JSON, we're going to parse that JSON with Codable, then we're going to populate our list with that downloaded data. So let's start that process. That's going to take us a couple videos to do, but the first step in that process is to set up our network call and make sure we're getting the right data back from the server. So let's do that. We left off last video getting the structure of our appetizer list view cell up and running. Now we need to start building the network call to populate this with actual real data from the server, not our mock data. So the first thing we're going to do is set up our network manager. Real quick disclaimer, there are a bunch of different ways to do network calls. For example, if you use Alamo Fire, that's fine. If you make your network calls much more generic, cool. If you use something like a request builder, awesome. There's so many different ways to do this. I'm keeping this very basic, very fundamental, right down the middle, for learning purposes. So just keep that in mind. If you have a different way of doing network calls, feel free to do that. That's fine. If you're here and you're not familiar with network calls, this is a good opportunity to kind of learn the fundamental way to do it, and then you can explore other options later. Okay, disclaimer out of the way. Let's create a new file in Appetizers, Command N, Swift file. So I'm going to create a network manager, hit create, and it's going to be a singleton. So we'll do a final class called network manager. And the first thing we're going to do is static let shared, right? This creates our singleton network manager. And then I need a private init and just an empty implementation of it. So what this did was create our singleton, right? We'll do network manager.shared to access the singleton. And then we're going to have functions on this that you'll see here. But that's the basic setup of the singleton. Why a singleton, you may ask? Well, if you look at Apple's documentations on that, they actually recommend things like network managers be a singleton. There's a whole other pattern other than doing things like manager. Again, that's fine. Keeping it simple. And sorry if I keep repeating myself with these disclaimers. That's just 4 years of hearing thousands and thousands of comments about my code. Like I can just see the comments before they happen. So I try to give those disclaimers. If you're sick of hearing that, I apologize. So the properties I want to set up on our network manager first are the URLs. So we'll do static let base URL, and I'll explain why I'm doing this here in a second. Equals, and this is going to be our URL string that we use to see our JSON. Again, that is going to be in the description of the video. Feel free to copy and paste that here. So it's a string, Command V, and that's not our base URL. That's really like the whole URL, right? So the base URL would be, the Heroku app.SwiftUI fundamentals. And then, right, each individual endpoint would be /appetizers/ whatever other endpoints we have. This is going to be the only endpoint on the app, but I'm showing you how I structure it for like a kind of like a real app. So for example, I would do static this is kind of like a whole list of URLs that I would have. Static let appetizer URL equals, and then the string would be base URL plus, and then I would take the appetizers and put it here. And then make sure we delete the appetizers here. I usually keep the / there so I don't have to repeat it in the back end of my URL every time. So that's the general setup of our network manager. Now what we need to do is write the individual functions that will be our network calls, right? This app is going to have two. We're going to have one to get the appetizers, retrieve that from the JSON that we just saw, and then we're going to have one to download the images from a URL, to download our appetizer images. So those are the two network calls that are going to eventually be in our network manager. For right now, we're just doing the get appetizers one. Func get appetizers, and then here's our completion handler completed, and it's going to be an @escaping, and that is going to return a result, and then the result is going to have two values. One is going to be our array of appetizers. I'm going to explain this, give an overview of this real quick when I'm done typing, and then the other piece of information the result is going to have is an error. We're going to create our own custom error here in a bit, but for now, to get Xcode to stop yelling, just call it an error, and that's going to return void. All right, and then open and close brackets to get the scope of the function. So that is our function signature. So I'll run through this now. I'll keep it at a high level because again, results can be a whole video. In fact, I've done a whole video on results. I'll link to that in the description if you want to dive in. I've done a whole video on escaping closures. So I'm not going down those rabbit holes, but high level, The function is get appetizers. Once that is completed, we're going to have a result. That result is either going to have an appetizer, or I'm sorry, an array of appetizers, which is what we want. That's the success case, or it's going to return an error. That would be the failure case. And speaking of that error, let's take a second real quick to build our custom error before we start writing this function, because we're going to use that custom error throughout this function. So I'm going to go to appetizers here, Command N for a new file, new Swift file. We'll call this AP for appetizers error. I usually like to preface it with the first two letters, of the app. So AP error, and we're going to make this an enum called AP error. And we're going to have four cases, right? Case invalid URL, case our URL is messed up, case invalid response, case invalid data. So invalid response is, when we get like a 404 or 500 or whatever from the server. Invalid data is if, the data we get back, we can't parse that out. It's something's wrong there. And then case unable to complete. We're going to use this one for just the general error, right? Like if the Wi-Fi is turned off or something like that. You'll see how we'll use these in a second, but I had to create them before we can use them. So back to our network manager. Okay, so now instead of returning just a Swift error, oh, I forgot something. Back to AP error. In order to use the AP error here, it has to conform to Swift's error protocol. So that's what I forgot. AP error can't just conform to nothing. It's got to conform to error. There we go. Forgot. Key piece of information here. So now in Network Manager, I can replace this just generic Swift error with our AP error. And that will work because we conform to the error protocol. Cool. And like I said, you're going to see how we use these errors in the network call. So I'm going to run through building this function. I'll talk through it, but at the end, I'm going to come back and walk through it just like I always do to hopefully make it make sense. So the first thing I want to check on is make sure the URL that I'm trying to use works. So guard let URL equals, and we want it to be, because we don't want to create a URL object, right? Not just the URL string, we have to create the URL object, and we want to create that URL object from a string, right? There you go. And the string we want is our appetizer URL, right? Because we're doing get appetizers. That's the endpoint that we want to hit. Appetizer URL. And then, yep, our guard statement needs an else, right? So what we're doing here basically is when you create a URL from a string, it's an optional in case it doesn't work. So if we actually get, I made this static instead of private. Oops, got my keywords mixed up there. Okay, so now back to what I was saying. URL from a string returns an optional, so we want to make sure, it's not nil. If it's nil, that means we couldn't create a URL object from the string, so we want to return an error, right? So we want to call completed. This is our completion handler here. And in this case, we want to initialize that with a .failure case. And then the error we want to pass in, right? This is how our result works, is we want to pass in invalid URL. This way we know what type of error happened here, and then we'll hit return. So cool, get used to this structure. We're going to be using something similar a lot to check for all the other data. But right now we're just checking to make sure we have a good URL before we try to use that URL to make a network call. That's basically what's going on here. And again, if we have a bad one, return that specific error. So that's the first check, the URL. Now we can actually start creating our data task to download the information. So we can do let task equals URL session.shared.data task. And we want to do with request, but we want to have the completion handler, right? You see, we want to get back data, response, or an error, right? So data task with request that has that completion handler. So the URL request we want to create, let's create a new one. URL request with the initializer. You can see it takes in a URL. Good thing we checked to make sure we had a good URL up here. So we're going to pass that URL in. Now the completion handler, I'm just going to hit return here, and I can name these whatever I want, but I'm going to name it basically exactly what they have. Data, response, and you can see they're all optional. So this is what we're going to have to check to make sure we have these items, right? And I don't like these parentheses here. They're optional. Less clutter. Keep them if you want. Okay, so now what we're going to get back in this completion handler is data, response, and error, and they're all optional. So that's what you're going to see us do. We're going to unwrap all these optionals and handle them accordingly. So first, let's tackle the error case. So guard let underscore, we're not going to be using the error, equals error else, and we're going to pass in the error here, unable to complete. So else we'll do completed with the failure case of .unable to complete, because again, this usually happens when the Wi-Fi is not working. That's just one example. Then we want to return here. So basically we're saying, hey, if error is not equal to nil, go ahead, fire off the failure case and pass in unable to complete as the error. Okay, so that takes care of the error. Same thing with response. So guard let response equal response. Oh, okay, response has a P in it. I thought that looked weird when I typed it, but my mind's elsewhere trying to explain things. So garlight response equals response. And then we're going to cast this as an HTTP response because we want to get a specific code here. So if we have a good response, let's also make sure the response dot status code equals 200. And then now we'll do else. And let me walk you through that here. So basically what we're saying is, hey, is response not nil? Cool. If it is, cast it as URL response, and then take that response that we got and then check the status code on it to make sure it's the 200. If you're not familiar with HTTP status codes, 200 is usually the, hey, things went good. So we're making sure we got a 200 back. This is where you could check against the status code, like, hey, if I got a 404, send back this error. If I got a 500, send back this error, right? You can really tailor your error messages based on the status code. We're not going to go that deep. We're basically just going to get a pass-fail just to keep it simple. So if we don't get a 200 here, or if response is nil for some reason, we're going to call completed and then pass in the failure case of .invalid response. Again, I'm keeping these kind of high-level and generic, but we've taken care of our error. We've taken care of our response. Data is the good stuff, right? Data is our array of appetizers that we get back if we get it, but we got to check to make sure we have it first before we use that data. So again, guard let data equals data, else completed dot failure case with dot invalid data and return. And I forgot the return up here, right? Because if we get a bad response, we don't want to run the rest of the code. If we get bad data, we don't want to run the rest of the code, right? We just want to exit out. That's why we're returning right there. Okay, now that we made sure we have data, now's the good stuff. All this up here was just all the bad stuff, right? Checking for all the errors. If we made it past all those checks, now we have our data, and now we can parse that data and create our appetizer array from the JSON. So we'll do that with a do try catch block. So do, we'll say let decoder equals a JSON decoder. Remember we talked about encoding and decoding. We want to decode the JSON, right? So let's create our decoder here and let's say let decoded response, right? This is where this will give us the our object here equals, and here's where we need to do the try, right? So decoder.decode, and then it's from, well, what type do we want to decode? And this goes back to our model, right? A review from last video here, back to our appetizer, right? If we can't just decode an array of appetizers because remember our JSON is not structured that way. Our JSON, if we look into our response, remember our JSON was structured with a request that had an array of appetizers. So in decodable, this is what we want to decode, our appetizer response. Speaking of, I forgot to do this. We got to make this decodable. And a note on codable and decodable, the reason I can just add that and not have any extra code is because all the underlying types conform to codable. And the underlying type here is an appetizer. But if you look at our appetizer, all these basic, things, right? Int, string, double, int, those are all going to conform to codable. If you have really weird, unique types, you may have to write some extra boilerplate code. But as long as you're using these fundamental ones or foundational ones, I guess, because it's in foundation, you'll be fine to just conform to decodable without writing any extra code. So anyway, we're going to decode our appetizer response, which is going to have an array of appetizers attached to it, right? So by decoding the response, we're also decoding all the appetizers as well. Okay, so back to the network manager, that's what we want to decode. The type we want is our appetizer response. And you have to do .self here. And then what do you want to decode that from, right? It takes in data. Well, this is the data that we made sure we had up here, right? So pass in that data, cool. So basically what we're saying here is from the data that we have, decode that data into an appetizer response. And again, our appetizer response is going to hold our array of appetizers. And speaking of that array of appetizers, as a reminder, look, that's what our result types returns, an array of appetizers. So now we want to handle the success case, right? This whole time we've been doing completed failure, talking about failures, right? Now we want to do completed .success, and you can see the success case takes in an array of appetizers, what I just pointed out up top. So now we want to pass in decoded response .appetizers and do Command B. I think it's telling me that, yeah, I need to do the catch case here, I think. Let's put this in here and let's just do completed. So basically, if we can't decode correctly, we're going to pass in the .failure case, and that case is going to be invalid data, right? Because our data was messed up. Oh, I'm sorry, that it's not decoded response.appetizers, it's decoded response.request. Because if you look at our model, and we just named it that way, Like we could have named this Appetizers, but I wanted it to match the structure of the JSON. So that's why we did that. If you want to name it differently, fine. But that's why we do decoder response.request because that's what it is. And then again, if that decoding fails, we completed with the failure of invalid data. And then the last piece of the network call puzzle that many forget, and it always trips people up. And this is why I like this error right here. It says, hey, you initialize a task, but you never actually use the task. Aha, that's my reminder to do task.resume down here. And I think I'm in the wrong scope. Too many curly braces. So I didn't get the autocomplete because I'm in the wrong scope. So now we do it down here. There we go. Command B, make sure that's all good. Cool. All right, as a review, I'm going to do a quick high-level run-through of what we just did. So we created our network manager, right? Our share. We're going to be using network manager.share.get appetizers, right? And if you had more network calls, you'd be using that as well. Same thing with our URLs. This is all we're going to have, but that's the structure if you had more URLs. Here we have our function get appetizer. It has a completion handler that's escaping that returns a result. A result has a success case and a failure case. In the success case, we get back an array of appetizers. In a failure case, we get back an AP error, which we can handle later. So we check to make sure we have a good URL. If we don't have a good URL, return failure with an invalid URL. Here we create our network call with the URL request based on that good URL we got. Our network call is going to either give us back data, response, or an error. So we got to check for all that stuff because they're optional. So if I have an error, cool, return the AP error called unable to complete. If my response is either nil, like I don't get a response, or it's the wrong status code, like a 404, return the failure, invalid response, be done. Same thing. If for some reason I don't have data, okay, return the failure, get out. Now, if we made it past all those checks, we have good data. So now we're going to try to decode that data using our JSON decoder. This is where the codable, decodable protocol comes in. We decode that into an appetizer response, which we created in our model. That appetizer response has a property called request, which is our array of appetizers. So if this all goes well, that means our data was good. We've, decoded our array. We have it here. So let's call completed.success. Again, remember, success case gets the appetizer. And so we're going to pass back our array of appetizers in the success. And then if this decoding goes wrong, we pass back invalid data. When your decoding goes wrong, it's, remember I talked about in your appetizer model, how maybe if you had a misspelling here, or if you use image with lowercase URL, like that's when it'll trigger this decoding error down here. So if you're having trouble in other apps or network calls, or even in this one, and this keeps firing off, double check to make sure your model is properly formatted to what you're expecting back from the JSON. And then you call task.resume to actually fire off the network call. So I know that was a lot. If you're familiar with network calls, that was all review, old hat. If you're new to network calls, that may have been a lot. Happy to answer any questions in Slack or in the comments, but our network manager is set up. We're ready to use this. Now we just got to connect it to our list screen, and we're going to handle that in the next video. Last video, we got our network manager in place, as you can see here. So now we just need to connect this all together, right? We got all the pieces in place. Let's connect it. So back to our appetizer list view here. Currently, we're using our mockdata.appetizers. Well, we're going to need an array of appetizers to populate from our network call, right? So let's create a state variable here. And really how this video is going to go, spoiler alert, I'm going to get everything working in the view, and then we're going to refactor into MVVM, okay? Little heads up. I like doing it this way because, again, I want to get it working in the view and then refactor rather than refactoring and wondering, like, one, is my network call messed up or is my refactor messed up? That's the trouble when you refactor too early. You never know, like, which is the error, and it makes, debugging it hard. But if you get it working in the view first and then you refactor, like your refactor broke it, not that, right? So that's why I do it this way. So anyway, state private var, call it appetizers. That is an array of appetizer. And for now, we'll just initialize an empty one. So how this is going to happen is we have an empty array to start. We're going to make our network call. Our network call is going to populate that array. And when we populate this array, because it's a state variable, that means our view is kind of watching it and our array will have changed. So that change is going to trigger a redraw of the view. But now when it redraws the view, we actually have appetizers in our array and that will populate. So that's the flow. We'll go over that once we get it all working as well. So one thing we haven't done yet, I don't think, is we haven't added functions to our view. That is possible. I know when I was first learning SwiftUI, like it's once you see it, it's like, oh yeah, of course you could have functions. It's just a struct. But I remember the first time I saw it, I was like, oh, duh, that makes sense. You can have functions. So anyway, let's do func. We'll say get appetizers. And here's where we're going to use our network call. So we'll do network manager.shared.get appetizers. You can see the completion handler we get. I'm going to hit return. I'm just going to call this result. You can get rid of the parentheses again. So here, remember, our result is a success case or a failure case. Success, we have our array of appetizers. Failure, we have an error. We're going to handle errors in a future video, but we'll come back to that. So we do a switch off of our result, right? Because that's the cases. And the first case is dot success. And you see we get an array of appetizers here. So we'll say let appetizers, right? We just basically give a variable name to what we get back here. Yep, switch case must be exhaustive. Cool. Let's go ahead and fix that so I don't have to type. Cool, failure case. And we're going to say let error. We're not going to use that error like right now. I forgot the colon after that. We'll just do print error dot localized description. We're just going to do that now. We're going to actually handle that later, but we're worried about the success case, right? We want to know what to do when we get our appetizers. So when we get appetizers passed back, we want to set that equal to our array up here. Remember I said our network call is going to populate this array. So cool. In our success case, we have an array of appetizers. So let's set self.appetizers equals appetizers. And we want to make sure it's the local variable here. That's what this L means, by the way. If you're not familiar with these little icons, L means local. So there you go. And you can see it's also green to let me know it's this one, and then white to let me know it's this one. And that's because they're named the same thing. And that's also why I had to use self here. Well, I could capture self up here new in Swift 5.3, so I didn't have to use it, but I would have had to use it anyway to differentiate between the appetizers on my view and then the local appetizers. So one other thing that will get you is, think about it. We're on a background thread right now with our networking. All your UI updates should be on the main thread. Well, what happens here, and this kind of threw me for a loop when I was first learning, is usually in UIKit, you could set the data on a background thread, that's fine. But SwiftUI is different because setting the data is triggering a UI update. So this needs to happen on the main thread. So you want to get on the main thread. So dispatch queue.main.async, and then the code here. And then we're just going to cut and paste our code into there. So we're on the main thread now. Okay, so we have our function, right? We're going to use get appetizers to make our network call. If it's a success, set the appetizers. If it's a failure, handle the errors. We're going to do that in another video. But when do we call this, right? Because remember, in the view builders, like I can't just call a function, right? Remember we talked about how view builders were limited. Well, there's a modifier called onAppear, which again is similar to, view will appear. And there's also on disappear, which is like view will disappear. So here in our navigation view, we want to do onAppear. And we just want the closure here, right? We just want to call get appetizers, right? So when our navigation view appears, we're going to make this network call, get appetizers. The network call is going to fire off. It's going to set our state variable equal to the appetizers we get back, which is going to trigger a view redraw, which now we don't want to use mock data.appetizers. I'm glad I did that run through because I forgot this. We can just delete this and do appetizers, right? We want this variable. So moment of truth, we've done all this setup over the past 2 videos. Let's see if it's working. So I'm going to run it on the simulator. This is legitimately the first time I'm running it, so fingers crossed. Okay, so let's debug this. I messed up somewhere. We'll do this. It's kind of live. I thought this would work. I messed something up somewhere, right? So it printed off the error.localized description, right? That's what you see here. Operation can be completed, AP error 3. So if I go to my AP error, I can print off a better thing. Looks like unable to complete because I think these are, I don't know if they're 0 indexed. Here, tell you what, again, live debugging. This will be educational, right? So in our network manager, I'm just going to add some breakpoints real quick just to see which one it hits. I believe it hit the unable to complete, but let's see here. Run it again. Let's see what breakpoint we hit. Okay, so we're in here, unable to complete. So we're getting the big error. So that tells me maybe something is messed up with my URL up here. Okay, so let's test something. I went back and I copied the whole URL here. Maybe I messed something up here, pasted it there. So we're going to use here, instead of appetizer URL, we're going to use base URL, and it's a static variable. So I got to do network manager dot base URL, but that is going to be this whole URL that I literally just copied and pasted that was working in our JSON preview, like on Safari. So this will tell me if it is in fact my URL or not. Again, we just process of elimination on debugging here. Again, I'm debugging on the fly. This is not part of the script. Man, still in completed, unable to complete. So something else is messed up here. Okay, I see it now. I see it now. So I'm going to actually Command Z to undo what I did to get this back to appetizer URL and get my base URL back to just SwiftUI fundamentals / and then appetizers. And it's this right here, simple mismanagement of unwrapping the optional. And let me walk you through this so you can see in case you run into something similar. This was just a brain fart, slip up thing, right? So when I unwrap this error, listen to, maybe you picked this up when I was typing it. If you did, kudos on you. But think about what I'm saying here, right? I'm saying if I have a value for error, great, continue on. If error is nil, then I go into my statement. Well, error being nil is a good thing, right? You know, response being nil is a bad thing. Data being nil is a bad thing. But error being nil is what you want. So instead of guard let, I do if let, get rid of the else. So now if you read if let and how that reads, you're saying, okay, if error has a value, then go into the scope, right? So if error has a value, now I want to do this completion handler. If error is nil, then we're going to skip this whole scope entirely and move on. And that's the behavior we want. So let's undo these breakpoints. I might be a little overconfident. I'm like 99.9% sure that's what it is, but you know, famous last words. So let's run this again. Things should be working fine. Again, a little bit of a live debugging there. Okay, great. It's working. Now our pictures are the same because remember, we're not downloading images yet, but you see we have Asian flank steak, blackened shrimp, buffalo chicken bites. You know, we have the correct count. We have all the names and the prices. You know, we're going to download images in a future video. So anyway, apologies for that little detour down the live debugging. That wasn't, you know, on the script, but you can see how simple little errors, you know, can trip you up. And here's my excuse, right? Call it an excuse if you want, but you know, when you're filming yourself, you're, you know, recording, you're kind of only half engaged with the actual code part because you're worried about explaining it correctly and talking and looking in the camera and all this stuff. So for me, whenever I'm recording my videos, little slip-ups like that happen a lot because again, there's a lot of other stuff going on. That's my excuse and I'm sticking to it. But hopefully that was helpful. You got to see me debug a little bit and you saw this is what it is most of the time, a silly little error. But anyway, let's get the simulator back up. We're working. We have this connected. We're good to go. I'm going to stop this and go back to our appetizer list view. Hit resume there. So we have our network call running, working. However, it is in our view, right? You don't want your network calls in your view, right? This is what you want in your view model, right? You want your view to be as dumb as possible. So here's the challenge for you. We're going to do this here in a second, but the challenge is, you know, we've done view models a couple times now in previous apps. So see if you can refactor the network call into the view model, right? Create the view model, set it up, move the network call to the view model and make sure things are all connected and get it working again. That's your challenge. You have 3 seconds to pause and try it. 3, 2, 1. All right, now we're going to do it. Okay, so to create the view model in the appetizers folder, Command N for a new file, new Swift file, hit next. We're going to call this the appetizer list view model. Hit create. Cool. We want to import SwiftUI because we're going to be using observable object. And then this is a final class appetizer list view model. There you go. And again, we want to conform to observable object, not observed object, observable object. Now let's create this in our appetizer list view. We'll do @state object. Remember, if you're initializing your view model, you want to use state object. If you're passing the view model in from another previous view because you needed data from that view, use observed object. I'm just, again, reviewing, pounding that into your head. Now we do view model, and that is going to equal a appetizer list view model. And initialize that. There we go. So that's our view model. I'm going to cut this state variable. So Command X, go to our appetizer list view model, Command V to paste that in. Now it's not state, it's published. Remember, your view model and observable objects needs to broadcast when it changes. And what we're setting up on our appetizer list view is we're setting up to listen to those broadcasts that it's changing. So in order to broadcast the change, use the property wrapper published. Okay, so now our appetizers are in the view model. Now we're getting all kinds of errors because we don't have the appetizers here. So well, first of all, let's kind of fix some spacing. We look ridiculous. And then now instead of just appetizers, we are doing view model.appetizers. Good to go here. And then here in our network call, get this whole thing out of here. So Command X, get this function out. Again, our view is as dumb as possible. Appetizer list view model, paste the function here. So now we have viewModel.getAppetizers. Can add some spacing, let it breathe a bit. The code doesn't change, right? Because our network manager is still getting appetizers, and then we're still setting these appetizers. And again, because this is an observable object and this is published, whenever this array of appetizers changes, it's going to broadcast its change and back to our list view. Because we have a state object called viewModel, now we're listening for those changes. So the same process is still going on, just like a little in a slightly different way. And the last piece of the puzzle here is get appetizers. Like we no longer have that function here. Who has the function, right? The viewModel. So now we do viewModel.getAppetizers. Do a Command B. Make sure we're good to go. Hit resume on the preview, even though there's nothing to show because we're relying on the network call to show our appetizers. So now let's run this, and then I'll walk through it one more time again to just like really drive the point home. Okay, cool. Asian flank steak, Philly cheesesteak. You'll notice it took a while to like load. We're going to do like loading views and spinners in a later video, step by step here. But you see our network call is working properly. Let's walk through that refactor one more time. Again, repetition is the name of the game. Apologies if you don't like my repeating itself. I feel like this really helps. So when our appetizer list view appears, it calls onAppear viewModel get appetizers. Cool. Let's go to our viewModel. Get appetizers gets called. It makes the network call. When it gets that back, it switches to the main thread because we're updating appetizers, which causes a UI update, which needs to be on the main thread. So in a success case, set the appetizers that we get back equal to our published variable. This is an array of appetizers. So when this changes, it broadcasts its changes. So somebody's got to be listening. Good thing we set up somebody listening in our appetizer list view, right? That's what the state object viewModel is. We're listening to that now. So we got those changes. Our appetizer list view is like, cool, that changed. Let me redraw. It redraws the view, and now it uses the viewModel appetizers array that is no longer empty. It has our actual objects in it, populates all the cells. We're good to go. So hopefully that whole flow is starting to click with you. Hopefully this is becoming review and repetition. If not, it's okay. This stuff took me a long time to learn. It's all good. That's why we're doing this. That's why we're repeating this. That's why we're getting practice. But our network call is up and running. And in the next video, we're going to handle those errors properly like I talked about. So let's do it. We left off last video refactoring our network call into our viewModel, as you can see here. Well, one thing we're missing is the error handling. That's what we're going to tackle in this video. You can see in the failure case, we're just printing error.localizeDescription. Well, in this case, we want to show an alert depending on what error gets passed to our failure case. Just to recap, back in our network manager, remember, we're passing the failure case, right? Depending on what happens, we're passing unable to complete, invalid response, invalid data, etc. That's our AP error enum. You'll notice there's no like raw value like we did before. Remember, that was only temporary. All we need to know is like, hey, what was the case? And then here in the viewModel, we'll figure out like what we want the error to say. We'll create that alert item and that alert context. If you remember that from our barcode app, we're basically going to do that same setup, except in this app, it'll be built out a bit more because there's more screens, there's more opportunities to show errors. So you'll get to see us build upon that concept, but the basis is the same. So that being said, let's create our alert file. So click the appetizers folder, Command N for new file, Swift file, hit next. And if you remember, we called this alert, and this is where we put our alert item and our alert context. It's so similar. In fact, we're going to do file open recent. We're going to pull up our barcode scanner and copy and paste from our alert view here. So pull up your barcode app, copy paste this, just save some time. Some may say that you should maybe avoid doing this. Like I could see the argument for that because copy paste errors, I've said it a few times in this course, they definitely are a thing. But what you're going to find as you build more and more projects throughout your career is you're going to have a lot of the same code that kind of gets shared, maybe tweaked a little bit, but for the most part, it gets shared between projects. This alert item is something that I've been using in all my SwiftUI projects. So let's close out the barcode and just copy and paste it here into our alert. And I wanted to show that because, I just want to be transparent. Like that's how I legitimately work, right? Like if I have to build even like my network manager, again, just being straight up, like I don't type this out every time. I have the same structure of a network manager in like all the apps that I make. So when I'm making a new app, I'll literally copy and paste like the first chunk of my network manager, paste it in, and then make my adjustments. And again, I'm telling you that even though some may consider that a bad habit for the copy paste stuff, but again, just want to be transparent. That's actually how I work. Anyway, let's make the tweaks. Because like I said, you can almost never copy and paste and not change anything. There's always some tweaks to be made. One thing that I didn't do correctly in the barcode is I made the title and the message a string. And if you remember in the barcode app, I had to like go back and like, oh, I forgot I got to wrap these in a text to show the alert. Well, let's just, take out that step altogether and make these texts instead of a string, right? So we'll make them text in our alert item. You'll see how this, benefits us and cleans up the call site when we implement this. That's the first tweak we need to make. The next tweak is, these aren't our 2 errors, right? These are the errors specific to the camera from the barcode app. So this is what we got to change. But to me, the value of copying and pasting it is like, I get the same structure, right? I just got to change the names and then, what the strings actually say. So let's start changing this. If I go to my AP error, I see I have invalid URL, invalid response, invalid data, unable to complete. Okay, so we're going to create those here. So I'll do, let me just make 2 more here to get all 4 of my structure here. Okay, so this first one, again, was invalid data. This was invalid response. This was invalid URL. And this was unable to complete. Okay, and if you know me, I like to get these equal signs lined up and not have anything look ridiculous. There we go, looks nice and neat. And while we're here, so this is what a lot of people don't like about like lining up the equal signs like I do, is sometimes it messes up your lining here, and then you got to take that extra 3 or 4 seconds to line that up again. I don't know. To me, having things be nice and neat and easy on the eyes to read is worth those extra couple seconds to line it up. If you don't agree, cool, don't line your stuff up. No big deal. I'm just giving you the reasons why I do it. Okay, so I'm going to call these server errors. So one thing to think about when you're creating these error messages, right, is oftentimes developers, will make these error messages for themselves. Like if I said, could not parse the data, that means nothing to the user. It means a lot to the developer, but it doesn't mean anything to the user. So that's why you'll see a lot of these messages not really developer focused, right? You want to focus them towards the user. So, you may not want to give all the details. Whoops, I was supposed to say server error. So here, I would say, the data received from the server was invalid. Please contact support. And I forgot about our new change here, right? We made these text. So again, instead of string, wrap these in a text. And right, by doing it here, I don't have to do it at the call site. So text. I probably should have done this before I copied and pasted, so I don't have to write this out a bunch of times. Okay, so all I did was each title and message, I just wrapped it in a text, sorry, to make it a text view, not just a string. So that's all I did during that fast forward typing part. But okay, back to our error messages. Again, invalid response. I'm just going to call this server error again. They're all going to be called server error pretty much. And we're going to say invalid response from the server. Please try again later or contact support. And then invalid URL, right? Like we don't want to tell the user like it's an invalid URL. They might not know what that means. So you'll say something like, there was an issue connecting to the server. If this persists, please contact support. And look, I'm not gonna lie, I don't claim to be the guru of error messages, right? My error messages could use some work. We're keeping these generic, but you should put some time into coming up with good error messages that really inform your user. Again, I forgot this is server error, and then server error. That's the title of them all. And then for the unable to complete, we'll do something like this. Unable to complete your request at this time. Please check your internet connection. And I'm going to say that because most of the time when we get that overall error, again, back to our network manager, this is what fires it off. The vast majority of the time, that is because there's no network. There's obviously other ways to trigger it, but most of the time, the internet's down or something like that. Okay, back to our alert. So what we have set up here is our same old alert item from our barcode app, and then we created our 4 alert contacts. So this is the same exact thing we did in the barcode app, just adding 2 extra errors. Okay, so now that we have our alert set up, right? We have the item and then our specific alert context for the specific cases. Now let's go put these to use. And we're going to go to our appetizer list view model, right? Where, we're getting the network call, and then we got to handle the failure case. So as you see, we're passing an error from the failure case, like I said, from the network manager, right? We're passing .unable to complete, .invalid response, etc. So in our view model, we can switch off of that error and show the right alert accordingly. But before we do that, I got to actually create the alert item on my view model. So again, this is exactly what we did in the barcode app at published var alert item, and that is of type alert item that we just created. And it's going to be an optional. And again, it's published because anytime our alert item changes, we want to broadcast that, notify our list view that, hey, it's time to show that alert. We're going to connect that here in a second. But we have to make this alert item like a different alert based on what we get back from our error, right? So, okay, let's switch off this error that we get back here. So we'll do switch error. And the first case will be .invalid, we'll say data or response, whatever. The order doesn't matter. Here's how I do my switch statements. I type the first case, and then I let Xcode say the switch must be exhaustive. And I'm like, yes, Xcode, I know. Thank you for typing that for me. I'm lazy. So in the case of invalid response, we want to make the alert item equal to alert context dot invalid response, right? So what we're doing here is we're tying the alert item to the alert context we created for invalid response, which back to the alert here, you can see for invalid response, we're going to show server error, invalid response from the server, please try again or contact support, right? So we're going to show this alert. And you see reference to alert item needs self, so I can do the quick fix here, or what got introduced in Swift 5.3 is the ability to capture self up here. That way you don't have to use self everywhere in your closure here, right? Because each one of those would have had to have self next to it. But again, new in Swift 5.3, captured up here, and you don't need to use it. Again, we still needed to use it here, not to make sure we're referencing self, but to differentiate between this appetizers, right, that's attached to the view model, or the local appetizers. And again, that's because they were the same name. If they were named differently, I wouldn't need the self here. Okay, just a little clear that up in case you're confused. So now we're just going to do some copying and pasting again, because we're just going to set the alert item to different alert contexts based on what happens, right? So invalid URL, again, alert context, invalid URL, same thing, invalid data, now invalid data, and unable to complete is unable to complete. And I'm going to let this breathe a little bit, have the two, put a space in between these two cases, and then each individual case have a space. This is just formatting. Again, I think this is easier on the eyes, easier to read rather than it being all clumped up. And if I only have two cases, I'll probably keep them clumped up. The more cases you have, the harder it is to read when they're clumped up. So this is completely subjective styling. I just wanted to put that out there. But what we have set up when we get our failure, depending on what that failure is, we're setting our alert item to the alert context that we created. So what triggers here is this alert item variable here will change. That change is going to cause this publish to say, hey, whoever's listening, my alert item changed, do what you need to do. So we've set up the broadcast side of things. We haven't set up the listener, if you will. So into our appetizer list view, on our navigation view, we're going to do the .alert. And again, this should look familiar, right? You can do the isPresented. We talked about this last time. That's just based on a true or false variable that you pass in. But we want to have this alert be triggered when an item changes. That's what this item content is, right? And the binding needs to be identifiable, but that is our $viewModel.alert item. Right? And remember, our alert item here does conform to identifiable. We talked about that in the barcode video. It's back to our appetizer list. Now the content we need is our alert. So we can do alert in, and now we do capital A for alert and initialize a new SwiftUI alert. And just like before, we're going to do title message dismiss button. So the title is now alert, and we're actually going to change this name to alert item just to be, real clear on like what we're talking about here. So alert item dot title. And now this is where last time I had to like wrap this in text, I messed that up. Well, now because we put that text in our alert item, we can just keep it neat at the call site and just do alert item dot title. Same thing, alert item dot message, and then alert item dot dismiss button. Now, quick disclaimer on how I'm doing these alerts. This is for the basic alert that just pops up and you hit OK to dismiss, right? If you had an alert that had like maybe 2 options or 2 or 3 buttons that did something on the buttons, you can't do that. We have to create a whole new thing, which we'll get to, later in this section. But, majority of your alerts are going to just be the okay to dismiss type stuff. So it's nice to have that, structure. Okay, so we should be all connected here. Let's run it on the simulator. I'm going to run it first. Nothing should happen. This should look like it's been looking. And yep, here we are. This is what we had before. Nothing has changed. All we did was mess with the alerts, but I wanted to show that real quick. Now let's start messing with things to break it, like on purpose. So going into our network manager, let's put a nice little emoji in our our URL, right? Because what's going to happen here is URL is going to try to initialize a URL object from the appetizer URL string. Remember, I said this returns an optional, because if it can't create a URL object, it's going to return nil. So what's going to happen with our emoji here, it's going to be an invalid URL. URL is going to return nil. So we should go into the invalid URL alert. Let's see here. Let's test this. There it is. Okay. Yep. Server error. There was an issue connecting to the server. If this persists, please contact support. Cool. All right. Let's just try one more. Let's get rid of that. Let's turn off our Wi-Fi here. If anybody gets the reference to this Wi-Fi, leave it in the comment. Kudos to you if you get that. Okay, so let's run it again with the Wi-Fi turned off. Yep, server error, unable to complete your request at this time. Please check your internet connection. Okay, so our errors seem to be working. Let me turn my Wi-Fi back on. Okay, so our errors are working. One last overview to finish out the video. Again, our network call passes in various errors depending on what happens. Here in our alert, we created our alert item. We have our alert context for all the various different errors that we could have. In our view model, on our list view, right? Depending on the failure case, what gets passed back, we make our alert item equal to whatever alert item is applicable to that specific error. That sets this alert item, and because this is published on our observable object of the view model, it broadcasts it out. Our appetizer list view is listening to that because we have our view model as a state object. So here in our alert, this view model.alert item has changed. This alert is listening to that change. So when it receives that change, it presents the alert with the title, message, and dismiss button based on the alert item that we passed. That's the overview of what's going on to show those alerts. So the basics of our errors are in place. We're going to be building upon this, in future videos and in our other screens, but this is the basics. That was a bit of a review. Like, we did a lot of the similar stuff in the barcode, but again, practice, 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 repetition, repetition, repetition. Let's move on. In the last video, we got the foundation of our alerts in place. In this video, we're going to implement a loading spinner screen, for when the network is slow and you want to let the user know, like, hey, this screen is loading. Now, as of iOS 14, there is no SwiftUI native spinner view. If you're watching this in iOS 15 or iOS 16, I bet this is going to come pretty soon. Seems like a pretty obvious candidate for something to get in there quickly. But for now, we still have to go down to UIKit, which means we got to do UIViewRepresentable. I didn't say UIViewControllerRepresentable, UIViewRepresentable. So it's basically the same thing, but a small little tweak that you'll see here. Okay, so in Appetizers here, Command-N for a new file. We'll call this loading view, because we're going to combine our UIViewRepresentable and the actual loading view, because it's super simple, in the same file. And I'll tell you why when we're done here. So again, loading view, hit create. We need to import SwiftUI for sure. And then we want to create a struct called activity indicator. And this is going to conform to UIViewRepresentable, because we don't need a whole view controller. We just want this view. And then just like last time, it's going to say we do not conform. So hit fix. Remember last time we had to do the type alias. What type of UI view is this going to be? It's going to be UI activity indicator view that you see right there. And then now when I hit Command B, remember this was like the two-step process. Now it's going to say I don't conform. Hit fix. Cool. Now I get the protocol stubs that I wanted with the it returns UI activity indicator view. It has my update view all filled in with the type. So now we can get rid of the type alias. Again, I'm going quick because this is a review. I think we've done this 3 times now. Again, the only difference is it's just a UIViewRepresentable, not a UIViewControllerRepresentable. So again, the update UIView is just an empty implementation. But here in make UIView, just like last time we had to actually make our UIViewController, well, now we're going to make our UIView. So let's say let activity indicator view equals UI activity indicator view. We're going to initialize it with a style, and the style we want is .large, right? You can do .medium, it's fine. We're going to do .large. We want this a nice big fat spinner here, and then we can customize this a little bit more. We don't want to make it gray. We want to make it our green color, our brand primary color. So I can do activity indicator view .color, equals, and you see we had color with the name. Now, here's where we're going to fix this real quick, right? Because I don't want to have to type out brand primary every time. If I have a typo, it's not going to work, right? We don't want to keep repeating these strings. So right now, well, let's actually finish this so Xcode doesn't give me errors. Activity indicator view dot start animating, right? So when this gets created, it's going to start animating, and then return activity indicator view. So again, all we did was we created the view here with the large style. We set the color, and as you're seeing my error, right, we're in UIKit, right? UIKit just doesn't have color, right? It's got to be UI color, and then UI color has to be, you know, named with the string, right? So anyway, we're gonna fix this, right? Because I don't want to type brand primary, and then we animate the activity indicator, and then we return that, right? Remember, the make UI view or make UI view controller is what replaces the body variable on our view, right? Just to be clear about that. So now let's go refactor our color out a bit. So again, click on Appetizers, Command N, and we're gonna do project organization soon because you can see this is starting to get ridiculous. Let's call this color plus EXT. We're gonna build an extension for color. And that's how I usually name my extensions, you know, whatever the object is plus EXT, and then I usually have an extensions folder. Again, project organization coming soon. So let's import SwiftUI, and we're actually gonna do this two ways. We're gonna do an extension on just color, right? Just color, remember, is the SwiftUI color, not the UIKit color. And remember, we're in UIKit currently for activity indicator. So our extension here, we're gonna say static let brand primary equal, and then we're gonna initialize a color with the name brand primary. And then here we're gonna do another extension on UI color. This just covers our, you know, UIKit bases, and basically the same thing, just the UIKit version. Static let brand primary equal UI color, and then just like we just did, right? Named, and we'll copy and paste this just to make sure we don't mess that up here. So named brand primary, do a Command B, make sure we're good. Okay, so now if you remember in our tab view, appetizer tab view way back in the beginning, we did accent color, brand primary, and now we can fix this and change that. But to be sure, let's search for it, right? Let's be safe here. So hit this search button in the Finder. We're gonna type brand primary, just to make sure we get them all. All right, so appetizer tab view, that's the first one. Cool. So instead of color, brand primary, we're gonna do dot brand primary, right? Because we made an extension on color, now it's much easier and nicer to read. So assets, cool, I'm not gonna change that. Loading view, right, okay, cool. Instead of UI color brand primary, we can do UI color dot brand primary to get that color now. And where else do we have it? Okay, in our extension, yep, that's where we just created it. Okay, cool. So we have all the instances of brand primary now refactored into, you know, the colors, right? And you would do this for a lot of the colors you use in your app. Brand primary is the only color we're gonna use now, but that was a little side adventure on refactoring out our colors. So now that we have our activity indicator all set up, formatted, ready to go, now I just need to use this activity indicator view in some sort of view that we wanna present when we're loading, okay? So we're gonna create that right here. And this is what I meant by I keep these in the same file. So we're gonna do struct loading view, and that is conforms to view. Right now we're in SwiftUI right now. So that is a var body of some view. Okay, so now we're just a typical SwiftUI view setup. We haven't returned anything yet, so it's yelling at us. So what we want in our loading view is just a white screen in light mode, a black screen in dark mode. So we're gonna use system background as the color. So we just want that as the background and then the spinner on top of that. So we're gonna need a Z stack, right? The bottom of the Z stack is our color background. On top of the Z stack is our spinner, okay? So Z stack, and again, the bottom is the color, and we're going to do dot system background. So again, system background will be white in light mode, black in dark mode. And we do wanna make sure we do dot edges, ignoring safe area, dot all, because if we don't ignore the safe area, our background's not gonna go up to the status bar, and it's not gonna go to the home indicator at the bottom. So we wanna make sure we fill the entire screen, okay? So that's the base layer of our Z stack. So on top of our Z stack, all we gotta do now is just do activity indicator, right? And create a new activity indicator view. And that's it for our loading view. Again, the background color, activity indicator on top. When this gets called, it's gonna call make UI view, which is gonna initialize this activity indicator view with a style of large. We're gonna set the color to brand primary, and we're gonna start animating. Okay, great. Now let's use this loading view. So in our appetizer list view here, I now want to make this entire thing a Z-stack. And the reason being is because I want to basically put my loading view on top of everything when it's loading and then remove it when it's not. Okay, so wrap this navigation view in a Z-stack. And then I'll copy and paste this whole navigation view, Command X, Command V, I should say cut and paste, not copy paste. And then I actually want to move this alert onto my Z stack. I want that to be on the root view, if you will. Before our navigation view was the root view, now the Z stack is. Okay, so if you look at our Z stack, remember the Z stack is the layers, the view hierarchy. Well, right now the bottom layer of our Z stack is our navigation view that holds the list. Well, what I want to put on top of that is the loading view, but only when it's loading. So I want to do something like this, right? Like if is loading, now I show my loading view, right? And that way, if it's not loading, the loading view never shows up. So I need this Boolean of is loading, okay? So let's go to our view model to put that on, because that relates to our network call, correct? So back to our appetizer list view model. Man, we really need to organize this stuff. I'm having trouble finding that. Again, soon. Okay. So here is our network call, right? This get appetizers. Okay, so we know we need to work with this. Well, first I need that is loading Boolean. So at published, right? Because we want to let our appetizer list view know when this changes, because we want to redraw. So var is loading, and that is a Boolean. We'll just say equals false for right now, because right, the default state is we're not loading, it equals false. So before we go any further, right, we created that Boolean back in our appetizer list view. Here we have it now, except it is view model dot is loading. Okay, so now we're good. We've connected that. Now we just need to go back to our view model and actually flip this Boolean at the right times. Okay, so basically as soon as we call get appetizers, we want to set is loading equal to true, right? So as soon as this function gets called, that's going to get flipped to true. And then what's going to happen on our appetizer list view is this is going to get redrawn. We're going to go into this if statement because now we are loading, and then our loading view is going to show, and it's right on top of the Z stack. So just imagine like our loading view getting smacked on top of our list as essentially what's happening. And then what's going to happen here back in our view model, we need to flip this to false when we're done loading. So when are we done loading? Here in when we're going to the main thread, because this triggers a UI update, so we want to make sure we're on the main thread for this, we can do is loading equals false. And this is basically as soon as we get back a result. We don't really care if the result is a success or a failure. We're done loading, right? Whether it was good or bad, we're done loading. So here we flip this back to false. And then again, what happens is this changes, it publishes its change in our appetizer list view. This is going to say, okay, cool. Is loading is now false. It's going to redraw, and then it's not going to go into this if statement because is loading is false. So therefore our loading view will not get put on top and you won't see it. Okay, hopefully that all made sense. Let's see this in action. So run it on the simulator. You're probably not gonna see it because it'll be too fast. Okay, you saw it for a split second. Now let me use my network link conditioner. If you don't know what that is, I'm not gonna derail this video and teach you how to do that. I just did a video on my YouTube channel recently. I'll link to that in the description because many of you may already have this. But in your system preferences, here next to my Xbox 360 controller, I have my network link conditioner. And this is basically, I can turn it on and you see very bad network. And you see my little menu item up here. This tells me my network link conditioner is on. So basically I'm slowing down my Wi-Fi intentionally so I can test bad network connections. So let's run this again and test the bad network. You'll see how slow this goes with my network link conditioner, right? So there's our spinner. It's going for a while because our network sucks. We're simulating that. Maybe you're in a spot you don't have to simulate that. Who knows? But now you saw our spinner in action and you can see that flow that I talked about. I'm going to run it one more time. Right? As soon as we call get appetizers, it redraws and our spinner shows. And then as soon as we get a result back from those get appetizers, our variable gets published. We listen to that. We see the change. We redraw again, and we don't show our loading screen. So now our basic loading screen is in place. That wraps up this video. In the next video, you see all these Asian flank steak images. We're going to start downloading these images from the server and populating the correct ones. We left off last video getting this simple loading screen in place. In this video, we're going to implement another network call to download the individual images of our appetizers. So back in Xcode, just to refresh real quick, if I go to my appetizer model, right, we have this image URL that is a string, right? So the data we get back from JSON has a URL attached to it, and that's what we're going to use to download this image. But the first thing we got to do is into our network manager, we have to create another network call similar to our get appetizers. Now, the concept for this network call is the same. However, we're going to handle it a bit differently. And the reason being is looking at the design, like we want to show a placeholder if something goes wrong with our network call or if there's no image, right? We don't want to pop up an alert to like bug our user every time like an image goes wrong, right? Because you see all the images on this screen, like you'd be popping up alerts. That's just so annoying. So our way of showing an alert when an image goes wrong is just showing the placeholder, right? Just kind of, it's almost like failing silently, except you have that placeholder. Anyway, we're just not bombarding them with alerts. So that's why this network call is going to be a little different, because this is our get appetizers network call, right? You see, we had to check for the error, check for the response, check for the data, because we wanted to give specific errors for each case. Well, in our network call to get the image, we're not worried about specific errors. So you're going to see this get simplified a bit. Okay, so let's write this. So I'm going to scroll down here, create a new function, func download image. I'll move this up a little bit. And we want this to be from URL string, right? Because we're going to pass in a string here. And the reason I like to be specific like this, like say, hey, it's a URL string, is to just differentiate between when I'm expecting a string or when I'm expecting, you know, like the URL object. So that's why I like to do that little tidbit there. So it's going to take in the URL string. Again, that's what I showed you. It's the URL attached to the appetizer. And we're going to have the completion handler completed, which is an @escaping closure. I don't know if you had a chance to go review that on my YouTube channel that I linked last time, but if not, you should definitely check that out. And then here's where it's a little different. I'm going to scroll up to compare, right? Last time at this part, we returned a result that either had an appetizer or an error. Remember, because we wanted to pass back the error. Well, like I said, I'm going to copy this for format purposes. So Command C, Command V. So, and this is just to also illustrate the differences here. So we don't need a result type because we don't care about the failure case. Remember, we're just using the placeholder. All we want to return is a UI image. And it's telling me it doesn't know what a UI image is because if I go up to the top, I have not imported UIKit. Side note, UIKit automatically imports Foundation, so you don't need both. Command B. So now I have UIKit. Now it knows what a UI image is. However, like we talked about, there could be an error case. So UI image could be nil. We're not always going to have a UI image. So let's make it an optional with the question mark. And then let's create our open and close brackets for the scope of our function. So again, that's our function signature. You know, we're going to do network manager.share.download image. We're going to pass in a URL string, and the completion handler is either going to give us a UI image or nil based on what happens in the network call. Now, one thing we're going to set up for our images is the cache, right? Like, we don't want to always download our images repeatedly as we're scrolling up and down the screen. So we want to put those in the cache for fast scrolling, and you know, we'll check to make sure it's not in the cache, then we'll download it. If it is in the cache, we'll just yank it out of the cache and then use that image without even bothering with the network call. So that's what we're going to set up now. So to do that, we need to set up our cache up here. So private let cache equal ns cache, and we got to use ns because cache is still pretty old school. So ns string. What we're basically putting in here is the key value pair that we expect in our cache, and I got to initialize that. So basically what this is saying is our identifier is going to be a string or an ns string, and at that identifier in the cache is going to be a UI image. So we're kind of telling our cache what to expect to store. Okay, so back in our download image network call, this is the first thing we want to check, right? Again, before we mess with making a network call, let's make sure it's not in the cache first. So we're going to set up a variable for a cache key, and this is just a quick way to reference it here. Remember, the key is this ns string right here. And the key we're going to use is the actual URL address because that's pretty unique, right? You want your keys to be unique. So that's going to equal an ns string from a Swift string down here, and that string is going to be from URL string. That's what we're passing in here. And you know what, that naming can be better. Quick tip here on like argument labels versus parameter labels. So I can say from URL string will be what shows up at the call site, and if I just do space here, URL string, that's what shows up within the scope here. So I don't have to say like from URL string everywhere. I can say something that makes a little more sense, you know, a little more readable. It's just URL string, not from URL string. Small minor detail, but you know, it does help, especially when your scope is really long and you're using it, you know, it just makes more sense. So here we have our cache key, which again is just the URL that is attached to our appetizer. That's a unique string to identify the image. So let's check our cache. So if let image equals cache dot object for key, right? We're going to go, you know, whatever object is at this key, and the key we created was cache key. So if we have an image, cool, we're going to call completed and pass in the image, right? We're going to fire off our completion handler because we have an image there, and then let's hit the old return, and we're done here. We're out of the function. We're not even going to like mess with the network call. However, if we check the cache and we get a nil, it's going to continue on, and now is where we need to make the network call to download the image because we don't have it in the cache. So now's where we have to do a similar check, right? We want to make sure our URL is fine. So guard let URL equal URL string else and completed nil, and then we return. We're out of here. We're just going to show the placeholder images. Okay, that's the same URL check we did before. Now let's actually start creating our data task. This is where it gets a little different. But this first part's the same, so you know what? We're just going to do a copy and paste so I don't mess that up and type it. Like I said, I do the copy and paste on the same stuff like quite often. What I mess up here, guard let URL equals URL string else completed. Oh, we're not just checking against the string, we're checking against the URL initialization of the string. Remember, because when you initialize a URL object, it can return nil if the string is invalid. So yeah, forgot to do that part. We're not just checking the string. And then down here, I need a closing bracket to finish that off. Okay, cool. So we have the same setup that we did before. Remember, we get back data, response, and error. Well, remember, this is different. We don't care about the errors, right? We don't have to check all this. All we care about is, did we get back good data? So that severely limits our checks here. So I can do guard let data equals data. And then I can combine another one here to say let image equals UI image. If you're not familiar with this, I'll walk through it afterwards. We want to initialize the UI image from data, and then that's the data that we got. And then else, so if we don't get any of this, we're going to call completed nil, and then return. So what's going on here is I'm saying, hey, if I have good data, great. Now keep going. If I have data, let's try to initialize an image from that data. Now, when you initialize a UI image from data, that can also return nil. That's why we're unwrapping this. So either we have bad data or trying to create an image from that data. If that returns nil, we're going to call completed nil. If we got good data, we were able to create an image from that data, we're good to go. Let's keep moving. So now we have our image. So we want to do two things, right? We've downloaded the image, so let's put it in the cache so we don't have to download it again next time. And then let's call our completion handler with our image. Okay, so let's do that. So self.cache.set object for key, right? So now we're saying, hey, whatever's at this key, make this the object in the cache. So the object we want to set is the image that we just created from our data up here. And then the key, again, is cache key, which is essentially the URL string that we're passing in. So this line of code sets the item in the cache. Now we want to call completed with our image, not nil, right? And that's what's going on up here in our completion handler, right? It's passing back an optional image. Now we actually have the image, so we're good to go. This would be like the success case. And then the last piece, as always, the one that trips everybody up, task.resume. Did I mess up the scope again? Nope, I didn't. All right, so let's clean this up again, do a Command B to get rid of any warnings or errors or see if we messed anything up. Nope, I like 2 spaces, vertical spaces between my functions, just me. All right, so let me walk through this high level one more time before we wrap up this video so you understand the network call, right? We're calling download image. We're going to pass in a URL string, which is the URL attached to our appetizer view. This network call is going to return a closure that's going to either have a UI image or it's going to be nil, right? It's optional. We're going to return nil if things go bad. We're going to return the image if things go good, right? Now we want to set up our cache. And again, we did that up here with the cache, and you see the cache takes a key and then the object. It's key value pair. So the key is going to be a string, and we're going to use the unique URL for the image to be the key to identify it. So we create that cache key from that URL. And then here's we're checking our cache to see if we have that object before we download anything, right? So if we have the object, cool, call completed, return the image, we're done. Good game, right? If we don't have the image in our cache, all right, now we got to download it. So now we check to make sure our URL is good, make sure nobody's given us any funky URLs. Cool, if the URL is good, now let's create our network call here. Remember, the network call returns data, response, or error. In this case, because we're just showing the placeholder if things go wrong, we don't care about the errors, so we don't have to do all these other checks we did before. We can just see if we got the good stuff, right? So guard let data equals data. Did we get good data? And then if we do have good data, cool. Can we make an image out of that data? If we can't, completed nil, show the placeholder, we're done. If we can make an image out of that, cool. Set that image into the cache so we don't have to download it again next time, and then call the completion handler to pass that image up as the success case. And then task.resume is what actually fires off the network call. So we're going to stop here on this video just to set up that network call. But in the next video, we're going to create our custom SwiftUI image that can download images remotely. So let's do that. We left off last video creating our network call. Now let's put that network call to use. Okay, so in Appetizers, and I promise the next video is project organization. So we're gonna clean this mess up over here. One more file. So Command N for new file, new Swift file, hit next. We're gonna call this remote image. We're actually gonna have a couple objects in this file because I find it easier to keep this all together rather than separate, less confusing. Okay, so we definitely wanna import SwiftUI. And now we're going to create a couple of objects, like one is an observable object similar to a view model, but like not the same, that we use with our custom SwiftUI image. So this is going to be multiple puzzle pieces working together. So as we build this out initially, you may be like, what's going on? But as you've seen in all these videos, at the very end, I walk through it to connect all the dots for you to hopefully help you understand. So if you're a little confused while we're building this out, don't worry, I got you. So the first thing we're going to create is our image loader, which is that class. So final class image loader, and this does conform to observable object because we are going to have a property of an image, var image, that is a SwiftUI image. And for right now, it's going to be optional, and we're going to give it a default value of nil. So what this image loader does is it actually downloads the image and then it broadcasts, hey, I've got my image, right? Just like the view model does, right? It broadcasts its changes. So in order to do that, I got to make this published, right? Because we want to know when this image changes. And this image is going to change when we have a successful network call. So now we got to make that network call here. So we can do func load from URL string. And again, similar to what we did, we're just going to call this URL string, and that is of type string. A lot of strings there. And then here we call network manager dot shared dot download image, from URL string. Well, that's going to be the URL string that we pass in here. So URL string, and then the completion handler is going to be image, and then we get rid of the parentheses. Now remember, this image is optional, so we have to handle both cases if it's nil or if we actually have an image. And we're going to handle that nil case first. So guard let image. Okay, I messed up the naming. We actually want this to be UI image, just for clarity, as you'll see in a little bit, because we're going to be talking about SwiftUI images and UI image. So we don't want to get those confused. So we want to be very clear that this is a UI image. So I messed up my naming. So we can do guard let UI image equals UI image, else, and then we're just going to return here. So we're going to keep that on one line, else return, because again, we're not handling the errors. We're just showing the placeholder if things go wrong. So now that we've unwrapped the optional, like we know we have our UI image, we need to set this image here, the SwiftUI image, to the UI image. Hopefully that wasn't confusing. Maybe this will help you out here. So we do self.image equals, and we're going to initialize an image. And this is a SwiftUI image, not the UI image, but an initializer on the SwiftUI image. You'll see I can initialize one from a UI image, right? And that's the UI image we have. So this is why I wanted to be clear and name this UI image and not image to be confusing, right? I wanted to definitely separate the two. Now, again, one thing that trips people up, remember, yes, we're just setting the data behind the scenes here, but because this is published, it's going to trigger a UI change, right? Because once the download is successful and we set our image equal to the actual image we have, we're going to redraw the UI and show the downloaded image. So because this triggers a UI change, we want to dispatch this to the main queue. So dispatch queue, and by the way, I just tried it, so I don't have it on this machine, but on my development machine, my laptop, I have a code snippet where I just type DQ and it types out dispatch queue.main.async because you type this so often. So little tip there, if you want to create a code snippet, I would recommend that. So Command X, Command V to paste that in there. So now we're updating our image on the main thread to trigger the UI update. Okay, so that's the first piece of the puzzle. This image loader is what downloads the image. The second piece of the puzzle, which is kind of just like a helper for the final piece, and it'll make more sense when I get everything together, is going to be a struct just called remote image, and it's going to be of type view. Now we're in just the regular SwiftUI view here. And a property on here is going to be var image and is of SwiftUI image, but it's going to be optional because again, it's going to use this that returns. We may not have it, right? If the network call fails, we get a nil. So we got to make this optional. And then here we're going to have var body some view. This is just the standard initializer, for SwiftUI. And here we're returning, this is where we want to return an image, like a SwiftUI image. So if we have image, we're just going to return what we got back. So image. And it's an optional. We'll call .resizable because .resizable is one of those custom modifiers that can only be called on an image. That'll come into play later, but just remember this is why we have to call resizable here. So if we have the image, cool, just, the remote image is that image. However, if it's nil, we don't have it, here's where we want to return an image except the name here is food dash placeholder. And I just realized we forgot to bring this in. So I'm going to bring this in. This file, of course, will be attached below the video, but I'm going to drag this into our XC assets so we have it. So if I go to my Finder here, I got it ready. See, these are all the images. Here's my food placeholder, and then we'll drag that. Whoop, let me open up XC assets, go back to Finder, drag that into here, and hopefully you do the same thing. And then you get this nice placeholder image that will look good on both light and dark mode. So now back to our remote image, that's what we're gonna do. If we have an image that's returned nicely from the network call, show that, give it the resizable modifier. If we don't, if we have nil, show the image with the food placeholder, also dot resizable. So that is puzzle piece number 2. And it's really just the helper for puzzle piece number 3. Because if you don't have this helper, you'd have to write some pretty convoluted code and confusing code in the third puzzle piece. So we're going to write that right now. And this is actually what we're going to use in our usual SwiftUI code. So this is going to be struct. We're going to call this Appetizer remote image, and it is of type view. And again, it is the typical SwiftUI view. So we want to do var body some view and get that all set up. Now this is going to have 2 properties. We want a state. I'm going to scroll up here. My head's probably getting in the way. State object var that is a image loader, right? This is what we want to have attached, that we're watching this image loader, right? So var image loader, and that equals a new image loader. We're initializing a new one here. And then the other thing we need is a URL string, right? Because when we create this appetizer remote image, we need to know what URL to load from. So let URL string, and that is of type string. So that's what we're going to pass in based on what appetizer we have. Okay, so now here's where this helper comes in, right? We're gonna, for our body of our view, we're just going to return a remote image, right? That's what we have here, up here. And the initializer for the remote image, if you saw that, takes in an image, which is an optional image. So what we want to pass in here is the image that's attached to our image loader, right? Remember this image that gets returned after the network call is done? So right away, that image is going to be nil. But after the network call, finishes successfully, it's going to make this image, not nil, it'll make it the image. This will broadcast the change. Our appetizer remote image, because we have this set up here as a state object, is listening for that change, and then it will redraw and create its image, with the image we have here. So I do image loader.image. Right, so I'm initializing this remote image with whatever we get back from the network call or the placeholder until we get anything back. Now, you'll notice when I just draw this once, image loader.image is nil. So I gotta trigger the network call somehow. So when this remote image appears, so we'll do on appear and put the closure afterwards. So when this image appears, I want to call image loader dot load image from URL string. And what URL string do I want to load from? Well, whatever we passed in based on the appetizer we have. It's from URL string. Put a space there, and we'll remove this space. Okay, so like I said, here are the 3 puzzle pieces. I know I've kind of walked through it as I've gone, but I understand this may be confusing. So I'm going to do one more walkthrough now that we have all the pieces in place, and hopefully it'll make a little more sense. So this appetizer remote image is what we're going to use like on our list view to replace our just regular image placeholder. And what happens when this appears on screen, right? Because on appear happens. Well, when on appear happens, we call image loader.load. Remember, our image loader we have attached here as a state object, right? So it's attached to our view. Well, the image loader is going to call load. It's going to make the network call. If the network call's bad, it's going to stay nil, right? So we're going to show the placeholder. If the network call's good, this image is going to flip to the good image because it's published. Remember, it broadcasts the change. Our appetizer remote image is going to see the change and say, okay, I got to redraw. And now when it redraws, it initializes our remote image with an image, and it's going to use the image loader.image. Well, what is our image loader.image now? It's no longer nil because we had a good network call. It's going to be the actual picture of mozzarella sticks. So that's what we're going to show. So that's how this little puzzle piece works. And again, the remote image is just kind of a helper to make this code kind of clean. You'd have to write some pretty weird stuff. I tried. I couldn't get it working. It was weird. So the helper was nice. So that's kind of what's going on here. Now let's put it into play here on our appetizer list view and then test it and see if it works, right? We've been coding for 2 videos without testing. Let's see if this works. So I'm sorry, not our appetizer list view, our appetizer list cell, right? And what we want to replace here, I'm going to pull up the canvas, minimize it there a little bit, hit resume, should pop up. Okay, previews. Am I right? Never mind. Get out of here. We're good. This is, by the way, I just downloaded Xcode 12.2 the other day, so maybe that's why it's taking longer. Anyway, we just want to replace this. Remember this generic image we had that was just the Asian flank steak all the time? It's kind of our placeholder. Well, now we don't want that image. We want our appetizer remote image. And when we initialize that, right, that takes in a URL string. And the URL string we want to pass in is our appetizer.image URL. Right? And you'll notice, remember, this is what I said, resizable is one of those modifiers that can only go on an image. Well, even though our appetizer remote image, like, you know, is basically an image, we're doing some other stuff to it, and it's not just that raw image. That's why, going back to that remote image, like that's why we had to put resizable here, because this is actually on the image, right? So we're handling the resizable stuff, you know, abstracted away. So on our actual cell here, we can just delete the resizable because we're already doing that. And you see, we even if we wanted to do it here, we couldn't because that only goes onto an image. So do Command B, get a build, should be good to go. All right, moment of truth. Last time this didn't work out so well. Again, I haven't tested this, I'm just building it now. So first time, let's see if this works. Bam, there we go, nice. No more embarrassing debugging on the fly, even though I think it might have been helpful. But yeah, so you see, we have our images here. We're no longer just looking at Asian flank steak. We're pulling up the proper images for each appetizer. Now, let me break this down again real quick. So we'll stop this. We'll pull up the network link conditioner, turn this on. This is just a valuable tool. If you didn't bother to set it up last video or last time I showed this, go do it. It's very valuable. So I can show you what's going on here. So I turned it on. I'm on very bad network. Now let's run it again. And you'll see kind of the process here slower. First of all, we get our spinner. That's fine. We're going to get back all of our JSON for that. And you're going to see the images start slowly loading in, right? So you can see we're showing the placeholder until we get the proper image. And I'm scrolling up and down real fast to show you that, you know, we're still getting the proper images. Yeah, so you can see while the image loader image is nil, we're showing the placeholder. Wow, this is really bad. There it goes. So here we're showing the final image once it's finally downloaded. So hopefully slowing down the network connection showed you the process because it happens pretty fast. I have Google Fiber here, weird flex, I know. But anyway, our image loader is in place. That wraps up this portion. Our list is looking good. In the next video, we're finally gonna tackle this mess over here and start organizing our project. We left off last video downloading these beautiful images that you see here. Now we're going to clean up this rat's nest that is our files, right? And, you know, maybe you want to challenge yourself, organize it yourself real quick. I'm going to follow basically the same organization principles that I've been following. So it should be a little bit of review. But again, organization, subjective. If you have a different way, cool. Again, more practice doing it my way. So new group here. So the first thing we're going to start off with is the screens, kind of like the heart of the app. I did new file. I did command. I'm so used to doing command N. Right click, new group. We're going to call this screens. And okay, so the screens we have, right? Well, I'm going to create a new group in here before I start moving stuff, right? I want a appetizer list view. Okay, cool. Now I want a folder new group for account view. You can see I'm basing this based off of the new group, the tabs on the tab bar, right? And then we have a order view, right? Because again, when you're organizing the project, I find this easier, right? Especially if a new developer comes in that's not familiar, you know, and it's broken up by the tabs, it's a lot easier to like navigate and know what's going on. So that's how I like to do it. And then I do like to have them kind of in chronological order, right? Appetizer, not in the folder. That's one thing that gets tricky. Sometimes it's finicky, right? So appetizer account order view, cool. What goes in the appetizer list view? Well, that's our appetizer list view. That's one. Our appetizer list view model, that's two. And again, I like to put my view model on top. And then let's take our account view into our account view. And then I like to open up the folders just to confirm, you know, things are where I expect them to be. And then the order view. Cool. Now I'm going to create in appetizers my utilities folder. Right? Remember I said this is kind of like the catch-all and it can get out of control, but I think if I have subfolders, I think it's fine. So new group, here I call this like managers, because usually there's a couple, like a session manager managing the user, network manager, there's a couple of these. So back in utilities, new group, now let's add extensions. Okay, now let's start organizing this a little bit. So network manager goes into managers. Where's my color extension? Color extension goes into extensions. Okay, let's create a new folder, new group. I don't always do a separate folder for this. Do alert, And, I can probably put my AP error and my alert in that folder. I thought about naming it like errors and alerts, but I don't like super long folder names. So those kind of go together. So now what are we missing? The appetizer.tab view, that's kind of like the overarching thing. I put this in screens at the top. I don't put it in a folder though, right? So you see my screens folder has the app tab view and then the screens. I kind of like the way that looks. Again, completely subjective. Of course, we're going to need a new group. We're going to need a model folder for our appetizer and then, some future other stuff. So appetizer.swift, move it into our model. You see, and I'm kind of just going down the list, right? So loading view, I'm going to put this in my UIKit components because like I said, I fully expect an activity indicator to be native to Swift pretty soon. I'd be shocked if it wasn't like in the next major Swift update. So we're going to put this in UIKit components. And the reason I like to keep that separate is because I know exactly what to go in and replace as SwiftUI, evolves and gets all this functionality. So let's minimize my folders to look at my overall structure real quick. So model utilities screens. So again, this is where I start doing the views folder. So new group, call it views. And this is kind of like overarching because there's a lot of different views, especially in SwiftUI. So the new group in here will be UIKit components. And then the other one will be cells. You see my appetizer list cell. So new group, call it cells. And then remote image. So we'll call this new group, call this image. Okay, so let's just drag this here. Cell goes into cells. Loading view goes into my UIKit components. And remote image goes into my image. So, and then I usually like to have views down here above screens. So I like to have like the stuff like the model, utilities, all that kind of stuff. I like to have at the top, and I like to have my views and my screens, the stuff I use the most, at the bottom. I understand that sounds kind of backwards. That's just my preference. But you can see the folder structure, right? Model with the appetizers, utilities. We have alerts, extensions, managers in my utilities, views, images, cells, UIKit components, screens. See it's broken down with the tab view by tab. And then of course, as these get more complex, these can have subfolders as well. So I've said it 1,000 times, and I know, but organization is subjective. Just take what you like from me, leave what you don't, come up with your own system. Just try to put yourself in the shoes of somebody new coming into your code base and not knowing your special cool little system. Like I try to keep it the most logical and obvious as possible. At least that's what I strive for. That's what I think you should strive for too when organizing your project. Now that we've got our project organized, let's shift gears a little bit and start building our detail screen, right? As you see in the design, this is what pops up when we tap on the table view. We see this detail screen. It's kind of like a card with some information about the appetizer. And you know what? It's challenge time again. I encourage you to try to build this on your own. Now, this is probably the most complex piece of UI like we've done yet. So if during that challenge, you struggle, don't worry, it's fine. That's what we're here for. We're here to learn. But, if you've been skipping over my challenges so far, I highly encourage you to not on this one, right? Like just watching me type and typing what I type. Yeah, that's cool. But, you're really going to learn when you start to push yourself and do this on your own and try and figure it out and use what you've learned to build this. Now, before you do this challenge, a couple things of note, some things that are just different than what we've done before, just to give you a heads up so you're not banging your head too much. As you can see in the design, right, we're not designing a whole screen, we're designing like a little card. So keep that in mind. Also the blurred background over the list, don't worry about that. That's not part of this view. That's part of the list view when we present it. So don't worry about that. And then there's one piece that we haven't touched on yet, and that is the overlay modifier. And that's what we use to build the little circle dismiss X button in the upper right-hand corner. So just a little heads up on that if you do try to build this on your own. Okay, so now's your last chance to pause if you want to try that challenge yourself. Again, I highly encourage it. If not, oh well, we're about to get going in 3, 2, 1. All right, here we go. Looking at the design, let's break this down, right? So we have our overall card, which is our view, right? That's just going to be a VStack, right? We're going to give it a background color of .system background, so it shows appropriately in light or dark mode. We're going to give it the rounded corners that you see on the card, and then we're going to give it a drop shadow. So that's like the basis of our card. It's just our overall VStack. And then the way I like to break this down is I like to break it down into main UI elements. Now, quick disclaimer, the way you do this is kind of subjective. Like there's many different ways to skin a cat, so they say. I don't even know where that came from, but there's a lot of different ways you can lay this out. I'm just going to show you how I think about it. If you like it, use it. If you don't like it, figure out your own way that's better. Cool. But how I do it is I like to break it down into major like chunks of UI, right? So the way I look at this, I look at the image, that's a major component. All this text, like the title, the description, the nutrition information, to me, that's another chunk, that like text information chunk. And then the third chunk is the button at the bottom. So I have three main UI elements in my VStack. And then of course, the text in the middle, that's broken down into another VStack with my title, my description, and then the HStack, which has a VStack inside it, with the calories and then the number. So that's just how I look at like a complex UI like this, is I break it down in maybe chunks is not the, the technical term, but that's what I call it, just the major UI components. And then I break those down like even further. So that's how I tackle something like this. So that's the overview. We're going to be revisiting that design throughout, but let's get started here, right? So in our appetizer list view, our tab, right? I'm going to do Command N for a new file, SwiftUI view. This is going to be our appetizer detail view. Hit create. Cool, here we are. And then the first thing I want to set up before I forget is like, I know I'm going to need an appetizer on this view. So I can do let appetizer of type appetizer, and then we're good to go. There, we're passing that in. Of course, our preview is going to say, hey, you need an appetizer. And just like before, we did mock data.sample appetizer. And let's actually pull up the canvas for this one because we're going to be building this as we go here. See if previews give us a headache. Get my usual routine there, make it smaller. All right, cool. So the first thing we want to build is our overall VStack. This is the card that we're going to build. So let's get that structure going first. So VStack. Now for right now, let's just put a text in there just to give it something to show. Hello, just so we can see it on our preview. But now we're going to start adjusting this to make it look like a card. So the first thing I want to do is give it a frame with the width and height. All right, so the width is going to be 320, and then the height 525, and then we don't need an alignment. So you can see the red outline on our preview. That is the general size of our VStack. And I chose 320 by 525 because that's going to be a good size on phones. We're not worried about the iPad right now. This is an app that you're going to use in a bar or a restaurant to order appetizers. So we're just worried about the iPhone for now. So you can see the general structure starting to take shape. The next thing we want to do is give it a background color, but this is going to be color. Now see it's blue just to show you what it is, but we want to do .system background. So again, this is going to be, you're not going to notice it because it's going to be white in light mode, black in dark mode. But again, when it's over the blurred background, like you see in this design, that's how we get this look. So now we want to give it a corner radius of 12, right? To give it that rounded corners. Again, you still can't see it. Now let's make it so you can kind of see it by giving it a drop shadow. We haven't done this yet. Drop shadows in UIKit were always kind of like a pain, but they're pretty easy in SwiftUI. You put the modifier of a shadow and give it a radius of 40. You can add a color, but the default is the black color that we want. So we're not going to mess with like adding a color. But if you did want like a red shadow, you could do that. So let me click on the overall screen to get rid of that red outline. Now you can see the structure of our card. And like I said, because the background color is system background, once we put that drop shadow on it, it really makes it pop. So now let's start filling in our VStack with the three major chunks, right? I talked about the image, the information piece, all the text, and then the button at the bottom. And again, this is how I build the UI. I break it down, by components like that. So first thing we have is an image. And then the name we're going to use is our dummy data here, XE assets, the Asian flank steak, copy that, paste it into there, and there you go. Now, as usual with our images, doesn't look right right away. We got to make some adjustments, right? .resizable. Hopefully this is review by now. Okay, so see it resized it to fit. That's not what we want. We want to do aspect ratio content mode .fit. Cool. So now it's going to keep the aspect ratio, but fit it within the VStack. So you see it fit it horizontally. But we want to give it a specific frame here. We'll do frame width was 320 because we want it to fill the whole thing. But the height is 225. And actually, I made a mistake. You see it doesn't fill it because I put in the wrong number here for the frame. I wanted to do 300. So now let's go up and change this to 300 like we had. So it fills up the entire width there. Now that's the first major component of this card. The second one is going to be, as you see on the design, that text information. And that's going to be in a VStack overall, right? So I'm going to add my VStack here. And just for now, I'm going to put in a text that just says title. Again, what I'm building right now is kind of just my overall structure of the card. And then I go into each one of these components to flesh it out. So there's my VStack. And then the third component is my button. Again, we'll just print tapped, and then the label for the button, which this is where you design it. Again, we've built a couple buttons by now. Again, for right now, I'm just going to put text button. Again, we're just building out the structure. Now, I don't want my button hugged up against, all my information, right? I want to add a spacer between my title and the button. And remember what the spacer does, it's going to push everything out. So put a spacer under my VStack, because really I want the button to be pushed all the way to the bottom. There you go, which also pushes everything up to the top, which fills in the card on my image nicely. That's what I wanted there. However, my button is hugging the bottom, like literally. I don't want that. So on our button, let's add a padding bottom. So we can do dot padding, and then again, we can specify, like we could leave it like that, but we just want to, specify the bottom padding. Dot bottom, and then we're going to give that 30. So now you can see our button is pushed up from the bottom, and we're going to design our button later. But you can start to see the structure of the card, taking shape. So it looks like the image is good. Now let's start working on our text in the middle, right? So this title, we can actually change this to appetizer.name, right? And it should be like test appetizer. That's what our sample is. Now let's start changing the font. So we want font of .title2 and .font weight, .semi-bold. And again, this is just the design I came up with. If you want to tweak this and make it your own, go for it. Now the next piece of text we want to add is our description, right? So we can do text appetizer.description. And then we're going to add a new modifier that we haven't used yet, right? Because take a look at it. It's not centered, it's left aligned. So to do that, you can do .multi-line text alignment. Again, this is a new one. Instead of .leading, that's the default, .center. All right, so now that centers it. And then we want this font to be body, which again, body is usually, anytime you have like a paragraph or a description, you typically want that to be body. And then the last thing we want to add, because it does feel cramped, right? Look at it. I'm going to get rid of that red outline, right? It's all the way to the edges. It's pushed up against the test appetizer. So to fix that, we can just add some default padding around it. There you go. So see, it pushed it down a little bit into the middle, got it away from the edges, made it look a lot easier to read. Okay, so pulling up the design again, the next piece is our nutrition information. Well, you can see that's an HStack of VStacks. So let's build that. So under the text here, do HStack. And then in here, we're going to do our first VStack. And then you'll see we'll just kind of replicate it 3 times. So the first text we want is just a text. And this is calories. Now here we're going to change the font size to .font.caption. And again, I just played around with this to get a size and feel that I liked. And I think if we did caption.font weight.bold, that's the look I liked. And actually, you know what? Let's do something a little quicker rather than spelling out font weight. Remember, we can do this on text, just to point this out for educational purposes. It really doesn't matter, but I just want to point this out. Remember, we can just do .bold on the text. So slightly smaller, but again, educational purposes. So now the next text we want is our actual number. So text, and we want this to be appetizer.calories, right? And that's an int, so we need to do some string interpolation here. I'm doing this string interpolation way backwards, but whatever. There we go. So now you see 99 calories under it. Now we need to format this a little bit. Foreground color, I'll scroll up. Remember this is secondary because we want it to be that gray. We want to do font weight, semi-bold, and then italic. So there you go. You see we get that look, right? The italic's 99. Now, in this VStack, right, the calories in the 99 is kind of cramped. So I want this VStack to have some spacing of 5, right? So you see that made it breathe a little bit more. So now what we're going to do is copy this VStack 2 more times, right? Because it's going to be the same format. And we're going to refactor this whole screen in another video. We just want to get it working first. So 1 VStack, 2 VStacks. And now you can see it's not looking exactly like we want, but you can see the structure is there. So let's go up to our HStack. And if we want these to be spaced out a little more, like look at the red box. Like maybe I want that to be wider, they're too close together. So again, we can add some spacing on our HStack, and we're going to, let's try 20. Let's try 40. Now again, just tweak it, dial it in. It's the nice part about these previews. Okay, that's spaced out enough. I feel like it looks symmetrical with the rest of the text in our VStack. So we're gonna go with 40. Now, the only thing we have to change is we don't want calories every time, right? We want carbs, and then make sure there's appetizers.carbs, and then protein, and then appetizers.protein. So there you go. Now we're starting to get this layout looking good. The last thing we need is to style our button. So here in our button label, instead of, well, we'll keep just text for now. We're going to change that in a bit, but I want to get it formatted first. So let's change our font. So we'll do font is going to be title 3 and font weight dot semi bold. And then our frame is going to be 260 by 50. Remember, this is kind of my go-to button size. I feel like it feels like those Apple buttons. We do need to give it a dot foreground color of dot white, because we want our button title to be white. Well, we just lost it, so let's give it a background color. Dot background color, so we can see our text here. Color dot brand primary, right? Remember, we created the extension on the color so we could use it easily. So there you go. There's our button. We are missing our corner radius, so dot corner radius of 10. Okay, so now looking at our preview, let me click off so I can get rid of that red outline. Cool. You can see our card of our description is coming into shape, right? We have everything we need. Looks good. We're missing two things, right? If you look at the design, our button actually shows the price of the item. So we want to incorporate that into our button. And then we're missing the overlay, which is in the upper right-hand corner that has our X button that we use to dismiss the detail view. So let's take care of that. Okay, so back down to our button. The title, again, we don't want it to be button. We want a $ string interpolation here to get our appetizer dot price. But if you look at our button, remember, we have to use the specifier to say we only want 2 decimal places. We don't want all those decimal places, unless you do for some reason. Specifier, again, the string is %.2f to give us the 2 decimal places. Cool, so we have the price of our appetizer. Now we can add a dash and say add to order. Right, so now the button says $9.99, add to order on the button. So cool, we've customized our button to show the price, and it's dynamic based on whatever appetizer we have. Okay, so now let's talk about our overlay, and this is new. We haven't talked about this yet. So on our VStack, right, which has our frame, shadow, corner radius, we're going to add an overlay. So I'm going to start off simple, and then we're going to build up to our button just to explain this. So if you do .overlay, you can see it takes in an overlay content, right? So let's just, for right now, let's give it a text of, we'll say, test, right? And then you can see, or I put text, let's say test, right? So you can see it's right in the middle, it overlays it. It's kind of like a mini VStack, right? That's how it's treated. It's an overlay on your VStack. So right now it's in the middle. Well, we have an alignment parameter, and you can do, if you hit dot, you can see bottom, bottom leading, top leading. So let's do top trailing, because we want it in the upper right-hand corner. So if I do that, now you can see our test got pushed up all the way to the upper right-hand corner. So again, you can overlay text, you can overlay basically any view. So this is going to look ugly before we refactor. This is also a good reason to refactor, but I wanted to show you the 2 basic elements, right? So you have your view here. Right now we just have our text. For us, it's going to be a button, right? It's going to be our circle with an X in it. And then you have the alignment. Okay. So just keep those 2 factors in mind. So let's create our view. And our view, again, is just going to be a button, which is the typical button layout here, right? You do the first closure here. And remember, the first part of the button is the action. So for right now, we'll just say print dismiss. And then here at the end of the closure, like I said, this is where it's confusing for right now. Label, and then the second trailing closure. This is multiple trailing closures. This is why you do that. So again, just the structure here, right? We have our overlay. The item that used to be a text, well, now just the highlighted part is our button, right? Remember the button structure? That just replaced our text. So the highlighted part is item 1, and then the second part is the alignment, right? I know this can look confusing the way we have it right now, but I wanted to highlight that. So now, just like the button up here, right? The label here, we can style however we want, right? Get our button to look what we want it to look like. Well, our button, that's the circle with the X on top, just think about the way I just said that. It's a circle with an X on top. That's the way our button looks like. So that's a VStack, right? The circle's on the bottom, the X is on the top. So VStack, and then we have the shape. Remember, we think we did this with a rectangle before in the barcode. Circle, same thing. But that's obviously not what we want it to look like. So let's give it a frame, and we're going to do 30 by 30, because again, it's kind of small in the upper right. There you go. You see how it pushed it into the upper right, and the reason it did that is because our alignment is top trailing. Right, so okay, so it's all the way in the upper right. We still got some work to do. We don't want it to be blue, right? So dot foreground color is dot white, and we want it to be white because even in dark mode, we want it to look the same. And then as a nice little touch, I like to do not just a solid white, just a dot opacity, and we'll say dot 6 for like 60% opacity. Oops, I got to put a 0 in front of that. So 0.6, and again, it's just subtle see-through, right? You can't really tell on the Asian flank steak image, but some of the other images you'll be able to see very subtle, alpha there. And then now we got to put the X on top, and we're going to do the same thing we did in the frameworks app, where we use the SF symbol for an X, and we're going to give it a frame to give it the bigger touch target, all that stuff. So this is a little bit of review. It's the same exact thing we did there. Really, the only difference is there's a white circle under it for styling purposes. But anyway, image. This is going to be system name because we're using the SF symbol. System name, and this was X mark. Again, same thing we did. Dot frame. We're going to give this 44 by 44. And this is a little trick I did, right? I didn't make the circle 44 by 44 because it looked ridiculous in my opinion. It was too big, too overpowering. However, you can still make your image, right? And you can see the red square around my image, which will also equal my touch target on the button. So that way I allow the user forgiveness on tapping the actual button, but it's kind of like invisible. And then actually on the image, let's do .image scale. And then here's what we can do like medium, .large, right? If we do .large, that's too big. That I don't like the way that looks. Keep an eye on like the upper right as I change this. Let's do .medium. That's okay. I actually think I like the small better. I just like the way that looks, right? Okay, cool. And then the last thing we need to add is the foreground color, because right now it's a blue X. That doesn't go with our motif. So we want to do foreground color .black, not blue, black. Right, there you go. So that now our X is black, as you can see in the upper right-hand corner. So the styling and layout of our detail view is complete. I'm curious, if you did the challenge, how different was mine? Did you see anything that you disagree with what I did? I'm happy to discuss that in the comments. Did you see anything I did that was like, oh, wow, great idea? Again, I always like comparing and contrasting other people's implementations because like I said, there's many different ways, to put this together. But the last thing I want to mention, because we're gonna keep working on this for 2 more videos, is look, this is quite long, and believe it or not, you'll see a lot of SwiftUI code like this that's not refactored out, and I just think this is hard to read. So in the next video, we're going to connect the detail view. That way, when you tap on a row in the list view, we'll show this. We're going to get all that connected, and then in the video after that, we're going to refactor it, and that goes back to the lesson of like get it working first, then refactor. Right? That's the thing I want to drill into your head as well. So let's move on to getting all this working. We left off last video getting our appetizer detail view UI built. Now let's connect it to our list view. So if you go to appetizer list view, let's talk about how we're going to do this. Okay, our preview, let's just get rid of the preview because we're just gonna be looking at the loading screen the whole time. So I'll buy some screen real estate. So thinking about how we're gonna do this, right? We wanna tap the list row, right? The appetizer list cell, we wanna basically add a way to tap. If you're familiar with UIKit, we're basically implementing the same thing of like did select item at index path. However, we don't have index paths, we don't have table view delegates. It's much simpler than that in SwiftUI. We do on our cell, right? Not on the list, like on the actual cell itself, because we want to know like which one we tapped. We can do it modifier on tap gesture, and then we get the code here. And what we want to do here is one, display the detail view that we have. But we also need to pass data, right? We need to pass whatever appetizer we tapped into that detail view. Okay, so we're gonna need a variable for the selected appetizer, and we're gonna need, a state variable like is showing detail, right? Back to the whole reactive programming declarative, right? We need to flip is showing detail, and that's what determines if the detail view is showing. So let's do this one at a time. Let's first get our detail view showing. Okay, so here we're gonna create at state private var is showing detail. It's going to equal false by default. And when we do the refactor in the next video, we're going to move this into the view model. Again, I like to get it working here first and then refactor. Okay, so on tap, we want to flip that to true. So is showing detail equals true. Okay, so we're changing the data, but like nothing's listening to that data yet. Well, let's create that. And very, very similar to what we did with our loading view, right? Like remember a couple videos back, like if we're loading, hey, slap the loading view on top of the ZStack that we created. Well, our detail view is also going to go in the ZStack. However, it's above the list view. Like as you see in the design, we have the list view in the background with the detail view on top, but it's not above the loading view. So it's in between them. So again, very similar concept to the loading, right? If is showing detail, then we'll show the detail view. So appetizer detail view all the way at the bottom, initialize a new one. We're gonna have to initialize that with an appetizer. For now, we're gonna initialize it with the sample that we're using, right? The mock data run. We're gonna eventually switch that out, but just to get this first part working, let's try this. Mock data.sample appetizer. Cool. Okay, so now let's run the app and try this. So again, we put a tap gesture on the cell. When the cell is tapped, we're flipping our is showing detail, to true or false. And because we're watching that is showing detail, because it's a state variable, we're going to redraw. And then if is showing detail is true, then we're actually going to initialize the detail view and show it, in theory. Run it, see what we got here. Okay, let's tap on, let's just pick one, right? Let's pick meatballs. Okay, well, it didn't matter what we picked because we're not passing the data yet. All we were testing was to make sure we got our detail view showing up when we tapped the cell, and we did. Okay, so now the next thing we want to do, actually while we're here, because right now, like I'm just tapping dismiss and nothing's happening. So let's get that part working again before we start passing the data. So we're just going to get the structure of the UI working first. If you remember, it's the same thing as the framework detail view that we did before. So we're going to need a binding to is showing detail in our appetizer detail view, right? Because when we tap the X on our appetizer detail view, we want to flip is showing detail to false. So this redraws and then hides the appetizer detail view. Okay, so on the appetizer detail view, another property, we need at binding var is showing detail, right? And that is a bool. Okay, if I do a command B, Xcode is going to yell at me because now I have to initialize my appetizer view with the binding. So back to the appetizer list view, do command B because I want Xcode to yell at me right here. Cool, missing argument and parameter, right? It's saying, hey, you said I had a binding, you're not giving it to me. So is showing detail, we want to pass a binding to is showing detail. And again, I know I'm repeating myself, but really driving this home. That is a binding to this state var here, right? So think of a binding as almost like a reference, between views. And then again, I'm going to put the parameters down here for ease of reading. Okay, so now that my detail view has this Boolean, I need to flip this Boolean accordingly. And where I want to flip this Boolean is in my overlay down at the bottom that we created. Oh, the previews. How many times I'm telling you, you're going to be so annoyed with these previews. So again, we want to, for the previews, we can do .constant and then just give it, a value, true. And then for ease of reading, cool. Okay, so anyway, back to our overlay button, right? Remember the circle with the X button? Well, here, instead of just printing dismiss, which you can see in the console as I was tapping it, now we want to do is showing detail equals false. And again, that will change this binding, which is a binding, or if you want to think about it as a reference, to this is showing detail. It'll flip that, it'll redraw the view, and then we will not be showing the appetizer detail view. Let's test it out. Cool. Click on chicken dumplings. There it is. Again, we got more work to do with the UI, but hey, it's showing up. Hit the X, it dismisses. Great. The basics are done. Tap on another one. Cool. There it is. Now, again, before we pass data, let's set up our background blur. Because again, looking at the design, right, it's a nice blurry background on top. You can see the shadow making it pop. Back to what we have, like this doesn't look great. Not to mention it doesn't look great, but look, I can scroll behind. You don't want that. And I can like even tap something else. I mean, you can't. It does pull up another detail view. You can't see it, but it messes up our UI like all the time by like being able to scroll behind that. Okay, so let's handle the blur, and then we're also going to disable the list so you can't interact with the list while the detail screen is showing. All right, so let's do the blur first. So on the navigation view, right, that's what I want to do this on. I don't want to blur out everything else, just the list essentially. So under on appear, I want to do dot blur. Pretty straightforward. This was a lot more complicated in UIKit. And then we want to give it a radius. I want to give it a blur radius of 20. However, not all the time, right? Because if I run this, that's not what we want, right? We don't want it on all the time. We only want to show the blur when is showing detail is true. So we can use the ternary operator here. So is showing detail, ternary operator. When it's true, be 20. When we're not showing detail, be 0. So let's run this real quick. So our blur should be gone because is showing detail is false. Cool. Blur is gone. Now let's tap an item. Cool. Blur is there, right? That's the look we're going for. Now you can see I can still scroll in the background, right? That's not what we want. Bad behavior, not what we want. So now that the blur is handled, let's disable the list using the same logic here that we only want to disable it when is showing detail is true. So disabling a view is quite simple as well. And we want to disable our list. So below the navigation title here, which is our list modifiers, type .disabled, right? And now we need to pass in a Boolean. Well, what Boolean do we want to pass in is showing detail. So is showing detail. And what this will do is, if is showing detail is true, disabled will be true. If is showing detail is false, disabled will be false, which is the behavior we want. Let's run it and test it out. Again, you want to be testing like step by step, so like if you have a bug, like what broke it. Okay, now look, now I can't scroll on the back. So that is the behavior we are looking for. The only thing we are missing here is actually showing the correct data here. So let's stop running this and let's talk about that. At the beginning of the video, I said we're going to need two things, right? We're going to need the variable for is showing detail. We've handled that. Now we're going to need how do we track the selected item, right? What appetizer was selected? We need to, track that somewhere because we need to pass that into our detail view, right? And we have that appetizer locally, but only locally like on our list, right? We don't have access to it outside of that scope into our detail view. So we need to create a variable that holds that. And it needs to be state, because again, we want to hold state. We don't want it to, revert back to no value. When our view gets destroyed and recreated, we want to hold state here. So state private var, you can say selected appetizer, and that is of type appetizer. And it's going to be an optional because right now there is no selected appetizer in the beginning. So now what we can do in the tap gesture, we can set the selected appetizer to whatever appetizer was tapped, right? We have access to that locally. So we can do selected appetizer equals appetizer. So now that we have a value in our selected appetizer, now we need to pass that selected appetizer into our appetizer detail view. So just pass in selected appetizer. It's an optional. We'll force unwrap it for now. Now let's test this. Hit play. And we're going to see it half working. Okay. And see if you can think about why it will be half working. You may not know. It's because the image, watch the image no matter what I type or tap. So I tap meatballs. Cool. I get the meatballs title, the meatballs description, all the stuff about the meatballs, just not the image. The reason being is because we never set that up. Remember, we just used our dummy image. So let's close this, go back to our appetizer detail view. And instead of just using the image, which we hard coded to Asian flank steak, right? Well, now we can do our appetizer remote image that we created a couple videos ago, right? And the URL string is going to be appetizer dot image URL. And then again, because we're already using resizable within the remote image, we can delete that, do a Command B, we should be good to go. Now, the way we have this set up, like you may be thinking, oh man, we got to download this again when we tap it. But if you think about how we have this set up on downloading the images, remember, we're putting them in the cache with the image URL as the identifier. So what's going to happen, I'll walk through this. Well, let's make sure we have it working before I explain it. So let's tap on chicken avocado spring roll. Cool. There's our chicken avocado spring roll. There's the long title, description, everything seems to be working. But what's going on here is when I tap this item here, right, I'm not actually downloading the image again. And that's because we put it in the cache. Back to our network manager, right, what happens here is it's going to go into download image, but the first step of download image is to pull it from the cache if we have it. And because we've already downloaded them the first time on the list, they're pretty much always going to be in the cache when we go to the detail screen. And if for some reason it's not, okay, we'll download it again, but that should never happen. Famous last words of the developer. That should never happen. We're good. We're safe. So anyway, that is our detail view, connected, up and running, working. Again, just the basics of it. So cool, looking good. And then in the next video, we're going to go back to our appetizer detail view and clean this up a little bit. And then in our appetizer list view, right, we should have these on our view model, not in our view. But again, I wanted to get it working and then refactor. So let's do it. We left off last time getting our detail view just connected to our list view with a blurry background, looking good. What's not looking good is our appetizer detail view. It's what a mess. So let's stop this and let's start refactoring. I'm going to start with the buttons just because I feel like we've done that before. That's kind of a review. So let's refactor out this kind of main button. Again, this is the price button at the bottom. This should be review. I think we've done this twice now. But here in the views folder, let's create a new group called buttons. And within buttons, new file. And we're going to make this a SwiftUI view. We're going to call this AP button. Again, AP short for appetizers. Hit create. Cool. And then in our appetizer detail view, I can literally copy and then back to the AP button, replace text with paste. And instead of, we're not going to like pass in an appetizer, which you may be tempted to do because not all buttons are going to need appetizers. We just want to pass in the string that is the text, right? So we're going to do let title, and that is of type string. So we can just get rid of all this and make this the title, right? So whatever title we pass in, that's what it's going to be. Again, keep all our formatting there. Cool, good to go. Let's check out the canvas. Oh, I'm going to need a title that we did. Again, previews always get me. Maybe you're better about the previews than I am. They always get me. So we'll say test title, and let's pull out the canvas just to make sure we got this. Cool. Yep, there is our button. So if you did want to play with the button, maybe make a crazy gradient or shadows or whatever you want to do, this is your playground to like test that out. Okay, so back to the detail view. Here we already have our button highlighted. Let's do, I'm gonna keep that text because I'm gonna copy and paste it. Actually, I'm gonna copy it right now. Or Command X, whatever. Just get rid of all of it because this is going to be a AP button, but an AP button takes in a title, and the title is a string that I just copied or cut and pasted, right? So that's the string we want to put for the AP button. Hit try again. Okay, what did I mess up? Oh yeah, that's right. Just a normal string doesn't have this specifier. We need to go back to our AP button and make this a localized string key. And then now if we go back to the detail view, do a Command B, now we get that specifier. Okay, so there we go. We got our specifier now. Our preview still looking good, and our AP button has been refactored. So now the other button we want to refactor is our circle X, right? Because that adds a lot of like bloat to this overlay. Makes this overlay like 12 lines of code. So let's basically do the same thing we just did, right? We can we'll go ahead and cut it actually. So Command X to cut that ZStack, and in buttons, new file, new SwiftUI view. Call this, I can't remember if it was dismiss X button or X dismiss button. I'm gonna go with X dismiss button. Again, because this is a common type button that you're probably gonna use, throughout your project. And instead of the text, we're going to copy and paste the ZStack there. Let's take a look at our preview. Yep, there it is. Again, you can't see the white circle because we're on a white background. That's all good. Let's go back to our appetizer detail view. And instead of having nothing here, let's call X dismiss button, and there's nothing we got to pass in. It's just generic. Okay, let's run this to make sure our refactor is working. Make sure our X dismiss button still looks how we expect. Yes, it does in the upper right, and we tap it. We're good. Okay, cool. Stop running that. So again, I always like to test along the way on the refactor because it's very common to break things, when you refactor it, thinking you got it all set up right. Okay, so the next thing I want to take a look at, right? We refactored our buttons, got that looking nice and neat. The next thing I want to look at that's really kind of out of whack, right? Like our image, that's fine. The top text of our VStack, this is a font of title 2, semi-bold. This is very different, right? It's body, multi-line text center. So you don't want to like refactor that into the same thing. I mean, you could refactor these out. So this would just be like, description text, and then you pass in description. I find that unless I'm going to reuse that like all over the app, then yes, of course, refactor it out. Maybe you want to refactor it out for practice. Great, even though we're not going to use it. But I find when there's just like one or two modifiers, I think it's simpler to keep it here because it's easier to change. It's easier to like see what's going on. It's in the case of like our button, right? Like going back to the AP button, like when you have, 6 modifiers, X dismiss button, like it's a Z stack, like that type of stuff, I refactor even if I do only use it once. But back to the detail view, like I said, there's only 2. I'm not really reusing it, so I tend to keep these, but if you want to refactor it, I wouldn't argue against that. However, these VStacks, that are nutrition, right? These are being reused. So I would refactor these. Okay, so what are we going to need, right? We're going to need a title because it's different every time. And then we're going to need a value, right? The 99 that we'll pass in. So let's Command C. And again, this is the case where I would keep this in the same file. Again, unless you were using this nutrition stuff elsewhere in the app, but I would keep this in the same file just for ease of use. So we'll call this struct nutrition info, and that is of type view. And I'm going to scroll up, get it out of my face. And we got to conform to that, right? So var body some view, again, the typical SwiftUI view. Now, like I said, it's going to take 2 properties, right? So we need let title, that's going to be a string. And then let, we'll call it value, and that's going to be a string as well. And in fact, you know what? I'm actually going to make this an int, just to be very clear what we want to pass in, because we'll handle a string interpolation down here. Okay, so again, let's paste the VStack that we copy and pasted. Okay, so instead of calories, I want title, right? So whatever we pass in. And then here's where we're doing that string interpolation. So it's expecting an int, so we'll just pass in value there, right? So title and value. And now let's go up to our HStack. And instead of having 3 VStacks here, we can do nutrition info. And you can see that's going to take in a title and a value. And the title is going to be carbs, and the value appetizer dot carbs. And then I'm going to delete these VStacks because we don't need them. And really just copy and paste our nutrition info 2 more times. So 1, 2, cool. Hit resume on our preview to make sure everything is fine, cool. Except, yeah, obviously we don't want carbs each time. We want this to say, actually, I think I got those out of order. I think it's supposed to say calories, then carbs. I think it was calories, protein, carbs. Either way, the order doesn't matter. Do whatever you want. Calories, and then carbs, and then protein. If I change the order, oh well, not a big deal. But you can see how our HStack looks nice. And the reason why I didn't like refactor out the whole HStack, because you could have done that and then just said like nutrition info HStack or something like that. I think when you look at the screen and you see this, 3 of these, like to me, looking at this image that's in the red square and then seeing this, to me, I don't know if maybe I'm just experienced with code and maybe you don't see that, but that's automatically related, right? It's obviously 3 of the same items. I can see that's 3 of the same, when I say items, like UI elements, I should say. 3 of the same UI elements, and I can see that's 3 of them. So to me, I make the connection in the code by having this spelled out with 3 items. So again, I'm just giving you the insights on like how and why I choose my style and to format my code like I do. Because again, I'm always aiming for ease of understanding, right? I'm not trying to be super clever. I'm not trying to be like, hey, look, I did this in 4 lines of code. Like, no, that's confusing. What is the easiest to understand for a new developer coming in? That's what I'm always thinking about when I try to style this. So now that we have that refactored, I would say our screen is looking a lot better, right? Let's run through it again. We have our overall VStack, which is the card, right? And this is all the formatting on the card, the shadow, the corner radius, the background color. Cool. And then we have our VStack, which is the text information here. And then within that VStack, we have our HStack with the 3 nutrition info views. And back to the refactoring discussion, like I said, if you wanted to make this just like, title view, body or description view, that could clean it up. Again, we've discussed that. I don't want to go down that path again. Our button, nice and clean, AP button. And then our overlay, nice and clean, X dismiss button. So I would say our nutrition detail view refactored pretty well. Now let's go back to our appetizer list view. The last thing we're going to do in this video, get rid of the preview here because it's useless. Now the small adjustments we want to do here is, like I said, the view should be as dumb as possible. So we want to move our is showing detail and selected appetizer into our view model. So I'm going to Command X to cut that and get rid of that spacing there. Open up our view model, and then here below our variables here, create 2 more. And then instead of @state in private, again, these are published because we want to let whoever's listening know when these values change. Okay, and then as you may have guessed, now that we no longer have is showing detail and appetizer in our list view, we should get some errors here saying, hey, yeah, what is showing detail? So again, it's view model dot. And then when I refactor, and I know I'm gonna have to type view model dot everywhere, I'll copy that and then, just kind of paste it in front of all the stuff that's applicable, which again is our selected appetizer and our is showing detail. So that's all I did. If you thought that was fast, all I'm doing is pasting the view model dot in front of everything. And some people, maybe view model's long. This is subjective, but some people will do VM for view model to keep it short. Some people just say model. Subjective, do you. But anyway, let's run this and make sure we're looking good after the refactor. Cool, chicken avocado spring roll, looking good. Dismiss that. Everything seems to be working. These stuffed shells are my favorite. I just want to keep looking at them. This app has made me hungry like all the time working on it. I see add to order, just the tap that shows up. So we need to eventually have this actually add it to an order to show up in our order screen. We're going to create our account screen, but all that is to come. Let's keep it moving. Over the next couple of videos, we're going to get this account screen that you see here up and running. And if you look at this screen, like it's a pretty common looking screen, right? It looks like a typical setting screen, account screen. These are like all over the place in iOS apps. And this type of screen for building the UI for it, like this is where SwiftUI really shines because we have an element called form that basically does a lot of this stuff for us. And it's great. So that's what we're going to build over the next couple videos. Let's get going. Okay, so here in Xcode, make sure you click on your account view, right? Remember we set up this just basic skeleton view, which is like our network view, shows account. Let's actually pull up the canvas to see this. And as always, make it small, hit resume, zoom out a little bit to 75%, so it's not ridiculously huge. We are on the iPhone 12 Pro, cool. Okay, so like I was saying, just the basic view we set up before. Well, let's wrap this text in a form and then watch the preview. You can see what we get just by wrapping it in this form element here. Let me actually put the text inside the form, Command X, and then put our navigation title on the form element. Cool. Now, if we look, you can see the beginnings of our form, right? It's just a text. This is account. It's not a text field or anything like that, but you can start to see it taking shape, and we get that format automatically just by being inside this form. And now we're going to format our first section, because again, if you look at the design, you see how our form is broken up into sections with section titles. Well, that's also relatively simple as well. So inside our form section, we initialize that, and you see it can take a header and then content. So the content is what's going to be inside, which is going to be our text. Our header is going to be a text that says personal info, right? This is going to be our first name, last name, email, and then content, just like we've done with all these before, is now our view builder here with the text. Put the text inside the section. So now you can see what it looks like. Do a Command B, make sure all of our errors are gone. Cool. Resume the preview, should be good. But now you can see again, our form starting to take shape. We have the personal info label, that's our section header. And then we have one element in the section, which is just our text of account. But again, it's taking shape. But we don't want just a text in here. We want a text field. And this is the first time we've been using text fields. So new stuff here. So text field, you initialize that. Just like a lot of stuff, there's different things you can initialize it with. But the main thing I want to point out is the binding to the text. So the first part of this, I'll just hit return here. The first part of this title key is the title, like what you want your text field to say. So this is going to be first name. And then the text, we need a binding to a variable to hold the value that's in the text field, right? Like if I were to type Sean in the text field, I need something to hold, that value of Sean or whatever I type in there. So here we need a binding to that. So we can create a state variable up here. So at state private var first name, and that is of type string. Actually, we won't typecast it. We'll go ahead and just initialize it with an empty string. Use the type inference there so we know first name is a string. So now when I put the binding to this first name variable, now whatever I type in the text field will be the value of my first name, right? They're bound together. So again, for the binding is $, first name. We get that. So hit try again to rebuild our preview here. Now this account text view on the preview will turn into a text field if my preview ever gets going. Try again. Tiny man, these previews. So there you go. Now you see the text field with the first name, right? You see that's the title we gave it. And then the value as we type in, like if I hit play and I start typing SEAN, right? So now the first name variable is going to be whatever I type in there, right? We've created the text field and bound it to a variable. That's how text fields work. We're going to do this a couple more times, but that's the overview. So pulling up the design, we're going to need a last name and an email. So let's build those two text fields as well. And it's going to be the same thing as the first name, last name. So we're going to copy, do paste, paste. So instead of first name, we want last name. And instead of first name, we want just email, right? And now we're bound to first name. That's not what we want, right? We got to create state variables for last name and email. So again, I'm just going to copy the first name, paste, paste. And you see invalid redeclaration. Yep, I know I got to make these different. So last name and then email. And then we'll hit resume on the preview. And then again, now you can see the form coming together. First name, last name, email, and these are all text fields. Now, just like text fields in UIKit, you can customize them. So for our first name and last name, we want auto capitalization, we want maybe autocorrect, or maybe if you don't, turn that off. But in the email, we definitely want to turn that kind of stuff off. So I'm going to show you how to do that on the email text field. And you can do this with modifiers. So I can do .keyboard type. And you see if I hit dot, there's a whole bunch of keyboard types, right? Like if you were entering a phone number, you can show that. Well, for email, there's a special email address keyboard type. So let's make sure we do that. So again, pulling up the proper keyboard. And then we can do auto capitalization equals none. You see sentences, words, all characters. For an email, we want none. We don't want any auto capitalization. Same thing with autocorrect, right? Don't you hate when your email autocorrects, right? So we're going to disable autocorrection. Okay, so we have the first part of our form, coming together, pulling up the design. Okay, we need a date of birth and then a save changes button. So before we've been dealing with text fields, Now we need a date picker and a button in our form. Well, it's just as we do the text field, it's the same kind of flow here. So I'll scroll up a little bit. We can do date picker and get the initializer here. And I want to do title key, selection, and then displayed components. So this displayed components is the important part because, a date picker can be flexible. You can be picking a time. You can be picking a time and a date. You can be picking just the date. Well, in the case of our birthday, we just want the date, right? Like I don't need to know what time you were born. I just need to know the date. So we'll use that one. So the title key, again, is what we want it to say. So we want this to be birthday. And then the selection is just like we had to do with our text field. We have to keep this value in a variable. So again, at state private var birth date is going to equal just initialize a new date for the start. So now let's set up that binding here. So $birth date. So again, now whatever date we select from our date picker, we're going to store it in this state variable of birth date. And then like I said, displayed components. So I'm going to hit dot, and you can see date, hour and minute, etc. We're just going to do .date because again, we just want to know the day. So hit try again on the preview. And you can see now we have the birthday that says today's date, November 16th, 2020. And if I actually run this, now when I tap on that November 16th, 2020, you can see we get the calendar, and then we can go back and select our birth date. Now you might be noticing like a user experience issue, right? Like, man, if I was born in 1981, I know I'm old, I'd have to go all the way back to like 81, right? So we're going to fix that in the optimization section where we actually come up with some logic as to like what type of date we want to show and dive into that. But again, I don't want to derail this video with that quite yet. We'll come back to that. Let's get our form built. So now that we have our birth date, we just need a button, right? We need that save changes button. So if we change any of this or create this, we can save it. Okay, stop that from running. Now we're just going to put in a normal button that we've used a bunch of times in the course already. So we'll do button. Again, the first closure is whatever you want the button to do. For right now, we're just going to do print save. And then the label is what we want the button to look like. Again, in the multiple trailing closures, the second closure here, we just want a text, right? We're not going to get fancy. The text, we can't get too fancy in a form anyway, but we're going to keep it simple. So save changes, right? And now you can see our button show up in our form on the right. And then when we tap it, for now, it'll print save changes. We'll do more with that in a future video. Again, this one's all about getting the UI set up. And speaking of that, our first section, right, with the email, first name, last name, email, date of birth, button, right? The first section is all set up, nice and neat. The next section, as you can see on the design, is where we start introducing our toggles. So let's do that. So as you can see, I have this section highlighted. I'm not going to copy and paste because I'd have to delete a lot, but I can just create a second section. So section, again, we initialize it with a header and then content. So again, the header is a text. And we're going to call this requests, right? Extra napkins, extra refills. I just thought of some cheesy requests that you might want at a restaurant to demonstrate this. It's not easy coming up with like a sample app that properly demonstrates all the stuff you want to teach and makes sense. That's tough to do. So anyway, like I said, we want this section here to have the header of requests. There you go. You see my little request title. There's nothing in there yet, but we want these toggles. Well, that is just a toggle. And we initialize the toggle, the same way we've been initializing all this other stuff, right? We have to give it a title key and then it is on. So the title key is again what you want the title of the toggle to be. So for our first one, that's going to be extra napkins, and then is on, again, same concept, right? We need to bind this to, something's got to hold the Boolean here. So we'll do at state private var extra napkins, and that is going to equal false to start. And I like to give these default values because if I just left it, say, hey, this is of type bool, then when I initialize my account view, like I have to initialize these with like initial values anyway. So you might as well just kind of like do that here. Okay, so I'm just going to copy and paste this because we're going to need this again. Instead of extra napkins, it's going to be frequent refills. This is our other option in the toggle that we can do. I'm just kind of getting ahead of myself here. So anyway, the toggle on extra napkins is, you guessed it, $extra napkins. And then let's hit try again on the preview, get this going so we can see this. Cool, there you can see our extra napkins toggle. And let's go ahead and copy and paste this because we're going to basically need another toggle for our frequent refills. So again, instead of extra napkins, frequent refills, and then is on is not going to be $extra napkins. It's going to be a binding to our frequent refills boolean that we just created up here. So now let me run this on my preview, and you're going to see something that we want to change here. So I'm going to hit play. Extra napkins, cool, and I can toggle these, but it's that default green toggle, which really clashes with our brand primary, right? Pulling up the design, we got that dark green that you see. So we need to add a modifier onto our toggle to give it that dark green color. So if I stop running this, I don't know why I keep stop running that. I can run that. I'm so used to being like a simulator where you got to stop and start it. You can keep that running. Anyway, so on the toggle, we can do .toggle style that you see here. And that toggle style will take in a switch toggle style. And then if I initialize that, you can see it takes in a tint, which is a color. And we have .brand primary, right? Remember we created that extension on color to give us our brand primary color. Cool. Now let's run it again on the preview. See, extra napkins is that dark one, but frequent refills is not, right? You can see the difference there. So what you could do, and this is not what you should do, but you could do copy, paste, look, and then now when I flip these, cool, now they're both dark. Well, if you remember all the way back to when we talked about modifiers, there's certain things that are environment modifiers. So like if I have a bunch of toggles, I don't have to have this like on each one, right? My environment for these toggles is this section. So I can put this toggle style on the section, and what that will do for me is every toggle in that section will get that toggle style, right? So I don't have to stylize each one individually, just put that on the section, and now, again, toggles are still dark green. So now let's run this in the simulator to make sure everything is working good, outside the preview, because the previews can be weird sometimes. Again, I always like to confirm on the simulator. Okay, so here we are. We have our typical table view. Let's tap on account. Cool, we have our account screen, and you can see we got the dark green on our date and our save changes. That's because it's part of our Tabbar tint color, and that's why it doesn't show up here on our preview, because that preview is outside the context of our Tabbar, because it's like solo, the preview. Well, now that we're within the context of our Tabbar, we get those tints. However, we had to change our toggles manually like we did just there. So there's our account screen, the UI, looking good. We have our text fields here, Sean. Oh, we messed this up. See, we forgot something, but that also demonstrates the power of binding, right? So accidental lesson here, you can see my code on the left here, right? All my text fields are bound to first name. We forgot to change that. My mistake, but I think it illustrates, if you weren't sure what binding does, I think now you can kind of see it, how, no matter what I put in the text field, it's bound to this variable. So that's going to be the value, right, for all my text fields. Okay, so let's stop this. Let's fix our mistake here. So we're not bound to first name. We are bound to last name, and we are bound to $email. Okay, let's run that again to make sure that is working. Again, oftentimes mistakes lead to good learning lessons here. So, okay, so account, here we have Sean, Alan, cool. That is working. We can tap on that. Nice. I even misspelled my name. Cool. Anyway, so that is the UI, right? Again, the main takeaways here are just this thing called form. And the nice thing about form in SwiftUI is forms look different on the Apple Watch, on the phone, on a Mac. But if you wrap it in form, you're going to get like the native looking form for whatever platform you're on. So form is like really powerful. And then again, if you want the section headers, you just create the section and then put your items, within it. And again, the text field, the date picker, the button, because they're within form, they automatically take the styling that a form expects, right? When you put a text field, off by itself, not within a form, like on a normal view, it's going to look different. Same thing with the date picker and the button and all that stuff. So it's nice that things inside a form will adopt the proper styling. Okay, that wraps it up for just the basic UI. In the next video, we're going to refactor this into the view model, add some basic text validation, because we want to be careful what the user's like submitting, so they can't just submit like all kinds of like gibberish and cause all kinds of network errors. So that's what we're going to handle in the next video. Let's keep it moving. Last video, we created our form and got the UI structure for our account screen done. In this video, we're going to refactor a bit into the view model and then also implement some text validation and a little bit of error handling. Okay, so the first thing we want to do is in our account view folder, because again, the view model should go in the same screen here, do Command N for a new file, SwiftUI, nope, just Swift file, not SwiftUI view. This is our view model. So account view model, cool, hit create. And again, I don't know, my personal preference, I like to have the view model on top of the view. And okay, cool, import SwiftUI. Hopefully some of this is starting to be review, right? And maybe you can even try to do this yourself before I do it. I know I didn't issue an official challenge, but if you want to try it, give it a try. Final class account view model, and that is going to conform to observable object. And then now before we go any further, let's go into our account view and actually create that view model. And again, we're going to initialize a new one. So when we initialize a new one, which one do we use? At state object. We actually haven't even used observed object. And again, it really depends on how your data is structured, if you're passing data, etc. But anyway, state object var view model equals account view model, initialize a new one. Okay, while we're here, what we're going to refactor is all of this stuff and some other stuff, but to start, all of this stuff here, right? So I'm going to Command X, copy that, go back to our view model. We're going to paste it here, and then a little quick editing trick. If you hold Option and drag here, you can like edit these all at once. So these are not state private vars anymore. Remember, they're going to be published, because when these change, we want to publish it. Our account view is going to be listening to those changes, right? Said that a bunch of times. Hopefully you get it by now. At published var. There we go. And now, as usual, when we go to our account view, we're going to get all kinds of errors because we no longer have first name. We no longer have last name, right? Well, just like we've done before, we're going to do view model dot. And then again, just like I've done before, I'm going to copy the view model dot, paste it in right in front of the $sign everywhere I need it. Okay, so basically I just changed all the variable names from just their normal variable names to, view model dot, whatever we needed. I did a Command B, hit resume, no errors. We are good to go. Again, I just like to test along the way. This should be working, but pulling up the simulator, hitting account, cool. I can type something. All right, cool. Again, just want to make sure you don't break anything when you're doing these big refactors. Okay, so that first part of the refactor is out, right? In the view model, we got all the properties here. Now we want to start validating the text. Because again, like we want to let them know if they entered a wrong email, like if the email didn't have an @ sign or didn't have .com at the end, right? We want to let them know if it's valid. Or we want to like, hey, if they missed a field, we want to pop up an error saying incomplete form, please fill out everything. So this is just basic text validation. Text validation can get pretty tricky if you have a very extensive form, but this is just kind of a basic, couple examples to get you started on that. And for that, we're going to create a computed property called isValidForm. So I can do var isValidForm, and that is of type Boolean. And the computation that has to happen is here's where we check to see if it's valid or not. And the first check we want to do is to make sure all the forms have some value in it, right? Make sure it's not an empty form. So we can do guard not first name dot is empty. So we're checking for an empty string, right? But we want to make sure like it's not empty, right? So basically we're going to do that for our text field. So and not last name dot is empty. Again, same thing for the email. And email dot is empty. Cool. So if well, we can put this all on one line because we're just going to return false, right? So if any of these are empty, we're returning false, basically. So isValidForm is not valid, it is false because we have an empty field. And again, I just put that all on one line for neatness. Oh, I forgot my else. Yep, there we go. And then Xcode's telling me I'm missing my overall return. So how this works is return true. Basically, we're going to do these checks, and if the checks fail, we're going to return false. If all the checks pass, we're going to return true for isValidForm. That's the rundown here. So our first check is to make sure we have values in all the fields, to make sure it's not like an empty form. Cool. Actually, you know what? I just realized I can't put these all in one line because I got ahead of myself. We are going to be, showing an error item or an alert item. So we'll make room for that for later. So the next check we want to do is to make sure the email is valid. And this is very common. Like anytime you have like a login screen or anything like that, you're probably going to want this check. So this is well, I'm getting ahead of myself. Let's type this out first. Guard email.isValid. Well, what is that is valid? We don't have that yet. I know. We'll get there. Else return false, right? And we're going to pop an error message up there. So we'll leave room for that. Okay, so let's talk about this is valid. This is going to be an extension on a string that uses a regular expression to check to make sure it fits a proper format. So as you'll see, this is kind of complex and well beyond the scope of SwiftUI fundamentals, talking about regular expressions, but I'm going to include this extension as a file that you can download. It's real short, but go ahead and download it from below the video and then copy and paste into your own project here. But in our utilities, right, in our extensions folder, do a Command N for a new file, new Swift file. This is going to be a string extension, so string plus ext. that's the typical format for our extensions. And then I'm going to paste this in as well. I'll explain it, don't worry. But this is something that I carry with me from project to project because, again, you pretty much always need to make sure the email is valid. And this is why like I'm not going to explain this because I'm not gonna lie, I don't know how to write these regular expressions. You can Google like regular expressions for password validation and it's some combination of this gibberish, right? Don't get me wrong, it's valid. People know how to use this stuff. I never took the time to learn how to write this code off the top of my head. I don't suggest you do either, unless regular expressions are a huge part of like your job or your project. But typical things you're going to use these for are, to validate an email. Again, the password validation, you know how passwords have like, hey, 1 capitalized letter, 1 special character, must be 8 long. Like you can implement all those requirements via a regular expression like this. And again, it'll be another gobbledygook of characters. But kind of what this does here is you can see I have a certain range of characters where I can use capital letter A through Z, 1 through 9, and lowercase letters A through Z. It's basically alphanumeric. Here's some special characters I can use in my email, right? Dashes plus, but you see this plus @ sign? This means an @ needs to be in my email, right? Like my email can't just be Sean Allen, right? This is basically gonna make sure I have an @ sign in my email. And then before the dot and the .com, like I can have, this would be like the Gmail portion of the gmail.com, the Yahoo of the yahoo.com. Same thing, alphanumeric, capital A to Z, lowercase a to Z, 0 through 9, and then these characters. And then it makes sure it has a dot, and then it makes sure, again, A to Z. And then here's the thing. After the dot, like the .com portion, it must be at least 2 characters. So an example of this would be like .co, .us, right? 2 characters, but it can be max of 64. So that way you can't just have like .z, like, because that's not a valid like domain name. So that is like what the regular expression is doing. Now, again, these can get crazy complex. I don't suggest you go out and learn them. That's why I recommended just copying and pasting this in here. All this is doing is checking to make sure it follows that specific format that I just went over. Okay, so back to our account view model. Now, if I do a command B, or is valid, should be working. It's not, I probably named it differently. Yes, is valid email. Yes, let's be very specific there. So back to our account view model, is valid email. Because really this check can go on any string. So if I just said is valid, that's confusing, right? So we want to make sure you're checking for an invalid email. So naming matters. Okay, so now we have the logic for our checks in place. The only thing missing is what we do when false happens. Well, what we're going to do is show an alert. And this is challenge time, right? Here you have the project as it is. We're going to implement something we've implemented twice already before, and that is our alert item and then the updated alert context, right? So see if you can, use what we've done before, add your alert item to the view model, add your alert to the view, and then update your alert context, right? If you haven't done my challenges yet, this should be a relatively easy one. We've done this 3 times. It's the exact same thing. So give it a shot. I encourage that. 3, 2, 1. All right, we're going to do it. So like I mentioned, we need to have that alert item that we've had a couple times before now. So at published var alert item, it is of type alert item, it is optional. And here before I can create these, right, I want to do alert item equals alert context dot, well, I don't have my alert set up. So let's go to alert context. That is in our alerts folder. In the alert, okay, so alert context, we have these alerts. Going to copy and paste because again, we're going to use the same structure twice, except here before we customize these, here's what I do. Because like I mentioned, when we first built this can get out of hand. So there's many ways you can organize it. You can create separate files in an extension on alert context to group them that way. Typically what I do is I use just, / mark, and then I will say, network alerts, and then I'll copy this, and then down here I'll give some visual spacing, like 1 extra vertical space, and then this will be account alerts, right? So I separate them like that. Or again, you could parse them out into their own separate files on extensions. That's cool too. But anyway, this one is not going to be unable to complete. It's going to be in valid form, and then we'll tab this over to where it needs to be, and then it's not going to be server error, again, invalid form, and then it will say please ensure all fields in the form have been filled out. Cool. And then this one is not going to be unable to complete. It is going to be invalid email. And then title, same thing, invalid email. And then similarly, please ensure your email is correct. Right? You can write whatever you want in there, but that's the message that's going to show up in our alert. So if we do Command B to make sure that's all good, go back to our view model. Now our alert context for our empty field should have invalid form. Okay, cool. So that's the alert we're going to show up if any of these are empty. What don't you like? Command B. Okay, Xcode. So now here we want to make our alert item, alert item dot equals alert context, and that alert context, if the email is invalid, is dot invalid email. Cool. So those are our nice clean alerts that we're going to pop up in those cases. If these checks, pass, then we're just returning true, which means our form is valid. So now that we have this alert item being set properly, again, we're only doing one side of the communication pattern right now, right? We're broadcasting. We've set up our broadcast perfectly. It's going to broadcast the right stuff. Nobody's listening to this alert, right? We have our account view set up to listen to the view model. Cool. But we're not utilizing the alert anywhere here. And again, this is review. We've done this before. So on our navigation view, I'll scroll up a bit, do .alert. And then again, not just is presented, because that's where you got to pass in a bool. We want the item, because we're passing the item. Again, this is review. We want the binding to .viewModel.alert item. And then the content, get rid of that. Open the closure, alert item in. And then here's where we create our alert. And then initialize it with a title message dismiss button. The title is alert item dot title. What are we missing? I misspelled it. Forgot the T up there. Cool. And then alert item dot message, and then the dismiss button, alert item dot dismiss. Again, we've done this like 3 times by now. Hopefully you got it. Hopefully you did the challenge. Hopefully you got the challenge. Do a Command B there. Hit resume just to make sure our preview is working. Cool. Now we're about 90% of the way there. We're missing the final piece of the puzzle, and that is like what triggers all this. So back to the view model, right? We've set up the variable, but we're not like calling this variable or using it anywhere. So here in the account view, when do we want to do this? We want to do this on when save changes gets tapped. So we got to create a function in our view model to do something when we tap save changes. So in the view model, below is valid form, let's create a function here. So func save changes. And the first thing we want to do is check is valid form, right? So guard is valid form, else return. And we're just returning, we're not showing an error here because our error handling is handled in this is valid form, right? So is valid form, we'll check that. So basically, if is valid form is false, we're just going to return out of save changes. We're going to show the error properly. If is valid form is true, we're going to continue on in this function. For now, we're just going to print changes have been saved successfully. And we're going to deal with this in a later video, but for now, that's what we're going to do to prove that this is working. So let's test this, and then I'll run through the logic again real quick as a review. So back to our account view. I didn't have to do that, I guess. Let's just run it in the simulator. Okay, let's click on account. Now, the first thing we want to test is empty form, right? So hit save changes. I do this all the time. I do this all the time. All right, hit stop. You got to call the function. If you want your function to run, you got to call the function. So instead of just printing save, we got to call view model dot save changes. Okay, I do it all the time. Hit play, and let's do this again. Okay, now back to the account. Save changes. There you go. Invalid form. Please ensure all fields of the form have been filled out. Okay, cool. I'll listen to you. So click in first name, type Sean. And by the way, if you can do Command K to hide and show your keyboard, if you want to like see the UI. So Sean, okay, last name, Alan. Cool, that's all filled in. Email, right? That's not a valid email. So hit save changes. There you go. Invalid email. Please ensure your email is correct. We can test our validation even further. So we can do Sean Allen.dev @ Gmail, right? We have the @ symbol, but we don't have like the .com. Save changes. Nope. Invalid email. Okay, let's try .c, right? Because .c is not a valid email either. Save changes. Invalid email. Okay, so .com. Save changes. It printed. Should have printed. Yes, changes have been saved successfully, as you see down there. So our UI is done. We've refactored it to the view model. We've kind of handled text validation. We've error handled a form, because error handling on forms is important, because as I just showed, users can typically mess up a form. So you want to be very good about your error handling in that case. We just did some basic text validation there. But yeah, let's move on. In the last video, we did some text validation and got our view model on our account screen all set up. In this video, we're going to start talking about persisting data using the new property wrapper in iOS 14 app storage. Now, basically what app storage is it's SwiftUI's way of interacting with user defaults. If you're familiar with UIKit, you've built apps before, you're probably familiar with that concept. If you're not, a quick overview of what user defaults is it's local storage on the device that will persist in between launches of the app. Now, it is not a replacement for like a database, right? You don't want to store heavy things in there like images or a ton of data. That is not what it's meant for. A typical use case would be like preferences or settings. Back when apps had to handle dark mode themselves, you could have the preference, prefers dark mode, true or false, and you would store that Boolean in user default. Or maybe you allow your user to select an accent color for your app, right? They can customize it. You could store that color selection in user defaults. So what app storage is it's SwiftUI's way of monitoring user defaults. So by using the app storage property wrapper, you can kind of watch that item in user defaults. And when that changes, it's like a state variable. The app storage will see that change and then trigger a UI update to, update the data accordingly where you're using that item. Now, if you didn't quite follow all that, that was the overview explanation. Of course, we're going to build it. I'm going to be explaining it as I go. So hopefully it'll make more sense then. What we're going to build is a user object and store that custom object into app storage, user defaults. Huge disclaimer, right? In a real app, like you don't want to store your user in user defaults, right? Because if the user deletes their app, user defaults gets deleted, so they delete their user. That's not what you want. This, of course, would be stored on a server in a database. This app is educational purposes. It's actually pretty tough to come up with an app that's like realistic and covers all the topics you want to cover. So I had to take some creative liberty here. So again, huge disclaimer, you're not going to want to store your user in user defaults, but it's the example I came up with to show how to do it. Because at the end of the day, these apps, this course, like you have access to it forever. This is a reference for you to come back to. So when you're building your project, you're like, oh, I need to store a custom object in my user defaults. How do I do that? Oh, that's right, we did it in the Appetizers app. Let me go back and look, right? It doesn't matter what we stored there. You can just come back, see how we did it, and then use that information accordingly. Disclaimer out of the way, let's start building. So the first thing we're gonna build is that user object. So here in our model, let's create a new file, and it's gonna be a Swift file, and we will just call it user. Hit create. So struct user, and here's the thing, it's gotta conform to Codable, and let me tell you why. So when you're storing a custom object in user defaults or app storage, now if I use user defaults and app storage interchangeably, it's because they're kind of the same thing. Again, app storage is just SwiftUI's way of doing it. But anyway, when you're storing a custom object into user defaults, you have to convert it to data first, right? So when you're storing just like an int, a string, a foundational type, you don't have to convert that to anything. User defaults can handle that. But user defaults doesn't know what my custom user is. So I got to break that down into data first and then store the data in user defaults. So the flow goes like this. When we're storing into user defaults, we need to go from user to data down into user defaults. However, when we're retrieving from user defaults, right, because we want to retrieve this data to populate our user on the next app launch, we pull it from user defaults, but it's data, then we got to convert that data into our user object. So that's where Codable comes in because we're encoding and decoding data, right? We're going both ways. If you remember last time, we just used decodable because we were only going one way. We were just decoding. In this case, we're going both ways, so we're using Codable. Now, what properties does our user have? Well, let's go to our account view model, and it's basically all this stuff. We are replacing all this. So I'm actually going to hold Option. I just want the var. I don't need all the publish stuff. Command C to copy. Back to our user. In here, we're going to do a Command V to paste. Oh boy, not what we wanted. All right, we'll make this work here. I guess when you copy with the multiple cursors, it doesn't like that. So anyway, neat little tip here. Highlight your whole thing. Control I will do the automatic indentation here. And then if you know me, you know I got to tab these babies over. You don't have to do this. This is just my personal style. I think it looks neater. But again, I don't think I've said that too much in this course. Last course, I said that a ton. So yeah, our user is going to have a first name, last name, email, birth date, extra napkins, frequent refills, right? Basically all the stuff that was on our form. So now with this on our user, we can actually go back to our account view model and replace all this stuff with just a user object and make that user object published. So we'll delete all that, well, up until published, and then we'll go var user, and then that is going to equal, and we want to initialize an empty one. And when we initialize this empty one, if we go back to our user object, right, we have default values for our properties. That's why I just copied and pasted that over. So when I initialize a user and don't give it any values, it's going to give it blank, 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 today's date, false, false, because that's how we want our empty user to be when we first open up our account screen and see the empty fields. So back to account view model. That's why I can initialize an empty user, but I also get the member-wise initializer that has all this stuff, for if when I need to create a real user. But for now, we're just creating the empty one. Okay, so we're gonna get a ton of errors because we deleted all those properties, right? So right now I need to do user dot in front of all this stuff. And in fact, so much, I'm going to copy that user dot, just like I did the view model dot, and paste it everywhere I need it, right? So instead of just first name, it's user.firstname, user.lastname, user.email. Instead of just email, user.email. And then, as you can imagine, on our account view, we're going to have all this stuff as well. So again, view model dot, and then after the dot, user.firstname, after the dot, user.lastname, user.email. So all I'm doing is just adding view model.user.whatever we need here. Because again, everything is attached to our user object now and not separate properties. Okay, so let's run this on the simulator just to make sure nothing broke. Everything should still be fine. Okay, and if I hit account here, first name, Sean, last name, yep, save changes, we're gonna get an error because invalid email. Cool, okay. Everything still seems to be connected and working, good to go. Again, that was expected. We just refactored a little bit to get set up for this. Okay, so back to our view model. We need to, save our user-to-user defaults using app storage, and then also retrieve it. So we're gonna have two functions for that. Well, we kind of already have one function, this save changes. I'm actually going to move this up top. I like it up here. And then we'll need another function, func retrieve user. So this is what will get called when we want to retrieve it and save it. So let's set up our app storage first. And that is the app storage property wrapper. So it would be at app storage. And then here you have to give it a key, and that's a string. And our key is going to be user. Again, if you're familiar with user defaults, you had to give it a key because there was a key value pair in user defaults. So you would get like object at key, and it would have to match this identifier. So our identifier is going to be user. Then we're gonna do private var. We're gonna call this user data, because remember, it's going to be data. It's not like our actual user. It's gonna be of type data, but it's gonna be optional. Because again, remember, like if we've never saved a user, we don't have a user there. Okay, so let's clean up this top part a little bit. Let's work on save changes first, right? Okay, we no longer want to print anything. We want to encode our user into data and save it into user defaults. So just like we did in our network call, I'm going to go back for a review here. Remember on our network call here where we're downloading the appetizers and we have to decode our JSON response. So we're going to do code that is very, very similar to this, where we create a decoder and we decode it into an object, just for review there, what we're going to do. So back to the account view model, we want to do a do, try, catch. So do, and what we want to do is encode our user into data, right? Because this is where we're saving it. We're converting our user into data, saving that data into user defaults. So let data equals try. This is the try of the do, try, catch block. And we want to do JSON encoder, right? Not decoder. We're encoding it to data. Create a new one, dot encode. Value is user. So we're encoding our user that's up here published, right? And that user is constantly being updated as we type stuff. And then in order to save this user to user defaults, we need to set our user data variable up here that is app storage equal to that. So we do user data equals data. And then I'm getting an error because I haven't written out my catch block yet. So catch. So now we want to handle the error, like just in case this encoding went wrong. Because remember, it goes into this catch block if this encoding fails. And usually this encoding will fail if like you messed up your model and like you had a typo in here or it doesn't quite match. That's the common reason why this will fail. But still, we want to create an alert here. So back to our account view model. Well, we already have an alert item, right? We've already set that up for our isValid form. So now we just need to pass in a different alert context for the specific cases. So back to our alert. Let's create another alert context here. Again, copy and paste to get the structure. So this is going to be called user save success. And here in the title, we'll say profile saved, just that. And we'll say your profile information was successfully saved. Done. Okay. Back to our account view model. Do a Command B to make sure we get some autocomplete here. So now in this, well, that was a success case. I meant to do the error case, but hey, I got ahead of myself. We need to do that here, right? Because we want to show a pop-up when it was saved successfully. We don't want them to just hit the save button and then like nothing happened, right? We want to notify them that, hey, this was saved successfully. So we can do alert item equals alert context dot user save success. Okay, so now we need the error one. Back to our alert, we got to create that. Again, copy, paste, and we'll call this one invalid user data. And then what we'll tell the user is, call it profile error. Say there was an error saving or retrieving your profile, because we're going to use this for both when we try to retrieve it and there's a failure, and when we try to save it and there's a failure. So again, that is invalid user data. And again, these error messages, like I said, I'm not an error message pro. You know, you want these to be really, really good to let your user know what's going on. Back to the account view model. So now in the catch block, we'll set our alert item. And if you remember, whenever our alert item changes value, it's going to trigger the UI update and show it. Alert context dot invalid user data. Okay, clean this up here. So now let's walk through this. When we tap save changes on our account screen, first we're going to check to make sure the form is valid, right? We don't want to save anything that's invalid. Then we're going to encode the user, which is this user here, which if you remember, anytime we're typing in the field, this user is getting updated because it is published, it's attached to our text fields and all that stuff. So whenever we hit save changes, whatever user we have, we're going to encode that into data. We're going to set our user data equal to that data. And our user data is our user defaults, essentially. Again, that's what the app storage property wrapper does. So it's going to save that data at the key user in user defaults. And then if that goes through successfully, we're going to pop up an alert that says user saved successfully, good to go. If for some reason the encoding fails, we're going to pop up the invalid user data. Okay, so let's run this. Let's go to account, first name, Sean. Okay, let's hit save changes. Okay, invalid form, they're not filled out. That is still working. Always want to test that. Okay, Alan, email, seanallen.dev@gmail.com. Birthday, we'll just leave that it is. Again, we're going to optimize this birthday thing later. Cool, April tax day, or day before tax day. Cool, I want extra napkins. I want frequent refills. Okay, so remember that, April 14th, 2020, I flip these on, you see my name and my email, hit save changes, profile saved. Your profile information was successfully saved, right? It went into our do block, success. Hit OK. Now what we're not doing, watch when I stop this and I run it again, it's going to be blank. Because if I go to account again, like we're never retrieving from user defaults. All we did was save to it. So the next thing we got to do is retrieve it. Okay, back to our code. Okay, so we're going to do that in retrieve user. And again, I like 2 spaces in between my functions here. Okay, so retrieve user, the first thing we want to do, if you notice, our user data is nil, right? When we haven't saved anything yet, right? The user's first launch or they haven't created a profile, it's going to be nil. So we want to make sure we actually have data there before we try to decode it. Because what's going to happen, if we try to decode it and it's nil, it's going to go into our decoding catch block. Let me actually write out the code. It'll make more sense when I say that. But we need to guard let user data equal user data else, and we're just going to return if this is the case, because this is the case on, like, again, a fresh launch. And how we're handling the fresh launch is we have this default blank user that we're initializing, right? So we're going to get all the blank stuff that we want. So we don't have to like show an error or anything like that if it's nil. So we want to make sure there is user data in our user defaults. If there is, now we do basically very similar to this do try catch, except instead of encoding, we're decoding, okay? So do, and then we'll say user equals, because we want to set this user equal to whatever we pull from user defaults. User equals try. Let me move this up again. My head might be in the way. Try JSON decoder, right? We're decoding from user defaults. Dot decode from, and then we want to do user. This is where you just have the actual type that you want to convert the data into. And then what data do you want to make a user out of? Well, that's our user data that we have in there. So here we type user data. And then Xcode's telling me like my errors aren't handled because I haven't written out my catch block yet. So now we want to do alert item. This is if the decoding fails, right? If we try to pull out a user and we can't do it, alert item equals alert context dot invalid user data, right? The same error that says we couldn't retrieve or save. Okay. Now, when do we actually call this retrieve user? Because on save changes, right, we do it, when we tap the save changes button. We already had set that up. If we go back to our account view, see on the save changes button here, we have viewModel.SaveChanges. So that's when we were calling that. Well, on the retrieval, we want to call on appear. So in our navigation view here, above the alert, we can do .on appear. And then here we do viewModel.retrieve user. Okay, hit resume, make sure everything's good to go. So now, because we have already saved the Sean Allen user in user defaults, it's already there. We just haven't retrieved it yet. So now, as soon as this screen appears, viewModel.retrieve user is going to be called. And then on our view model, this is going to run. We're going to make sure we have data in there. Again, in our case, we do have data because we already saved Sean. If we hadn't saved Sean in there yet, then this would return nil, nothing would happen, you would just get the default user. So if we have data in there, we're going to decode that data into a user and set that equal to our user, which again, the user is published. So when this user object changes by getting set to something else, published means it's going to broadcast its change, and then our account view, listening to that change, will trigger a view update and populate the new data. And then, of course, if we can't decode that for some reason, we're going to show the alert context invalid user data. Okay, so let's run this and test this out. Okay, so let's tap on account, and there you go. Sean Allen, all my stuff is there, April 14th, my extra napkins and frequent refills, right? So now our user data is persisting in between app launches. And the thing to remember about like user defaults is if the user deletes your app, right, they just get rid of it, then user defaults will clear as well. So the stuff you want to store in there, make sure it's not something super useful that if the user deletes the app, they never have that again, because user defaults gets deleted when the app gets deleted. Okay, so that is data persistence with app storage and user defaults. Again, app storage was brand new in iOS 14. It's basically just like a state variable that watches user defaults. And again, the disclaimer here is you probably don't want to be saving your real user and user defaults for reasons like I said. Usually a user object is much more complex than this, so it's probably too complex for user defaults. And if the user deletes their app, they delete their user. So you want to keep your user on the server, but again, it's just an educational example of how to store a custom object and persist the data in between app launches. In this video, we're going to build the UI for our order screen. And here's the quick challenge. As you see here, it's a relatively simple list, may look familiar, and we have a button that also may look familiar. So the point of this screen was for us to start using our reusable objects, right? That's kind of the lesson I wanted to show here. So that's my hint. I'm going to see if you can build this yourself. The little trick here is we're going to do the swipe to delete. So that's the new little wrinkle. But if you want to try to build this yourself, again, it's mostly review, but we're using reusable objects. So give that a shot. If not, that's cool. We're going to build it now, but I always like to give you the opportunity to, try and push yourself. Okay, so into our code here, the order view, move it up here. Let me minimize these folders because I don't want my head blocking the way here. So screens, we are in the order view, which is nothing, right? We just have the basic placeholder that we had. Now again, pulling up the design, let's kind of break this down a little bit. It's a list view, but there's a button at the bottom. So that's going to be a VStack with the list view at the top of the VStack and the button at the bottom of the VStack. So pretty simple layout. So let's build that basic structure. So first of all, let's, in the navigation view, build a VStack and put the text in the VStack so Xcode doesn't freak out. You got to have something in there. And then we'll put our navigation title on the VStack. Okay, so nothing should have changed, but we just put a VStack in there. So instead of text and orders, let's create a list. Now we got to do this list a little bit differently because of the fact that we're doing swipe to delete. The onDelete modifier we're going to use is only on for each, like it's only a modifier for that. Like list doesn't have an onDelete modifier. So something to keep in mind, if you do want swipe to delete on your list, you can't build lists how we've been doing it, where we initialize the list with our data and then the ID and all that stuff. You have to put a for each inside a list, which is also another common way to build lists anyway. So you should be familiar with both methods. So we'll type for each and then we'll initialize it. And the for each has a similar initializer to just our list, right, where we have our data, which is unnamed, that's that underscore, ID, and then content. So it's pretty similar to how we used to initialize the list, so it's not a complete departure from what we've been doing. Okay, data. We need to adjust this a bit. So let's go to our appetizer, right? This is where we have our mock data. We have our sample appetizers, so we have an array already that we can use. However, if you remember what I said, that this sample data is a little messed up because our ID is what matters. It's how SwiftUI knows what object is what. And right now, our ID is the same for everything. And this only comes into play when we're like adding items to an array or deleting items from an array, which is what we're doing in swipe to delete. So we need to create some different dummy data to create our UI. So I'm going to copy this here. And basically, we're just going to create 3 items, and they're just going to have different IDs. That's all. So down here, we'll do order item 1, tab that over, forgot to tab this over, and okay, cool. So now instead of 00, well, we can keep this 001. We'll do copy, paste, and paste. Again, just 3 items here. So 2, and all we're really changing is the ID. So they have unique IDs, and then 3. And get this back to be lined up. Okay, so again, instead of ID 1, we want ID 2. Instead of ID 1, we want ID 3. So again, just unique IDs. You can change the name if you want. In fact, let's do that. Test appetizer 1, just to be sure, we have the right items here. 3, and then 4. I'm dumb. I forgot 2. Can't even count. 2 and 3. Okay, so it doesn't really matter. We just want to make sure we have the different items. And then now we'll create an array called static let order items, and that is going to equal order item 1, order item 2, order item 3. And again, this is just building out some quick dummy data that I use to build my UIs. Of course, we're going to populate this with real data, eventually, but to get the UI going and the structure of it, this is what we want to use. So again, it's going to be mock data dot order items, and that's going to be our array of order items 1, 2, and 3. So back to the order view, that's what we're going to use here for data. So mock data dot order items, the array. And then the ID would be the key path ID, but remember, we don't need that because we're conforming to identifiable on our appetizers. And then the content, we don't need, we can do our view builder here, and this is where our cell would go. And oops, I forgot. Again, the same way we do it, we need appetizer in, right? Because as we're iterating through, we get an appetizer for each thing. Now I need something to return here as the cell. And like I said, we're going to be using the reusable objects here. So this is going to be an appetizer list cell that we've already created. Remember, that takes in an appetizer, and we'll pass in the appetizer. So again, very, very similar, almost exactly what we did before on our list view, except now we're using for each instead of doing it on the list. Try again on the preview. There we go. Okay, you'll notice something different. Like our list looks funny. So here's where we have to give it a list style. So on list, you can do .list style, and here's where you can do a couple different ones. There's plain list style. So if you initialize that, now that's going to look like our normal list. However, kind of the new hotness in iOS is the grouped list style. So this is where you would just do group list style. And this is what gives it that kind of new look. Or you can do inset grouped list style. I guess this is what I was talking about when I was talking about the new look of list, not grouped. I just forgot the inset part, right? How table views now are kind of like, they got that padding on each side. So if you want that style, cool. We're going to go with the old plain list style. I don't know. I still like this. Like I like the inset grouped for like settings. I don't think it applies for every type of table view. So plain list style. So now that we have our list, now we need our button in the VStack. So button, again, the first closure is going to be what happens when we tap the button. For now, we're just going to type or print out order placed. We'll obviously be implementing that later. And then the label, the second closure in the multiple trailing closures is what the button looks like. And what our button's going to look like, if we go to views, we have an AP button. Great, AP button. Again, this was all about kind of reusing the objects that we've used. So for the title, again, the string we're going to pass in right now is just kind of a placeholder. We'll fix this once we actually have the value. This is where we're going to have our price total and then place order. So we'll say like, 99.99 place order. And, later on, we're going to write some logic that will calculate the total of our order. But for now, again, as we're building the UI, that's what we want. Now, to me, that is hugged up a little bit too close to the bottom. So we're going to add some padding bottom. So dot padding, dot bottom, and then we'll just give it 20 question mark. Who put the question mark on the teleprompter? Who gets that reference? 30. Sure. 25. Again, you can just dial it in however you like. Well, we'll stick with 25. Put whatever you want in there to get the look you want. Okay, so the UI is done. As you can see, pretty simple, right? We just had the VStack. Our VStack holds a list and a button. Our list is just another version of Appetizer list cell, except it's going to hold our order items. In a later video, we're going to create our order object that is being manipulated. When we add an item to order, when we delete it, that's coming later. For now, just for the UI, we have our mock data. Again, we're showing the list reusing the same cell that takes an appetizer and shows the pertinent details. We went back to our plain style list, and then we added our button, which again reused our AP button. So we have it nice and simple, and we'll calculate the price total, later. So our UI is pretty simple. Now let's implement the swipe to delete. This is kind of the new twist we haven't done yet. Now, like I said, the onDelete modifier is only on the for each, and it comes with some special features for that reason, right? This is why you can't use it like everywhere. So if you do on delete, here you go, perform, and you can see we get an index set. And I just realized that I need to actually create a variable for our mock data array. So we'll do @state private var. We were gonna have to do this anyway when we actually had our order items, but we'll need this now. So we'll say order items, and that's going to equal mock data.order items. So instead of mock data.order items for our for each, we can just say order items. Now I know you may be thinking, well, it's the same exact thing. Well, we need access to our order items elsewhere. So that's why I did that, like specifically here. So here we can do order items.remove, and then not just we want to do @offsets, which is kind of hidden down here. So remove @offsets, and then you see @offsets takes in an index set. Oh, good thing we got an index set right here. So here we do index set. So what's going to happen when we swipe to delete, it's going to know the index of the item, and then we're going to call order items.remove basically at that index. So our swipe to delete should be working. So let's run it on the simulator. Okay, go to our order screen, which is new. Okay, so swipe, there we go. Delete, appetizer 1 goes away. Appetizer 3, gone. Appetizer 2, gone. We haven't put an empty state yet. We're going to do that in the next video, but that's where we would show the empty state. So our swipe to delete is working. Okay, back to our code. We'll stop this. There is a bit of a cleaner way to write that, but I wanted to show you how to use it when using just like the autocomplete that you get, because I feel like this spells it out a little more and is a little easier to understand how it knows the index set. That's why it's got to be on for each, so it knows, this index. But we can write this a little cleaner by adding a function here. So let's do func delete items @offsets, and it takes an index set. Remember, that's the index set we got. And then here we can just call order items, the same thing we just called basically. Remove @offsets, and then we pass in offsets. And then now, again, this isn't as straightforward as this, right? Because you can see, hey, get an index set, cool, I'm going to remove that index set. But it is cleaner that we can write just on delete, perform, and then instead of all that, we can just call delete items. We don't even need the @. And there we go. Let's test this again just to make sure it's working. Go to order, swipe to delete, delete. Cool. So it is still working. So again, the first way was just to really spell it out. This way is just cleaner. But that wraps it up for our order view UI. Again, in the next video, we're going to create that empty state. That's a pretty simple video. But then after that, we're going to create our order object that's in our environment that we can add items to the order, delete it on our order screen, all that good stuff. That's going to be probably a couple videos. So let's move on. We left off last video getting our order UI in place. But what do we show when they haven't added any items to their order, or maybe they've deleted all their items from the order? Well, that's where we're going to create this empty state that you see here on the screen. Now, empty states are very common in apps, right? Anytime you just have a empty data, you don't want to just have a blank screen. You want to have a nice, graphic and a message letting the user know what to do, to populate data on this screen. So we're going to make this empty state reusable to where we just pass in an image and a message. That way you could, change the image and the message accordingly. So here in our views folder, hit new group, we'll call it empty states, because you may have a different style of empty states throughout your app. You never know. New file in the empty states is going to be a SwiftUI view. Hit next. We're going to call this empty state. Create. Cool. Here we go. Resume on the preview just to get the basics up there. Great. Now pulling up the design, it's a real simple view, and it's going to be similar to what we did on the spinner view, how we had a color as the background, and that background is going to be system background in a ZStack. Forgot to mention that, right? The background is the ZStack. On top of that is going to be our VStack that holds our image and our message. So that's the basic structure. So to start that, let's do a ZStack around our text hello world. This is what happens when you have two views out there. You get all those two previews. So again, in our ZStack, the first thing we want to have is our color. And we want to initialize that with .system background, because again, we want this to be black in dark mode, white in light mode. And we want to make sure we do .edges, ignoring safe area .all. And the reason being, say instead of system background, we just did blue, right? Well, we are ignoring safe areas. Let's comment that out. And you can see, right, we want it to fill the whole screen. We don't want it to look weird like that. So I know that's review, but I like to reiterate. So that's why we want to do edges ignoring safe area and .system background for our color. So that is the base layer of our ZStack, right, our color. So on top of that color, we want to have a VStack for our image and our message. So VStack and image. What image do we want? Well, it doesn't exist yet. So we need to add that image. So on your XC assets, and by the way, the image, it'll be called empty order. It'll be attached to the video. So download that image, drag it into your XC assets like I'm about to do right now. So in Finder, we have empty order PNG, drag that in, and then you should see this little list receipt type looking thing. So go back to empty state, and the title of the image is now empty order. In quotes. Hit try again on the preview. Hit resume on the preview. There we go. Just like all of our images, super large, right? We need resizable. We need to do all of our typical image stuff here. So here we'll do .resizable, .scaled to fit. And now we want to give it a specific height. The width doesn't matter because it's more of a vertically oriented image. So we'll do frame with a height of 150. I'm sorry, that was width. I want height of 150. Got to be careful. So we can delete the whole width because we're going to leave that nil, delete the alignment, and we're good. And that's just a styling choice. If you want your image to be super huge and fill up the whole screen, go for it. I like the minimalist feel, so I don't like it to be too big. But our image is set up. Now we need to set up our message, which is a text. So if I go text with a string, let's say this is our default message. We're gonna fix this later, but we're working on the layout. Let's do font, and we'll do title 3 maybe. We're gonna kind of play around here. Okay, title 3 font weight of semi-bold. And this message could be long, so we want to do multi-line text alignment .center. So if it does line wrap, we want it to be centered, not left or right aligned. And we do want the foreground color to be .secondary. We want it to be this like gray color. And then for my taste, it's pushed up a little bit too close to the image. So I want to add some padding all around, because I also don't want the message to go all the way to the edge of the screen. We want some padding there. Cool, that's the basic structure of our empty state. Now let's make this reusable like I said. So our empty state is going to take in two parameters. It's going to take in let image name equal, be of type string. And then now empty order will be image name. And then our message is also going to be a string. So let message equal string. And then, okay, default message will now be message. Okay, so that's how it's reusable. When we create our empty state, we're going to have to pass that in, which again, our preview is going to have to take that kind of stuff too. So fix the image name here will be empty order. The string will be, this is our test message. I'm making it a little long for testing. Hit resume. And you can see how our text now wraps. It's centered. We got the padding so it doesn't go too far. And if you wanted to, just a little, I like to do this with my messages, right? I don't like how the period is right there. This is a little sidebar. I like to do, /n to add a line space. You can kind of break the line at the period, right? This is our test message. I'm making it a little long for testing. I usually like to do that. I find that easier to read. Just a little small tip. So now that we got the view built, let's actually put this into action here. So on our screens, let's go to back to our order view. So we're gonna do something similar to what we did on the loading view, right? We're gonna smack this empty state on top of everything if basically our order items.count equals 0, or we're gonna use is empty, but that same idea. So now we want a Z stack as our root, and let's drag everything, the VStack here in there, and our navigation title is on the Z stack. So the base layer of our Z stack, right, is the VStack that we've already built, the list and the button. Again, we want to smack the empty view on top of that. So that's the top part of our VStack here. So moving up here, now we want to do if order items dot is empty. So we only want to show this if order items is empty. And then now we'll show empty state, right? But empty state takes in two parameters, the image name and the message. So the image name is going to be empty-order. And then the message will be, you have no items in your order. Please add an appetizer. Okay, so to run through that one more time, when this redraws, right, and it's going to redraw at the moment every time our order items change. So because we have this mock data in here, the first time you come here, there's going to be orders in there because there's mock data. But once we're done building like kind of the real functionality, until they've added an order, we're going to see the empty state. But for now, the only time we're going to see an empty state is if we use our onDelete, right? We swipe to delete 3 times, then order items will equal 0. This will redraw. It's going to go into this if statement because now order items is empty. It's going to smack our empty state on top of everything, showing the our empty state view. In theory, let's run it and see if it works. Okay, so going to our order, again, this is our mock data. If we didn't have the mock data, we should see our empty state here because order items would be empty. Okay, swipe to delete, gone. Swipe to delete, gone. Moment of truth. So every time I swipe to delete, our order items is changing. So it's triggering a view redraw. So now when we trigger the view redraw, order items is going to be empty. We should see our empty state. There we go. That was a little fast because I didn't get a chance to delete. But yes, you see our empty state now. You have no items in your order. Please add an appetizer. And again, here's another example. I didn't do the /n here to make that please add an appetizer go to the next line. We're going to do that real quick. So down here, /n. There we go. That just looks a little neater. Hit play. Order. Again, we'll test this. Swipe to delete. Swipe to delete. Swipe to delete. Cool, now our empty state shows you have no items in your order, please add an appetizer. Now for my taste, again, this is purely subjective, this feels a little low on the screen, even though it's centered. Back to what we talked about, how like it's only centering from the navigation bar down, right? So it looks lower than centered. So I want to bump it up a little bit. So we're going to talk about a new modifier we haven't really talked about yet, at least I don't think, called offset. So we'll stop this, go back to our empty state, and we're going to add an offset to our VStack to push it up just a little bit. So we can do .offset, and you can see it takes an X or a Y. We don't care about the X. We want it to be centered. We just care about the Y. So we need to give this a value that will push it up a little bit. All right, let's hit resume on this. Get rid of that so we can see this in action. So put 10 in there, but a positive number will push it down. Like let's use 100, right? See how it gets pushed down? We'll use 200, right, to really push it down. But you can see the frame of the thing is still there. It's just pushing it down a little bit. We don't want 200. We probably want like -50. And again, this is me just playing around. And that to me looks good. Again, we're just bumping it up just a little bit. Let's run it to see it with the navigation bar in place to get the real deal look here, right? Delete, delete, delete. That's okay, perfect. At least for me, for my taste, right? It's just like a little above center. I feel like that looks really good for an empty state. And that was just a quick introduction to offset. Again, you can kind of nudge things left or right, up or down by using that offset there. Okay, so our empty state is in place. Let's resume this here. Let's move on to actually, building this order object so we can get the functionality. Again, where on the home screen, we're adding appetizers to our order. Those orders that we add are showing up in the order view, and then we can swipe to delete. Our total is going to be calculated, all that good stuff to really bring this app together. In the last video, we added a bit of polish to our app by adding this empty state for when our order was empty. But up until now, we've been faking our order, right, with some mock data. Well, in this video, we're going to create our order object that's going to go into the environment, new topic, brace yourselves. That way multiple screens can access it. For example, we add to our order from the appetizer list view, more specifically the detail screen, and then we want whatever we added to show up on our order screen, and then we can also remove items from that array on our order screen. So the main topic of this video is creating that order object and then using the environment. Now, before I explain the environment, let's actually create that order object. So in our model, do Command N for a new file. It is a Swift file, hit next, and we're going to call it order. And it's going to be very similar to our view models. So the difference between view model and the environment, like overall the concept is kind of the same. However, our view model is very tightly coupled with a specific view, whereas an environment object isn't attached to a single view. Like I said, multiple views can access it depending on where you set it up. More on that later. I don't want to get ahead of myself. Anyway, back to this order object. So we do want to import SwiftUI. And like I said, this setup is going to be very similar to how we set up our view models. Make my font a little bigger. I noticed in editing, my font was kind of small sometimes. Anyway, final class order, and it is an observable object. Again, this is the same setup as a view model, because again, the concept is the same. We want a published property on this, and we want to have an array of appetizers, right? That's the items on the order, right? If we're adding multiple appetizers, we're very hungry, we need an array of appetizers. So let's do @published. So again, this should look very, very similar to a view model. Var items, and items is an array of appetizers. And we're going to initialize that with an empty array, right? Because when we fire up our app, we have no orders. So again, the setup is like exactly like a view model for this part of it. However, here's where it is different. Now that we have our order object, we need to inject it into the environment somewhere. And here's why the somewhere matters. That's how you dictate what has access to your environment object. Think of all the views like downstream, or all the child views are the ones that are going to have access to our environment object. So pulling up this little visual here, in our example, our app is kind of laid out like this, right? We have our tab view, and things like the appetizer list view, the account view, and the order view are all children of that tab view. Back to the code, let's look at that. Go to screens, scroll up, appetizer tab view, get rid of our preview, we don't need that. Look, see our tab view, or appetizer tab view, I'm sorry, is the name of the view. And you can see the appetizer list view, the account view, order view, etc. are all children of our tab view. So if we put our order object into the environment at the appetizer tab view level, again, think of it as like flowing downstream, all the child views. So that means appetizer list view will get access to that environment object, account view will get access to it, order view will get access to it, and then all their child views, right? So when you inject something at like the very, very top level, you can consider that as like everything in the app is going to have access to that. Now, you may not always want that. In our case, we do, right? Because, our appetizer list view is going to change stuff in our order view is going to change stuff in our order. Our account view is not, but that's fine. But you can see how our entire app will have access. Now, when I mentioned that, you can give certain views access depending on where you inject it into the environment, well, we just gave the example of injecting it at like the top level. Well, let's say our account view, like our settings or whatever, was actually more complex. Like here's a visual example of the Apple settings. You can see as I'm going deeper into these settings, like I'm like 4 screens deep into my settings, or if you can imagine, this is our account view. So if you can imagine injecting something just at the account view level into the environment, now our whole app doesn't have access to it, but all the settings child views, again, if we had a very complex setting setup like Apple does, all those child views, again, all the views downstream have access to that environment object, and that could be something like a settings environment object, right? So the main takeaway here is where you put your object in the environment matters, because only the child views of where you inject it are going to have access to it. So if you try to access something that's not in that view hierarchy, your app's going to crash. In the review section coming up later in the course, we're going to do a deeper dive into some more examples of that, but that is the overview. Let's get back to our example where we're injecting it at like the very top level of our app, so all of our views have access to it. So how do we do that, right? You may think do it in this appetizer tab view, but no, you want to go to our app lifecycle, actually, right? Remember this? We went over this, appetizer.app, because this is where we're first initializing our appetizer tab view. So when we initialize our tab view, we want to initialize it with an object in its environment, right? So again, the very, very top level. So we can do that by creating an order object on this app here, struct. So var order equals, and we're going to initialize a brand new order, right? And if we go back to our order, just to double check, right? We don't have an initializer. So when we create our order, it's basically just going to get created with an empty array of appetizers. So back to our app view here. So now we need to take this order that we created here and actually inject it into the appetizer tab views environment. Now there is a modifier for this. We're just one line. So dot environment object here. And then we want to pass in the order that we created. So do Command B. There we go. So the order that we created here on line 13, we are injecting into the appetizer tab views environment. So again, all the child views of the appetizer tab view are going to have access to this order object. So I just said they have access to it, but how? Well, let's go to our appetizer detail view. This is the first spot we want to use it, right? Because if I pull up the canvas, right, when we tap our add to order button, right, we want to add it to our order object. So here we are in our appetizer detail view. And in order to get access to that environment object, it's a property wrapper at environment object. There you go. Var order, and it is of type order. Now let's talk about this real quick because there's kind of a gotcha, right? We're not like setting this equal to anything. We don't have to initialize our appetizer detail view with it. You know, like for example, how we have just our appetizer, when we don't give it a value, you know, it's going to say, hey, add this to your preview, or you have to pass in a value. It won't let you do that. The environment object is different because it's assuming that because you did this, something is in the environment and it's just going to pull from it. So this is where your app will crash if you don't inject it into the environment properly, right? Like we said, only the child views have it. Good thing appetizer detail view is a child view of the app tab view because we put it at the top level. But if you were getting more specific with where you put your environment, this is where you got to be careful. Because again, if appetizer detail view was not in the view hierarchy of our tab view, this would crash because there's not going to be anything called order in the environment. Okay, luckily for us, there is. So now we have access to this order variable that we can use. So where do we want to use it? Well, we want to use it when we tap on the add to order button. So that is down here. Right now, we're just printing tapped. Well, let's do order. Well, we want to add the appetizer. So order has a variable called items, right? Just to verify that, let's go back to order. There you go. Yep, our variable called items is an array of appetizers. So we're going to append our appetizer to this items array. So .items.append, new element, and then we want to append the appetizer. And the appetizer we have is the appetizer we passed into this detail view, like from the very beginning, right? So we know we want to add that one to it. Now this is a fine line of code. It's not super hard to read. I don't know. I like to refactor this a little bit further. This is completely subjective. If you don't want to do this, don't worry about it. But I also like having, you know, functions on my order object here. So in order, I'm going to write a function. So we'll do func add, and then we won't give it a name, but we'll give it a argument label appetizer, and it is of type appetizer. And then here, I'm going to do items.append appetizer with whatever we pass in there. So again, this is just a very, very small refactor, but you'll see at the call site how it makes it a lot more readable, even though that line of code was fine, right? So, and real quick, you'll see why I'm not going to give it a name. If you don't want to give your functions like a parameter name, you use that underscore there, and then you can use this to use like within the scope. So you'll see why I did that here in a second, if you're not already familiar with this technique. So appetizer detail view, instead of order.items.append, you know, let's just do order.add, and you can see I get this. And here's the reason why I didn't name my parameter is because it tells me I need an appetizer of the type. So to me, that is letting the user of my code know, hey, it expects an appetizer, rather than just like naming the parameter appetizer and then passing in an appetizer, a little bit redundant. So here I can just type in appetizer. Right, so order.add appetizer. I like the way that reads. Just a small little side rant on, you know, refactoring and code style. Okay, so what's happening here, right? On our detail view, we are basically getting access to our order that's up in the environment, right? And the environment is kind of like global across our whole app. So we're getting access to that in our detail view. And then when we tap the button, that order that's up there in the environment, we're adding this appetizer to that order, right, in the items. So now that our order has the item, we need to read that item in our order view, right? So let's go to the order view, and I'll minimize all this stuff so my head's not in the way. Okay, let's hit resume here to see our order view. Cool. Here we can get rid of this mock data, right? We don't need this at state private var order items. Okay. What we need access to is our environment order that has items. So at environment object var order of type order. Cool. So now anywhere I was using those order items, I can now do my order dot items, right? Because that's items is the array that's on my order object. So instead of order items, order dot items, and then same thing here. Cool, do Command B, we should be good to go. Cool, so now that we're not using our mock data anymore, right? So this should be empty if my preview ever works. Okay, the preview hates me, that's fine, we'll use the simulator. But, so now if you can see what's going on here, right? I'm getting access to the order that's up in the environment. In my table view, now I'm reading that order object in whatever array of appetizers is on there. That's what I'm going to show in my table view. Same thing for delete items, right? Delete items is going to remove items from the order.items, right? So we're just accessing that order, a little bit of refactoring thing. Same thing here. We're just checking if my order.items is empty before we show the empty state. So let's run this on the simulator and see if this works. Okay, here we are. We should see an empty state when we tap the order. There we go. Empty state. Home. Okay, let's add these stuffed shells. Again, these are my favorite on here, I think. Okay, add to order. Okay, we should probably dismiss this. So let's go back and update that later, but let's close this out. Our stuffed shells should be in our order. So let's click on order. Bam, stuffed shells, nice. You'll notice our price isn't updating. We're gonna fix that in a bit, but our order is updating, right? We added something on our home screen or our appetizer list view, and it showed up in our order. Because again, that's what the environment object does. Your screens have like global access to this item. And then likewise, I can still delete. From there, we see our empty state, right? We're just manipulating that order that's up in the environment. So cool. That's kind of the basics of using the environment object. Let's clean this up a little bit though. Like I said, if we go back to our appetizer detail view, we want to dismiss the view. So we'll do is showing detail equals false. So we'll dismiss the detail view after we hit add to order. And we can optimize that even further for just user experience. We'll handle that in the optimization section. So let's test that real quick, just to be sure. Cool, we'll add chicken fingers to the order, add to order, and that dismisses and you're back shopping. Okay, and let's double check the order. Yep, chicken fingers are there, great. Now another thing I wanna clean up in the order view is this delete items, right? Because again, I like to have these functions like on my object that it's manipulating, because like we're only deleting items like from that order. So I'm gonna actually Command X to cut this function, go to my order, just like we had add, here we go. We're going to have a delete items, right? Instead of order.items, it's just items, right? Because items is right here already on the order. And then back in our order view, instead of just performing delete items, we perform order.delete items. And again, as always, let's test this real quick to make sure we don't break anything. Let's add chicken avocado spring roll, add to order. Cool, there's our chicken avocado spring roll. And we deleted. I just did the fast, too long of a swipe. That's why it looked weird. Okay, so the last thing we want to do, if you notice, our price wasn't updating on the button. So we can write a function on our order to calculate that. And this is going to be a computed variable because this is going to get checked and computed all the time. So we'll do var total price, and that is a double. And that's going to return. We're going to use items.reduce 0, and then the closure here is going to be $0 plus $1.price. So basically what we're saying is here is go through the entire array and add, as you go through, add all the prices up to one total, essentially. If you're not familiar with higher order functions and filter, map, reduce, I don't want to derail this because again, I was assuming some Swift knowledge, but I'll link to a video I did on it a long time ago and some other resources in the description. But what this is going to do is it's going to basically add up all the prices in our items array to get a total number. So where do we want to use our total price variable? Well, that is on our order view. And you see here our AP button. And like I mentioned, we're just hard coding the 99.99, right? Just to set up the UI. Well, now we want to replace 99.99 with our order.totalPrice. So again, string interpolation, order.totalPrice. And remember, we got to do the specifier, specifier %.2f, and that'll give us our decimal places, right? We want 2 of them. So now let's run it and test this out. And I'm going to add like multiple items to the order, just to show the total. So Asian flank steak, $8.99, sounds good. Mozzarella sticks, $6.99, sounds good. Jumbo tater tots. Yes. Meatballs. Yes. Damn, meatballs are expensive. All right. Anyway, order. Cool. Those are all 4 of my items. You can see it tallied it up, $42.96. And then watch, as I delete it, like I'm, $13.99 for tater tots. That's insane. Let's get rid of that. Cool. And you can see my price calculated and updated accordingly. And again, back to the environment object, that is because anything that is like listening to this. And what is listening to this? Well, our appetizer detail view is listening, right? The environment object. And then our order view is listening, right? The environment object. So any of these views that are relying on this order object, when our order changes, the UI for those views will also update. Again, back to the big picture of SwiftUI. Remember, SwiftUI is all about having one source of truth and then setting up your UI to react to whatever that source of truth changes, right? The data. So when the data, which is our order, changes, our UI is just going to react to whatever our data says, right? That's SwiftUI in a nutshell. And back to the simulator here, just to finish this out, right? Get rid of the meatballs. Okay, man, $15.98, cool. Mozzarella sticks, so we should see $8.99, done. And then delete again. Now we're back to the empty state, so you have no items in your order. So our order is functioning. We injected it into the environment at the top level, so all of our child views have access to it. That is the basics of environment. And in the review section of the course, we're going to do a deeper dive into the environment to talk about other situations or examples on when you might use it. But something like this, having an order or a cart, on an e-commerce app is pretty common. So this was a good example to get you started, because even in those other examples, the concept is the same. Wherever you inject something into your environment, all the downstream views, all the child views are going to have access to that. Anything that's upstream from that view will not have access to that. So if they try to access it, it'll crash. Okay, that actually wraps up the Appetizer app, right? Everything is functioning, the home screen, the account, the order. We're going to come back and tweak some things in the optimization section. But overall, the basic functionality is done, right? So let's add something to the order real quick. Give us those tots again. In a real app, when you hit place order, right, this would send up a network call, to place the order, do all that stuff. Of course, I don't have a full backend database all set up for this, but you can imagine that's what would happen there. But anyway, hopefully you have a good basis to explore with this app. Start, trying to add features to it or change the design or just use this as a basis to play around with. And I hope that's what all of these apps over the past, 40 videos have given you. Just again, a basis to play around with and explore as you learn SwiftUI further. Now it's time to update the Appetizers app for iOS 15. And because this app was much bigger than our previous apps, this is going to be broken down into, I'm not sure exactly how, but 5, 6 videos. So the source code for all the updates is going to be attached to the end of the last video, just as a heads up. But I definitely wanted to break this up into a bunch of different videos so it wasn't one marathon video. So to kick that off, I'm going to start with how I actually update an app when a new iOS 15 version comes out. So the first thing I do is I open up the app and I want to run it on iOS 15 to see if there's any errors or warnings in my code, see if the UI is acting weird anywhere. And then I fix all that stuff, just get it running in iOS 15, and then you start adding the new stuff and refactoring the code, all that stuff. So this video is going to be the initial run of the app and see how bad iOS 15 messed up our app. So first things first in Appetizers, and by the way, this code I'm starting with is the last source code on the last video when we finished the iOS 14 version of the Appetizer. So this is the source code from right before the iOS 15 updates. So click on the Appetizers app, hit the Appetizers project. Again, iOS deployment target, make that iOS 15. And then in the project, iOS 15. And then while we're here, not iPad, not landscape left, not landscape right. Maybe you've played around with that. Looks like crap on the iPad, looks like crap in landscape. That's a little bit beyond the scope of this course, but if you want to, take these projects and run with them, maybe getting it working in landscape is a good project. Maybe getting it working on the iPad is a good project as well, but we're not going to mess with that. Okay, so now that we've done that, I do a Command B to see if there's any errors or warnings. See, I got build succeeded, no errors, no warnings. Now, that in a bigger, like quote unquote real app, that is going to be pretty rare. The reason we don't have any warnings is because this app already had a minimum target of iOS 14, so it's not like it was an older app. If you've been working on an app for years, maybe since iOS 11, iOS 10, you're going to have older code that the deprecations are slowly going to catch up with you, and it's going to be a bigger code base. So I just want to set those expectations when you're in the real world that anytime a new iOS version comes out, if you're working on an app that's been around for a little bit, you're going to see a ton of warnings and errors that you have to fix. We don't have to do that because this is a relatively simple and new app. But again, going through my process, cool, no errors, no warnings. Let's run it on the simulator and see if the UI is messed up at all. Okay, here I'll go back to light mode. You can see our table view, or list, sorry, got inset by default. That must be the new default in iOS 15. Now, if you want that, you like that look, cool. You don't have to do anything. I'm gonna go back to the look that we had before, which if I, let's practice adding something to order, add to order, cool. Now if I go to order, you can see the list style. I just like the way that looks better in this circumstance. So it's fine on our orders, but on our home screen, it's not fine. So, okay, we're gonna have to fix that. And obviously adding to an order worked. Account, everything looks, good there. I always test, let's add an account, Sean Allen, me@email.com. Birthday, cool. It's not my birthday, obviously. Napkins, save changes, profile saved. Okay, that seems to be working. So like I said, I just run through the functionality of the app, make sure things are working fine. So that account should persist, right? So I'm gonna stop running it again, just to make sure my persistence is still working. My account still shows up, cool. Okay, so the app seems to be working. The only issue we have here is this list inset that's on by default. So let's fix that real quick. So we'll stop running that, get rid of that, go to Appetizer list view. Hit resume here. I think we just see the loading screen here. But here's our list on the Appetizer list view. So in order to get that plain list style, a modifier on list, which here's our list, we can do this. We'll do it below the navigation title. We can do dot list style. You can see we do dot grouped, inset grouped, plain, sidebar. I believe grouped is what they have. That's the default, but I want to do plain, right? That'll give me back my plain list. So if I run it again, we should see this. Yep, there's our list looking like it used to. Okay, cool. So that's fixed. The next step I do is go through known deprecations. If you watch the weather app update, I talked about deprecations. I'll give a quick 20-second review, but deprecations are, when Apple decides to change SwiftUI and the syntax and the way they do things. So they'll deprecate the old code, which means it's no longer going to work at some point in the future, and they'll give you a new way to do it. Now, luckily, they usually give you a couple years to do it, right? They'll first tell you it's been deprecated, then maybe a year later, they'll start putting up warnings in your Xcode, and then maybe a year later, they'll make it not work anymore. So you have plenty of time. And like I said before, how do I know about these deprecations? You can look at the Xcode beta release notes. So during the whole beta period of Xcode from June till September, you can follow the release notes to see what's been deprecated, but it's usually a lot. It's a lot to keep track of. People are talking about them on Twitter. Usually during that time period, I'm making a list of what's been deprecated. And then when I go to update my project, I go through that list and I search for that stuff. For example, like we talked about before, I know edges ignoring safe area was deprecated. So I typed in edges. Okay, cool. So let's go to this edges ignoring safe area. I know that is now .ignore safe area. And then the next place I'm using it is down here. Cool. So like I said, part of the process, I go through and try to fix all the deprecations that I know of. And I say that because it's not the end of the world if you let some slip through. Like I said, that edges ignoring safe area was actually deprecated in iOS 14, and I missed it for this course. Not a big deal. You see the app still worked fine. It still worked. Like I said, Apple gives you a couple years. They don't just change the code on you and break it right away. Sometimes. But that was one of them. Another one I know of was accent color. Now, what accent color am I talking about here? So let's go to our Appetizer tab view. This accent color, which was, the brand primary, which is what makes our tab view at the bottom of the tabs, that color. Cool. Xcode does not like this part. Okay, so you can't see the preview of the tab, but the tab colors are our brand primary. Xcode crashes, gotta love it, right? Anyway, this accent color has now been deprecated. And if you option click on it, you can go to the documentation and you can see deprecated over here on the right. So the new way to do this is if you go into assets, you can see accent color here is now moved into the assets, and you would create something just like you did brand primary for accent color. So let's create that. So I'm gonna click on brand primary, open up the right pane here, click on the color, and you can see here's the 8-bit hexadecimal. You see content sRGB. So I'm just gonna copy that hex and then go to accent color, universal, make sure you do appearances, any dark. So for any appearance, again, the color, we did sRGB, and then we did 8-bit hexadecimal, and then paste that into there. And then we'll do the same thing with brand primary in the dark. There might be a quicker way to do this. I'm happy to hear it. And then for dark, you see we're doing display P3. Let's go back to sRGB, and then let's go to 8-bit hexadecimal, and you can see here's the 8-bit hexadecimal. Copy that, go to accent color, in dark, again, content, sRGB, not floating point. We want to do 8-bit hexadecimal, and then we'll paste in that hex code, hit return. See, we get the same color. So now that's the accent color for our app. So we no longer have that in our tab view. So if I delete this code, the Xcode crap, it doesn't like this preview. I'm getting rid of this preview. Brand new Xcode 13, you're going to have issues here. Okay, so we'll delete that accent color, now run it on the simulator, and we should see our tab view still working as expected, but we just deleted that code accent color. Yeah, so you see our bottom tab, we have that dark green. If I do Command-Shift-A for dark mode, you can see we get that brighter green down here on the tab. So cool, that is still working, accent color. Again, minor language deprecations you're going to see, especially early in SwiftUI. As SwiftUI matures, you're going to see these deprecations less and less. But in the early days of SwiftUI, this is kind of the norm every time a new iOS comes out. So always look for deprecations. That's another phase of the initial getting the app running in iOS 15. So now that we have no warnings or errors in our code, we fixed deprecations, we fixed any iOS 15 UI bugs. Now it's time to actually start adding the new stuff. All right, let's go. In this video, we're going to make some small tweaks to our UI. I'm going to show you how to hide the separator lines in a list, as well as change the color. We're going to add a badge to our tab bar for when we add items to our order. You can see that badge show how many items in our order we have. That's a nice little addition. And then I'm going to implement the new button system that we covered in the Frameworks app, except we're going to write a custom modifier to reuse that on various buttons. Okay, so first things first, the appetizer list view, right? So here it is. It's the list of our appetizers on the initial screen. So on each cell, we want to change the separator. So we'll do it above the tap gesture modifier. So it's relatively simple, right? You can do .list row separator, and you see it's a visibility modifier or parameter. So you can do .hidden, automatic, visible. So you can do .hidden, and we'll run the app, and you'll see our separator lines will be hidden on the cell. I'll do Command-Shift-A to go back to light mode, right? See, there's no separator lines. Purely a stylistic choice. If you want that clean look, there you go. If you want the separator lines, leave it in. Okay, so we'll stop that. So I'm just going to comment that out so you can still see the code, but we can also do .list row separator tint, right, where you pass in a color. So do that, and we'll say brand primary, right? We'll keep the look going. So brand primary. Now when I run it, you can see now our lines are green. I don't think that looks great, but I'm sure there's a situation where you'd want to color these lines or style them however you like. You can actually make the lines different colors per item, right? Like say our appetizer here had like a color, like a background color. Well, the color you would pass into this list row separator tint is whatever background color that appetizer had. So it can be dynamic, right? Some can have red, some can have green. Again, I think that would look pretty ugly, but I'm sure there's a situation where that would come in handy. So I'm going to leave that commented out because I don't like the way that looks, but I'll leave it commented so you can see the code in the source code. So that is how you can adjust the separators. Let's make that smaller. Now let's talk about the badges because I love how simple this is. So back to our appetizer tab view. I'm going to not show the preview because I kept getting the crashes as you saw. But before we get to the badges, I'm going to show you I can clean this up a little bit just because, I don't know, I like the way this code looks better. So you can make these a label. So instead of having an image and a text, that's pretty much what a label is, right? So you could do label, again, make sure you do system image name. So same thing, home, and you'll see how the code looks better. So all I did was passed in the text here and then the system image name here, same thing. So we'll delete that. And then when I see something like this, again, this is pure style preference. If you don't like it, that's fine. But I like to make that one line just to condense the code and make it pretty easier to read here. So again, same thing. Label, system image name, account, and then person. And you'll see why I'm doing this in a second. Well, at least why I like this. Because we're going to add a badge modifier to our order view. And then I like the way the modifiers look when they're all like on one line like this. Again, purely code style preference. As you go through your developer career, you're going to have many debates about like code style, highly subjective. So anyway, if you don't like this, cool, do you. All right, so label, tab item, there you go. But now when I add another modifier, this is the badge, right? Super simple, .badge. And you can see we need to pass in an integer, right? Because we want a number on our little badge. Now, what integer do we pass in? Well, I want however many items are in our order. If we go to our model, right, in our order object that we have here, right, we have an array of items. So I want to get the count of this items array, and that's what I want to show in the badge. Now, how do I get access to this order? If this is still fresh in your mind, you just did the Appetizers app, maybe you know we used an environment object. So if I go to my order view, right, you see we have environment object order. In fact, I'm going to copy this because we're going to need that exact same code. And real quick refresher on environment object in case you're coming back for the updates, or hey, just repetition, right? Remember we injected this order. If we go back to our app here, like the main root, right, at main, the main root of our app, we created an order and we injected it into the environment right here. So all of our views will have access to this order, but to get access to it, like we do in our order view, we have to create an environment object variable called order, right? And that's how we get all this information. Well, because it's up in the environment, like I said, all views have access to this. So if we go to our appetizer tab view, now we can get access to it in our tab view, right? Just environment object, like we just did, I pasted it in there. Cool, now we have access to this order. So when I want an integer to pass in, I can just do order.items. Remember, items is the array of appetizers, .count. And if the badge is 0, like if nothing's in there, it just won't display. Like it's not going to display as 0. So relatively simple. Now let's run it and we'll start adding some stuff to the order and you'll see the badge work magically. Like I love this addition. So we're going to add Asian flank steak, add to order. Bam, look at the badge on our order. Let's add chicken dumplings, add to order. I'm going to add a bunch of stuff real quick. So you can see, cool, 4 items in our order. And then another cool thing, if we go to order, I don't want the chicken dumplings anymore. Let's delete that. Look at our badge, went down to 3. Look at our badge, went down to 2. Look at our badge, went down to 1. And then our badge disappears because we have nothing in our order. That is awesome with relatively simple code. So that's our badge working. Now let's go to our button here, right? So if I go to views, buttons, right? We did AP button. Very similar to what we did in the frameworks app. Remember how we, passed in a title and had our styling like on the text, right? Well, what we're going to do is implement pretty much the same thing we did in the frameworks app for our button, except we're going to refactor that out into a custom modifier so we can reuse that on multiple buttons. I don't think we've covered custom modifiers in this course yet, so another nice learning opportunity. So appetizer detail view, let's get the preview out here so we can see what we're doing. Hit resume. Cool, you see our button $9.99 add to order. Now, if I go to the button down here, you see we have the AP button where we pass in the title. Just like we did in the frameworks app. Well, no, not just like it, because remember, we passed in a label so we could have the little book image. So we could have the book and then learn more. I don't necessarily want to add an image because we have the price here and then add to order. I think it would look too cluttered, too cramped if we tried to squeeze in an image there. So instead of a label, because we don't want an image, I'm just going to do text. And then the string I'm going to pass in is the string I have right here. So copy, paste that. I'm going to comment out this AP button here. So now we should just see some very generic text down there. So now let's start adding modifiers to our button. So .button style, remember this is the first one. This is the style that you're going to go with. Remember border prominent was kind of the style we want. I'm going to mix up the style a little bit. Remember I want to go bordered because I like that new tint look, right? Where it's the same color button with just the tinted background. So that's what we're going for again. And if you skip the frameworks app and just went right to this appetizers app, if you're coming back to the course, go back. I cover all this in depth. Here, I'm just going to do it pretty quickly to get the style we want. So I want to do .tint, and then the tint is .brand primary. And you can see what we got working over here in the preview as soon as I resume it. There you go. I'm going to click off the button so we get rid of that red square for the padding. Cool. If you like that skinny button, you're done. Again, I like my buttons fat. I like them nice and easy to touch. So you can do control size, and then we'll do .large. Now let's run this app to see this in action because you're going to see how this changes with dark mode too. And I think it looks really cool in dark mode. So let's see our button here. Cool. That's our button. Command-Shift-A to go to dark mode. And you can see we still got that change in color. And now those buttons look really cool, in my opinion, in dark mode. So that's the style I'm going for with my buttons. But you'll notice we use this button again in, well, let me add to order here. In order for place order, we're using this button again. Well, now we're like not consistent. I want that same look and feel of the button. So what I could do, stop running, I could just, copy and paste this and then paste it to my button in the order view. But the reason you don't want to do that is because let's say we do want to change our button style. Well, now I got to go to like every single button and make the change because I just copied and pasted. And that can lead to errors because maybe you'll miss a button or maybe you'll have a typo on one of the buttons and all your buttons won't be consistent. So what we want to do is we want to refactor these modifiers away into a custom modifier. That way on the button, I can just put one modifier and say standard button style, and I know it's always going to be the same. And if that standard button style changes, I can just go into my custom modifier, make the change there, and all my buttons will update. So that's the benefit of doing this. So here in views, right click, new file, and I'm going to create a Swift file here next. And again, this is project organization, but usually I just do custom modifiers because I don't usually have too many of these. So I like to have one file, and if I have 5 or 6 custom modifiers, they're just all here in this file. Again, if you use custom modifiers heavily, maybe you want to organize a little bit different. Again, that's project structure, organization, highly, highly subjective. So import Swift UI, and I'm going to do a struct called standard button style. And the reason I called it this, well, real quick, this is a view modifier. And the reason I called it standard button style is typically in apps, you have many different types of button styles. I don't know, throughout the app. So the standard button style would be like, that's my typical button. And if I had different buttons, maybe I had like a checkout flow and I had like a checkout button style, and that was different, right? You can see how you would label your button styles differently, but we're going to call this standard button style. So you can see I'm not conforming to the view modifier protocol because that needs a func body. You can see body, content, some view. So content is whatever you're putting this modifier on. So in our case, it will be the button, but we just want to basically modify the content, right? Which is some view. So let me show you what that actually means. So when I go to appetizer detail view, whatever I put this modifier on, like you're going to see, we're going to put a modifier here. The content would be the button because that's what the modifier is on. So while I'm here, I'm actually going to copy this. I'm not going to cut it because I'm just going to comment it out again, just so you can see the code in the source code. And then I'm going to go to the custom modifiers here. And those are the modifiers that I want to put on this content, right? Button style, tint, control size. Now, button style can only go on a button. So what's going to happen if I try to put this on a different view? Well, these modifiers just aren't going to apply, and it's going to be like nothing happened. So that's fine. So now what I can do, if I go back to my appetizer list view here, right? So the modifier I can put on, I can do dot modifier, and you can see this is where you put in your custom modifiers, and I can do standard button style. I'll initialize that, do a command B, and resume my preview, and you should see that the button doesn't change. It looks the same. So now what I can do is go to my order view, like where this button is, right? Instead of app does not like previews, Xcode 13. Just so you know, we all deal with these like bugs and issues. So anyway, here's the button. Here's the AP button. That's the old custom button that we made. Well, I don't want the custom button. Again, I just want this to be a text. And then the string I'm going to pass into the text is this one here, same thing, and comment out the AP button. And then here's where the power comes in, right? I can just do modifier, standard button style. And then now when I run the app, my order view should have that button. And again, all I had to do is add my custom modifier. So let's add something to the order. Cool. Check the order. Now it looks like that as well. So now you can see if you had a bunch of these buttons in your apps, you just add that one little modifier to the button and you get your standard button style. So it's nice. Now, another way to refactor this, I'm not a fan of this style, but again, style is subjective. But what you may see as well is I'll just do it in the custom modifiers real quick, since this is just an example. Normally you'd want to put this extension in a new file. So you do an extension on view, where you do a func, and you would say, standard button style, and then it would be self.modifier, basically what we just typed, standard button style. So that's basically, you can put this on any view. And the reason you would do something like this is so if we go to our appetizer detail view, the button, what was that warning? Oh, I forgot to return some view. Yeah, you need that for a modifier. So now when I go to the appetizer detail view, and again, this is purely code style, you would just do dot standard button style. Here's why I'm not really a fan, is because this is just a function on a view. Like I could have put anything on that function. Yeah, I named it standard button style. I don't know. I like the fact that I have to type dot modifier. So I know, and the reader of my code knows, hey, this is a modifier, right? That's all this is a modifier. Whereas this, you can have other stuff in that function. Who knows what it does? Even though if you named it properly, like standard button style, you're just styling the button. I'm really splitting hairs here, but I think it's a good discussion on, just code style and why people like certain things, right? This is cleaner. And if you name it right, it'd probably be good. But I kind of like the fact that this is a modifier. Just my preference there, but I'll comment that out so you can see both ways in the source code. But that is our buttons now working with the new iOS 15 button system. We also talked about showing and hiding and colorizing the list separators, and we added our badge, which I think is really cool, that worked pretty flawlessly with very minimal code. In this video, we're going to work with the new @FocusState property wrapper for SwiftUI introduced in iOS 15. And we're going to use this to improve the UX of our keyboard so you can just navigate through our account view form pretty easily by just tapping the next button on the keyboard. So here I am in the account view, and again, just continuing on from the previous video. So the first thing I want to have is @FocusState private var, and I will call this focused text field. Because we have more than one text field, right? We have our first name, last name, and email. So I need to keep track of whichever one is focused. And what I mean by focused is which one they're tapped into, where their cursor's at, and what the keyboard is, inputting to. So focused text field, I need to keep track of that. You might think, oh, this is going to be a text field, but no, I need to create an enum to help me keep track of that. So I'll do that real quick down here. So enum, we'll say form text field, and that will be a case of first name, last name, email, right? Those are just our text fields. So now our focus text field is of type form text field. And you're going to see how we utilize that in a second. If you're a little confused, hopefully it all makes sense at the end. And as always, I go back and explain things so they do make sense. Oh, I'm sorry, this needs to be an optional because I don't want to give it a value because nothing is focused in the beginning. They got to actually tap something to be focused. So that will be an optional. And another reason, because when we make it nil, that will dismiss the keyboard. Again, you'll see that in play later. So let's use this enum. So on each text field, right, we have first name text field, last name text field, email. So on each one, I can set like what their focused means. So I can do .focused, and you can see I get this parameter that has equals in it, where I can like give it a value. So focused, see it takes a binding to a focus state, which our focus state is up here on line 13. So I need a binding to @focused text field. So if I do $focused text field, there's my binding, and then equals is whichever enum case I have here. So I want this to equal, and it's got to be hashable, which our enums are hashable by default. So this is going to be first name. So basically what I'm saying is when this text field is focused, the focused text field equals .first name. That's essentially what that says. Cool, so I'm gonna copy this modifier because we have to tell our other text fields like, hey, when you're focused, what does it mean is essentially what I'm saying. So .focused, focused text field, except our last name text field, I'm gonna put some space in between to make it easier to see. So our last name text field, the focus equals last name. And the reason we're doing this, just to get a little bit ahead of myself, is because we need to change the focus manually when the user hits the next button. And this is how we know what to focus next. So now email focused equals email. Okay, so now that our text fields know what they're focused, when we hit on submit, we need to change that focus. Now, what is on submit? Okay, let me run the app and I'll show you what I'm talking about here. Maybe should have done this in the beginning to explain it, but this should clear things up. So when I have the keyboard open, and if on your simulator, your keyboard doesn't show up, do a Command K. So see this return button in the lower right? This is what happens when on submit fires off. What I want to do is, one, I want to change this instead of saying return, I want it to say next. We'll get to that in a second. But on submit is what fires off when this happens. So what I want to happen on submit is it to just go to the next text field. Again, we're improving the user experience of using our form, so I don't have to keep tapping each one. They hit next, they go to the next text field. Right now when they hit return, the keyboard dismisses, they have to type in last name and the keyboard goes up and down. So you're going to see it's going to be a much smoother user experience. So we'll stop that. So back to on submit. So focused, I want to do on submit. So now what I want to do is change the focused text field, right? So I want the focused text field after first name to be last name, right? We want to go down the form. So focused text field equals .last name, right? I want it to be this next one. And I'm going to make this one line. Again, code style. You do you. If you don't like that, that's fine. But I'm going to copy this line because when we tap on submit on last name, I want that to go to email, right? The next one on the list. Now, the interesting thing, email is the last one on the list. So what do I want to happen on the last name? Well, if they hit next, I want the keyboard to dismiss. Because again, if we look at our form, go to account, right? They go first name, last name, email, and then now they're on the birthday. There's no thing. So if they hit return here, I actually wanted to dismiss the keyboard. Well, all right, I already got some code in there messing with it. I wanted to dismiss the keyboard there. So that's why I want focus text field to be equal to nil, and that will dismiss the keyboard when they're done. Okay, so now you saw that was that return button down there. Well, I can change that label. So that's just called the submit label. So .submit label. and you do dot, you can see you can't like set it to anything. So you have to be return, continue, done, go, join. You've probably seen these in keyboards a lot. Next, route, search. So you would name this whatever is most relevant to what you're doing. So on first name, I want this to be next. And then on last name, I also want that to be next, right? And then email's a little different, right? Because that's when we get to the end of the form. Instead of next, because there is no text field for them to go to, I want this to just say dot continue. Right, continue with the form. So now when I do this, we should have this basic functionality working, right? So account. So look, I'm in the the first name text field. Look, my button says next. When I tap next, the keyboard doesn't go away. I don't have to tap the last name. I go right into last name. Cool. Then I hit next, go right into email. And then now you see my button change to continue because there's no other like text field to go to. There is no next text field. So when I hit continue, it just dismisses and I can go to birthday and all that stuff. So again, a much better user experience. Now, we need to add one little thing to our user experience to really make it nice, and that is dismissing the keyboard. Because right now, when I'm in first name, like I can't dismiss the keyboard. I used to hit return to dismiss the keyboard. Now it's like, wait, like how do I dismiss it? I got to go next, next, continue. So we want to add an accessory view on top of our keyboard to dismiss it manually should they do that. And again, all we're doing here is just improving the user experience of our form. So we'll stop running this. Now we want to do this for our entire form. Like anytime a keyboard pops up on our form, which is only in these first three text fields, we want to have this accessory view. It's a toolbar that you can put on the keyboard. So here in our form here, so I want to make sure I have I'll do some code folding. I need to get better at doing this. Okay, so here's my form modifiers. So below the navigation title, I want to do a .toolbar, and then now I'm going to unfold this. I always like to just fold it to make sure I'm on the right curly brace, but now that I know I'm there, let's update our toolbar. We'll need a toolbar item group, and then you see that takes an initializer of placement, and placement is the key new feature here. Again, this is new in iOS 15. So the placement, I'll do dot, well, you're not going to give me the autocomplete. There you go. Bottom bar. There's a whole bunch of different places you can put it, right? Depending on how you want to use it. We want to put it on our keyboard. So this will put a toolbar that's always on top of our keyboard, right? So that's what that is. And then the content is a simple button. So we'll do button, and then I don't want to like style this or anything like that. I guess you probably could. I haven't experimented with that. Maybe you can experiment with that. But I just want a basic title and action, right? So the title I want is dismiss, and then the action is I want to dismiss the keyboard. Do you remember how we dismiss the keyboard? Back up to our focus state. All we do is set our focus state to nil, right? Just like we did on the on submit for email, and that will dismiss the keyboard. So that is just focus text field, not focus state, equals nil. And again, like I said, I'm going to put this on one line. I just like the way that looks better. So now you're going to see a toolbar on top of our keyboard anytime it pops up. When we tap the dismiss button, we're going to set the focus text field to nil, which dismisses the keyboard. Okay, test it out. Back to our account. Okay, so Sean pops up. There's our dismiss button. So I can type, I can go to next, but let's say I don't want to go to next. I just want to dismiss. Boom, keyboard dismisses. I'm in email, dismiss. I'm in last name, dismiss. And again, I can go through the form just by hitting next down here in the lower right, next, then when I get to email, continue, dismiss. Again, we just made our form less annoying to deal with. And I'm sure many of you have filled out very annoying forms before in the past. So anything you can do to make this user experience a little more pleasant by making it convenient and easy to fly through a form, you definitely want to do that. And hopefully you learned a little bit on how to do that with the new in iOS 15, things like on submit, submit label, the keyboard accessory view, all that stuff. In this video, we're going to dive into the new concurrency system introduced in Swift 5.5 and iOS 15. And I'm going to be honest with you, it's a pretty big system. Like there's no way you're going to learn everything you need to possibly know about this new system in this update section. Like it's so big, it's going to be released over multiple Swift versions over multiple years. Like this could be an entire course in and of itself. Now, I don't want to scare you because in this video, we're going to cover the basics and the context and the initial foundation, right? The fundamentals of it. So when you do go to learn all the future stuff around it, you're coming at it with a solid foundation that will help that learning even more. So what we're going to do here is, again, I'm going to give you the context on what it is, why it's happening, the benefits of it, and then we're going to refactor our network calls in the Appetizer app to the new async await so you have experience with it, you've seen it in action, and I think that will really help, again, your future learning. So on to what this is, why it's happening, etc. So here is a gist from Chris Latner. Highly recommend checking it out if you're interested in this stuff, but you see the Swift Concurrency Manifesto. By the way, if you're not familiar with who Chris Latner is, He's no longer at Apple, but he was at Apple in a big part of the creation of Swift itself. But anyway, this concurrency manifesto, here's the table of contents. I'll scroll real quick. You can see it's ridiculously long, tons of code, samples, all that stuff, all the reasons behind like why they wanted to do this and how. Here's the table of contents that I wanted to show you, right? Part 1, async await. Part 2, actors. Part 3, 4, 5. So with Swift 5.5 and iOS 15, I believe we got parts 1 and 2, and 3, 4, and 5 will come, in future Swift versions. But the foundation is being laid, and again, check out this manifesto if you really want to get nerdy about this stuff, right? It talks about the past and why they did things and where they want to go. Speaking of where they want to go, here's the roadmap. And again, for context, like they've been talking about this for a while. Like you see the date of this is October of 20. So about a year ago, we laid out the roadmap and now it's starting to execute. But if you're curious about the timeline, you can see here, right? You can see the introduction of these new features will span multiple Swift releases. Features will be introduced in broadly 2 phases, right? So Swift 5.5 was the first phase. So the first phase introduces the async syntax, which we're going to talk about, actor types, which we're going to talk about. The second phase will enforce full actor isolation, eliminate data races, do a bunch more stuff. So the reason I'm pointing this out to you is, again, so you can go check it out. You can see their ideas. You can see, again, the motivation behind this if you want to learn all the history. But again, I wanted to illustrate that it's a huge topic, and we're just going to barely scratch the surface here in this video. And lastly, like I mentioned, WWDC 21. This was all introduced in June of 2021, right? Just a couple months ago, and it just came out of beta like a week ago, as of, late September 2021. But you can see here's the WWDC session. I think there's like 5 sessions dedicated to this topic. Here's where I would start, by the way. Meet, async, await, and Swift. Oh, I didn't mean to click on it, but that's where I would start. But you can see all these WWDC videos. So yeah, it's a big deal. And like I said, I think this video will give you the foundation, the general knowledge. So when you do watch these videos or do more research, again, you're coming at it from a place of context. Okay, enough rambling about the history. Let's actually dive into some code. So here I am in our network manager. We're going to focus on this call, right? This get appetizers call, which pulls up this list of appetizers that you see here. We're not going to mess with our download image function because iOS 15 and SwiftUI 3, or that's what we're calling it, I guess, also introduced something called AsyncImage, which wraps up this downloading images like into an object. Pretty cool stuff. There are some pros and cons to it, which we'll talk about in the next video, but that's why we're not going to mess with this function because that's going to be handled there. So we're really focusing on this get appetizers function. What I'm going to do is copy this whole function. And the only reason I'm doing this, let me comment it out, is so you can see like the before and after, right? You can go back for your learning and compare and contrast like what we had versus what we did. I think it's helpful to leave the old code there so you can see that rather than deleting it. But now that we have our copy, I'm going to start hacking away at this. And throughout the process, I'll talk about like the benefits of this new async await system. And then at the end, I'll go back and do the run through as I usually do. So if you don't quite get it the first time through, you'll get another chance at it. So one of the big errors that happens in this asynchronous code the old way, this old closure way or completion handler way, was you'll notice every time there's an exit from this function, like we get an error or we get an invalid response, we have to manually call completed, right? Completed, failure, invalid URL. If we miss a spot, like let's pretend we didn't have this code here and we just had return. Well, if this happens, the code's just going to return. We're not going to show an error. Nothing's going to happen. It's like a mystery to the user what went wrong. As developers, we have to make sure we handle every single exit. And that's error prone, right? Sometimes people miss one and they forget or whatever, and that leads to errors. So a big part of this new async await is not allowing that. So to do that, we get rid of this whole completion handler paradigm like altogether. But before I delete this code, let's pay attention, right? What does this return? Like the end result of this function returns an array of appetizer. So let's remember that. So we're going to delete our whole completion handler, right? And we're going to return that array of appetizer. Now that's a much simpler function signature, but we're not quite done yet. We have to mark this async to use the new async await system. And that's one part of it, but we also want to throw various errors, right? We still want to handle invalid URL, invalid response, invalid data. And actually on that note, what I'm going to do is we're going to do this first without handling individual errors, because handling these individual errors actually adds a bit of extra complexity that I think might be confusing in the beginning. So we'll do a really stripped down version where we don't care about specific errors. We still want to throw an error if something goes wrong, but it'll be a more general error. Like, you've probably seen them before, right? Something went wrong with your task. Please check your internet connection or try again later, right? Those generic errors. We're going to work with it in that format first because that will focus on async await. Because again, handling individual errors adds a bit of complexity that I don't want to confuse you with. We still want this to be async throws. So the throws means we want to throw an error if something goes wrong. We'll come back to this more when we handle the individual errors, but you'll see this is also kind of a catch-all. Like this won't let us not throw an error by marking it throws. Oh, actually I put these in the wrong spots. That's what this error is right here. It says async may only occur before the arrow. Sometimes, when you're talking and teaching, you mess up little things like that. Yeah, so async throws goes before this. So let's read this function signature, right? Get appetizers, it's an async function, it's gonna throw an error, and it returns an array of appetizers. You'll notice, this isn't optional, like we don't return an error. If this function is not able to return this, it's gonna throw an error, you'll see. I'm just gonna comment this out for now, these specific errors, because again, we're gonna come back to these specific errors, but so I don't wanna have to retype them. But for now, we're going to keep it simple with just a generic error. So the first big thing here is we have this let task, URL session, data task with URL. And if you remember from the previous way, like it returned data, response, error, and these were all optionals, right? That's why we did if let error equals error, guard let response equals response, guard let data equals data, because we had to find out if we had a value here because they were optional. Well, as you'll notice, we no longer deal with optionals in this new thing. Another nice little perk here. So we don't have to do a task here. What we do is let, and we do a tuple of data, comma, response, and I'll show you how I know this here in a second. Try, await, these are the two keywords you need. And now we do the URL session.shared.data from. Now this is the new one. You can see it's marked async and it throws. That's the key thing. So this data from is what we want. Now delegate, we don't need that. That can go away. Now we do need the URL, and that's not an optional, right? So I know I said we're not going to handle specific errors. Here's a little taste of how you handle specific errors. We'll just do just this one because I need that URL and I don't want to write a bunch of hacky code just to get around it. So basically garlet URL equals the appetizer URL. Else, we don't want this completed anymore, right? Or the return, because our return is going to be throw. This is the old completion handler way. Now when we want to throw an error, we will say throw, and then we can do AP error, which is our custom error that we created before, dot invalid URL. So that is throwing our custom error. Remember, that's what I said. I didn't want to get into too much, but it'll make it a lot easier. So we need the URL here that we unwrapped right there. And if that URL is invalid, we throw the AP error. Okay, that'll be the last custom error we do initially. So let's talk about this line here, right? This line basically replaces this. And if I click into hold Option and click on it, hit open in developer documentation, you can see here's the data from async throws, and URL session delegate equals nil as the default. That's why I was able to delete it. But look what it returns. It returns a tuple of a data and URL response. Okay, so that's where I got this data response tuple right there. Now, the thing you'll notice, if I go back to that, it wasn't optional. Look, data and response are not optional, which is a huge difference from how it was here, where data, response, and error were optional, right? Now, what's going to happen is if they do return nil, like we don't have a data or response, that's why this throws. This will then throw this overall error that we talked about. So we don't need to handle the specific cases when data, response, or error are nil. We just get data and a response, and we can use that. So that being said, I can delete this URL session data task. And what I'm going to do is I'm just going to start deleting stuff as we go through. And again, if you're not quite following, I will do a recap to tie it all together. But because we don't even have an error here, we don't have to like unwrap it. Cool, guard that response equals response. Like, remember, we're going to handle generic. The only reason we wanted to mess with this response is so we could show a specific failure. Now, big picture, usually you want to be very specific with your users on what errors to show. I'm sure you've all received that generic error that tells you nothing and is more frustrating than helpful. So definitely want to do that. That's why we'll come back and I'll show you how to do that. But for now, on this easy one, I'm not even going to mess with, well, I'm going to delete the return and completed because that's the old completion handler way, but I'm going to comment this out for now. We'll revisit it when we want specific errors. And then this whole guard let data. Remember, data is not an optional anymore, so I don't have to unwrap it. That goes away. So now we're into the do, try, catch that where we're working with our data, right? Where we have our decoder, we have our decoded response from the data, right? And this data is not optional, so we have it right here. And then I don't need the completion handler, right? Don't need that. But before I delete it, remember, decoded response.request is our array of appetizers. Just for refresher, if I command click into appetizer response, which I misspelled, Respose. I won't fix it now because that'll derail me. But you see the request is the array of appetizers, just as a refresher. So that's what I want to return, right? Because this function returns an array of appetizers up here. So instead of completed, I will do return decoded response dot request, right? Because it returns an array of appetizers. And then here, instead of completed invalid data, we'll do throw ap error dot invalid data. And then we can delete this task.resume because we don't have it. So now if we go back and look, we're doing the same thing, but it's a lot simpler, right? Because we don't have to handle every possible exit. So, right, we make sure we have our URL, cool, if not, throw invalid URL. And then we get our data and response back here, right? And because this is marked try and await, if it fails, it's just gonna throw an error, right? And we'll handle that accordingly. And then we're not worried about specific responses, so we can go right into decoding our data just like before. And if the decoding fails, we'll throw invalid data. Now, back to these errors, right? What we throw kind of like doesn't matter here. It's how we handle it on the other side that matters. That's why, even though I said we're just doing a generic error, I'm throwing specific ones just to basically get Xcode to shut up. Again, how we handle it at the call site is what really matters when it comes to this, and I'll show you both ways. Okay, and it looks like I have a copy and paste error here with an extra curly brace. That's what happened, too much scope. So I'm gonna highlight this, Control I to really line that up again. And you know what? I am going to delete this just to really clean that up. We'll come back to that. So yeah, one quick run through because I felt like I was a little jumbled there. So I'm going to really tighten this up here, right? So we have our function signature of get appetizers. It's marked async throws and it returns an appetizer. Marking it async lets you know that, hey, you can use the async and you can see the await keyword here. You don't have to mark it throws. Like if you're not going to throw an error, you don't have to mark it throws, but we do want to throw an error. So we marked it throws. And then here's where we're unwrapping our URL because we need a solid URL, right? To pass into our URL session here. And if we don't have that, we're going to throw invalid URL. And then here, this is the new way to do a data task. And the key difference here is it returns a tuple of a data response that aren't optional. We don't have to unwrap any more optionals. That's great. Because if this fails, it's just going to throw an error. Remember, like I said, it was like the catch-all. We don't have to handle all the individual exits. So cool. Now this is all basically the same as what we just did, right? We have our data, use our decoder, we decode it, and then we return the decoder response.request. In fact, what I could do is instead of saying decoder response and decoder response.request is that's just kind of a little extra line here. I can just return the try and then do .request at the end of that, and that gets rid of that because this is the response and then .request. So just one little extra line of code because again, this is marked try. So if this fails, right, if I can't decode the data, it's going to throw the API error invalid data. So as you can see, when we're not too concerned about our custom errors, really the only custom error we didn't throw was our response one. This gets a lot simpler. Now let's talk about the call site. So if I go to my appetizer list view, you can see where we're calling it here, on appear. So this is the first order of business, right? On appear, the only thing we're doing in on appear is making a network call. So there's a new thing called .task, which is very similar to on appear, and it's basically meant for specifically this thing where you come to a new screen and you're making a network call. The benefit of .task, well, real quick before I forget, let's put our view model in here and let's delete on appear, is that it'll put you in an async context, which means you can use your async await code. And what happens is if the user navigates away from the screen before our network call completes, it automatically cancels the network call. Again, this was basically tailor-made for making a network call when the view loads, like we're using it for. So now we want to go into our view model to the get appetizers here. So appetizer view model, get appetizers, right? Here's this function. And again, the reason this looks so complex is because we're handling the individual errors. That's what adds that extra layer of complexity. But I'm going to do the same thing. Well, you see we're getting errors because we messed up our function here. I'm going to do the same thing where I copy, comment, and then paste it down here again so you can see the before and after. And I'm going to delete everything, really. Delete this whole network manager. I'll keep is loading equals true because that's going to happen. But now this gets a lot cleaner. So let's scroll up a little bit. I know it might be hard to see, but the whole point of this network manager, right, is to, in a success case, you see we set appetizers or self.appetizers equal to appetizers, right? Which is our publish variable appetizers. So when that array updates, it updates the UI, right? Triggers all that. And we're doing all that on the main thread. It's another benefit of async await we'll get to in a second is we don't have to manually put something on the main thread anymore. Another common error that gets abstracted away into the language. Backing up real quick, that's kind of the point of async await is to take a lot of this error-prone code. Like I mentioned, all the exits from the completion handler that we had to handle, and sometimes you miss one. Here we're talking about, routing things to the main queue. Sometimes people forget that. That causes a lot of bugs. A lot of error-prone code is getting like abstracted away into the language. It's one of the benefits of doing this. And the code is like easier to read and understand. That's the whole like point of why this is happening. I probably should have mentioned that in the beginning. Here we are. Anyway, so we want to return an array of appetizers. That's the main goal. So what I do is and it's going to be in a do try catch block because like I said, when this fails, we want to handle the error accordingly. So I'll say appetizers equals try await. And here's where we use our network call. So network manager.shared.get appetizers. Now, what's going to happen here is if we get a great appetizers, everything goes smoothly. Cool, it's going to be set to this and our UI will update. If this fails, however, it's going to go into the catch block. I'll handle that error in a second. And this is where we will show our error. So we'll say alert item equals, we don't have a generic error, right? So if we go to our alerts in the alert thing, right, all this alert context, we don't really have a generic one. We can create one real quick, but this video is already pretty long. So you can imagine just creating another one of these like generic errors that says something along the lines of like, we were unable to complete your request at this time. Please check your internet connection or try again later. Some generic thing is what we would fill out here to show. But again, I want to keep this focused on async await and not get distracted with this little stuff here. So we're just going to say equals alert context dot, we'll say invalid response. Again, this would be where our generic error goes, but that's what we'll put there for now. So now what you're seeing here is async call in a function that does not support concurrency, right? So this is where we need to mark this as a task like we did before. So you do task, put it like that, and put this in here. Now you're in an async context. There's other ways to do this. Like you can mark this function async, but you got to do other stuff to the function to get that to work. So the simplest way here is to just wrap this in a task to put it in an async context. So I want to make sure I handle this is loading, switching that back to false on both of these cases. So I got to make sure I do that here. Is loading is true. Don't make it false. That way I hide the loading spinner, whether we get a good response or a bad response. Now that's pretty much it when we're not handling specific errors. If I go back up to our main function, you see the bulk of the work was handling our specific errors there. So again, that's what adds that confusing complexity that I wanted to stay away from. But some things you may notice, right? This self, and you may have seen like weak self before. You no longer have to handle that in the new async await. That was another common source of errors, was that whole weak self dance. That's out the window. And then the other thing you'll notice here on line 21, I'll actually uncomment it to make it easier to see, we're manually putting this on the main thread. Remember I said you no longer have to do that in async await. So let me comment that back out. And that's because we now have something called actors. So by marking our view model at main actor, basically anything that happens in this view model that's UI related will be rerouted to the main thread. So to put it like very simply, marking this at main actor basically does the same things as dispatch queue.main.async, except it, again, abstracts it into the language and like does it for you. And again, for context, I'm giving you super high level foundational stuff because again, going super deep on it would be an entire course in and of itself. But let's make sure this works before I do the recap. So I'm going to run it and we should see the app acting like as we expected, right? Nothing should be different. Yep, here we are. Our image is loaded. App is still working. Accounts there, order there. Cool. Yep, cool. So again, we just refactored the network calls. Okay, so let me do a recap because again, I know that might have been fast. Maybe the first time you heard it might be a little tricky. So back to network manager, right? Okay, so the only reason we're getting this error is because we didn't use response. So for now, I can do that to shut it up. Do Command B, should be good. Okay, so now let's run through this again real quick. Again, review, repetition, that's the key to learning. Function signature, it returns an array of appetizers, but we marked it async. So we're in the async context, we can use async await. It throws because we want to throw an error. So because we marked it throws, if I go back to the call site in the view model, that's why we have to use a do try catch because it throws an error. So in the catch is where we catch the thing that's thrown, right? We catch the errors and handle them accordingly. And how we're handling them is setting our alert item to our placeholder for a generic response that will show the alert. back to the network manager. Okay, so that's the function signature. That's why we mark it throws. And again, the benefit of marking it throws here is that's the catch-all. If anything in here like fails, like we have to handle the error, whereas before we could like forget to handle one of the completion handler exits and we wouldn't handle the error. It'd be confusing. Very common error. So here we're just unwrapping our URL to make sure we have a good one to pass into our data here. Now this is the new in Swift 5.5, this URL session, share.data from URL. Like I said, it returns a tuple of a data and response. These are not optional, right? You're gonna have them because if something fails and you don't have them, because this is marked try, now it's gonna throw an error, and then back to our appetizer list view model, because it threw an error when it tried it, it's gonna go into the catch block, and we're handling that with our generic error. Okay, so that's that line. And because we're not like parsing through the individual responses with the status code, like status code 200, 404, 500, like we're not worried about showing individual errors. We don't need to do anything with the response. We only care about the data. So now that we have the data, we can do what we did before, which was have our decoder and then try to decode an appetizer response from that data. And then I want that response.request, which I showed you the request is the array. So I'm returning that array up here. And then if this fails for some reason, like I can't parse out that array of appetizers from that data, we throw AP error invalid data. And then now let's start talking about these custom errors, right? So when I'm throwing this invalid URL, throwing invalid data, this all happens in the catch block. So you'll notice this doesn't throw one of our specific errors. This throws like a typical Swift error. So how we can handle the difference here and handle the individual errors is to go to our call site. And I'm just going to leave the response one. I mean, once you see how I handle these two, you can see how to do the response one and should be able to put that together. We'll do appetizer list view model here. So in our catch block, we have to check for the type of error. So what we can do here, and this is what I was talking about, how this adds some like complexity that doesn't really have much to do with async await, the core principles of it. So I wanted to add this at the end so I wasn't too confusing. So what we can do is just check for the type, right? Our errors that we're throwing, our custom errors, are AP errors. And as a refresher, if I command click into that, remember this is the error we created right here. That's our kind of custom error type. So I want to differentiate between that custom error type and the error that's thrown from here, by Swift automatically. So back to appetizer list view model, right? I can check for that. If let, we'll say AP error equals error. So this error is what gets passed to the catch block. And then I want to cast it, right, as AP error. So essentially what this line is saying is if the error that is in this catch block is of type AP error, okay, cool, let's do some stuff here. And that stuff I'll do is I will basically do similar to what we did up here, right, where we switched off the error and checked the cases, right? So I will switch AP error, and then you see I hit return, another new Xcode 13 benefit. It gave me all the possible cases, right? So essentially I want to do basically this same exact thing right here, right? So just to really play it out, we'll say alert item equals alert context.invalid URL. I'm just going to copy and paste this so I can speed this up a little bit. And this is .invalid response, invalid data, and then unable to complete. Now you'll notice if I go back to Network Manager, I'm only possibly throwing invalid URL and invalid data, but I want to keep these other cases in case that ever changes in the future. But really invalid data and invalid URL are the only ones that are possibly thrown. But this is how you check for your custom error, right? Is it of type AP error? And if it's not of type AP error, then you would do an else statement on that if let up here, right? If that's not the case, then we want to set our alert item to our generic error. And I know this says invalid response, but remember this is just the generic error placeholder. So you can see why I didn't want to like start with this, because this is just handling specific errors. Doesn't really have much to do with async await. So I didn't want to confuse you with that. Hopefully that wasn't too confusing. Feel free to ask questions in the comments or on the Slack channel. But that is async await. Again, if you're not handling specific errors, it's really short, simple, nice. And again, the main reason you may think, oh, this isn't much less lines of code. It's not necessarily about being less lines of code, even though sometimes it is. It's more about, like I said, back to the network manager and all these completion handler exits. It's more about abstracting away many of the common errors when writing asynchronous code. Again, handling all the exits, doing the weak self dance, routing things to the main thread. Those are all very common errors. And what async await does is abstracts that away into the language and protects us developers from making those errors. Now let's talk about AsyncImage, a wonderful addition to SwiftUI. And the use case for it is like our appetizers, right? We are downloading an image for our cell here. Well, to refresh your memory, here I am in the appetizer list cell, and we wrote this appetizer remote image. Remember that? If I command click on it, we can go to the definition here, jump to that, and you see we had this whole like image loader, remote image, appetizer remote image. It was kind of this confusing like dance we had to do to get this working. Well, all this gets handled, I shouldn't say all of this because there are some pros and cons. We'll talk about it at the end, but most of this gets handled in AsyncImage for us. Again, real great stuff. So back to appetizer list cell. Here I'm going to comment out appetizer remote image. That's what we had initially. And now I'm going to type AsyncImage, right? You see it right there. And if I do the initializer, you see we get a couple different ones here. So we have just a URL, we have URL content, and placeholder. So the content allows us to tweak the image like we want, right? We want it to fit in our cell. We want the corner radius on our image, etc. And then this one allows us to put a placeholder, which is also what we want because that's what we were using before. So the URL I can pass in is the appetizer image URL. And the nice thing, you'll notice this isn't optional because what's going to happen is if this URL fails, like if the URL returns nil, it's just going to show the placeholder. That's already all built in. So we don't have to like worry about unwrapping optionals. I can't even remember if our appetizer.image URL isn't optional. I guess we'll see. Appetizer.image URL. No, that was not an optional, but hey, it doesn't matter. So the content, this is what happens, as you can see, when we get back an image. So if it downloads it and everything's great, like we got a good image, we need to show an image here. If not, we show our placeholder. So this is the UI image, so we can just do image right there. And then below it, right, we do .resizable. Remember, this was abstracted away, I believe, in our appetizer remote image here. Yes, we did image.resizable, right? So we abstracted that away, but we're actually going to do that here now because we're not using our abstraction anymore. And then we'll just do the rest of our modifiers that we had up here, right? We had .aspect ratio. So I guess I just did content mode there. .fit, .frame of 120 by 90. We don't need an alignment, and then corner radius of 8. Cool. Now we need to basically do the same thing for our placeholder, except our placeholder is image and we want name, not system name. You could use an SF symbol like if you wanted, but we have our custom like placeholder, remember? So we want image named. Where's that at? I guess it's right here. We don't need that, but I can delete the bundle here. Initializers, so many of them in SwiftUI. But what is the placeholder image name we had? I'm going to go back to our assets here, food placeholder, right? There it is. So I'm going to click on that, copy that, go back to our appetizer list cell, paste that in there. And then now I need to give it these same modifiers if I want it to look the same. Maybe there's a case where you want your placeholder to be of different dimensions, different sizes than your actual image. You know, I'm sure that's a case. That's why you have this flexibility. But for us, it is exactly the same. Now, I'm not going to do this in the video. Let me do a Command B real quick. I hate seeing errors. Okay, what is going on? Oh, that's what's going on. This takes a URL. I pass it in a string. So if I Command click on image URL, jump to definition, you can see our image URL is a string. But AsyncImage takes in an actual URL. So let me delete this, and we need a URL. You can initialize a URL from a string, and the string we'll pass in is appetizer.image URL. Do a Command B. Now, normally this returns an optional, and we either have to give it a default value or force unwrap it. But like I said a little bit ago, AsyncImage takes in an optional URL. So if this URL fails, it's just going to show the placeholder. So that's super nice. All right, Command B. No errors? Okay, cool. Good to go. So let me run through this one more time, right? AsyncImage is built in. It's going to try to download the image from the URL that we pass in. If that image fails, or while it's downloading, it's going to show the placeholder, which we set here. Once the download is complete, and it's successful with an image, it's going to show the image, and then we added our modifiers, which again are the same. Now, let's actually resume the preview. We should see our placeholder here, I believe. Yep, there's our placeholder. What I'm not going to do in this video, but we did in a previous video, so if you want to take that on as a challenge, go ahead. As you can see, maybe we have this as a custom modifier, right? We refactor these away, so instead of adding the same modifiers to both things, we say maybe this is a list cell image style or something like that, right? But feel free to take that as a challenge. If you're not sure what I'm talking about, I believe we did this a couple videos ago where we refactored our AP button to use the standard like button style. Now let's run this to make sure it works, and then I'll talk about the con to using this method versus the method we were using. Yep, there you go. You saw the placeholders for a second while they were loading, and then here they are. Right, here's all of our image. Now, the downside to AsyncImage is that you'll notice in our remote image, well, I guess that will be in our network manager, right? Where we did this, where we downloaded the image, we have a cache, right? We're caching the images, and if we have that image in the cache, we're not downloading it again, right? We already have that image. Well, the bad thing about AsyncImage is it doesn't cache for you. So if caching is important to you, I wouldn't use AsyncImage. I would use our old method that we did before. Now let me expand on that if caching is important to you. So for our app, right, let me pull it back up. Right, we have like 5 images. You can't really scroll that far. I would say maybe we're borderline. But you know, if you had a list of 1,000 things and as you were scrolling every time, like nothing was caching, absolutely you want caching. I think we're kind of on the limit to where like caching's not a big deal because we don't have that many items. Like there's not that many being re-downloaded. But again, this is very situational on your product. If you're downloading a bunch of stuff and it's insanely inefficient, absolutely cache it. You know, if you only have a couple and maybe you're not like re-downloading much, maybe it's not that big of a deal. Again, pros and cons that you got to weigh for your own project, your own product, your own team, that kind of stuff. But I did want to point out that is the downside of using AsyncImage, even though it's super simple, right? And we didn't have to write all this kind of convoluted, right? We had an image loader, a remote image, an appetizer remote image, kind of convoluted. That all gets abstracted away into just this. And then again, once we abstract away our modifiers, like this is really simple, you know, just a couple lines of code. But again, the downside, it doesn't cache. So that's how you use it. Use it accordingly in your future projects now that you know the pros and cons and how to do it.
In this video, we're going to run the Appetizers app on iOS 16 to make sure everything's all good. And then we're going to talk about some new Swift 5.7 features, things with the if-let and the guard-let, as well as new regular expression syntax introduced in Swift 5.7 to help us with our email validation. So first things first, we're going to run the app on iOS 16. So I have the iPhone 14 Pro selected because that'll give us iOS 16. I think all the simulators will give you iOS 16 actually. So yeah, we just want to run through the app, make sure everything is working as expected. So home, account, order, everything looks good. So blackened shrimp, there it is. Add to order, cool, there's our order. Avocado spring roll, things are looking good. Dismiss it. Chicken dumplings, add to order. Cool, now we have 2 in our order. So when I click on my order, there's the 2. Place order, and we print out order place. Like that's all we're doing. Again, demo app. And we can swipe to delete. There we're good, 1 order. Okay, things are working fine. We're gonna come back to this account when we do our regular expressions to validate our email. We're gonna come back to that. So let's make sure, actually, let's make sure things save in iOS 16. So we'll do Sean Allen, email is my email at email.com. Cool, extra napkins and frequent refills. Now, I don't want frequent refills. Save changes, profile saved, hit OK, stop, rerun. What I'm doing is just making sure things are persisting in our user defaults. Account, there we go, Sean Allen, my email at email.com. Cool, okay, so iOS 16, pretty smooth sailing. Things are working. So now let's talk about the new Swift 5.7 stuff. And we'll start with the if-let and the guard-let way that we unwrap optionals. So what's new in Swift 5.7 is you no longer need the boilerplate like if-let error equals error. You can just cut that out. So what I'm gonna do in this project is we'll do search for if-let, and we see all the places we're using if-let. So not many places. This is old commented out code that we don't need because that's our old way of doing things before Async 08 that we did in iOS 15. This is where you wouldn't use this new feature. So if-let image equals cache.object, whatever. You've probably seen this before, right? Where you do if-let image equals image, and then you do a bunch of code. This is the fix, is where you don't have to do if-let image equals image. You can just do if-let image, and it's the same thing. So it just removes a little bit of boilerplate code, but we're gonna go through our app and search for all the if-lets and the guard-lets and make the fixes. But I just wanna point out, it's not at every single if-let. It's only when it's like if-let image equals image, not if-let image equals cache.object for key, whatever. So same thing here. We don't want to do the error because we are casting the error, so that won't work with it. So now let's search for the guard-lets. That was all the if-lets. And by the way, you'll notice I'm like manually searching and going one by one into our project. As you can imagine, if you have a giant, ridiculously huge project, this probably isn't very feasible to go one by one. So I am going to link to an article that will show you how to do a find and replace for the if-let and the guard-let that will change everything. That would make me a little nervous if I had like a huge project with thousands of files and just doing a find and replace everywhere. That would make me nervous. But also the alternative is to go through one by one. So I don't know. And obviously if you're going through manually one by one, you can make a mistake. So it's tricky to go through and fix all these. So anyway, these are all of our commented out code here. I'm just gonna go down the left on the search thing. We're not gonna mess with the commented out one. Again, guard-let URL equals URL. That's fine, we don't wanna change that. Down here, guard-let URL equals URL. I'm just going down this list. Okay, here's one. guardlet data equals data. So here we can just do guardlet data. Again, it's just a very small syntax change, but it is nice quality of life because you see this everywhere. Guardlet image equals image, or UI image equals image. Nope, get rid of that. Now it's just that. So much cleaner. Again, it's a small thing, but these small little quality of life things like really add up. Okay, not there. Guardlet user data equals user data. Nope, we can do just guardlet user data. Do Command B. And down here, okay, these are just regular guard statements. So now let's run the app just to make sure we didn't break anything. Cool, that's working. This is the only one I was a little nervous about, this retrieve user, because this guardlet user data is based on this user data in app storage that's optional. So let's make sure this works, because I believe it'll work. Account, it is retrieving the user, it retrieves Sean, because remember this is in the retrieve user function, and this is where we're retrieving our existing user for the account, and it did retrieve my information. Well, let's stop and rerun just to be sure. Can't remember if I reran. I do that sometimes. I'll leave the simulator running and it won't run the new code. So account, yep, it did pull in my existing data, so that works. So again, that if let guardlet, super nice quality of life thing, just removing some unnecessary boilerplate. Now let's talk about regular expressions in Swift 5.7. So for that, we're going to go to our utilities, extensions, or string extension, right? Because this is this gobbledygook stuff that we put in there. And don't worry if you don't understand regular expressions. Most people, even programmers, don't. They usually just find something to copy and paste. That is not uncommon. But Swift 5.7 introduces a couple different ways to work with regular expressions. Of course, I'm not going to dive into everything about they introduce because it's pretty involved actually. And to be blunt, I'm not a regular expressions pro. I'm one of those people that just like, I kind of know what they are. All right, cool, let me copy and paste. But Swift 5.7 now has native support for regular expressions. So if we do slash and then slash, you see we get syntax highlighting. And now this is a regular expression. It's not a string anymore. Remember, I'm gonna do Command Z, don't do that. It was just a string and we're passing that string into a predicate matches. Now, what I'm gonna show you is way more code than this. However, it's a lot easier to understand. And when I was doing this, I discovered we have a bug. So let me show you the bug. We'll rerun the project. So when I do my email, go to account, and you see email.com. With our current regex, you can do .com, save changes, profiles saved. So we're allowing multiple dots. We only want one dot after the @ right? We don't want to have .com. I believe these top level domains cannot have multiple dots. Someone can correct me on that, but obviously most of them aren't like .com, .co, .io, or .gov. Like there's just one of them, right? So that is a bug in this regex. But I also noticed something when I did this, because here's what Swift will do for you, which is awesome. Or Xcode will do, I'm sorry. It will refactor. So let's get rid of the string. I'm just gonna get rid of the quotes at the end and replace them with the slash. So now we have regex. And then now when you highlight it, right click, refactor, convert to regex builder. So one thing that's new in Swift 5.7 is just native regex will be supported. Actually, you know what? I'm gonna do a Command Z. I'm going to copy and paste and then comment out that code. That way we're preserving the old stuff. So what I can do now, well, first of all, let's get rid of the predicate stuff. We're not dealing with NS predicates anymore. I can highlight the regex. Remember, it's gotta be the native regex. You can only do this when it has the slash and it recognizes regex. Right click, refactor, convert to regex builder. Now you're gonna be like, whoa, well, first of all, let me fix this equal sign. And I got a bunch of errors. Let me return something, right? Because our computer property needs to return Boolean. So for now, we're just gonna return, I think this is just gonna get Xcode to stop. We're gonna return false. We're gonna like change that because we don't want it to always return false. Okay, we're getting errors because I didn't update to iOS 16. So because regex does require the iOS 16 stuff. So go ahead and do that. I mean, this is the simpler way to do it, by the way. Like say you did have a project that you didn't want your minimum target to be iOS 16. Well, then you would need to do, let's go back to the code here. Then you need to do the, if at available iOS 16, do all this, else, iOS 15 and below, do all this. We're not gonna dive into all that, but you could support that. I just wanna focus on showing you the new regex stuff. Like I said, this is a lot more code. However, I would argue this is a lot more readable. So I can see, okay, the regex is one or more of a character, and we're allowing specific characters, A to Z, 0 to 9 in lowercase a to Z. And then the @ symbol, right, is going one by one. So cool, the first part, hey, just any character, essentially. And then the @ symbol. And then after the @ symbol, again, any character. And then this is where I see the bug here. I don't want this string. I don't know why that was in there. Again, I'm not a regex professional here. And then I don't want one of any character. I want a specific dot, right? So you can pass in a string for if you're looking for a specific string. So I want a dot. And then here, up to 2 to 64 characters, right? It's got to be at least 2 characters, max of 64 of any, character. And then what we want to do is we don't want to return false all the time. We want to check if there's a match. So we want to turn self.full match of, and you can see it returns a regex optional. If there's a match, it will return it, but it'll be optional. So the regex we want to pass in, it's not email format. We'll call this email regex just for good naming. So email regex, that's what we want to pass in, email regex. So what this is going to do, it's going to see if there's a match. If there is a match, it's going to return it. Well, I don't care what the match is. I just want to know that it exists. So I'm going to say return not equal to nil, right? Because we have to return a Boolean. So this is either going to be true or false. If it's not nil, this is going to return true. That means there is an actual match. If it is nil, that means it's going to return false. That means there's no match. So is valid email will be true or false based on that. Now, just to repeat, like I said, this is a lot more code than just these 3 lines, but look at this gibberish. Like no one, I mean, I guess you can kind of figure out what it means, but I feel like this reads a lot more clear for new developers coming into the code base, new people joining the team. I like this regex builder, a lot more cleaner. Maybe you like this other way, cool, do it that way. But just as an example, this helped me find that bug when I converted this, because I saw that, remember we saw this // I was like, what is that? I don't need that. And it allowed me to clean this up and then use the whole match to find that. So now when I go to the iPhone 14 Pro, let's double check to make sure our email is good. And again, I'm gonna run through the whole thing since we did this, right? So if I type in just my email and I hit save changes, invalid email, and then my email well, let's get rid of the keyboard. Command-Shift-K. You'll still see that dismiss down there. That's because I'm just hiding the keyboard. And then now I hit save changes. Invalid email. Okay, we're just gonna start building this. Yahoo. Save change. Nope, I need the dot. Save changes. Nope, invalid email. Okay, now we'll do com. Save changes. Profile saved. Great. Now let's try what was broken before. .com. Save changes. Okay, that still worked because I forgot something. So we'll stop running this. So again, this makes the regex more readable. So in my opinion, it's easier to find errors like this. So what I did was after the one or more character of class, any of, I'm saying I can have a dash or a dot. Well, I don't want a dot. I'll allow the dash, but I don't want a dot in the domain name. I think dashes are allowed. If they're not allowed, hey, just delete that line. But now when I run it, because again, what was happening, the reason I could do .com is because I was saying any of dot or dash. Well, now I want to clear this up. So like I said, the regex builder breaks things out so it's much more readable. So now when I run the appetizer app, go to account, .com, invalid email, doesn't work. By the way, this error up here, publishing changes from a view, updates is not allowed. That is an Xcode bug. If you Google that, you'll see a lot of people saying like, no, it's an Xcode bug. So don't worry about that. But yeah, so now our regex is working as expected. And if I go back to just the regular .com, now when I do save changes, profile saved. So that is regular expressions in Swift 5.7. One last bonus tip that I noticed as I was building this update here, I misspelled respose, right? Appetizer response is what it should be. You see, I had this little red line under it. You may not have that. That's how I noticed when I was doing this update, like, oh, I misspelled that. To do that, do edit, format, spelling and grammar, and then check spelling while typing. This will spell check stuff, and it pays attention to the casing. So now I know that I misspelled response. So I'm gonna right click, refactor, rename. That way it renames it everywhere. We'll say response, right? Let's actually spell it correctly. Hit rename, good to go. And then I believe there's one more in order. Yes, offsets. So it's just, there's no E in offsets. So that was just a little bonus tip on how you can, notice any spelling errors and fix your spelling pretty quickly. So we focused on a lot of Swift 5.7 stuff because when we ran the app, everything was smooth in iOS 16, and there wasn't any SwiftUI updates that were pertinent to the way the Appetizers app works. So we focused on Swift 5.7 with the regular expressions and the regex builder that really breaks things out, and then the guardlet, niflet, quality of life, better syntax.
This video kicks off the optimization section of the course. Now, what is this section? Well, This is kind of a living section, meaning that I'm going to be adding videos to this over time, because this is the chance to go back and revisit the projects that we've done. I can, fix some mistakes because nobody's perfect. I make mistakes, or maybe I made an oversight, or maybe through the conversation in the comments or in the Slack channel, I realized there's a better way to build something or architect something, right? Because after, 1,000 or 2 students take this, there's a lot of discussion. And I realized that, there's some things I probably could have done better. So that's what this optimization section is for. It's a chance to go back and fix and optimize things. And I've done this in a previous course, and this turned out to be a lot of people's favorite section, because as you'll see through some of these videos is we start to have nuanced conversations about, how you style something, how you structure something, how you architect or build something, right? So this is more nuanced than like a straight up tutorial. And like I mentioned, a lot of this usually comes from discussions with students when they ask questions. So back to what I said about this being a living section, this is still during the pre-sale. The course isn't even fully done yet. Over the next 3 to 6 months, a bunch more students are going to take this course. More questions are going to pop up. So over that time period, if you are one of those early adopters taking this course right as it releases, I would check back in a couple weeks, couple months, because again, I expect this section to, have a few more videos in it. Okay, so with that out of the way, let's jump into a project and start optimizing, right? The whole reason why we're here. So open up your Apple Frameworks project, and we're going to do 2 things here. The first thing we're going to do, if you see on the framework detail view, is we're going to add a view model, right? We don't have a view model for this yet. And this is going to bring up, again, an interesting nuanced discussion about should we even add a view model here? It'll also give us a chance to use @ObservedObject, because before we've been using @StateObject for all of our view models. Well, as you can see, we're relying on a framework. So we're going to pass that in. Anyway, I'm getting ahead of myself. The second thing we're going to do is, if you remember this Safari view that we created using the UIViewRepresentable to show the Safari view controller, well, again, somebody mentioned in the comments, and this I completely missed this, is that iOS 14 introduced a link object in SwiftUI that kind of renders this obsolete. Now, it's not 100% the same, so there could be value in knowing both, but we're gonna talk about that at that point. So anyway, those are the 2 major things we're gonna handle. Let's get to the view model first. Okay, so scrolling up here, I'm going to copy all of this, and we're going to put it in the view model. And I did copy instead of cut because I don't want Xcode to yell at me quite yet. I'm not ready for that. It's too early in the morning. Command N for a new file, Swift file. And then we're going to do framework detail view model. Now, this initial part should be, a lot of review because we've done a lot of view models by now. Import SwiftUI, final class, framework detail view model. And of course, what does it got to conform to? Observable object. Okay, now I'm going to paste in the 3 things I brought over, and we're going to adjust this a little bit. So this can be a let, right? We're not tweaking or changing the framework. We're just kind of like reading the data. And instead of @state private var, again, this is review. We've done this a ton, right? This needs to be published because again, on our view model, we want to broadcast whenever that changes. And actually, as I'm typing this is actually the thing we're not going to need anymore. I'm going to keep it here so you can flip back and forth between doing it the Safari view controller way and doing it the new, switching to Safari separately. We're going to dive into that when we do the link thing, but I'm going to leave that here for now. So the main change we got to make is with this binding. So when you pass a binding to a view model, you have to initialize it. So as you can see, it says class framework detail view model has no initializers. That's because we didn't give this a value. We didn't give our framework a value either. So we're going to have to create an initializer that gives these 2 things a value. However, we got to do something different with binding when we create an initializer on our view model. We'll talk about that in a second. So let's create our initializer. And this is just the typical class initializer. So init, and then we want to pass in a framework, which is of type framework. And then we want to pass in is showing detail view. And that is a binding bool. So it's a binding bool. Now, I'm going to try something, right? So I want to do self.framework equals framework. Again, typical initializer stuff. Self.is showing detail view equals is showing detail view. Now, it's going to get an error. Should, right? Yeah. Cannot assign value of type binding bool to type bool. So right now, is showing details is a bool. Well, @binding is just a property wrapper. So we can actually write this out the long way, var, and make it of type binding bool, just like we passed into our parameter down there. And then now we should be good to go. So essentially binding is kind of a shorthand way to write this, but also when you declare it like this, you have to use the wrapped value. You're going to see that in a little bit, but when you use @binding, it kind of does all that for you. So this is kind of like the long way to do it, but we have to do it here when passing this into the initializer. So now our view model is set up. Let's go back to our detail view. And real quick, I like my view model on top. Okay, so now I'm going to delete all these because we have them in our view model. But actually, hold on. We have to do @observed object. Remember, this is where we used to do @state object to create our view model. Var view model. And then we don't set it equal to something. Remember, with state object, we were setting it equal to the initialization of our view model. Well, we're going to be passing it in with the observed object. So our view model is of type framework detail view model, right? We're not initializing it with a value because we're going to be passing it in. So because we didn't initialize it with a value, anytime we create a framework detail view, we have to have an initializer on that now that creates a view model at that point and passes it in. So I'm going to do a Command B real quick so Xcode can tell me all my mistakes in life. Okay, all the way down here. So here we just want to do the typical view model dot, right? Because we moved everything to the view model. So Command C for the view model dot, Command V. And then up here, yep, Command V. And here's where you're going to start to see some of the wrapped value come into play. Yep, so this is showing detail view. If we go back to the view model, right, this is where we declared it not as an @binding, because again, that would take care of all that for you. We literally went the long way and say it's a type binding bool. So here's where you have to use .wrapped value. And you can see the underlying value referenced by the binding variable, right? So again, this is just kind of the long way to do it. Okay, one more Command B. We should be fine on this screen, or not. Okay, yes, previews. I was going to say we should be fine on this screen. The issue is going to be when we initialize a framework detail view, because we no longer initialize it with a framework, is showing detail, yada, yada, yada. We initialize it with a view model. So let's get some practice with our preview here and initialize our framework detail view, get the autocomplete. You can see it takes in a view model. We can do framework detail view model. And then we initialize that with a framework. And do we have sample framework on here? I can't remember. Mock data.sample framework. Yeah. It's been a while since we touched this project, right? Okay. And then now hit return here for the is showing detail. Again, in our preview, remember we can do .constant, false, just to give it a value. Okay. That sets up our preview, but that was a preview. Sorry. I know that was bad, of what we're going to be doing when we initialize our framework detail view. And if you remember, when do we initialize our framework detail view? Well, that is in our framework grid view when we actually tap on one of the frameworks. And you can see Xcode's yelling at us for where we're messing this up here. So we're going to do almost exactly what we just did here. So when we initialize this framework detail view, we need a view model, right? This is us creating the view model on the previous screen and injecting it into our framework detail view. And again, back to our framework detail view. In that scenario where we're injecting our view model, that's when you use observed object. Again, before we were doing, equals, and then we were initializing our view model. That is when you use state object, when you're creating a new one on that view. Okay, I think I've said that a bunch before, but again, remember, my main goal for this course is for you to understand this passing of the data. Okay, so because we are injecting in, we're using observed object. Let's go back and create our view model here. So framework. And again, the reason why we're injecting it is because we're relying on data from the previous screen, which is what we're on, right? We're relying on this view model dot selected framework. And let's hit return here to line these up. And then is showing detail view, right? We're relying on this binding. Well, it's on the view model. View model dot is showing detail view. Okay, my font is like really, really big. I'll make this small so it's not super ridiculous. Oh, remember, because it's a binding, we need the $. Forgot about that. A little smaller. Okay. Command B to make sure nothing is broken. Okay, so we should be all set up with our view model on our framework detail view. Let me run through that one more time. So now when we tap on our framework, right, we're going to initialize a framework detail view. However, we're creating a view model here because we're relying on the framework that we tapped in. We're relying on the is showing detail view that's up in our view model, right? We're relying on data from a previous screen. So we use that data from the previous screen, create our view model here, inject it into our framework detail view. So let's go to our framework detail view. And because we're injecting it, we're using @observed object, and we're not initializing a new one. We're just making it of type framework view model. And then now, our view model has that data, right? We passed the framework, we passed the is showing detail view. Again, this is showing Safari view is kind of irrelevant at the moment. We'll come back to that. But we should be all set up. And then we just switched everything to view model, view model, view model. So let's make sure this works. And then we'll talk about like the nuance of, why you should do this or why you shouldn't do this. Okay, here we are. Again, Command-Shift-A to switch to dark mode. I just don't like this app in light mode. Click on ARKit. Cool, there's our ARKit stuff. Hit learn more. Okay, the behavior is exactly the same, which is expected because all we did was refactor and everything is working. So now let's talk about like, should you even do that, right? Because you could argue, if I go to my framework detail view here, right, you could argue it's just a framework is showing detail. And then if we continue to use the link, like we don't even need this one. So really it's only two properties on this. So I guess the debate, if you will, the nuance, should you even do this, right? Because there's a valid argument for, Sean, it was much simpler to just have those two properties here. Like, why are you creating a view model for two properties? You're almost adding unnecessary complexity to make it more confusing than it was. That's argument A, right? So again, it's nuanced. The other side of that argument is, you should be consistent with your coding, right? If all your views have view models, any new people coming into your code base, they're going to expect that, right? If some of your views have view models, some don't, that could be confusing, right? So you can see why this type of stuff is very nuanced and highly debated, right? This is why there's all kinds of architecture and structure, debates in programming. You can see both sides of it, right? So I wouldn't argue with you if you thought adding the view model for this added unnecessary complexity. I wouldn't argue that. That's kind of how I feel. But at the same time, if you want to preach consistency in your code base, because that makes things understandable, I agree with that as well. So you see the dilemma here. And welcome to the wonderful world of online programming debates. This is why I stay away from this kind of stuff on Twitter, because it's meaningless. What you should do here, right? For your project, your team, whatever that is, you all should come up with an agreement on the style that you all find is best for your project. Right? There's no blanket correct answer. Do what's best for you and your team. Okay, let's talk about link now, not Zelda, like a link. So basically we want to replace this button. If I run this again real quick, let me tell you what we're going to do with some visuals here. So tap Health Kit. This button right now, as you can see, is a button with a label, and this button, when it's tapped, we're flipping, is showing Safari view equal to true. That presents this sheet that you see here. We've done all that before. Well, again, new in iOS 14, which went over my head. I completely missed it. This is kind of the problem with SwiftUI being so new and so much getting added. It's very hard to keep up with everything. Even for someone like me, who it's kind of my job, with Swift news, creating content, it's kind of my job to keep up, and still stuff slips through the cracks. So if you're not up to date on everything, like don't worry about it. It's tough. Anyway, we're going to basically make this a link that pops open the Safari app. It doesn't keep you in the Safari view controller. It pulls up Safari app, but it is built into SwiftUI. So we don't need to have here in our UIKit components, right? This whole Safari view with make, view controller, all that stuff. Whoops, did not mean to do that. This could all be irrelevant, right? All you would have to do in the framework detail view, I'm going to write this above our button because we're going to use it. You type in link, initialize it. You see we want a destination and a label. As with all the SwiftUI stuff, there's a bunch of different ways to do it. The reason we want a label is because that allows us to kind of create our own view. If you just did the localized string and a destination URL, you're going to get the typical plain blue text link. No, we want our red button. We like the way that looks. So destination and label. And the destination, I'm going to literally copy and paste it from here, right? It's the same URL, right? So what this means is if we have a URL, like it doesn't return nil, we're going to use it. If it does return nil, we're going to send them to apple.com as like a default. So paste that there because that's the same. And then hit return here in the view builder for the label. And now this is similar to a button, right? If you think about how the button's structured, the first part of the button is what we want it to do. The second closure in the button is how it looks. Similar thing, right? We want this to go to this URL. How it looks is in the view builder. And we're literally going to do the same thing. Copy, paste the AF button into the link. And I'm just going to comment this out, because I want to keep it in here so you have like a reference for both methods. Because again, there's a slightly little difference that you may need. Okay, so right now we just have our link. We don't have our button. We can actually even comment out this sheet stuff because we're not even using the sheet, right? We're going to pop open Safari, the app. So let's look at that. Run it. Click on Metal. See, our Learn More button looks the same, right? If we didn't do that initializer, it would have just been a blue typical link button. But now we got our styling that we want. Tap Learn More. Okay, see how it popped us over to Safari. It didn't just slide up the Safari view controller. We're now outside of our app in Safari, right? We can navigate wherever we want. You see, we do get the back button to our Apple Frameworks app, but you see we're completely switching apps. Now, here's the debate. Again, nuanced conversation, right? I've seen debate on Twitter where people think it's a better user experience to completely pop somebody out to Safari, right? Completely separate versus just showing a Safari view controller. because the Safari view controller is kind of like a limited version of Safari and you're still contained within your app. I guess that would be the benefit to it, is the user never leaves your app. Whereas, here they're leaving your app and going into Safari. So again, nuanced debate, right? But I did want to show you this. If you use Link, like we did here, it's built into SwiftUI. You don't need our Safari view, UI view controller representable. You don't need all that. You don't need to present a sheet. And then this is what I was talking about. Because we're not presenting a sheet on our view model, like we would no longer even need this is showing Safari, right? That's irrelevant now because we're using our link to open up the actual app Safari. Okay, so those are the two things we handled, right? We added our view model. We discussed, should you even add a view model, that nuance. We talked about observed object because we hadn't used that yet. And then we converted to link, which again was new in iOS 14, away from our button and popping up our Safari view controller. So that does it for the first optimization video. Hopefully that gives you a little taste of like the type of stuff we talk about and we fix in these videos. On to the next one. In this next optimization video, we're gonna do a lot of little cleanup in between our barcode app and the Appetizers app. And then we're gonna finish off with some date formatting on our date of birth, right? If you see this account screen. So it doesn't show today's date, right? It'll show like a date like 20 years ago for ease of use, right? Because we're all 20 years old, right? Anyway, that's the gist of what we're gonna handle here. Let's start off in our barcode app. Okay, like I said, these are going to be small things, but looking at our barcode scanner view, like the main view, we actually don't need this max width infinity. Remember, we did this so the scanner view would spread across the whole screen. Well, one tricky thing with SwiftUI is some views will expand to fill all of their available space. Some will only take up as much space as they need. So an example of this is text. Let me pull up the canvas here to show it. So if we look at this not yet scanned, and again, the preview, I don't know why I'm clicking on it. It's not showing the red box around just the text. I wish it was. That would really visualize this, but I'll put one up of my own of what's actually going on. So our not yet scanned is only taking up as much space as it needs. A little bit more because we have the padding on it, as you see here. So it's actually, there's some padding around it, but it's not stretching to fill the whole screen. However, something like a rectangle or the scanner view that we have here will stretch to fit the whole screen. So what I'm trying to say here is we don't need this max width infinity because that's kind of like the default value for it. And if you remember, the way we can test this here is if instead of scanner view, let's do rectangle, right? This is kind of like our debug mode, right? Nope, we don't want that preview. Let's comment out the scanner view, right? So our rectangle, right? This is kind of like our default thing. Well, we don't have max width infinity. We don't need that because by default, it's going to stretch out as far as it possibly can. So, okay, that was just one little piece of cleanup that I wanted to show there, that it was an unnecessary use of max width infinity. However, if you wanted your text for some reason to stretch all the way to the edge, well, the text wouldn't stretch, but the frame of the text would stretch all the way to the edge. Then you would need to put like max width.infinity on your text. So again, there's certain views that I think Mark Moikin's term, I don't know if he coined this term, but I've heard him say it, where he says like there's push out views and then there's like pull in views. I like how he framed that. But again, we don't need max width infinity for that. And then the last bit of cleanup on this barcode scanner is in our alert item here. Remember, this was an error that I had here that I had to go fix. We fixed it in a later video, but we're just going to come back, make these texts instead of a string. So I don't have to wrap them in text at the call site, but I do have to wrap them in text here. And again, the reason you may want to do this is because it's just, I don't know, I like the call site to be cleaner because the call site to me is where, somebody using the code, right, another developer coming in is trying to figure out what's going on, right? And they only dig into like this kind of stuff, the stuff that's abstracted away, if they're like really doing a deep dive. So I like to make my call sites very, very clean and easy to read, for that reason. So I did a Command B, definitely going to get 2 errors here. And that is because we can get rid of you. See, I no longer have to wrap you in text, right? It can just be much simpler. Alert item.title, alert item.message. And if you remember when we originally did the video, I was confused why it wasn't working because I just messed up the setup. So to Command B, we should be away from our errors. And again, it's just making the call site cleaner and easier to read and understand. Okay, so that's it for our barcode scanner view. I'm going to close this and magically into our Appetizer project. I just had it open behind it. Okay, the first little thing is I misspelled in our utilities extensions, right? I think I pointed this out in the edit, but I never went back and fixed it. There's no T in extensions. So there we go. Small little thing here. The other thing on our Appetizer detail view, I will go ahead and pull out our canvas here because this will show it. Hit resume. So one thing I forgot is I forgot to add the G label, right? We have 99, G for grams, right? So 99 what of carbs, 99 what of protein, right? We want that to be grams. So down here in the nutrition info, now you could think that you could go in here and add the G afterwards, but that's gonna add it to all of them, right? And we don't want 99 grams of calories. So we do want to put that up here where we spell this out. But that illuminates something wrong with our setup, right? If we want to have this G here, this label, right? We're passing in an int. Well, yeah, we could add the G here, but that's going to add it to everything like we mentioned. We don't want that. So we're going to have to change the value to a string. And we don't need our string interpolation down here. We can just pass in value right there. And everything remains the same, except now up here, we're going to have to do the string interpolation up here. So let's make a preview smaller. So again, we want to pass in a string, and we'll do the string interpolation of appetizer.calories, not carbs, calories. Cool, that should be good. And then I'm going to copy and paste this just for that setup. Get rid of that, except now we want to add a space G after the carbs and space G after the protein. And we don't want calories here, we want carbs. And we don't want calories here, we want protein. You can see our preview. I should be updating in real time. Hit resume. There we go. Now we have the G after the carbs and the protein. So just a slight little fix there. And you could argue that like carbs and protein, it's understood that it's going to be in grams, but hey, you want to be explicit with your users. No confusion. Okay, next up in our loading view, this is another iOS 14 thing that kind of went over my head. Didn't realize you can do this. And again, this was brought up in the comments, so thanks for that. So let's go to our loading view. Where the hell is that? UIKit components, that's right. Loading view. Okay, so we no longer have to do this activity indicator for UIViewRepresentable. We can just do a progress view. So we do progress view, and then the modifiers we want to add, we want to give it a style. So progress view style of circular something, right? Yep, circular progress view style. And you can initialize that with a tint, which is a color, and we want to make that our brand primary, right? So we just want our spinner to be the green, just like we had before. So now to test this, let's go to the screen here, and in our appetizer list view here, instead of, I'm just going to put a bang in front of this. So if it's not loading, we're going to see the spinner. So I'm just using that for debugging, so we always see the spinner when we run it. And we're still in dark mode. More on that in a second. Let's go back to light mode. Cool, so you see our dark green spinner. It is a lot smaller than we had it. I don't know, maybe you like that small size. I'm gonna stop this, and we are going to go back to our loading view here. And then another modifier on progress view we can do is .scale effect. And we can pass in a scale of just, let's say 2. Doubling the size is basically what we're doing here. So let's run this again, and we should see our spinner nice and big. Yep, there we go. Big spinner in there. And you can play with the scale to get the size you want, but our spinner is back working. Another thing you can do with this progress view is you can initialize this with a title. Title key here, you can do loading ... Now run it, and you can see you'll see like the label here. It's going to be huge because we made it bigger. You can like adjust that, but I don't know. I just like the spinner. I'm a fan of like minimalism, white space. That loading to me is just clutter. I know it's loading. It's a spinner. So anyway, just letting you know you can do that. So the point of this is now you can use a progress view, and the new thing in iOS 14 is this circular progress view style that will now give us the spinner. And again, you can adjust the size of it with this scale effect here. So again, we no longer need this activity indicator view, the UIViewRepresentable. I'm going to leave it here just for reference, but you can now use progress view to do that. So nice, simpler, built-in SwiftUI way. And if you remember when we built this, I was like, oh, this is going to be added soon. I can't believe this isn't in there yet. Well, I'm dumb, it was in there. Okay, next, let's go to our assets. We are going to adjust our color. If you go to brand primary, right? Because, okay, let's run this real quick. iPhone 12 Pro, let's go back to dark mode, Command-Shift-A. So, okay, there's our spinner. Okay, this is what you got to be careful with this debugging stuff, right? So now I want to get rid of my bang there to make it so it only shows up when it is loading, not all the time. Again, that was just for debug purposes, so I could see that. Okay, so we're in dark mode. Now look at the dark green is kind of hard to see in dark mode, right? And especially on the account. Like look at save changes. The text is kind of hard to read. I mean, it's not impossible to read, but it could be better. And you can basically make colors for dark mode and light mode, like our brand primary. So that's what we're going to do here. So in our XC assets, see we have any appearance and then dark appearance. Click on dark appearance. Get rid of that here. Pull up your right pane here in the upper right, and you can see show color panel. And then just pick a color you like. I'm going to go with a more like vibrant green for when it's in dark mode. And we can close that out. Cool. So now you can see in our normal appearance, it's going to be the dark green. In dark mode, it's going to be this, much brighter green. So now let's run it. And you can see, look at our tab bar. It's much brighter. Go to our account screen. You can see it's much, much brighter. Some of you may even like that look even better. Well, the one thing I didn't do was, so this is an image and I custom made that image. So it had our dark green. And you can do what I did with images. I'm just realizing this now as I'm recording, so I'm not prepared for this. My apologies, but I can explain it and you'll get it. So if I go to my empty order here, same thing, right? If in appearances over here on the right, if I add any/dark, now I can add a dark appearance. Just like we added a different color, I could go in and customize this image in like Sketch or something. And, instead of this dark green, I can make that my bright green that I made it. And then I can import that image and then drag that down here to dark appearance. And now the image will change, based on whether I'm on dark mode or light mode, right? So you would see that image. But so apologies for not being prepared for that. It just came to me as I'm recording, but I think you get the idea. But you can see, I actually kind of like the way this looks, this bright green. It's a good color combo. So anyway, you can see how we're changing the colors. Again, Command-Shift-A to go back to light mode. Look, we're back to our dark green. Dark mode, back to the light green. So that is how you can use, light and dark appearance in your assets, to adjust for that. Okay, let's go back to dark mode because I'm really digging the way this looks. Let's pull up our date picker, right? So April 2020, that's what it defaulted to my birthday, but when we don't have a user in there, because remember my user showed up because we saved it in user defaults, it would show up to November 2020. Well, I want to I don't want to make my user have to scroll all the way back to however old they are, right? That's annoying for the user. So let's say we have we're in a bar, right? Appetizers or a restaurant, you got to be 18. So we want the minimum age to be 18, right? So that's where we want this to start at. So stop this. And then actually, let me open up my simulator. I suggest you do this too. Let's get out of this. So we'll go home. I'm going to delete the Appetizers app. That way it removes my user default, so we can go back to having the default setup there for when a user would actually change their date here. So we want to go to the account view here. Okay, so in the account view, right, we have this date picker. Well, we want to use a different initializer of the date picker because we want to get a date range. So I could just add a date range, but I found tweaking the parameters sometimes messes it up. So how I usually do it, just to be safe, because I like getting the autocomplete, I just do another date picker. I mean, I'm going to delete the one on top, and then look at all these different initializers. This is what I was talking about. I didn't want to try to custom my own and mess it up. But here's what we want. We want the closed date range that you see here. However, we also want our date picker components. So here it is, displayed components. You can barely see the edge of it, but we have our title, selection, closed date range, display components. That's the initializer I want, right there you can see. So the title is going to be the same. Command C for the birthday. Cool. Same thing here for the binding. And like I said, you could just add in this parameter manually. I don't know. Sometimes I found maybe I messed that up, whatever, .date. I like to do the initializer and fill these in just to be safe. So the thing we're missing here, so I can delete this up here now. The thing we're missing, so we have our title, our selection, our date range, which we don't have yet, and our displayed components. Okay, so we need a range of dates. The date range we want is we don't want somebody to enter a birth date that's younger than 18 years old. So that's the end of our date range. Also at the beginning of our date range, we don't want the user to be able to scroll back to 1492, because you can do that on the date picker, right? And you want to limit your users so they don't import crazy dates and mess up your error handling, right? Because you probably didn't think to handle when somebody entered a date, an age of 1492. So anyway, we want to give a very closed range of dates. So we need to create a date that is 18 years ago, and then also one that's, let's say the max age is 110, right? If somebody older than 110 is coming to your bar, what are they doing? They're 110. Anyway, that's what we're going to choose. If you want to adjust the dates, you'll see how easy it is. So let's create an extension on the Swift date object to create these dates. So in utilities, in our extensions folder, do Command N, Swift file, hit next, and it's going to be date plus ext. It's our typical extension format here. And then extension date. And we're going to create two computed properties, right? One is going to be var 18 years ago. And that's going to be a date. And here we're going to return just today's date, just for now, to get so Xcode doesn't yell at us. We're just setting up here. And another one, var 110 years ago. And again, that's also going to return a date. And it's going to return today's date. And I forgot, this is new in Swift 5.1 or whatever. When you only have one line, you don't need the return. I keep forgetting about that. So now let's do some date math, if you will, to figure out 18 years ago. So this is going to introduce you to some fun with dates, doing some date calculations. I could do an entire course on date calculations. This can get pretty complex. I have a bit of experience with it, kind of like building calendars and stuff, but this is like a simple version. What we're going to do is basically subtract 18 years from this date. So we want to do calendar.current.date by adding to, and there's no like subtracting, which is confusing. So you have to add a negative number. Date by adding, oh, I didn't even do the right initializer there. There's another parameter. So again, initialize that date by adding value to, right? Because we want to put a value in there, you'll see. So the component we want to add, right? You can do like, you can add an hour, a minute, a month, a nanosecond. We want to be in the year range here, right? Because we're subtracting 18 years from this date. So the value we want to add is we want to add negative 18 years to today. And it's, well, here too, you can pass in a specific date. Like if you wanted to do 18 years from the year 2000, like you could, create a date and do that. But if you do date like that, that is today's date. So our calendar, we just want to show 18 years ago. And creating this returns an optional, but we're going to go and force unwrap that because this is all like default stuff. If you were creating your own date and passing it in, then you might want to unwrap your optional, but this is all like Apple default stuff, pretty safe. So the same exact thing for 110 years ago, except instead of subtracting 18 years, we're going to subtract 110 years. Okay, so let's actually go back to our account view. I was about to run it prematurely. Our date range is we want to use the extension we just made. Let's do a Command B to make sure we get all the autocomplete stuff. So we want to do date. So this is the first part of the range, dot 110 years ago. So that gives us that date, dot, dot, dot. And then the end of the range is date dot 18 years ago. So let's run it on the simulator, check our date picker and see what we got. Okay, go back to account. Okay, remember we deleted the app, so we have no user. And you see it defaults to November 21st, 2002. That is 18 years ago. Today's November 21st, 2020, right? Cool. So you cannot enter a birth date younger than 18 years old. Let's try it. So see, it's all grayed out here, right? I can't pick a date. Even if I try to go further into the future, I can't click it. When I do my scroll wheel, if I try to go to 2010, nope, go back, right? You're forcing to be at least 18 years of age. So click off that. And then now let's go back to, I don't know why I clicked off of that. Now let's try to pick a ridiculous date, right? Okay, I'm back in the, damn it. I'm back. I see I'm back in the 1900s, 1800s, whatever. You can go way far back. And you see it automatically scrolls me to 1910, which is 110 years ago. So this is how you kind of block off the date range. And this is the little stuff, right? You've heard me talk about the first 90% and the second 90% of your project. This little like usability stuff is the second 90%. You don't have to do this, but your users, it's going to be a better user experience for them rather than as soon as this date opens up, it opens up to today's date. They got to scroll back 30, 40 years, however old they are. Like that's annoying. Well, if you kind of, put it as the minimum, that at least gets them, halfway there potentially. But really that's just an exercise in kind of like, making some date calculations and putting some limits on your calendar if you need to do that, right? For example, this also limits putting a date in the future, right? Because if you're not born yet, what are you doing? And again, this is nice to do so your users can't put bad data on your database by these ridiculous birth dates. Anyway, small little stuff like that. But that wraps it up for this optimization video. Again, we did a lot of small cleanup, fix that calendar, and that's it for now on the optimization, but there's certainly more to come. Over the next couple short videos, we're going to review passing data in SwiftUI, right? State, binding, add observable object, all of that stuff. And this review part, I think is very, very important. Like it's part of the learning process, right? You don't just hear about it once and now you know it, right? You've heard me talk about it. You've heard me explain it. We've had a chance to play with it and actually use it by building the past 4 apps. And now let's review it to like really hammer it home. Because remember, like I said at the beginning, my whole goal for this course was for you to leave it having at least a foundational understanding of how state works, binding, understanding the SwiftUI mindset, how there's one source of truth, you change that source of truth and then your UI updates, right? Just understanding that, like if you're leaving this course understanding that, it was well worth it. Because yeah, we may not have covered like all the animations, every single modifier, every single UI element. All that stuff is easy compared to passing the data. Like the biggest hurdle in learning SwiftUI is learning the data part. So hopefully after this review where we really hammer it home, that'll be successful. All right, so let's start off with @state. And to do that, we're going to go all the way back to our weather app, because for the most part, we've refactored our state variables into our view model. Now they're, published on an observable object. We'll review that later. But back in our weather app, we're using good old plain state. Now again, remember, all the views in SwiftUI are structs, right? Like content view, that's a struct. And structs are value types, so they don't hold state. And remember, in SwiftUI, our structs are constantly destroyed and recreated as we're re-rendering these views. Well, the whole point of state is so that we actually can hold the state of this Boolean, this isNight Boolean, right? Because if we weren't holding the state, every time we destroyed content view and rebuilt it, well, it would get initialized as false, and we would lose the state of our UI. So by marking this as a state property, SwiftUI manages this data separately for us. That way we can destroy and recreate content view all we want. We still have the value of state, stored elsewhere. And also, when this property changes, because it's marked @state, that is going to trigger a view re-rendering. Let's actually go to the documentation to see how they state it, because maybe that'll help you understand it when you hear it a different way. So here we are in the documentation, right? State, a property wrapper type that can read and write a value managed by SwiftUI, right? We're not managing it, SwiftUI is doing that for us. And here we go. SwiftUI manages the storage of any property you declare as a state. When the state value changes, the view invalidates its appearance. It says, hey, I'm no longer valid. Recompute, right? And it recomputes the body. So that's what I'm talking about when it triggers a UI update. Another way to think of it is how the documentation says it, right? It invalidates its appearance and recomputes, right? I'm no longer valid, redraw me. Use the state as a single source of truth for a given view. So back in Xcode, let's see that in action, right? We have our isNight variable is false. And if you remember, when we tap our change day button, we're flipping isNight to true. So let's run this on our preview. And that's what's happening. When I tap this button, I'm changing isNight to true. Our view invalidates, as the documentation says. It says, I'm invalid, redraw me. It redraws, except now isNight is true. It's no longer false because we flipped that. And then, our background view changes based on that. And then our icon changes based on that. So that is state in a nutshell. And again, it's because our structs are constantly being destroyed. So we need to store these properties elsewhere. And SwiftUI manages that for us. And changing that data updates our view. All right, now let's move on to binding. And for that, we're going to go back to our Barcode Scanner app. But first, let's check out the documentation on binding. Okay, in here it says a property wrapper type that can read and write a value owned by a source of truth. So it isn't the source of truth itself, it can just read and write a value owned by a different source of truth, right? And it says that more here in the overview. Use a binding to create a two-way connection between a property that stores data and a view that displays and changes the data. Again, they kind of say this in multiple ways here, right? A binding connects a property to a source of truth stored elsewhere. That's the key, right? The source of truth, for example, in our view model, right? The source of truth is stored in our view model. The binding just connects a property to that source of truth, right? It binds them together, or you can think of it as creating a reference to it. And let's go back to Xcode to actually see that in action. So if you remember on our barcode scanner view in our view model, let's go to the view model here, we have our scanned code, and we'll review observable object later, but just know, the source of truth, the data is stored, right? Scan code is stored on our class, our view model, right? That's where it's stored. So our binding basically creates a connection to this value. And that's what we're doing in our barcode scanner view. If you look, when we create our just regular scanner view, we pass in a binding to scanned code. So back over to scanner view, right? This is where we're using our UI, view controller representable. Here is the binding to scanned code. And then, when our barcode scans it, we get that data, we change this value, right? But it is referencing, it is connecting to the value that was in our view model, scan code, right? This is the source of truth. Our scanner view, this binding, this is not the source of truth itself. It is a connection to the source of truth. So you can think of a way, if we go back to our barcode scanner view, right, the kind of the home screen, you can think of a binding as a way to, pass the source of truth down to multiple child views if necessary, right? It's a way to communicate between views. Again, you're just binding to the original source of truth, which is in our barcode scanner view model. Okay, let's move on to coordinators. And by the way, I am going kind of fast because this is review. I've explained this multiple times. We've played with it. However, if you're still confused, you're still not quite sure, please ask questions in the comments or hit me up in the Slack channel. Please, like I said, I really want you to leave this course understanding this aspect of things. So if you're not quite sure, I'm not going to let you leave until you're sure. So get a hold of me. All right. So on to coordinators. If you remember, let's go to our scanner view, right? This is the UI view controller representable. The coordinators help communicate between UIKit and SwiftUI. And if you remember my diagram, UIKit, gets some information. In our case, it is getting the barcode that we scanned. Through delegates that we set up, our scanner view controller that is doing the scanning is passing the barcode to our coordinator. And now back to our code right here, you can see our coordinator set up. Our coordinator is created with a scanner view that again is this scanner view that has the scan code binding on it. So in our delegate methods, right, we had did find or did surface error. Let's just talk about the success case, right? So in did find, this is our UI view controller or UIKit communicating with our coordinator, right? So our coordinator gets the barcode and it's like, thank you, view controller. Thank you for that barcode. Now I'm going to tell my scanner view what that barcode is. So now the coordinator communicates with our scanner view, which is a SwiftUI view that has a binding to scan code. It says, thank you, view controller, for that barcode. Hey, scanner view, here's the barcode the view controller gave me. And then now the SwiftUI scanner view can tell its binding, its source of truth, which again was the view model on the home screen, what that new barcode is, and then the UI can update accordingly. So again, just to narrow in on coordinators, think of it as the middleman in between UIKit and SwiftUI. UIKit communicates with the coordinator communicates with SwiftUI. And if you're still unsure how to set all this up with the final class coordinator, again, go back and rewatch that section of the course. There's no shame in going back and rewatching certain sections or rebuilding certain apps. Again, repetition is the key. You don't just watch a video once and then you know it. No shame in going back and repeating things. All right, so that wraps up this review video covering state, binding, and coordinators. Again, if you have questions, leave them in the comments or hit me up in Slack. Let's move on to the other stuff. In this review video, we're going to talk about observable object, state object, observed object, and environment object. Sounds like a lot, but they're all kind of closely related, so we'll get through it pretty quick. So let's start with observable object. And we're going to start with the example that you see here on the screen as our typical view models that we've been using, right? By the way, we're in the Appetizers app. So as we've done before, right, we create a class, we have it conform to an observable object. And let's go into the documentation to see what Apple has to say about an observable object. Okay, so as you see in here, right, is a type of object with a publisher that emits before the object has changed. Kind of like how I described it, right, with how I say it broadcasts its changes, but let's go a little bit further. By default, an observable object synthesizes an object will change publisher that emits the changed value before any of its @published properties changed, right? So again, like I described, if you mark it @published, like this name variable here, whenever that variable changes or property changes, it's going to broadcast its change, right? I think I've said that a bunch throughout the course, but again, repetition is the key here. I'm repeating myself a lot on purpose, especially in this review section. Again, really want to drive the point home. But anyway, when this property changes, it broadcasts its change. So that's observable object in a nutshell, right? It's only one half of the equation because we got to set up somebody listening to that change. But as far as just the observable object, it broadcasts the change, but you have to mark it @published. If you're running into a bug and you're like, my UI is not updating, what's going on? Double check to make sure you marked it @published, because if you don't mark it published, it's not going to broadcast it. Okay, back to Xcode to dig into this further. So let's walk through the example, right? We marked all of this stuff @published. Let's go through our array of appetizers just to walk through what's actually happening, right? So our array of appetizers we get from the network, right? This is our network call that we created. Well, in the success case, we get back an array of appetizers from the network, right? We decode the JSON into our object. So we set the appetizers we get back from the network equal to this array of appetizers up here. So now what just happened, we went from an empty array to a full array. And because we mark it published and it's an observable object, that change is going to trigger a broadcast. We're going to say, hey, whoever's listening, I got appetizers now. We updated. Update your UI, and who's listening, right? Our appetizer list view is who's listening, right? And this is how we set it up, right? Our state object view model. More on state object in a second, but now we have a property view model that is listening for those changes, right? So now when I do view model.appetizers, right, this view will trigger because that changed, it'll redraw, and now it's going to pull from my list of appetizers to create our list. So that's kind of the flow on how observable objects works and communicates. So now let's talk about this state object up here. And if you remember, the key difference, I've said it a bunch, between @stateObject and @observedObject and when you should use what is when you're creating an appetizer list view model, or you're creating an observable object, which our view model is, that's when you want to use stateObject, right? And by creating, we're setting it equal to in these parentheses, right? That's the initialization. You may hear it called instantiating, initializing, creating, all saying the same thing. But the reason we want to do that is because when we create it on this view, it acts just like a normal state. Like that's why it's called stateObject, because now our appetizer list view owns this view model. And just like the state variable I described on our weather app, no matter how many times our appetizer list view gets created and destroyed, which is what happens when it gets redrawn, we're not going to instantiate a new view model, right? We're only going to create it once, and then SwiftUI is going to manage that, elsewhere. That way we can always reference this same view model no matter how many times our appetizer list view gets created and destroyed. Let's go to the documentation to basically reiterate what I just said. So here in stateObject, right, it's a property wrapper type that instantiates an observable object, right? Talked about creating one. If I scroll down a bit, here's the key, right? SwiftUI creates a new instance of the object only once for each instance of the structure that declares the object. So that's basically what I just said, back to Xcode. Whereas no matter how many times appetizer list view gets created and destroyed, we only have one view model. That way it can persist its state. Now let's shift to observed object, which is what happens when you're not creating it here, you're passing it in from a parent view, right? The appetizer list view in this scenario, we're actually going to use the frameworks app, right? Wouldn't own the view model. It's going to be relied on it being passed in. Let's actually switch to the frameworks app to show it in real life. So here I am in the frameworks app, and this is what we just did in the optimization videos. So hopefully this is fresh review for you, but we also didn't deal with this as much as we did stateObject. So if you're still not quite sure, definitely hit me up in the comments, hit me up in Slack. I want you to really understand this stuff. It's important. So again, we used observed object because, look, we're not initializing it. We're just declaring, hey, we have a view model that is of type, framework detail view model. We don't give it a value because we're expecting the value to be passed in when we create a framework detail view, right? It's relying on the data from the parent view. For this reason, and this is the difference between stateObject and observed object, right? stateObject, like I said, that view will own that view model. Here, the observed object, this framework detail doesn't own this. It will destroy this observed object every time this gets created and destroyed. It doesn't care about it. The reason it can destroy it all the time is because every time a new framework detail view gets created, it's getting passed in a brand new view model, right? Let's go to our framework grid view, which is the parent view here, right? Whenever we tap on a framework, we show the sheet, we create a new framework detail view, which requires a view model, a framework detail view model. Again, we just implemented this a couple videos ago. But what's going on here is I have to pass in a view model. And again, we're initializing the view model. The view model takes a framework and a binding to showing detail view. But again, the reason why our actual framework detail view can just destroy this at will is because every time it gets recreated, it's getting injected with a new view model that is created on the previous screen or previous view or parent view called the framework grid view. And the reason it gets created up here is because we're relying on data, right? We need to know what framework to show when we're presenting our framework detail view, right? That's why we pass in the selected framework. So that is observed object. Again, back to it, I think the key thing to know, you'll be pretty much safe if you just understand that, hey, if I'm passing in a view model, I need observed object. If I'm creating a brand new view model, like in our framework grid view here, I need stateObject. If you just remember that rule of thumb, you'll be pretty good. Okay, now let's talk about environment object, but for that, we got to go back to our Appetizer app because that's where we used it, right? And the environment object we created was the order, right? It's an observable object. This is what I meant by they're all kind of similar. So our order is just an observable object. So that's another key thing to remember, right? It doesn't have to be a view model, right? Remember, an observable object, the only thing you need to know about that is that it will broadcast its changes, right? If you mark it published. So in this case, right, we need our observable object to be accessed from multiple screens, right? We can add an appetizer from our appetizer list view, and then on our order view, we need to display, what's in our order, and we can swipe to delete, right? So multiple views, multiple screens need access to this observable object. This is different from a view model because our view model is very tightly coupled with a specific view, right? We don't want everything to have access to it, just that view. So that's the difference, right? Environment object, we want a lot of things to have access to it. That's the whole point. So where do we put it into the environment? Well, let's go to our app, right? The appetizer, app structure. And in our case, where we want our entire app to have access to it, we inject it into the environment at like the highest root view. And again, pulling up this visual, right, that we used before, that is our appetizer tab view, right? All the other views end up being children or their downstream views, however you want to look at it, from the appetizer tab view. So by injecting it into the environment here, everything's going to have access to it, which in our case, that's what we want. But remember, there are cases where you may not want everything to have access to it. Again, the example I used was the Apple settings app where I have to go 4 screens deep. Well, maybe I want to inject something into the environment like right at the settings root view, right? Not the entire app's root view, just the settings root view. That way everything downstream or all the children of the settings root view will have access to some sort of like, settings observable object that they can all access that. So coming back to our app object here, a key takeaway with environment object is wherever you inject it matters greatly. Because if a view that's not part of the view hierarchy where you injected it, right, it's not one of the children, tries to access it, your app's going to crash. Let's review how you access this real quick, right? Okay, so back to our order example where we injected it at the root view, at our tab view, so everything has access to it. So in our appetizer detail view, right, the view that pops up, this is where we need access because this is where we're adding the appetizer. So if I scroll up, right, you do add environment object var order. Now, this just means, hey, I'm going to reach up into the environment and I'm going to get access to this single source of truth, right? So this environment object is a single source of truth for all the child views for it. So that's how the appetizer detail view has access to it, as well as our order view has access to it, because we're writing this add environment object property wrapper. And like I said, it has access to the same object. It's the single source of truth, just multiple views can adjust it. Now that's one scenario where you use environment object. Another one is if you find yourself passing a binding down multiple views. Now I think all the examples we use, we're just passing a binding down like one view, which is fine. That's what it's meant for, that like one-to-one communication. But sometimes, you'll find yourself like having more child views. And if you find yourself passing a binding down like 5 views, that's a good time to use environment object, where at that root view, you create an environment object. That way you don't have to pass the binding from view A to view B to view C to view D. You just inject it at view A, and then view D, can automatically access it, right? You don't got to pass it all the way down the hierarchy. So that is another way to use environment object. So that wraps it up for the quick review on passing data. Again, I want to stress quick because we've been over all this before, but I did just want to go over it one more time to hammer it home. But again, I know I've said this before, please, this is the most important part of the course. If you don't quite understand this, hit me up in Slack, leave a comment, call me. Like, I want you to understand this. I don't want you to leave this course having this be fuzzy at all. This is where all the value is. Okay, with my plea done, let's move on to the conclusion videos of the course.
There's a new and improved way to update your user interface in SwiftUI. iOS 17 introduces the @observable macro, which is a cleaner, more performant way to handle UI updates in SwiftUI. I'll explain how it works, and we'll convert the old way to the new way to help you understand. Here in Xcode, I have a basic example of the existing way to update your UI when your data model changes. Let's run through this real quick to set the foundation for this new change. So here we have a data model. Right now it's a user. This could be a view model for your specific view. Maybe it's an order for an e-commerce app. In SwiftUI currently, if we want to update our UI when something in that data model changes, we conform to observable object. We mark any property we want to change with @published. That means when the name property changes, because it's marked @published, the UI will update. And in turn, where we use this user object here in our view down here, we mark it @stateObject or @observed object. Depending on how you're using it, that's a different topic. And then anytime this state object of a user changes, our UI will update here, right? User.name, user.jobtitle. The only change I'm doing right now for this simple example is incrementing the follower count. You can see user.follower count plus equals 1. So when I hit the add follower button, you can see 99 followers, 100, 101, 102. You can see the UI updates because my follower count is changing. And again, to go back up the stack here, that's because it's marked @stateObject and because the user object is an observable object and the follower count is marked @published. That is how the UI updates. If you've worked with SwiftUI before, this should be very familiar to you, but I wanted to walk through that to set the foundation for how the new way works. Okay, so let's update this to the new way. We'll talk about syntax first, and then I'll tell you what's going on under the hood and why this is such a great change. So the first thing we need to do, we need to import observation. Now you may see people importing Swift data. Swift data as a whole imports observation as well. So importing Swift data feels a little heavy-handed. If you just want observable stuff, just import observation. And now our class, instead of conforming to observable object, we delete this. And in front of the class, we mark it with a macro at observable. Now we get some errors because observable requires property of name, job title, follower count to have an initial value. Because in order to observe something, they need an initial value to know when it changes. Now I have seen things on Twitter that this requirement might go away. For a disclaimer, I'm on Xcode 15 beta 2. It is June 22nd, so WWDC was just a couple weeks ago. So this is all very fresh. So this may change in a future version of Xcode, just be aware of that. But for now, we're going to give our properties an initial value because we marked it at observable. So for the name, just gonna give it an empty string. Same thing for job title, empty string. For follower count, we'll say 0, and then bio, an empty string as well. So, okay, we marked our class at observable. That replaced conforming to observable object. Seems simple enough, but what's cool is now we don't need any of these at published. So that all goes away. Everything is being observed because it's marked at observable. So that cleans things up a bit. Again, we're just talking about syntax right now. I'll dive into what's actually going on. So that handles our data model. Again, this could be a view model for a specific view. Our simple example is just using a user. So when we want to use this observable object here, in our view, instead of marking it at state object, we just have it a var. And I'll highlight this, do a Control-I to line it up. But this eliminates the whole state object, observed object. When to use which one? What are the rules there? The concept of state object and observed object don't exist in this new at observable world. Now, of course, you still can use the old code, so I don't want to say those two things don't exist overall, but if you're adopting at observable, it simplifies things. You don't have to worry about state object or observed object. It knows here on line 27, this user is marked at observable, so it knows that it is observing these properties for changes to update the UI when necessary. So again, just talking about syntax, we got rid of all the at published. We just marked it at observable, and then we can get rid of state object and observed object. So syntactically, that is much cleaner. But there's a lot more benefit going on than just cleaner, easier to read code. Because the key thing observable does is SwiftUI under the hood is tracking the views that access properties of an observable class. Let me break that down a little bit. So the properties of my observable class are name, job title, follower count, bio. When I had them all marked at published, anytime one of those underlying pieces of data, like the follower count or the job title, would change, it would trigger UI updates. So a big picture of what observable is helping with, it's going to eliminate a lot of unnecessary UI updates, therefore improving performance. To put it super big picture, when you use @observable, SwiftUI is doing a lot of tracking under the hood as to which views are accessing specific properties on objects marked observable. It can be a lot more surgical with its UI updates. So that's why you're going to see a performance boost. And that's why this is such a big update. And to add to that example, right, we're just using the name, the job title, and the follower count. You can see I'm not even using the bio. So you may be saying that like, well, yeah, then only your follower count should have been marked at publish because that's all that's changing. Well, that may be true on this singular simple example view, but you can imagine in an app, something like a user, that's going to be accessed in multiple views. This kind of looks like a user profile. So maybe there's a separate screen where the user profile is being updated. So now you do need these to be marked at published. So this just reiterates that when you use @observable and you let SwiftUI handle all that tracking of which UI is actually accessing the properties under the hood, it eliminates all those unnecessary UI updates. And like I said, it allows SwiftUI to be more accurate and surgical with what specifically needs updated, which leads to better performance. Another cool thing about this observable macro, or just macros in general, it does seem like magic, right? I talked about all this stuff that's going on under the hood. Well, with macros, basically what they do is they abstract away boilerplate repetitive code into a macro so you can't see it. But in Xcode 15, if you right click, expand macro, you can see the quote unquote magic going on under the hood. So you can see each property is marked at observation tracked. That is how, like I said, we're tracking which UI is accessing each property. And you can see all this boilerplate code. To be honest with you, the heavy use of generics. If you don't understand all of this, that is fine. Again, this magic is abstracted away behind the macro, but again, it's not a black box that you can't see. If you are having an issue and you want to see what's going on with the macro, just right click it and you can expand it so you can actually see the magic of what's going on. So I think that's great about macros. And you click hide macro expansion, there you go, back to observable. So to put it simply, you get cleaner syntax and better performance. It is a great update overall to SwiftUI.
Don't be afraid to go back and redo things, review videos, right? Like I've said a bunch of times, you don't just watch one video and you get it. Like repetition is the key. Like SwiftUI is not easy to learn. Like it took me a long time. So if you're still shaky on some things, like don't feel bad. Go back and rewatch the parts you're not quite getting. And also, if you skip the challenges, which I know a lot of you did, go back and redo those now that you feel like you've got a little more experience under your belt. Or take these 4 apps that we've built, right? You got a nice base. Start building and expanding on those apps. Like start using your imagination to build a product. Like, right? Like what feature could make this product better? Or what animation could spice this up a little bit to be really, really nice? That is where like the real learning comes, right? Like listening to what I say, typing what I type. Yeah, that's cool. You're gonna get your start that way, and you need that for sure. But the real learning comes when you have your own idea and you're like, okay, how do I make that happen? And then you figure it out, like through other tutorials, reading documentation, experimentation, right? That's where the magic happens. So again, go back and use these 4 apps as a basis for that. I mean, just some ideas, right? You can explore with like landscape mode, like how would you adjust the UI to support landscape? Maybe you want to support iPad, right? Or again, maybe you want to add some cool animations and start going down that path on how you can spice these up. The next thing I want to talk about before you go is SwiftUI's evolution. We're still so early. It's not even 2 years since it's been announced, right? It's been 1.5 years since it's been announced. Crazy, right? And it's still growing, it's still evolving, it's still maturing. Like I mentioned in the beginning, like best practices are still being established. Like, with UIKit, we've had years and years and years of high level, huge production apps to kind of build these best practices and thoughts. None of that exists with SwiftUI yet. So this is me saying, use what we learned here as a foundation to help you grow and evolve. Like I guarantee you in 2 years, now that I've been writing SwiftUI for even longer and longer and longer, my style is probably going to change. Some of the things I taught here, I'd be like, oh man, I would have taught that differently, and expect that. And that's a very big takeaway too, is the only thing I can promise you about SwiftUI is that it is going to change a lot over the next couple years. So just be prepared for that, expect that. And the last thing before we wrap up this video is I would love to hear your feedback. If I'm being completely transparent and honest, like I was a little nervous about doing this course, right? My UIKit courses, I've done my whole career in UIKit. I felt confident about that, but SwiftUI is so new. Like nobody has a ton of experience in SwiftUI because it's only been out for like a year and a half. So I would love to hear feedback. Again, I have plans for future courses. I'm always trying to make them better. So good or bad, right? I can take it. Give me the constructive criticism. What could I have done better? I would love to hear it because again, it's only going to improve my future courses. And if you did enjoy this course, you got a ton of value out of it. I guess my one request would be to just spread the word, share it, right? Put it out on Twitter, tag me in it. I'll retweet it. It really helps me out a lot, right? This is my livelihood now selling these courses. So again, if you enjoyed it, I guess the only thing I can ask is to share it.